Hello everyone, welcome back to the channel. So this is going to be the ultimate data engineering prep video. It is around 13 to 14 hours of video and we will cover everything that you need to prepare for the data engineering interviews. Right? Because a lot of people are confused that just before the interview what should they prepare? They will randomly prepare SQL from somewhere, then Spark from somewhere, data modeling from somewhere, and it will be all messed up, right? So this is the ultimate video that you need to watch. We will cover five things in this and we will cover in depth. It is not only the overview I'm giving. We will cover in depth every topic so that before going into the interviews, you will feel very confident. So we will start with SQL, right? One of the most important thing for data engineering interviews. And we will solve a lot of questions which are asked in interviews. We will see some of the patterns that are frequently asked in interviews. So you can solve along with me or you can just watch it, whatever your comfortable level is. After SQL, we will move on to data modeling and data warehousing. One of the very important topic for data engineering again, right? Because it will tell you how to create tables, how to build data warehouse, and lot of questions around that, OLTP, OLAP. We have covered everything. Then we will move on to Python. Again in Python, we will solve a lot of questions which are asked commonly in interviews. So you can practice along with me and you will feel very good going into the interviews to solve Python questions. Now next is Spark and PySpark API, right? So first we will cover the Spark fundamentals, right? All how to see Spark UI, what is lazy evolution, all of the Spark concepts, right? In depth we will learn. And then we will see PySpark API, how to work with PySpark API. You can always use Spark SQL, but a lot of interviews will ask you to write code in PySpark API as well. So we will learn fundamentals of PySpark API, how to do everything like group by, join, select, whatever you do in SQL, how to do that in PySpark API using including window functions as well. Okay, so let's get started. Before we start, please make sure you like the video, share with your friends, and bless me with your support. Thank you. Let's start. I just want to mention some of my courses on namastesql.com in case you are interested to learn any of the topics from ground up to advanced level. We have some in-depth courses. You can learn Spark, Azure Databricks. If you are learning Azure Databricks, make sure you learn the Spark first because Azure Databricks is built on top of Spark. So under the hood, it is the compute engine. Or if you want to learn Snowflake, SQL, Python, Power BI, we have in-depth course for everything. We have analytics engineering bootcamp as well, where we cover SQL, data modeling, data warehousing, Snowflake, DBT, Power BI, right? And a lot of projects are also there. So whatever you are comfortable with, you want to take, we have great courses. You will get the coupon code at the checkout of each course. You can also have coding problems. So in coding problems, you can solve different questions, right? So for example, you want to practice SQL, you want to practice Python, anything you can. So for example, this is a question and you can go there and solve in any of the language, MySQL, MSSQL, Postgres. Python means you want to solve in using pandas, or you want to solve using PySpark, right? So you can solve all of these questions, as well as we have some Python questions as well, coding questions. So you can go to category and say Python coding, right? And you can solve all the Python coding questions, right? So these are very commonly asked questions again. So if you want to practice, you can practice here as well. Okay, so let's start the video now. Okay, so let's start with SQL. So in SQL, we are going to start solving questions, frequently asked questions. We are not starting with theory because this is an interview prep video. So there will be a lot of questions I will solve next 2-3 hours. You can start solving them, right, along with me. Or if you are comfortable, you feel confident, you can just watch it also. Whatever you feel good, do it.
So first question is how to find duplicates in a given table. So let's say you have a table um, and you have a duplicates. So if I take EMP table, if you see EMP ID is repeating here, right? So question is how do you find which all records are duplicated, right? There can be multiple records in a table. So what we have to do is, so on whatever column we have to find duplicates, we have to do group on that. So select a star from EMP group by EMP ID. Okay. So I will do EMP ID and will do count. If I run this, so for EMP ID 1, if you see, there are two records, and for everything else, there are one record. So it means this ID is duplicating. So whenever we have to, so I can filter on this, right? I can filter on count. If count is greater than 1, it means there are duplicates. So whenever we have to find, put some filter on an aggregated column, we have to use having. So I will say having count of 1 greater than 1. So it will give me employee IDs which are duplicates. So it will give me employee ID 1, right? So this is how you will find the duplicates in a table, and there can be two columns. If you want to find the duplicates on two columns, you can put two columns here in group by and here and put the same condition. Okay, let's move on to the second question. Now you have the duplicates. How you will delete the duplicates, right? I have created one more table just to illustrate it. Okay, so if you see here, again same table, right? We have duplicates here. So how do we delete it? So what I will do, I will find the row number first. Okay, so what I will do, I will do a partition on employee ID, which means for each employee ID I will have a running number, and then I will find out. So let's see how it goes. So select star comma row number over partition by EMP ID, and order by also I will do EMP ID here. Order by we can do on any column. Okay, so if I do that, um, order by as Rn, right? Okay, so if you see for the employee ID 1, there are two records, right? For the first row number is 1 and second is 2. And for each, so for the first record of employee ID, it will be always 1. If the employee ID is repeating, we have row number 2, right? What I will do, I will just treat it as CT with, let's name it as CT as this. Okay, and then I will say delete from, sorry, CTE where row number greater than 1, right? Okay, so one row affected. So if I check the employee table again, okay, select from, so here you see row 9 is deleted, right? So if I run this again, uh, again row number 1 and there is no duplicate. So how this is how you can remove duplicates. Okay, coming to the third question. This is very frequently as difference between union and union or. So again, let's see how we can do it. Select from EMP. Okay, I have created two tables, right? One is EMP and one is EMP1. Let's see both. Okay, so they have similar data. Uh, Only difference is it has one duplicate and it does not have duplicate, but that doesn't matter. What I'm going to show is I will do union on manager ID. Okay, so select manager underscore ID from EMP and manager ID from EMP1. So basically what happens is union will remove all the duplicates and union all will have everything. So first I will do union all. Union all. So if you see there are 9 records in this table and in this table we have 8 records, right? So if I do union all, we will get 9 plus 8, 17. Everything is coming, right? 4, 5, 4, and then everything is coming from second table. So there are no removed duplicate. As it is like a combining two tables, all the records from first table plus all the records from second table. But if I do union, It will give me only unique values like 4, 4 are repeating, 2, 2, 2 are repeating, but it will give me just unique values. So see 2, 4, 5, 6. That's it. So this is the difference between union all. Union all will give everything, just merge two tables and give as it is. And in union, it will remove the duplicates. Okay. Okay. Question number 4. Question number 4 is difference between rank, row number, and bench rank. So I have created a full video on this. This is a little big topic. So I will tag it somewhere on the top. You can go through the video. Okay. Next is, so not necessarily exactly these questions will be asked, but flavor of this kind of, I mean, they can have instead of employee table, they can be customer table or orders table, and similarly, say the flavor of questions will be asked. Okay. So next is employees who are not present in department table. So let's say select staff from EMP, and we have select staff from the EPT. So we have these two tables. Okay, so this employee ID has department ID also. So employee belongs to which department? And this department, there's this second table, department table, which has departments also, right? So department ID 100 is analytics department, department ID 300 is IT department. Now, if you see in this table, 100 and 300 are there, but department ID 200 and 900 are not there. So they will ask a question that give me all the employees whose department is not there in department table. Basically, they want all the employees from 200 department and 900 as well, because 100 and 300 are there, 200 and 900 are not there. So simply what we can do, one way of doing is select star from EMP, where department ID not in, select department ID. Okay, so what I'm saying, give me all the employees whose department ID is not present in department ID table, right? So let's run it. Okay, so if you see, it is giving me department 200 and 900. 200 and 900 were not there in department ID, department table. So this is one way of doing it, but this is a subquery basically. So next question what they will ask is, okay, so this is a subquery, performance will not be good. Let's say there's huge data in the table, and generally in subqueries you will get not get the good performance. So what is the other way of doing it? So other way of doing it is we can do a left join also. So let's do that way. So select star from EMP. Okay, I will do a left join. In left join, what happens? All the records from left table will come. I will create a separate video on join types, but let's consider this join for now. On EMP dot department ID equal to EEPT dot tab ID. Okay, I will just remove this. EMP dot star. I'm taking everything from EMP table, and from DEPT dot uh, department ID, let's say, or we can have department name also. Department, sorry, I don't remember the column name. Let's see. Okay, DEP name. Okay, DEPT dot DEP underscore name. So if you see, everything is coming from left table, all the records and the matching records. So 100 was there in the department table. So we have the details of those employees who are in department ID 100. But for these employees, it is not there, so it is null. So if I have to find all the departments whose department is not there in department table, I just have to put a condition where dept dot dep underscore name or dep ID anything is null, right? So this will give me all the employees whose department is not there in department table. So this is one way of doing it using left join. Okay. Okay, let's move on to the sixth question. So sixth question is, so again same table. The question is from each department. Okay, so in department 100, if you see, there are 4 employees. Again in department 200, there are 4 employees, and department 900, there is a 1 employee. Okay, so I want employees whose salary is second highest salary in each of the department. So for department 100, the highest salary is, if you see, 15,000, second highest 10,000. So I want all the employees whose salary is second highest salary in their department. So I can do it using row number or rank function, right? I will do emp dot star comma rank over, so partition by department ID. So for each department, I want a separate rank, right? Because in each department, I have to find second highest salary. Order by salary, descending. So descending means the highest salary will get the rank 1. So let's see what is the result of this. I will name it as then. If you see department 100, this is rank 1, highest salary 15,000, then 10,000, 2, and then 4. Again in 200, it is 1, 1, and then 3, 4, okay, and then this is again 1. Now this is rank. If so, what happens if, see, 1, 1 they have both got, and then it will skip the rank. So we can use dance rank also. If I do dance rank, so 1, 2, 2, 3, and again they have got 1, 1, and 2. So what I will do, select star from this, because I need second highest salary in each department, where Rn equal to 2. So I will get all the records for each department. So if you see, for department 100, there were 2 employees with the same salary, and they were second highest salary. And for department 200, we have 1 employee, and for the department 900, there was only 1 employee, so there was no second highest salary. So we did not get the output. So this is how you can answer this question. Okay. Find all the transaction by Silpa. Okay, so let's consider this table. This is also very common question. So if you see, this is a transaction table, and there are some transaction done by Shilpa. You see, Shilpa. There are 3 transactions. So the ask is, I want to find all the transaction done by Shilpa. Okay, so if I put where customer name equal to Shilpa, the problem here is, uh, okay, this is case insensitive here in the SQL server. But generally, what happens is, if you put Shilpa, only one record will come, this one, because this and this is not matching. Currently, the SQL server setting says it is just doing a in case insensitive search. So it is giving all, but in general, it will not give all. It will just give this record. So in that case, what we can do, we can just do upper of customer name, and I can compare with the uppercase Shilpa. So in that case, it will give all the records. Okay, so this is how you can answer this question. Okay, another very frequently asked question is, so you have an employee table, same table we were just discussing about. So you have employee ID and manager ID, and you will be asked, okay, give me all the employees whose salary is greater than manager's salary. Again, this is a little big topic. So I have created a separate video of it. I will tag somewhere here. You can go through it. Okay, question number 9. Okay, this will be like joins. So the interviewer will ask, what is the difference between left join, inner join, right join, and full outer join, and they will give some data also. Maybe they will So nowadays it is like virtual interviews. So they will ask you to open a Excel and ask, okay, these are the two tables. If we join, what will be the result? So generally the answer is inner join will give you all the records which are common in both the tables. In left join, you will get all the records from left table, and data, whatever data is there in right table. So similarly, right join and full outer join. So I will create a separate video on joins, but just be prepared for it. Okay. Okay. This is the last one, and this is also very common questions from orders. So let's say what happened is, in this table by mistake the customer gender was put wrongly. So for the male it is female. So for example, Shilpa is female, but it is populated as male. Similarly for Rahul, female. So it is exactly reverse. So what we have to do, the ask is we have to fix it. So basically what we have to do, wherever it is male we have to make it female, and wherever it is female we have to make it male. So we have to update this table. Okay. So how do we update it? The problem is, if I do this update orders, okay, set customer gender equal to male, where customer gender equal to female. So if I run this command, what will happen? It will make all the male to female. These three will become female. Okay. Once it becomes female, how I will identify which female I have to make male? Everything will be female, and I won't be able to fix these and this record, right? Similarly, if I do other way, if I take customer gender equal to female where it is male, so everything will become female. So that is the problem. I can't update one by one. So I have to find a way that at once I can update both. So what I will do, we can make use of case statement here. I will not put where condition. I will say set case when customer gender equal to male, then female, okay, and when customer gender equal to female, then male. And okay. So what it will do, wherever it will find male, it will do female, and wherever it is female, it will do male, and it will do at in one single query. So if we don't have to run one by one, and there won't be any issue. Okay, let's run it. Okay, there is some syntax error. Update orders, set. Okay, set. We have to do set. Okay, so yeah, 5 rows affected. Now if I see this, if you see, Shilpa has become female in all three records, and Rahul and Rohita male. So this is how you can swap the values. So if I run this again, it will again swap, right? Again, see, Shilpa has become male and Rahul and Rohita female. So this question is like, you have two tables with the duplicate keys, and when you join them, what will be the output, right? And they will ask you that, okay, with inner join, how many number of records, left join, right join, full outer join, and they will try to confuse you. I will cover all the scenarios during the video. I will insert more values in these tables and will cover all the scenarios so that there is no confusion going forward for all of you. Okay. Also, if you are not aware of join types, what is left join, inner join, full outer join, right join, watch out my video. I will tag somewhere on the top. Was that get your concept clear of four kinds of join, and then see your video so that it will make more sense to you. Okay. And please do like the video and comment on the video so that it will reach wider audience. Okay, so let's start. So I have created these two tables with one column, and for now I have created this two records in this with value 1 1 and three records with this with 1 1 1. Okay, so What will happen if we do inner join, left join, right join, full outer join? Okay, I will cover most scenarios. Let's start with this. This video might be a long one, but please do watch so that there is no confusion in future. So what happens when you join these scenarios, right? Where you have duplicate keys. So how join works? So when this record will go to this table, I mean this record will go to table T2. This is T1 T2. So this record of T1 when goes to table T2, it will find three ones, and this one will not be able to differentiate that he has to join with which, this one, this one, this one, right? So it is not a human that it can choose one of these. It is a machine, it is a database. It cannot differentiate between these three values, so it will join with all three. So this one will get joined with all these three values, and when this one will go to this table again, it will join with all three values. So there will be six records, right? So this is how you define number of records. Number of values in this, the common keys 2, and here 3. 2 into 3 6. So if I do a inner join, there will be six values. Okay, I will run this later. Let's talk about left join, right join, and full outer join also. So in left join, what is left join? Left join is all the matching records will come, like the output of inner join will be there, plus the non-matching records from left table. In our case, T1 is our left table. So first, whatever is the output of inner join, that will be there, plus non-matching records from left table. But there is no not matching record, right? All are matching records. This one, for this each one there is a one key in the other table also, so there is no non-matching records, right? So the output will be same as inner join, right? Similarly for right outer join, all the matching records plus non-matching records from right table, but there is no non-matching record again here, right? So in this case also number of records will be 6. What is full outer join? Full outer join is matching records from both the tables plus non-matching records again from both table right table also, left table also, because but in both the tables there is no non-matching record. Again, the result will be same as inner join for all four joins. So if I run this, there will be six records, or I run any join, it will be six records, right? So I hope this is clear. Do not get confused. Okay, if all are matching records in both the tables, then the result of all the joins will be same, right? This is a thumb rule. If all are matching records in both the tables, the result of all the four kinds of join will be same. Okay. Okay, now let me add some twist in this. What I'm going to do, I'm going to add a value 2 here and 3 in this table. Okay, let me execute it. So let's see the data again. So now we have a record here, non-matching record. This 2 is not matching here in T2. Again, 3 is not matching here in T1. Now what will happen? In the inner join, only the common records will come. So 1 is common. So there are two ones and there are three ones. 2 into 3 is 6 records. Right? Now, in case of left join, what will happen? In case of left join, all the matching records, 2 into 3 is 6 records, plus non-matching records on the left table. So non-matching is 2, so 2 will come. So there will be 7 records, right? In case of right join, all the matching records plus non-matching records from right table. So 6 plus 1, how many records? 7 records again. Okay, so let me run it and then we will go to full outer join. So 2 is there and null because there is no matching records for 2. From here 3 is coming and ID1 will be null. Okay, and here what will happen? All the matching records and all the non-matching records from both the tables. So there will be 8 records, right? 1 1 1 for 2 null I have a record and null 3 I have a record. Okay, so for full outer join, what is how you have to calculate? First we have to see matching records plus, so there are 6 records. So first we will calculate by doing inner join. 2 into 3 is 6, plus you will add non-matching records from left table plus non-matching records from right table. That will be the number of records in the output. Similarly, if you have to do for left join, first find what will be the output of inner join, that many number of records plus non-matching records from left table. I hope this is clear so far, right? Now let me add some more duplicate data here. So what I will do, I will add one more 2 and I will add a 2 here also. Okay, let's see the data. Okay, so now what is going to happen is, see, 1 1 is same. Now I'm doing a inner join. So 1 1 is there, right? And there are 3 ones. So 2 into 3, how many? 6 records, right? This will remain same. Now for 2, there are 2 records. And how many records are there? 1 record of 2. So 2 into 1 is 2, right? These are the only matching records, 1 and 2, 1 and 2. 3 is non-matching. So in the inner join, there will be 8 records, right? There will be 8 records, see, right? Now let's see what will happen in case of left join. In case of left join, what will happen? Just think about it. Comment in the comment section what will be the output. So if you see, when we do left join, this will be left the matching records from both tables. So 1 and 2 both are matching, right? And there is no non-matching records in the left table now, right? There is no non-matching records. 1 and 2 both are matching. So left join and inner join will be same in this case, right? There will be 8 records. In case of right join, what will happen? Now this is little tricky now. What will what how many records will be there in right join? Just think about it. So what will happen now? So first of all, let's do a matching record. So 1 is matching 3 into 2, 6 record plus. Now let's forget about 3 for now. 2 is there. So 2, 1 and 2. So there will be 1 into 2, 2 records, right? There is 1 record of 2 here and 2 records of 2 is here. So 1 into 2, 2 and 2 into 3, 6. And this 3 is there a non-matching record. So for non-matching record, there will be 1 record always. So there will be total 7 records in this case. There are I think something is sorry, 9 records. 6 plus 2 plus 1, 9 records will be there. Okay, so this is non-matching record, and for others we have the joins, right? Now let's see full outer join. At this point, for not null values, I think you should be clear how to do. We will work with null values after this. Okay, so full outer join, what will happen? Let's calculate full outer join. So what we said, first find out the, let me add one more value here so that it will be, it will cover everything. So I will add a 4 here. Okay, and then everything should be clear. Okay, so now let's do this. When I'm doing full outer join here, let's do first matching records. So matching records, 2 are there and 3 are there, 3 into 2, right? And let me do select 3 into 2 plus. Again, now we go to 2. How many records are there of 2? Let me add one more 2. Then it will be more fun. Okay. So if you understand full join, you understand other joins also. So 3 into 2 is fine. There are 2 records here, 3 there. So first we are covering matching records. What else is matching? 2 is matching. So there are 2 records here, 2 records here of 2. So 2 into 2. 2 into 2 plus. Now this is a full outer join, right? So all the matching records so we covered. Now 4 is not matching. So there will be one record for this. Plus there is one record 3 non-matching for one record for this, right? So one record for non-matching and inner join. So how many records are there now? There should be 12 records. Let's run it. There are 12 records. You see, 4 and 3 are non-matching, so other values are null, and everything else has just Cartesian product. Right? We call it Cartesian product also. 2 into 3, it is a Cartesian. 6, 2 into 2, 4. We call it Cartesian product also. Okay. Now last thing pending here is when we have null values. Let's cover that. So I will insert some null values. So let me insert null value here, and let me insert a null value here on both the tables. Okay, now you have to understand this, null cannot be compared to other null. What it means, null is not equal to null. So null value will not be joined also with null value. So in this case, when we are saying there is a null here and there is a null here as well, right? See, null is there. Okay, so null is there, null is there. These two nulls will not be joined because null is not equal to null. Null is a unknown value. So when I do inner join, what will happen? My bad. So when I do inner join, only the matching records will happen, right? So matching records 3 into 2 6 and 2 into 2 4, 10 records should be there. Null will not be joined with null. So there are 10 records, only the matching ones. Now look at the left join. So what will happen? In left join, all the records from left table will come. So null will come. One null will come, right? So let's do for this. So how many records will be there? 2 into 3 6 plus there are two twos and two twos. 4 plus there is a 1 4 here. This is a non-matching record from left table and this is also a non-matching record. So 2 1 1 for each. So there will be 6 plus 4 10 and 12 records. So we go to left join, there will be 12 records. Because we are doing a left join, so null is coming. This is not a matching null. For this null, there is no matching value, so it is coming as null, right? I hope this is clear. Now, who will answer in case of full outer join? What will happen? Okay. So just now we saw how many records were there? 3 into 2. So there were total 12 records, right? There were total 12 records. After that, we added null null. So what is going to happen? This null is different from this null. So whatever we have calculated 12 records, that will be there, right? And there will be one null values separate record from both the tables because this null is not joined with this null. So there is a separate record for this null and there is a separate record for this null. So there will be total 14 records now, right? So let me run this. Always remember, see, there is this null, one null and other null, right? And there is this non-matching record. These are also non-matching records and everything else matching records. So always remember, null is not equal to null. We cannot join two nulls together. We have to separate them out that this null is different from this null, right? I hope this is clear. Okay. Let me know if you have still have any confusion on this topic. I can create more video, but definitely this question will be asked to you in the SQL interview. Please do like this video so that more and more people can understand this concept and they should not make this mistake in the interviews.
So we have this employee table where we have employee details. What we want to do is we want to drive a rank column which will rank employees based on their salary, which means the employee with the highest salary. So let me do an order by salary. Okay, so I will do order by salary descending, right? So what I want to do, the employees with highest salary should get rank 1. So there will be one more column, we can call it as rn. It will get value 1 because it has the highest salary. The person with second highest salary should get 2. The person with third highest salary should get 3 and then 4 and then so on, right? So for that I'll write the window function syntax. So I will say rank, right? So I want to drive rank. So I'll say rank, right? This is how the syntax is. And then I have to tell based on what. So I'm saying order by salary, right? Based on salary, order the data on salary, and based on that, you assign the rank. So if I just execute it, you will see, let's call it as RN, right? You will see the person with lowest salary has got rank 1, but we want highest. This is happening because by default order by is ascending. So salary is getting ordered in ascending order, and then we are calculating rank 1 2 3 4, right? So highest salary person has got 10 rank, but we want reverse. So I will say DESC, right? Now what will happen? The person with highest salary will be on top, right? So now it is fine. So this is how the syntax is. You have to say rank, right? Then over in this you have to tell on what basis you want to drive rank, right? And now I'm getting my rank accordingly. Now let's look at the output. So this guy has highest salary, has got rank 1. This has 12,000, this has got 2. Now, interesting thing is, this guy is also 12,000 and this guy has also got 2, which is fair, right? If there are two people who has got same salary, they should get the same rank as well, right? Why to differentiate? So this is working perfectly fine. This guy got 2, this guy got 2. Both of them have got 2. Now let's move on. Next guy, 10,000. Now this 10,000 is not 3, it is 4, which is again fair enough because he is the fourth person as per the salary, right? There are 3% before him and he is the fourth person. So what rank is doing? It is skipping the rank number 3. So it is giving 1, 2, 2 and then 4 because this is the fourth person, right? Before him there are 3 people. So he is the fourth person. Now this guy again, Ankit, has salary 10,000. So both of them are getting 4, right? Next person, Sanjay, is getting 6. Why? Because he's the sixth person. Because the two people have got 4. So this is the sixth person. There are 5 person before him. So he has got rank 6. So fair enough. And then 7, 8, 9, 10. Right? So this is how rank function works. Right? It will assign same rank to the people which have same salary, or the whatever column is there in the order by, if the value is same, then those two rows will get same value of the rank as well. Okay, so this is my rank. There is another function called dense rank. So let's do that. So I will say dense rank and let's call it dense rn. Okay, so if I execute this, this is also very similar. The only difference is, if you see, the first guy has got rank 1, similar to the rank, right? Second and third has got 2 2. Again, people with same salary, right? Or the column which is in order by, if they have the same value, they will get the same rank. So both of them got 2 2, right? Now next person is not getting 4. In dense rank you will get 3, right? The meaning of the word dense is compact, right? So you are compacting rank, there is no gap, right? When you compact, there is no gap. So after 2 you will get 3, right? This is how dense rank will give you the output. You will have 2 2 and then 3 immediately. And then again this person has also got 3 because they have the same salary. So both will get 3 3 and then again 4. There is no gap, right? So we have rank till 8. Here we had rank till 10. Here we have till 8 because it is a dense rank. It is compacted rank, right? So there is no gap. Otherwise both functions work similar. Now you have third function which is called row number, right? So if I say row underscore number and let's call it row num rn, right? Now if I execute it, you will see there are no duplicates here, right? It will not assign the same value, never. It will always give you the unique value. So 15,000 has got rank 1, 12,000 has got 3 and 12,000 again has got 3 now. 1 2 3, there is no 2 2, there is no 4 4, something like that, right? So it will always give you unique values. Now you will ask me, Ankit, why this guy has got 2 and why this guy has got 3? Both have the same salary, right? On what basis database is saying this is 2 and this is 3? Why not Agam 2 and Mudit 3, right? How it is differentiating? So you can understand like this. What database will do, it will see the physical location. So physically, if the mudit is stored first in the database, it will give mudit rank, right? Because the salary is same, so it cannot differentiate based on salary. So what it will do, it will just randomly, based on physical location, it will assign a rank 2 or 3. So it will be a random, that mudit is getting 2 and agam is getting 3. It is a random kind of thing. You cannot guarantee who will get what, right? So this is how it works. There are no duplicates, right? There are no duplicates from 1, 2, 3, 4. Even there, if you see 10,000, 10,000, we have 4 and 5. So this is how it works, right? Now let's go a little bit more deeper. Now what I want to do, this is fine. That salary is same, so I'm assigning the same rank in case of rank and dense rank. In case of row number also, there is no guarantee who will get it. But what I want to do, I want to do some guaranteed thing, right? I want to make sure that if salary is same, I want to give preference based on some other column. So for example, maybe based on age. So what I want to do, if the salary is same, then based on age, it assigns the higher rank. So if the age is more, then that person should get the higher rank, right? So in that case, we can give one more column and I will say employee age descending, right? So if you see now, let me copy paste it on all three function, and now if you see, all three functions are giving you same thing. Why? Because there are no duplicates now. Now the order by is not only on salary, it is on the combination of salary and employee age. So on the combination of salary and age, there are no duplicates, right? If you see, 12,000 and 55 is different from 12,000 and 40, right? And both are descending, right? So 55 has got rank 2 and this guy has got rank 3. There are no duplicates, right? When there are no duplicates on your order by columns, right? On your order by columns or column, there are no duplicates, then rank, dance rank, row number will always give the same output. There will not be any difference. And if you want to break the tie, you can give second column. If you think that employee age can also be a tie, so for example 12,055, this guy also 12,055, you can give one more column, right? Then it will break the tie based on that, right? So remember, this is the important thing. If there are no duplicates on the order by columns, then rank, dance rank and row number will always give you the same values. There will not be any difference, right? I want to show it to you with the one column as well. So if you see in this table, employee ID is not repeating, there are no duplicates. So what I will do, let me remove this and I will assign rank based on employee ID, right? Based on employee ID. So let me do emp ID and let me just copy paste it. emp ID, emp ID. Now the person with the highest employee ID will get rank 1. You see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Again, if you see, rank, dance rank, row number all are same because there are no duplicates on employee ID, right? So when you are checking that on what basis rank will be assigned, it will be based on order by, and if you have two columns, it will be the combination of two columns. You can even do employee employee age ascending, right? In that case, what will happen in case of tie, the younger employee will get higher rank, right? So if you see now, in case of tie, Agam, which is 14 year of age, has got rank 1 second. So this is okay, I need to remove this as well. Okay, so if I just run this, yeah. So if you see now, in case of tie, right, younger employee is Agam and he has get rank 2, right? When I did descending, in that case Mudit had got 2. In case of tie, the the younger employee is getting preference here. Okay, hope it makes sense, right? So this is all fine, this is all fine. But what I want to do now, so this I understand that on whole table how to apply rank, right? But what if I want to find rank department wise? So for example, I want to see rank within department ID 100, who is the highest salaried employed, second highest, third highest, fourth highest. Now, when I come to 200 department, I want to reevaluate the rank from 1, right? I don't want full company rank, right? This is on full company, all the employees, all the department. I want department wise. So whenever this kind of keyword will come, department wise, category wise, it means you want to partition the data based on that column and then drive the rank. So what I will do, I will just add here partition by department ID. Okay, so let me just copy paste it. Okay, now let me just remove it for the simplicity. It will work same, right? Within each partition, it will do a order by and do. So for example, department ID 100, within this, it is checking that order by, let me remove this 1 second. Okay, so if you see within department ID 100, this guy has the highest salary, he has got rank 1. then these two have got 2 2, right? Because we have the duplicate now, we are doing only on salary. We can again add age here to break the tie. But if you see 2 2 and then 4, now if you see for 200 department, it is this starting again from 1 1 1, right? Because these guys have same salary, then 3 and then 4. Here it is dense rank, right? Starting with 1 1 and then 2, right? It is compact, dense, no gap. So 1 1 2 3, right? And we know in case of row number, it will be a running number. There won't be any duplicates. So 1 2 3 4, right? So when you do partition by, it means for each for each unique values of this column, we will reevaluate the rank from first. So department ID 100 will have its own set of ranks from 1 till how many ever employees are there. For 200 we will have a separate set of ranks starting from again 1 and again for 300, right? Now let's go a little bit more further, right? Now whatever I explained you applies on partition by as well. For example, if you want to add one more column to break the tie and everything. But what if you want to check within each department, within each manager, right? So what I want to do, I want to see within each department and rank within each manager, right? So for example, if department ID 100, manager ID is 5, let's say there are 5 employees. So I want to partition data based on the combination of department ID and manager ID. So I can add manager ID in the department in the partition by as well. So I will say manager ID, right? And now it means the partition will be based on two columns. So I will show you the output, then it will be clear. Okay, so if you see now the combination, the partition will be created based on department ID and manager ID. So if you see for 102, there is only one combination. So this is in this partition, we have only one row now. Earlier, there were 4 rows in the partition of 100. But now the partition is based on department ID and manager ID. So there is no other record of 102. So this guy will get rank 1. Right? That's it. This partition is over. Next partition is 104. Now in this we have 2 rows, right? This partition has 2 rows. So we will get 1, but the salary is same. So 1 1. In dense rank also 1 1. But in the row number you see we are getting 1 2 because row number gives the unique values. Now little bit go further, 105. There is only one row, right? So we have got rank 1. Now look at these 3 rows, right? These 3 rows has 202, right? 202. So these in this partition we have 3 rows now, right? So we have got 12,000 as rank 1, then 2, then 3. So there are no duplicates based on salary in this department. So if you see, all 3 things are same: rank, dense rank, and row number. Right? I hope this is clear. Again for 206, there is only one row for 206. So we have 1. If you look at 306, there are 2. Right? There are 2 rows. So 1 2 1 2 1 2. Okay. I hope this makes sense. Now the very common interview question is, I want, the question says, it can be variation of many of things. It will say, give me top one employee in each department, right? Or give me highest salaried employee in each department, right? In each department I want to know which employee has highest salary, right? So what I will do, I'll just use this, right? I'll use this, and I will create a CT or subquery, anything is fine, with CT as this, right? And select star from CT. So now I have done partition on department ID. Let me remove manager ID, not required, because it is asking in each department. So I have to drive rank department wise, right? So if I just run this, I have got rank department wise, right? So if I just little go further, okay. So if you see, within 100, I have rank 1, 2, 3, 4, right? Whatever. Again 200, I have 1, 1. Again 300. So I can say, give me all the data where rn equal to 1, right? So if I do that and run that query, I will get, I have got 4 employees. Why? Because in department ID 200, right, there are two employees with same salary and this is the highest salary. So both got rank 1. Dance rank also 1, but row number is different. So if you want only one record, you can use row number filter. If I use this filter, we will get only one record from each of the department, right? We have got one employee from each of the department, right? Now now one more important thing here, right? That what you want to do, you want two employees or one employee, right? So it depends on your functionality. You have to ask business that in case of a tie what we should do. Most probably they will say that if there is a tie, then use another column, right, to break the tie. So in that case we will use employee age as well, right? The moment I use employee age, there won't be any duplicates, and then I can just use rank as well, anything is fine, right? Because if there are no duplicates, rank, row number, dance rank will give you same value, right? So this is more a question to business, that in case of tie how it should behave. You cannot decide, right? You don't know what business wants in case of tie, right? So go back, ask your business that we have some duplicates on which we want to derive rank, what we should do, and you will get the answer, and accordingly you break the tie. Or if they want that, okay, randomly take one, then you use row number. Or if they say that then take all the employees in case of a tie, right, then you drive rank and just filter the employees, right? There are other questions like in each department top two employees, you can say less than equal to 2, right? So it will give you top 2, right? So if I just use this, it will give you top 2, isn't it, right? So within each department we are getting top 2, right? 200, 300, right? So this is how you should go about it. I hope it helps. Thanks for watching till here, and do like the video and comment your thoughts and share with your friends.
So we will understand why we need self join in what situations, and then we will solve a question. This question is very much as in interview questions. So basically, the question is find the employees whose salary is more than their manager's salary. Okay. So let's understand why we need self join first. Then we will jump on to the question. Okay. So let's say this is an employee table. In this table, you have employee ID, employee name, salary, manager ID, right? So you have, let's say, Ankit and his manager ID. Now this manager ID is basically pointing to the this column of the same table. So manager ID 4 is this, right? So this is basically in these kind of situation we do use self join, where one column is referring to the other column of the same table. So in this case for Rohit, so basically Rohit is the manager of Ankit. So if we can join this table with this table itself, so if we can join this column with this column, then we can get the manager details, right, for each employee. So for example, for Mohit, manager ID is 5. So 5 is Mudit. So Mudit is his manager. So we can get the Mudit's detail. So let's see how we can do it. So in cell join, what we do it, we create two instances of same table, right? Let's say you have another instance of this table here. Okay, and then what we will do, we will join these two tables, and we will join on which column? So from this table, let's say this is employee table, right? And this is manager table. Same table, but we are just giving aliases, different aliases. So I will join manager ID of employee table with employee ID of manager table. So this will be joined to this, right? Sorry, this will be joined to this. So if I join this and this, manager ID to employee ID, this information I can get, right here. Similarly, for employee ID 2, manager ID is 5. If I join, I will get from here and will get here. So once I get this information, let's say for employee 2, this is Mohit. I will get for all these three, it is same, right? So if I get this information, then I can compare, okay, employee salary, is it greater than manager's salary or is it less? I mean, once I have this information in same row, I can get the results, right? Let's jump on to the SQL and then we will see how we can do it. Okay, I will just select star from EMP. Okay, so this is my table basically, whatever we saw, right? So now what I will do, I will create, not create, I will just use this table twice in my table and then join manager ID with employee ID. So let's say first table is employee E. I'm aliasing it as E because this is my employee table. Then I will inner join this with EMP itself and will name it as M. So the employee table's manager ID I need to join with here. Employees tables manager ID I need to join with managers tables employee ID, right? So I will say E dot manager ID equal to M dot EMP ID, right? So I just joined this table with itself, right? So now let's take some data here. So from employee table, I will take employee underscore ID, comma employee E dot employee underscore name. Okay, and let's take from managers table some data m dot emp name. So this will be basically manager name because this is coming from manager table. Let's run this. Uh, there is some error on. Okay, so if you see for employee ID Ankit, I have manager name Rohit, right? For employee Ankit, manager ID is 4, which is Rohit, right? Similarly, I can get more details. So I can say uh, E dot salary, right? This will be employee salary, comma M dot salary. This will be manager salary, right? I'll just run this again. If you see, I got this is directly Ankit's salary and this is manager's salary, right? Okay, okay. So I got the employee salary and manager salary. E dot salary is employee salary, M dot salary is manager salary. So you can have multiple questions on this kind of cell join concept. So they can say just give me the manager's name for each employee, right? From employee table. In employee table, we have manager ID we saw, and we can just join it and get the manager name. Similarly, the other most frequently asked question is get me the employees where salary is greater than manager salary. So this we got all the information. We just have to put where P dot salary is greater than manager salary. So where employee salary greater than manager salary. That's it. And once I do that, I got three records. So for these three, if you see employee salary 10,000 is greater than manager salary, Rohit salary. Again, for Mohit, salary is greater than manager salary. Again, for Vikas, salary is greater than manager salary. So this is how you can solve these kind of self-join questions. There can be many questions, but if you understand this, you understand this concept, and if you can visualize in your mind, and today if you can practice once or twice this kind of question or similar question, you can just after watching this video you can try yourself without looking into the video. If you solve this, you don't have to you don't have to understand this concept again. It will be in your mind, and you can solve all the question on cell join. We are going to learn how to convert rows into columns and vice versa, basically columns to rows. Okay, so this is basically we call it a pivoting and unpivoting as well. But there, see in SQL Server there are pivoting and unpivoting functions, but we will not be using it because they are not standard functions. Like they will be there in some databases and not in some databases, and also there is some syntax which you have to remember. So we are not going to discuss those functions, but we will see how we can do without using those functions. Okay, so let's start this video. So this is my input data set basically. So for each employee, I have the salary component and how much it is basically in the val column. So employee ID 1 has salary 10,000, bonus of 5,000, and hike percentage 10. Again, for employee ID 2, I have 3 rows for the 3 salary component. Again, for employee ID 3, I have 3 components. Okay, so this is how my input is, but it doesn't look so good, right? So your manager asks you that can you convert this data to look like this? Because if you see this, this looks better, right? For employee ID 1, you can directly say salary is this, bonus is this, hike percent is this. So how you can do that? Okay, so we will write a SQL now to convert this input into this kind of form. Okay, so let's start. So this is my table. Okay, so I will start with, so in output what I need employee ID, salary, bonus, hike percent, right? So I will take employee ID. Okay, comma. I will put case statement here. So I have to create three columns, three new columns, right? Salary, bonus, hike percent. So for each column, I will create a, I will write a statement. So case when salary component type equal to salary and val, and as I will create new column, the new column name I am giving as salary. We will see how it will look like. Okay. Similarly, I will create it for other two components. So it will be bonus. This will be hike percent. Again, I will name column as bonus, and this column name is hike percent. Okay. So I created three columns. Now if I run this, how it will look like. Okay. So we have three new columns. You see, right? So for the first row, so okay, let's see the original table and then we will compare. Then it will make more sense. Okay. So here if you see what we have done three columns, and wherever there was salary, the salary value is coming. Other two values are null because for bonus and hike percent, for bonus at hike percent, the salary is null, right? So similarly, for each row, in each row we have one value and other values are null, right? So what we have to do, if you see for each employee ID I need one row only, right? So what I will do, I will do a group. See, other two values are anyway null, so I can just sum this column, right? And it will give me salary, bonus, hike percent. Again, if I sum this based on employee ID, this will be sum, this will be sum, this will be sum. Okay. So what I will do now, I will do group by, because I need output at employee ID level. I will do group by, and I will put this in sum. So this is a very important thing, using case statement with sum. Okay, there will be lot of use cases, interview questions. So you definitely should practice case when with sum. Okay, I do this. That's it. I will get the result. I got the result. Employee ID 1, salary 10,000, bonus 5,000, hike percent 10. So this is how we can simply pivot the data. Okay. Hope this is clear. Now we will move on to unpivot. So let's say my data is like this, and why I want to make it like the original, whatever we saw in the original table, like this. So we want to do from here, go from here to here. This we call unpivoting. Okay. So what I will do, so there is a way, so this is the result of a query. I can create a table from this result. Okay. So how I can do? So I can just select this into my new table. But okay, execute. So it will, this table would have been created. So this is how you can create a table also from a select query. Okay. Now how will I unpivot it? I will use union. Simply I will say select emp underscore id comma, uh, so salary as salary component type. So my component type is salary. So I will take val as, sorry, salary as val, right? So if I run this, so you see, for all three employees, we got salary component type and val also, right? Similarly, we just have to do the same for the other two component and union it. Union all. This will be salary. Second was my bonus, and bonus will be, yeah, this is fine, and this will be bonus. Okay, and third one is hike percent. This will be hike percent as well. So if I run this, I got the required output. So if you see employee ID 1, employee ID 1, employee ID 1, we got three rows, right? If you want to see it in a particular order, let's start from here, order by employee. I'm just doing ordering. So salary bonus hike percent for the employee ID 1, hike percent bonus salary. It might not be in same order, but that doesn't matter. So I hope this is clear. So you can just simply use sum with case when to convert from rows to column, and reverses column to rows, that you can use using union all. So I hope this is clear. This is very important concept, especially the first one. This you will be using multiple times in your job, or many questions will be asked in interview also based on this case case when with sum. This is very important. So I would say that please practice this, and do let me know if you have any doubt. I'm happy to clear. In today's video, we will talk about the difference between where and having clause. So in SQL, if you see fundamentally, there are two ways to filter data, either using where clause or having clause, right? These are the only two ways to filter the data. And I see a lot of people getting confused when to use where and when to use having clause. So in this video, I will make it clear that when you should use where and when you should use having clause to filter the data. Okay. So let's take this example. We have an employee table, and it has 8 records, 8 employees. 4 employees belong to one department, department ID 100, and another 4 employees, department ID 200, and their salaries we have. Now, let's say someone is asking you that give me the employees whose salary is greater than 10,000. So, here I will put where salary is greater than 10,000. Okay. So, when you use where clause, it will go to each row individually and check if this condition is qualifying. So when I say salary greater than 10,000, it will go to first row and see if it is greater than 10,000. No. So this record will not come in the output. Similarly, it will go to the second record, third record. So where clause will be applied filter on row by row. It will go to each row and apply the filter. That's it. It will not look at the another row. When it is checking this row, it won't check any other row. It will just check if its salary is greater than 10,000, then it will give. So if I run this, it will give me only the employees where salary is greater than 10,000. It is, again I'm saying, it is running this filter on individual rows. That's it. Nothing more than that. Now, let's say someone is asking you that give me those departments whose average salary is greater than 10,000, right? So this department, if I take average of these four, is it more than 10,000? Then give me the department ID. Again, if I take average of these four, is it more than 10,000? Then yes, give me the department ID. So in this case, if you want to apply filter, you cannot apply on individual rows, because by looking at this row only, I can't say the average of department ID 100 is greater than 10,000 or not. I will have to look at the all the department IDs, right? And that's where I will have to do the aggregation. And whenever I have to apply filter on aggregated value, I have to use having clause. So let's go there now. Select department ID, and then I will take average of salary from EMP by department ID. Okay, so here if I just run this, it will give me the average of each department. That for department ID 100, average is 10,000, and for 200 it is 9,500, right? Now I need to apply filter on this aggregated value. So I will say having average of salary greater than, let's say I want to find out greater than 9,500, right? So this record will qualify and this will not qualify, right? So here it is, right? So whenever, so I think it is clear now. Whenever you have to apply filter on any aggregated value, use having. If you have to apply filter on individual row, you want to check individually each row, then it is where clause. Now there can be instances where you have to apply both the filters, right? We will see that also. So always remember the where filter will be applied first and then having filter. Okay. So let's say this is what. So they are saying that first find out all the employees whose salary is greater than 10,000 and then see what is the average department ID and give me those departments whose average salary is more than 10,000. Okay. So something like this. Select where salary is greater than 10,000. Okay. So what it will do, it will first, we are first filtering on this. Then I'm saying give me department ID. On top of this will run average salary employee same group by department ID. Okay, so when I'm doing this, having average of salary greater than 10,000. Okay, we will run this later. Let's run this first. So what it will do, I, I will put this condition later. Let's see what are the values. So it will first applying 10,000 greater than 10,000. So where filter is applied. Now on top of it, I am getting the average salary. So average salary of this is 15,000 now and this is 12,000 now. So I will just say give me greater than 12,000 for now. And now it will give me only the department ID 100. So hope it is clear. Points to remember, again I will repeat that where clause is applied to each individual row and having filter is applied to aggregated values. If you have both, then where filter will be applied first and then having filter will be applied first. Always remember, if you can filter data in where, you have to filter in where, don't filter in having. Okay, hope it is clear. Do like the video, please. I see a lot of people are not liking videos. If you don't like, that is fine, but if you it is adding value, then please do like the video and click on the subscribe button.
So this is going to be today's agenda. We are going to discuss top 5 advanced SQL interview questions and their solutions. These are very commonly asked questions. But we all know these are the questions people will ask, but the problem is they will ask follow-up questions. There will be a variations of a question based on the granularity of data. So we will make sure we discuss all of those scenarios so that you don't miss anything. These type of questions are suitable for if you are 3+ years of experience, right? You will be asked these advanced questions and the variations of it. If you're less than 3 years, then also you can watch this video. You will learn something new things. Okay, so you can take notes when I'm discussing the question so that you can refer it later. But basically this video will going to open a lot of interview opportunities for you. Okay, So let's start with our first question. This is a very famous and very common question, but we will see how we can see how interviewer can confuse you. Okay, so the question number one is top three products by sale, top three employees by salary within category department. So this is a very common question where interviewer will ask you the top, give me top three products by sales or the top three employees by salary, and then they can also ask that within each category which are the top three products, within each department which are the top three employees. Now the answer of this depends on the table granularity, right? So let's see. Let's assume we have an employee table. Okay, we will solve it using two tables which have different granularity. Let's solve it using employee table first. So this is my employee table. Now in this table, I want top to highest salaried employee. Okay, so my question is top to highest salaried employee. When someone asking you top to highest salaried employee, right? Then in that case we don't have to use any rank or row number as such, right? So what we can do, we can just say select top to star from employee, because this is on full table, right? Order by salary descending. So what I am doing, I am saying sort the employee salary in the descending order. So if I run this without top two, these are the highest salaried employed, right? Mohit and Ankit. So if I say top two, right, I can just get top to highest salaried employees, because top two will run after the order by. In some databases you have limit two, but it is same thing. Limit two or top two is the same thing, right? So if I do this, I will get highest salaried employee, right? But the challenge here is when they ask that in each department we want, right? So if I do order by department id and salary, right, now in each department, highest salaried employed. So if you see in department ID 100, these two are highest salaried employed. In department ID 200, these two are highest salaried employed, and so on and so forth, right? Now for this kind of question, you can't solve directly using top two and order by, right? You will have to use rank and row number function. So you will say select star from employees, okay, and I will say row number over partition by DPT ID, order by salary, right? As Anand. So what I'm saying, within each partition, within each department ID, create a row number of salaries, right? So if we do this, you will see for department ID 100, there is a row number 1234, right? Now order by, I have done salary, which is by default ascending order. So I have to do in descending order, so that the highest salaried employee will get 1 and then 2 and so on. So the highest salaried got 1 and then 2, then 3, then 4. Now this is a new guy, right? New department. So again it is starting from 1, right? Now I'm using row number because if you see the salary is same, right? So it is 1 and 2, I'm getting the different values. Now if the interviewer asks you, right, that what you should do in that case, so you should ask a question that what we should do if there is a tie. In case of tie, you want to consider them as different ranks, or you want to consider them as same rank and you want one more employee. Depending on that, you will have your answer. So for example, if I say dance rank, right? In case of dance rank, what will happen? Let me show you as dance. So if you see, these are getting 1, 2, 3, 4. This is fine. But here we have 1, 1 because they have the same salary, and this guy is 2, right? But here it is 3. So if I say select star from this, this is a subquery alias I'm giving where Rn less than equal to 2. So I will get top 2 employees by salary in each department using this, right? So if you see for department ID 100, I am getting 2 employees. For 200, I am getting 2 employees. These department have 1 employee only in actual table as well. So they are getting 1 1 1. But if I use dance rank, right? In 10th rank, what will happen? I will get 3 employees from department 200 because there is a tie and 10th rank is giving 1 and next employee 2, right? My bad. I have to run just this one. Yeah. Okay, so if you see for department ID 200, I am getting 3 employees because the dance rank is 1 and next one is 2. So now you this there is no right answer for this. You have to ask the interviewer what they want. Okay, this is one thing. But the next challenge is, so in this table, if you see, there is a single record for each employee, right? The granularity is employee ID only. So also we want the top employees. Now let's say we have some data kind of orders table, right, where we have orders data. So if you see, we have a lot of data and we have a orders data as well. So you see, we have the product ID, right, and we have the sales, right? So let me take only the columns which I'm interested in. So let's say order ID, and we have, let's say, product ID, and then we have category, and we have sales, right? We are interested in these columns for now, so why to confuse you guys? So let me run this. Okay, so we have this data, right? We have different orders, product ID, category, sales. Now here they will ask, give me top 5 products by sales overall, right? Now here, if you write this query, that will be wrong. So if you write this from orders, order by sales, descending, top 5, this will be wrong. This will be wrong because one product have multiple rows here. For this product, so for example, let me do one thing: order by product ID sales, right? Let me remove top 5. Now the problem here is, if you see, for one product there are multiple rows because one product can be bought in different order IDs. So if someone is asking top 5 products by sale, I cannot do this top 5 order by sales descending, because we will have to first aggregate sales of each product, right? Each product had different rows. If I directly say select top 5 products from orders order by sales, it is checking at order level, not at product level, right? So what I have to do, I have to aggregate data at the product level first. So I will have to change the query little bit. So I will say with CTEs, let me create a CTE, select from orders, right, group by product ID, right? Because I want at product level sales, right? Then only I can rank them. Product ID, sum of sales as sales, right? If I run this, you will see for each product I will have one row now. There will not be any duplicates, right? There are total 1862 rows. For each product I am getting it. Now I can run the same query here. So I will say from CT top 5 product ID, right? Order ID is not required, category is not required, and sales is sales, order by sales descending, right? So this will give me top 5 products by sales, right? So this is fine. Now the next question is, I want within each category top 5 products by sale. Now again, it is a variation of department ID, right? So we need at category level as well. So category product ID, category product ID. So I will get category also for each product, right? Now what can I do? I will say within each category give me top 5 products, right? Now things are simple. I'll just say select star. Again, I have to use rank or row number, whatever you need to do as per the requirement, over partition by category, order by sales descending, right, as RN. Okay, from CT, and this is not required. And if I run this, I will get, for each category I will get ranking. So for example, for furniture, starting from 1, this guy has the highest sales, right? Again, if I go down for office supplies, again it will start from 1, you see, right? So 1, 2, 3, 4, 5. These are the top 5 products in office supplies. And similarly for the last category, technology. So again, I will say select star from, and let's create a subquery, or you can create another CT where Rn less than equal to 5. So I will get top 5 products within each category, right? So we have got 15 rows. So this is in the furniture, this is in office supplies, and this is in technology. Okay, so you have to very much clear about the granularity. What is the granularity of the table? What is the question asked? The keywords are, for example, here they are asking that within each department, what are the highest salaried employees? So if you have an employee table, there won't be any duplicate for employee IDs. So you don't have to do any aggregation. You can directly use top five, or if you want to do row number, you can do, right? When they are saying within each department, that keyword says that you have to do partition by department ID. Here in the orders table, if they are asking the top 5 products, so in orders table you can have multiple rows for each product, but in employee ID there was only one row for each employee ID. But here you can have multiple rows, so you have to first aggregate it at product ID level, sum of sales, then you can do top 5. Again, the keyword is within each category, so you have to get the category as well when you are doing the aggregation, and in the partition by you have to use the category again row number, rank, dance rank. There will be follow up questions, so you have to understand what they are saying, and accordingly you have to use row number, rank, or dance rank. Okay, so this is the first question, all the variations of it. It is very commonly asked question, so make sure you are clear about it. Let's move on to the second question. Okay, so second question is about year over year growth. This is also a very common question, and it checks your ability to use lead lag functions. Okay, we will see other variations. So other variations can be, we need product whose sale is more than the previous month sale, right? Whose current month product with current month sales more than previous month sales, right? So these questions will check your lead lag functions ability, right? So again we will discuss the different variations of it. So let's start. So we have the orders data. Now you know about the granularity. I'm not going into it. I will be using the orders data where we have to aggregate the data first, right? So depending on the question, you have to check what is the granularity and apply these lead lag or any window functions. Now again, we have a orders function, and we have to get the year over year growth, right? What is the year over year growth? Which means, let's say in 2020, my sale was 100. In 2021, my sale was 200. In 2022, my sale was 300. So year over year growth for first year will be 0 because there was no previous year, right? For this year, from 100 to 200, it means 100% growth, right? Again, from 200 to 300 is 50% growth, right? So this we have to get from the orders data, right? So it means clearly we want year level data, because at year level we want the growth. So what I will do, I will say select, let me copy this again here, year from order date, right, as year order, comma, sum of sales as sales from order group by again year order, right? So this is what you have to do. So I got each year's sales. Let me do order by as well, year, so that it makes sense. Okay, so for 2018 this is the sales, for 2019 this is the sales, for 20 this is the sales, for 21 this is the sales. Okay, so I got year wise sales. Now here granularity is year, you have to understand it, what is the granularity. Now I want year over year growth, so let's call it as a CT. You can create a subquery as well, which is fine, and we don't need a order by here, right? So if I just run this, so now I will say select star from CT, right? Now I will use a lag function. Lag function will give me the previous year sales. The moment I get previous year sales, I can do a comparison, right? So I will say lag of what? Sales, right? Lag of how much? One, right? Over, now here I don't have to give any partition by, because on the, this is the full table now. The CT is a full table. On full table, I want to see the previous value, right? There is no categorization or partition by we want to do. I'll show you a variation with partition by, but for now, I just have to say order by year order, right? I'll just show you what it will do. As previous year sales, right? So if I just run this, you see for first year, there is no previous year sales. So we are getting null. For 2019, I'm saying lag of 1, which means previous row. Lag of 2, I will say then it is previous to previous. So it will give me previous row which is coming here. Again for 2020, previous row is this, which is coming here. Again for this, previous row is this, so this is coming here. Right? Now this is null value. So what we will do, in the lag, we can give a third argument. So I will take sales only. In case of a null, when previous year sales is not there, give me sales only, so that growth I can show as 0, right? If you see, this is coming as sales only. Okay, so this is fine. Now what I have to do, let's call it as with CT2 as, this is my CT2, and now I have to calculate the year over year growth. So I will say select order year, sorry, I have to say comma, with year order. Okay, year order from CT2, right? And now I have to say that the year over year growth will be sales minus previous year sales, right? Divided by previous year sales. So this is how you have to calculate. Current year sales minus previous year sales divided by previous year sales into 100. Into 100 to get into the percentage term as YOY. Okay, so let me do a star actually so that we can see everything. Okay, so if I run this now, you see I'm getting 0% because first year nothing is there. For second year, if you see, the sales have been decreasing. Previous year sale is 40, around 4,84,000, and this year 2019 is 470. So there is a decrement of 2%. Then from 470 to almost 600,000, this is again 30% increase, and this is again 20% increase. So this is how you can do a year over year growth. Now the question can be that I want year growth within each category, right? This is plain on whole table, on whole sales. I want to see for company what is the year over year sales. But now I want to see within each category what is year over year sales, which means I need category also. I need the data at category plus year. So I will add category here, right? And in the group by also I will add category, right? So I will get, so if I just run this order by category, so I'm going to run this and you will see now I'm getting within each category what is the sales, not just overall, right? So for furniture, this is the sales of different years. For office supplies, sales for different years. For technology, sales for different years. Now I got this. Once I get this, what I have to do, I have to do lag partition by category. I'll just show you again how it will help me. Okay, partition by category, and let me do select star from CT2 just to explain. Okay, so if I run this, so now if you see for 2018, this is the first year. So we are taking sales only, right? Now here if you see, this is the sales for 2019 and previous year sales is this, right? Now if you go to office supplies, it is again starting. It is not taking the previous row's sales, right? 2021 furniture sales. No, because I am doing a partition by. If I don't do a partition by, what it will do, it will take the previous row's sales, which will be wrong. So you have to make sure you do a partition by so that each category is separately calculated. Okay, so once we do it, we have the previous year's sales for each category, and then the same formula will work. We don't have to worry about anything else. It will absolutely work. So if you see, this is 0 for the first year, and then this is the growth in furniture category year over year. For 2019, this is the growth. 2021 similarly for office supplies, for first year 0, then this is the growth in different year, and then in technology. Okay, so the main thing in these kind of question is you have to understand the granularity, right? There was one more variation I was telling you, that we have to get products, right, with current month sales more than previous month sales. So what we have to do, we have to get the data at product ID and month year level, right? Once we get it, then we will get sales, right? So for example, here we are getting previous year sale, there we will get at month level previous month sale, and then we can compare. If sales is greater than previous month sale, then those are the products, right? So I think you can do it, you can try it out, but the funda is same, that granularity will be product ID and month year. Here the granularity is category and year, that is the only difference. And you have to put a where condition where sales is greater than previous year sales, so we will get all the combination of product and month for which the sales is more than previous year sales. So you will do partition by product ID and order by month year. Okay, I hope you will be able to solve it. Okay, so this is the second question, very commonly asked question, again both of them. Let's move on to the third question. The third question is little more advanced, where we have to get running or cumulative sum or rolling n month sales, right? This is again very useful matrix. So the question is, select star from orders, right? Let me again query this. Now what I want, let me take only those four columns, we don't need everything else. So okay, I don't think we have that query. Let me write it. Order ID, order date, and product ID and sales, and we will see if we need anything else. But what we essentially need is, we want cumulative sales month wise. Okay, which means, or let's say year wise for simplicity, month wise also you can do. Which means, for example, if my sales for 2020 is 100, for 2021 is 200, right? For 2022 is 300, and 2023 it is 400. I want a cumulative sum. Cumulative means all the previous year sales plus this sales. So for the 2020 cumulative will be 100, right? For 2021 this year plus previous year, so it will be 300. Okay. Now for 2022 it will be this year and all previous year, which will be 300 plus 300, 600. All this if you add up will be 600, right? Now for 2023 if you add up everything till here it will be 1000. So this is your cumulative sum, right, year wise. So how we will do it? Again, we will first aggregate data at year level, right? That's what we have been doing. So let me copy this, and I'm saying that give me data at year level, right? And sum of sales. So this will give me for each year what is the sales, and then I have to find the cumulative sales. So if I run this, I got for each year, sorry, group by category is not required. Okay, so 2018, this is the sales, this is the sales. So I have to get the cumulative sales. So what I can do, I will say select from CT, right, and select star, and here we will use the cumulative function. So I will say sum of sales over. Now again here there is no need of partition by, because we need overall cumulative sales. So I will say order by year order, right? Order by year order, so that it will first pick this year and the sales of this. Now when it goes to 2019 it will sum all previous sales. When 2020 all previous sales. So if I just run this as cumulative sales, okay, or running sales, you can call it anything. So now if you see, order by year order, okay, this is not required. So you cannot use a order by in the subquery. That's what the error is. Okay. So you see this is my first year sales, because I have done order by year order. So ascending order. So this is the first year by ascending order. So this is the sales. This is a 44 lakh 84 plus 4 lakh 70, around 9 lakh 54,000, right? Then in this it is adding all these three, and this is the final result. And then in the last it is adding all those four, and this is the final result. Right? Now there can be one issue. If the sales for two of the years is same, right, so cumulative sales same shows the same result using this. So for example, if it would have been same both, let's say it would have been like this, 100, then it will show you, ideally it should show 100 here, 200 here, right, but it will show 200, 200. This is how it works because it is a duplicate, right? So what you have to do, actually it is not like that. It is based on order by column. So your order by is year order, so that will never happen, my bad. That's a different case. In this case it is fine, so your year will be always different. So if there is a tie in the order by, so for example if there are 2 years same, 2018, 2018, then you will see the same cumulative sum, but you can forget about it for now, right? Now, this is absolutely fine that you want order by year order, order cumulative sales, right? Now what we are saying again category wise cumulative sum, right? So again I have to say category, same thing I have to do, group by category, right? And then again here partition by category. Okay, forget about that duplicate thing. Okay, don't get confused. So if you see for furniture category, I am getting the cumulative sum, right? This is the value, then this plus this I am getting here, then this plus this plus this, then this plus this plus this. Similarly for office supplies, it is starting again because I have done partition by. So this is cumulative sum partition by. Okay. Now they can uh, for example cumulative sum of last 4 months or 5 months, right? Which means I need the months data as well. So let me get month as well here. So let me remove category. I'll see if we want to include category later. But what I want cumulative rolling sum, not cumulative. I want rolling 3 months sales. Which means if let's say this is my January, February, March, April, May, right? Now rolling 3 months sales, let's say this is my actual sales, right? So rolling 3 months sales will be for first month, there is no previous 2 months. So previous 2 months plus current month. So this is previous 2 months plus current month. This is what I have to do, right? So there are no previous 2 months, so only current month. So this will be this. Now for Feb, previous 2 months are not there. They only previous 1 month. So previous 1 month plus current month will be 300. So far it looks like cumulative sum, but it is not. So again for this previous 2 months sale is 300 plus 300, 600. Till here it has worked like a cumulative sum. But here for April, previous 2 months is only this much, not January. So here it is a different result. So 500 plus 400 will be 900. Right? When I go to May, previous 2 months will be 300, 400, which is 700 plus 500, 1200. Right? So this is my rolling 3 months sales. Right? So for that, I have to get the data at month level. So I'll say month also I will get it here. Right? So if I just run this, I will say give me month of order date as month order date. Okay, and if I just take this, I have to put it in the group by as well. Okay, and I will get year wise, month wise sales, right? So for example, I just show you here. So if you see here for 2018 first month sales is this, and so on till 12. Then 2019 first month sale, and so on till each month. For there are 4 years, we are getting 48 months of data, right? Now what we have to do, we have to go rolling 3 months sales. So for I have to say sum of sales ordered by year order as well as month order date, right? Comma month order date, right? In the increasing order, both are increasing order, right? This is the new syntax, rows between two preceding and current row. So I'm saying give me the sum of sales of previous two rows and current row, all three rows sales, right? If I run this, okay, again order by clause is wrong. So let's go back. So if you see, this is my first month sales, so this is same. This is sum of these two. This is sum of these three. Now look at the fourth month. For fourth month, if you see, the sales is sum of these three. So if you see, this is 28,000, 55,000, and 4,000. So this will be 88,000 around. So this is not included here. Again here, this will be the sum of these three. Current month and previous 2 months, right? 55,000, 28,000, 23,000, around 1 lakh 7,000, right? So this is how you have to get rolling sum. If it is 3 months rolling, 4 months rolling, 5 months rolling, accordingly you have to use the two preceding and current row. Sometimes they will say that they don't want to consider the current month. They want previous 3 months sales in the rolling 3 month, because the current month sale might not be full in actual, right? So you will say, for example, 3 months rolling, you will say between three preceding and one preceding, because you don't want to consider the current month, right? So three preceding and one preceding, right? So if I run this, I will get previous 3 months sale, not including the current one. So example, this one, if you see, this will be the sum of these three, right? It was coming against this row earlier, now it is coming here, because we are not considering this row, we are considering the previous three rows. So three preceding is this, one preceding is this, and everything between these, right? So this is another variation. Okay, so I hope you understand it. Again, you have to first aggregate data if required. If we have a table like employee ID, we don't have to aggregate first. So if the granularity is the same on which the question is asked, so here we are asking question on sales. So sales is not, we there are multiple orders in each order and month. So we have to aggregate first, and then we can have 3 months rolling sum or whatever, right? So this is the third one, running sum, cumulative sum. Now comes the fourth one, where we have to convert rows into column, year wise, each category sales. Okay, so let me explain it. For example, I want for each year how much is the sale in different categories. So I can simply say year, order date as year order, right? Category, sum of sales, sorry, as sales, right? From orders, group by year order, category. Okay, and let's do same for order by. So the question is, this is fine. For each year, I want category wise sales, right? So for example, for 2018, what is the sales in furniture? In 2018, what is the sale in office supplies, in technology? This is how we want, which is fine. But the question is, I want to pivot it. I want different columns for each category. So for 2018, I want what is the sales in furniture, what is the sales in office supplies, what is the sales in technology. I want in a different columns, right? I don't want like this, right? So I will have year, there are four columns: year, furniture sales, office supply sales, technology sales. So this is kind of pivoting from rows to column, right? So the simplest way of doing it is, you can use case when statements, right? So you want year wise, right? So you can say year wise, group by year, category we will remove it, right? Let's remove it completely. Now here I will say, I will put a case statement, right? Let's remove it. Sum of sales, case when category category equal to furniture, then sales. Then take sales, otherwise zero. For everything else, it is zero, and as furniture sales, right? This will be my furniture sales. Similarly, we will have two more sales. So this will be for office supplies, right? And this will be my office supplies sales, right? Similarly, this is for technology. This will be my technology sales, right? So I'm creating a different columns based on case one statement. And if I run this, I will get for each order, for each year, what is the sales in different categories. Okay. So this, there can be multiple variations of it. You can put multiple conditions here in the case one. So based on the question, you have to modify your case when statement, otherwise the structure of the query will be same. Okay, so this is your fourth one. Okay, last one is very important and very commonly asked. You have the result of inner join, left join, and different join. So you have, let's say, two table, right, where we have one, in one table we have one, two, null, three, three, and we have another table, let's say, where we have two, null, one, one, four, three, right? Now if you do inner join, left join, right join, different kinds of join, how many records will be there in the output, right? So this might be very confusing. So for this particular question, I have created a separate video where I have explained it in detail, in full detail, that you can easily understand it. So I'll put that video comment in the comment section, in the pinned comment, and the description also. Do check out. Okay, so what you need to do is go to namastesql.com and then sign up. If you have not signed up, please sign up. Once you sign up, you can go to coding problems, right? There you need to apply some filters. So you can just let me go to the first page, and then you can say question type free, right, and difficulty hard. Okay, so we have five questions, you can see, right? So we will solve all of these questions one by one. So let me start with the first question, workaholic employees. It was asked in Meta. Okay, so question number 14, workaholic employees. The question is, write a query to find workaholic employees. Workaholic employees are those who satisfy at least one of the given criteria. Okay, so we have an employee table. Let's look at the data quickly. I'll move on to SQL Server and let me run this. Yeah, so we have this employee ID data, you can see, right? So we have employee ID, login time and logout time, right? This is the time when employees log in on a particular day and log out on a particular day, right? We have three employees, 100, employee ID 100, 200 and 300. So we need to find workaholic employees, and this is the criteria for workaholic employees. First is worked for more than 8 hours a day for at least 3 days in a week, right? So this is a 1 week of data, right? So we don't have to filter on a week or something. It is just 1 week of data. So if an employee has worked at least 3 days in a week for more than 8 hours, then he will be considered workaholic. Another criteria is worked for more than 10 hours a day for at least 2 days in a week, right? So there are two things. Either he worked for more than 8 hours, 3 days in a week, or he worked for more than 10 hours for at least 2 days in a week. Then he or she will be considered as workaholic employee. You are given the login logout time of the employees for a given week, right? So it is for a given week. Write a SQL to find all workaholic employee along with the criteria that they satisfy, one, two, or both. Display it in the order of increasing employee ID. Right? So a employee can fall in this category, then the flag will be 1. So we can see the expected output here. Right? So for employee ID, he is workaholic and criteria is 1. For 200, he is workaholic and criteria is 2. 2 means this criteria it is satisfying. 1 means this criteria it is satisfying. Now, one of the employee satisfy both the criteria, right? So he worked for more than 8 hours for 3 days as well as he worked for more than 10 hours for 2 days. Okay, so this is the expected output. Great. So let's see how we can solve it. So the first thing that we need to do is we need to find number of hours, right? Number of hours each day each employee has worked, right? So we will simply say give me date diff, right? I want in hours, right? I think hour or hours we need to use between login and logout, right? As hours worked, right? Let me run this. Okay, so it is getting 9 hours, right? From 9:15 to 18:20. Okay, so it is giving me the exact hours, right? So most probably we should consider minutes, right? Because we need exactly 8 hours. So this 9 hours might be wrong. So what we will say give me in minutes so that I get exact value. This is rounding off. It is not giving me exact hours. See, 9:15 to 8:20 will be 9 hours 5 minutes, right? So most probably I will do minute and then divide it by 60. Minute, I think it is. Yeah. Yeah. Now I'm getting 545 minute, and then I will do divide by 60, right? And I will also do divide by 60, and then I will get exact hours. So let me done this. Yeah. So again, I'm getting in decimal values. So most probably what I can do, I can multiply it by 100, right? So that I get, sorry, 1.0, so that I get values in decimal points. Yeah, now it is perfect. I'm getting 9.08, 7.91. So I'm getting the exact value, right? So I can say if it is greater than 8 or less than 8. Great. So what we will do, we'll say with CTEs this. So this is my CT1. We will create multiple CTs. So let me take more space now. We understand the question, right? Okay. Now I need to categorize it in three things, right? One is that employee has worked 8 hours or not. He has worked 10 hours or not on particular day. So what I will do, I will say select star from CTE, and I will create one more column and I will say case when hours worked is greater than 10. Now it is important here that first case when condition you give is greater than 10. I will tell you why. Then, right, I'll say 10 plus. Right. Okay, I'll tell you why I'm doing it. Next is when hours worked is greater than 8, then 8 plus, right? Or maybe greater than equal to I should use, right? Great. Next is else I will say 8 minus, which means less than 8 hours here worked. And as a time window, we can say time window, right? So this is fine now, right? We have three windows. So let me run this and show you. Invalid object name CT. Okay, it is CT1. Okay, so now if you see, we have the time window as well, right? So it is 8 plus, right? Because it is 8 minus, it is 8 plus, and wherever 10 is there, it is 10 plus. Now, why I'm saying that we need to have this first, because if I say 8 plus first, so if I just do this, everything will fall under 8 plus, right? So if I do this and I will just comment it, what will happen is everything, even if the 10 plus employees are there, it will go here. So I'll just show you. So now if you see, everything is 8 plus or 8 minus. Yeah, 10 plus is not there. Because anything which is more than 10 will be more than 8 as well, right? So we have to make sure we capture 10 one as well, right? Because we need it, right? So I will just go back to the previous one, right? Yeah. So that we capture when it is more than 10 and when it is more than 8, not 10. Okay, so now we have the time windows. So let's make it as CT2 as this. You should give a good name of CTs, but for now I am just using CT1, CT2. Great. So now I have the time window. So what I can do, now from this I need only those rows which are either 8 plus or 10 plus, right? I'm not interested in 8 minus. If someone had worked less than 8 hours, I don't care, because I'm interested in 8 plus hours and 10 plus hours only. So I will say select star from CT2 where time window not equal to, I can say not equal to 8 minus, right? Or I can say time window in 10 plus or 8 plus, anything is fine, right? So let me run this. Now if you see, I am getting only 8 plus and 10 plus. Great. Now next thing we have to identify is if an employee has worked 10 plus hours 2 days as well as 8 plus hours 3 days, then he will fall into both category, right? So if you look at the 300, right, if you see he worked 10 plus hours 2 days, right, so he will fall in the second category, this one, and he has also worked 8 plus hours on all 3 days, right? 8 plus hours on all 3 days. So he is both. Now you understand. Let's look at one. If you look at one, right, employee ID 100, he has worked 8 plus hours, 8 plus hours, 8 plus hours. So 3 days he has worked 8 plus hours. So he is falling in the first category where we have to check more than 8 hours for at least 3 days. So he is good for the criteria one. Now look at the employee ID 200. Here if you see he has worked 10 plus hours 2 days, but he has not worked 8 plus hours 3 days, right? Because only 2 days he has overworked and both the days it is 10 plus, which means he is falling in category 2, not in category 1, right? So we have to categorize employees in that way now. So what we will do, we will get the count for each employee. So I will say EMP ID comma count star. Now I have already filtered on 8 plus and 10 plus. So this will give me that how many days he has worked for 8 plus hours, right? So 10 plus will also be considered in 8 plus, right? Now when I'm calculating it, the 8 10 plus also should be considered in 8 plus, as I will say uh, as total 8 plus days. I don't know if it will take 8 plus, but let's say total 8 days, right? Or 8 hours days, right? Now next I will say count, right? Case when, right? Case when I have to do group by here, by the way, group by emp underscore id, right? So I'll say case when, right, time window is equal to 10 plus, right? Time window equal to 10 plus, then I will count that. So I will say 1, else 0, and, right? You can do sum here as total 10 hours day, right? So let me run this and show you quickly. Okay, so if you see for employee ID 1, total 8 hours days 3, right? And total 10 hours days 0. So perfect, right? He worked for 8 plus hours for 3 days. Now for employee ID 200, total 8 plus hours is 2 and total 10 plus hours is also 2, right? So which means he will fall in second category. 8 plus hours is not 3, right? Only 2. Okay, for 300, both are satisfying. So 8 plus hours is also greater than equal to 3 and 10 plus hours is equal to greater than equal to 2. So now we can say, I can maybe use a subquery, select from, let's call it A, right? What we need in output, employee ID. So I'll say EMP ID, right? And then I will create this column, criteria column, right? So let me take this. Header doesn't matter, you can give any header. So I'll say case when. Now I will first check if both are satisfying, right? Again, if both are satisfying, then I have to give both. So I will say case when total 8 plus hours days is greater than equal to 3 and and total 10 plus hours is greater than equal to 2, then I will say both, right? This is what we need to do. Sorry, both. Okay, so I'll just take it here, right? So I'm saying case when total 8 hours days is greater than equal to 3, right? It should be greater than equal to 3, right? And this should be greater than equal to 2, then both. Okay, then I will say when, right? Now I will say when. So if both are there, then both. Now if both are not there, then only one of them will be there. So I will say when total 8 days hours, right, is greater than equal to 3, then it will be 1, right? Now I have to give this 1 in single quotes, remember, because this is a varchar column now, because both is a varchar string. So you cannot mix one varchar, one integer in case when. The output of each when should be a string. So I have to give in single quotes. Else, else there is only one criteria left, which will be 2. and we will say and as uh, criteria. Doesn't matter, I can give anything, right? That's it. So let me run this quickly. Okay, so if you see the output, we have 1, 2 and both 100, 200, 300. By default, the output is coming in order of employee ID, but output is expected. So we will give order by emp underscore ID, right? And run this, and you will see it is matching exactly, and it is a correct answer. Okay, great. Once you submit it, you can even see your submissions here, and you can check it again. So you can go here and see here, right? Whatever you submitted. If you submit multiple times or you submit a wrong solution will also be visible here. But every time you hit on evaluation, you will see an entry here. Okay, you can check the solution here as well, and you can see the video explanation as well here. Great. You can also see the discussion. Other people have also submitted their solution, so you can check it. Great. Let's move on to the next question. You could have clicked on next, but I'm just going back and coming back. Okay, so next question is 28 malware detection. So this was asked in LinkedIn, and the question is there are multiple antivirus software which are running on the system, and you have the data of how many malware they have detected in each run, right? So you have like antivirus system, let's say they are running in your laptop, right? And for each antivirus, right, we have the data that how many malware they have detected. So for example, software ID 100, on this date it has run whatever date time we have, and these many malware it has detected. It has run again on 2 o'clock, then again 3 o'clock, and then how many malware it has detected, and so on and so forth for multiple software. So we have software ID 100, up to 105, right? This is how the data is. Okay, you need to find out how many malwares each software has detected in their latest run, and what is the difference between the number of malwares detected in latest run and the second last run for each software, right? So we need to find that how many malware each software has detected in latest run. So for example, this is the latest run for software ID 100. So it has detected 9. So we have to get 9. As well as, let me show you the expected output, right? So we have to get 9, but 100 is not there in the output. We will see why it is not there, right? But let's say 101, right? So for 101, the latest is 12. So we are saying latest run count is 12, and difference to previous. So second latest is 10. So difference to previous is 2. So we are seeing 2, right? Similarly for other. So this is what we have to get, but there are some other conditions. Because of that, 100 is not there, 104 and 5 are also not there. So we will see. Okay, please note that list only the software which has run for at least 2 times, right? So there are some software, for example 105, it has run only for 1 time, so we don't have to take this in the output, and have detected at least 10 malware in each in the latest run, right? So it should have at least 2 runs, and in the latest at least 10 malware, right? So for example here in the latest there are only 9, right, for 100, so it is not there in the output. Similarly 105 is not there because there is only one malware. Okay, I hope you got the question. So let's start. So what we will do, the first and foremost thing we have to do is we have to identify which is the latest one and second latest one for each software. So we will get the row number and identify that. So we will say row number, right? Now we need for each software separately. So I will say over partition by software ID, right? And order by run date in descending order. Why descending? Because what will happen? The latest will have the row number 1 and second latest will have row number 2. So I will know that which is first and which is second, right? As Rn. Right. So let me show you quickly. So if you see for 100, the latest one is this 16 hours, right? You look at the time, rank 1, and then this is second latest, right? 2, and this is third latest, this is 3, right? So I'm interested in first and second only. I don't care about third or whatever. So I will filter that. So I'll say, let's say with the CT1 as this and select star from CT1 where Rn greater than or equal to, sorry, less than or equal to 2, right? So I need only those two. Great. So this will do for me. So for each software, I have got latest two runs, right? Wherever there is only one, so I am getting one. Okay. Now next, what I should do for each software, what I should do is, so I will say software ID, right? And I will do group by. I'll tell you why. Once I do group by, I will say case when Rn equal to 1, then give me malware detected, right? So I'll just copy this. I'll say when Rn equal to 1, then give me malware detected and as latest run, right? And then I will drive one more column and I will say case when Rn equal to 2, then how many malware detected and as last run, right? Latest run, last but one, right? Last but one, right? So this is latest run and this is previous to latest, right? Or previous run, we can say previous run, previous run. That is better, I think. Okay. And then I will do group by on this. And so if I don't do group by, what will happen? So let me show you. Okay. So I'm just running this and maybe I will take everything just to show you how what is happening. Okay. So if you see, what is happening is I'm saying in the latest run there are 9, right? And in the previous run they are null, right? Because why it is null? Uh, because there is no previous run for this, right? So the latest is this. If you see, this is the latest. No, this is the latest. This is the latest, right? And this is the second latest. Yeah, perfect. Yeah. So if you see in the first row, I'm getting latest run is 9, previous run is null, right? Because this is the latest run. So I'm getting value only in the latest run column because I'm saying Rn equal to 1. So in the latest run, I'm getting 9. Now this is second latest run, right? So I'm getting only in the previous run, right? So what I will do, I'll do group by and take max. What max will do? It will give 9 here and 15 here. So I will get for 100, 9 I got in the latest one and 15 in the previous one, right? Because it will always be null, right? Here again, if you see, for the latest one, 12 is there, and for the second latest one, 10 is there in that row. So I'll say max, because max will ignore null values, right? So in the one row, I will get everything. So let me show you quickly. You can even use sum, doesn't matter, right? And we'll do group by software ID, right? And here also I can just take software ID now. I cannot take other columns. Great. So if you see, I am getting software ID 100 in the latest one 9, in the previous one 50, right? This is exactly fine. 101, latest one is 12, previous one is 10. And in this editor, you can even use run multiple queries. So for example, you want to see if my output is correct or not, right? So what you can do, you can maybe run this again separately, right? So you can take this and this is another query and let me run both the queries. Okay, so this is my previous query, right? So the latest one has 9 and second latest is 15. So 9 and second latest is 15, right? Again, for 101, right? For 101, latest is 10, previous is latest is 12, previous is 10, right? So this is how you can verify by running multiple queries. Okay, for now we will do with this. Okay, now we have to do two things, right? First thing is we should have at least two runs, right? So for example, for 105, there is only one run. So what I can say, when I group those, I have already put filters, right? Only give me than less than equal to 2. So I can say having count star equal to 2. So there should be two entries, right? After I put this filter, right? Or I can say rn in 1 comma 2, just to be more specific. right? So if they are both the entries, and when I do group by software IDs, there should be two entries, right? If there is one entry, it will not come in the output. So if you see, the last one is gone. So this is perfectly fine. Now the next condition is that please note that list only software which have at least two times, which have run at least two times, right? So this is fine, and have detected at least 10 malware in the latest run. So in the latest run, there should be at least 10 malware. So I can just pick this up, right? This is again an aggregated value, right? And you can put here. I'll show you the other way as well. So you can do this at least 10. So greater than equal to 10, right? So if I run this, we will get only these three. See, 101, 102, 13. Right? These are the columns we need to just calculate, but we got it, right? If you are not comfortable with having clause here, what you can do is, right, we need another CT anyway, right? Another query anyway. So what we can do, let's create comma CT2 as this, right? And you can just select star from CT2 where latest run, right? This is the number of malwares and latest run is greater than or equal to 10, right? This will also give me only those three softwares, right? Now, what I need in the output, I need software ID. So I will say software underscore ID, comma. I also need latest run count. So I will say latest run, right? And then difference to previous. So I will say latest run minus previous one. This is what we need as diff, right? So I'll just run this and this should do for us. So we have got the exactly same output, right? 101, 102, 103, 12, 13, 16, and 2 minus 1, 5. Let's evaluate it. Perfect. So this is working fine. Great. And let's move on to the next one is user session activity. Okay, so next is question number 118, user session activity. So in this, what we need to do, we are given a table of events. You are given a table user events that tracks user activity with following schema, right? So you can imagine a user is going to a website, and we are storing all the events that he's clicking or scrolling or whatever he is doing, right? So that kind of data we have. So we have user ID, event type, what kind of event it is it scroll or is it click, right? And what is the event time, at what time this thing happened, right? So what we need to do, identify user sessions, right? So our task is identify user sessions. A session is defined as a sequence of activities by a user when the time difference between the consecutive events is less than or equal to 30 minutes. If the time between two events exceed 30 minutes, it's considered the start of a new session. And for that, for each session ID, right, we need to get all of this information, right? So we will understand with the expected output what we need to do. So this is the expected output, and let me explain you how it is happening. Okay, so if you see, we have the user ID, session start time, session end time, session duration, and event count. Okay, so if you look at the user ID 1, right, he started first event on 9 o'clock on the same day. They are of the same day, but the time is different. So 9 o'clock it is started. Then next session is 10 o'clock, right? Now the next, not session, next event is 10 o'clock. So which means it is more than 30 minutes, right? So it means the first session ended here itself. If it was less than 30, we will consider these two as same session. But because this event happened after 30 minutes, which is 1 hour almost, right? So it means it is a new session. So if you see user ID session ID 1, session start time is 9 o'clock and end time is also 9 o'clock. Session duration is 0 and there is only one event in this session. Let's look at the next rows. So if you see, this next event is happening at 10 o'clock, and after that one more is there in 10:20. So this is within 30 minutes. So they are part of same session. Again, this is also happening within 30 minutes, right? Less than or equal to 30, right? X is 30, but this is within 30. So which means all these three sessions, right, all these three events are part of same session, because next, if you see, it is more than 30, 10:50 and 11:40. So it is 50 minutes, right? So which means these three are part of same session, and this is session ID 2. And if you see, it is starting at 10 o'clock and ending at 10:50. So session duration is 50 minutes and total event count is 3. 1, 2, 3. Right? Again, it is starting a new session. If you see, there is one more session now, 11:40 it is starting, right? Again, there is only one event in this, because next is starting at 12:40. So this marks the new session. So 12:40 and 12:50 will be part of same session. So if you see, session ID 3 has only one session, event count 1. But again, there are two, right? Similarly, for user ID 2, we have to do the same thing, right? I hope the question is clear. Very, very good question, right? Try out yourself, right? It is not easy to solve this question, but if you are able to solve it, you can consider yourself as SQL expert. Great. So let's break it down how we will solve it. Okay, so first I will move to MS SQL, right? So wherever I have some date functions, I prefer to use MS SQL. I'm more comfortable with MS SQL for date functions. Okay, so what we will do first, we will get the previous event value, right? So event time of current event is this, and what is the time of the previous event, right? Then only we can compare if it is more than 30 or less than 30, right? So what we will say lead or lag, we want previous, right? So we will say lag of event time. How much I want to look at previous row? So 1. If I want to look at two previous row, then I will say 2. So I'll say 1, right? Let's take some more space. I'll say over partition by, I'll do partition by user ID, right? So because for each user, I want to say it separately, and order by event time in the ascending order as prev event time. Okay, so this is previous event time I will get. So I'll just run this. Okay, so if you see, I have got the current event time 10, previous is null for the first row. For the second row, current is 10, previous is should be 9, so it is 9. Again, 10, 20, 10. So we have 10 here, right? So I hope this is clear now why we use the lag function. So now we need to get the difference between event time and previous event time, right? And also it is null. I don't like null here. So what I will put the same value of event time, because the difference will be 0, right? And that's what we also see in the output, that whenever there is a single event, we want to see it as 0. So I'll use third parameter in lag function, and I will put event time as it is, right? So if I run this now, you see I'm getting the same value 99. Similarly for 2 first row 99, right? So this I sorted. Now next, what I want difference between event time and previous event time, right? So I can create a CT and do it, or I can directly use in the date diff function. So I'll say date diff. I want difference in minute, right? Between what? Between between event time and previous event time. So first we have to see give the lower value. So I will copy this. So this is my previous event time, right? And then I have current event time as previous diff, whatever you call it. Right? So let me run this quickly. And now if you see, I'm getting 0 for first, and for second it is 60. So because it is 10 o'clock, it is 9 o'clock. So we are getting 60 minutes. Then again 20 and 10. So we are getting 20 minutes. So we have sorted this out. I think this column is not required. So I will just remove it, and I will just keep the difference between the current event and the previous event. So we have this. Great. Now what we will do with CTEs this. Let's create a CT first. And now I will create a flag. So select, I'll tell you what flag from CT, right? Let's call it a star. And here I will say case when, right? Case when prev diff, whatever we are creating, is greater than or greater than 30, right? Not equal to, greater than 30. It means it has a start of a new session, right? So whenever it is greater than 30, here it is 60. So which means a new session is starting. Then this is part of previous session. This is part of previous session. Again, this is 50, which means a new session is starting now. So I'm saying case when previous diff is greater than 30, then 1, else 0. So whenever a new session is starting, I'm creating a flag as 1, otherwise it is 0. And as session flag, right? So let me run this. So see, wherever a new session is starting, it is 1. So for first session, it will be 0 always, right? So it is 0. But whenever a new session is starting, it is 1. And then it is 0, 0, which means these three part of same session. Again 1. Again 1. So there is only one session here, right? Now here if you see 1, it is part of a new session, 1, 0, 0. So until it is 0, it will be same session, right? And this is a new user now. So again, it is starting from 0, 0. They are part of same session and then a new session is starting. Now what I will do, I'll create a group, right? So basically these three rows should part of same group so that I can group them together. So I'll do a trick here. I will say sum, right? Just focus here and I'll copy this. Sum case when previous def is greater than 30, then once else 0 over partition by user ID, obviously, right? For each user we want to do it. Order by event time. Order by event time as group ID. And I'll tell you what will happen. So when I'm saying, okay, let me run this and then I'll explain you. Okay, so now if you see what I'm saying, that sum it, right? So it will do partition by user ID and it will sum all these session flag values, right? This is the session flag derivation anyway. So first is 0, 0. Now next is 0 plus 1. So this is 1 because I have said order by event time. So it will just do a cumulative sum here. So if you see this is 0, then 0 plus 1, 1. Now, until next session starts, everything is 0, 0, right? So all of them have got 1, 1, 1. 1 plus 0, 1. 1 plus 0 plus 0 is 1. Now, the moment new session is starting, it become 2. Then again new session is starting, it has become 3 and this will be 3 until there is a 0, right? So these are part of same session now. Now again for 2, if you see, this is a new session. I mean first session itself 0, 0. So these are part of same session. See, group is same, group ID is same. So these are part of same session and this is again a new session. Now I can group data on this group ID and I can get number of session, time difference between the current session, total time, right? So let's do it. So what we will say, let's call it CTE2 as this, right? Okay. And now I will say select from CTE2 group by user ID, right? And this is also user ID, right? Also, we need to do group by on group ID as well, right? So that we get the data at user ID and group ID level. All the values with same user ID and group ID should be together, right? Great. Now what we need, let's see in the output what all we need. So maybe we can look at it here, expected output, right? So session ID we need, we'll come to it later, right? We need session start time. So session start time will be minimum of event time. This will be my session start time. When I'm doing grouping, so 1 and this 0 will be a one row and minimum will be this and maximum will also be this for the first session. For the second session, minimum will be this, right? And maximum will be this because these three rows will group together. It is for the same user ID. Okay. So I'll say minimum event time as session start, right? And maximum event time as session end. Right. Then what else we need? We need session duration. So basically difference between these two, max and min. So we will say date diff. I think we need in minutes, right? So we will say date diff between in minute between minimum event time and maximum event time as session duration. Okay, this is also done. Now the next column is event count. So this is simply count star as event count. Okay, that's it, right? So let me run this. We need one more column, which is session ID, which is a running number. This is first session, second session, third session, fourth session. So we will do it, but let's see if this is working fine or not. Okay, so if you see user ID, group ID, right? So there is only one row in this group, so we are getting it, right? Now the second is user ID 1 and 3. So let me sort it, right? Sort it by user ID and group ID so that it will be clear. Order by user ID, group ID. Perfect. Okay, so now if you see user ID 1, group ID 0, how many events are there? 1, right? Now in the second session, which is starting at 10 and ending at 10:50, there were 3 sessions we saw, right? So this is all expected. One session, 3 session, then one session, then again 2 session, then again 2 session and 1 session and session duration also, right? Now in the output, what we need? First of all, we don't need group ID, but we need to keep group ID in group by. Otherwise, our calculations will be wrong. So we can remove it from select. It is absolutely fine. But we need one more column, which will be, we will say row underscore number, right? It is just a session, a running session, right? And we will say over. Again here, it should be partition by user ID, right? Because for each user it is starting again 1 2. So partition by user ID, order by what we should do. Maybe we can do minimum of event time, right? That should be fine, right? So here we can take anything, or partition by group ID also we can do. So let's do partition by group ID. This should also work as session ID, right? And let's run this. And you see user id 111122, this is session id 123412, session start time, session end time, session duration, event count, right? I hope this should work. Perfect. I hope it makes sense. Let's move on to the next question. So next question will be project budget. Okay, so let's solve 125 project budget. So we have three tables here: employees table, right? And then we have projects table and project employees table, right? So let's read the question. You are tasked with managing project budgets at a company. Each project has a fixed budget and multiple employees work on these projects. The company's payroll is based on annual salaries and each employee works for a specific duration on a project. Okay. So let's understand three tables first. So we have a simple employee table where we have employee ID, name and salary. This is a simple straightforward table. Second is projects table. In this, we have project ID, title. What is the title of the project? Start date of the project, end date of the project, and the project budget. What is the total budget of the project? How much money we can spend on employee salary basically. That is the salary budget basically. Okay, and it has start date, end date. So we can see this project is running for 6 months or 4 months or whatever. Great. Next is for each project, which employees are working. So for project ID 1, employee ID 1. For project ID 2, if you see 3 employees are working, 2, 3, 4. For project ID 3, 4 employees are working, and so on and so forth. Great. So we understand the tables, right? Now let's understand the ask. Over budget on a project is defined when the salaries allocated on per day basis as per project duration exceed the budget of the project. Right? For example, if Ankit and Rohit both worked, combined income is 200k. So let's say there are two employees whose combined salary is 200,000 for a year. They work on a project of a budget 50k that takes half a year, right? So if the combined salary of Ankit and Rohit is 200k, and if a project is taking half a year, 6 months, so which means we are spending 100k on salaries, and the project budget is 50k, right? Then the project is over budget, given 0.5 into 200k, 100k, which is the salary we have to give to employees, is greater than project budget, right? So this is a over budget. Write a query to forecast the budget for all projects and return a label of over budget if it is a over budget and within budget otherwise. Order the result by project title. Assume that employees only work on a one project at a time, right? So if you look at the output, so let's understand with one example, right? So let's say analytics platform, right? So this is my analytics platform. Now if you look at analytics platform, it is starting on 5th of May and going till August, which means June, July, August, 3 months of project it is, right? 3 months. So let me write down, right? Okay, so it is a 3 months project and budget is 80,000, right? So we will see if it is under budget or over budget. Okay, so budget is 80,000 and it is from May till August. So June, July, August, 3 months. Perfect. Now, how much salary we will have to spend? So who all are working on project 4? So let's see. So employee ID 6 and 7 are working. So if I go back to 6 and 7, their salary is 1 lakh 5,000 and 98,000, which is around 2 lakh 3,000, right? So 2 lakh 3,000. Okay. Yeah. 2 lakh 3,000, right? Now this is 1 year salary, right? This is the 1 year salary. For 3 months, what will be the salary? Around divide by 4. Divide by 4. So it will come around 50,000 something, right? So we will have to give 50,000 salaries to complete this project, and the budget is 80,000, which means it is within budget, right? Sorry, this is within budget. Let's look at one over budget example so that it will be absolutely clear. Okay, so now let's say app development. Okay, now app development is starting from May. So May, June, sorry, Feb, March, April, May. So around 4 months of project it is around, right? Okay, the budget is 100,000. So let me write it 100,000. Okay. Now how much salary we will have to give? So let's look at the who is working on app development. So there are 3 employees working, 2, 3, 4. Employee ID 2, 3, 4. So let's look at their salary. So 1,20,000, 90,000, 1,10,000. So total 3,20,000. 3,20,000. This is the total salary of all 3 employees, right? Now they have to work for 4 months, which means this is a 1 year salary. To get the 4 months, we have to divide it by 3. And divided by 3 will be around 1 lakh something, 1 lakh 6,000. Right? 1 lakh 6,000, which is more than the budget. So budget was 1 lakh and salaries we will have to pay 1 lakh 6,000. So it is a over budget, right? So I hope question is clear. Great. Now let's move on to the solution. What we will do, we will just remove all of this, right? And run it one more time. And let's start. So what we will do first, for each project, right? For each project, we will get how much salary that we need to pay, right? Or what we will do first, we will get the total salary of all the employees, right? Total salary of all the employees, yearly salary. Then we will see for project duration how much is required. But yearly salary of all the employees we will get for each project, right? So what we will do, we will say we have to basically join all the tables, right? Because we need title as well. So we will say select star from employees, right? And then we will say E, and I can do inner join on P on. So between employees and no, I have to first join project table and the project employees, and then employees I can join it with employee table. Okay, so let me do this. So I'll say from project P, right? Inner join project employees PE on ID of the project. So P dot ID equal to PE dot project ID. Right. So now what I will get? So let me take whatever I need. P dot star comma. We will get employee ID, which will be from PE. So PE dot employee ID. So we got this information. So let me run this. Right, employee ID, we got it. Great. So employee ID was not there in this table. It was project ID, right? So we got the employee ID as well. Great. Now what we will do, we will inner join with employee table, right? So that we get the salaries also of these employee. So I will say inner join employees e on pe dot employee ID equal to e dot id, right? E dot id. And from here, what we need, we just need salary. We don't care about the employee name as such, right? So let me make it E, and we will say E dot salary. Right? So let's run. I think we have all the columns now that we need, right? So we have all the columns now. This is all we need. Perfect. So let's create a CTE so that we can simplify the query. So with this, we have all the data. So we'll say with CT, and then we will write our query on this CT. You can directly write logic here itself, but just to simplify, I'm doing it. Select star from CT. Okay. So now what we will do, we will say group by project, right? So in the output, if you see, we need title. So I'll use title here, right? So I'll say title, right? And group by title. Okay, this is the project name basically. Okay. Now we will say, okay, give me total salary. So sum of salary as total year. This is year salary, right? We have to see that what is the duration. As per that, we need to reduce number of days, right, from the salary. This is total yearly salary. Okay. What we will also do, we will also get the duration of the project, right? So we will say duration of the project will be date diff. We will get in days, date diff, right? And date diff in day between start date and end date. Now, if you see, this is repeating, right? I cannot do sum here. If I do sum here, what will happen? It will get number of days and then it will add it multiple times, right? So if the three employees are working, it will do 3 into number of days. So I don't have to do sum, I can just do max because I need just number of days. So when I group these three projects together, I will get number of days every time from each row. So I just have to give max, min, anything we can give because it will be same for all three rows, right? You can even do group by this column, but that's fine. As project duration, right? So I got project duration as well. Okay. Do we need anything else? Let's look at the output. Budget and label, right? We need budget as well. So we will say budget, right? And we can do group by budget as well because budget is again same for each project. So I can do group by. Okay. So I think that is all we need for now. So let's run this. Incorrect parameter. Okay. It is again my. Okay. This is MySQL. Okay. I will just run it as SQL server. Okay. Because this date diff function is works differently in MySQL. So I'll just use MS SQL. Yeah. Now it is fine. Perfect. So we have the title, budget, total year salary of all the employees, and this is project duration. So this is 92 days, this is 120 days, 60 days, 182. Now what we have to do from this total yearly salary, this is for 365 days, right? Yearly salary. Now we need to get for 92 days how much we will have to pay to all the employees. So what we will say, give me sum of salary divide by 365. Right? So what it will give me? It will give me single day salary, right? This will give me 1 day salary. What is the 1 day salary of all the employees working on a particular project? Into, I can say, get me number of days. This is the number of days as project salaries. So this will be project salaries. Let's run this. Okay, so now if you see, for analytics platform, budget is 80,000, total salary is this. But for 92 days, you will have to pay this much, 51,152. Similarly, for app development, this is the salary you have to pay. Now let's look at the output. Is it fine or not? So analytics platform within budget. So the budget is 80,000 and salary is 51,000, then perfect, right? It is within budget. Here 1 lakh, 1 lakh 5,000. So it is over budget. 20,000, 67, too much over budget. 50,000, 49,000 within budget. So we just have to create a case one statement and we are done. So maybe we can just say select title, comma budget, comma we need to get the label, right, from this, right, and I think that's it, right? So we'll say case when budget is less than okay. So I'm saying when budget is greater than or budget is less than salaries, right? Or let me say this, total salaries is greater than budget, right? So if the total salaries that we have to pay is greater than budget, then it will be over budget, right? Else it will be within budget. And as label. This is all we need in the output. Let's run it. There is some syntax error. Okay, I have given 2 times comma. Again, title, budget, sum of salary. This is fine. Case when this is this, then over budget. Okay, I need to put it in the single quotes. My bad. Yeah. So let's run this one more time. Still there is some error. Case when project salary is greater than budget, then over budget, else within budget, and as label. Okay, I think we have to give the alias, right? It is a subquery and we need to give the alias. Yeah, now it is fine, right? So analytics platform, app development, cloud migration, website design, budget, within, over, within. Perfect. Let's evaluate it. Yeah. Okay, let's move on to the last question. So the last question is employee's current salary. So now the question is 150 employees current salary. Now what we need to do in this question, we have two tables, employees table and promotion table, right? So let me explain you tables first. So in employees table, we have the employee ID, name and the joining salary. Basically at whatever salary a employee joined the company, right? So this is a joining salary for Alice, Bob, Charlie, right? Then we have a table where we have employee ID and their promotion and percentage increase. Percentage increase means 10%, 20%. This is in percent. So which means in the first promotion, which happened on 15 January, the percentage increase is 10 for employee ID 1, which is Alice. Then again he got promotion in March with percentage increase 20. Right? So this is what the tables are telling you, these two tables. Similarly, our employee can have n number of promotions, 4, 5, we don't know. It can be 100 promotions. So we have to write a generic solution. We cannot write a solution looking at, okay, only 4 maximum promotions are there. We have to write a generic solution. Even if 10 promotions are there in this table, we should be able to solve it. What we need to do is, your task is to write a SQL query to compute the current salary of every employee by applying each of their promotion increase down to one decimal place. If an employee has no promotions, their current salary remains equal to the joining salary. Okay, straightforward. But it is a very complex question, right? So I'll tell you why it is complex. So what we are saying, that he got 10% promotion, then 10% increase, and then 20% increase. So his initial salary was 50,000, right? Let's try to understand. Now, one way of doing it you may think is, what I will do, I will get all the percentage increase and add that to 50,000. So for example, 10 plus 20, 30%, right? Total 30% he got. So if I add 30% in 50,000, it will be 65,000, right? 30% of 50,000 is 15,000. 15 plus 50 is 65. But that is wrong. He got 10% increase first, which means after 10%, his salary got become 55,000, right? And then on 55,000, he has got 20%. So 50,000, 55,000 plus 20% will be 11,000. So it will be total 66,000, right? So this method is wrong, directly adding the percentage and applying it to initial salary. We have to one by one increase the salary. First 10% increase, then on top of it increase 20%, right? I hope the question is clear. This is what the complexity is, and this question will just open up your mind. Okay? It will go deep in your heart, trust me. Okay, so first and foremost thing is you need to have understanding of recursive CTs, right? If you don't know recursive CTs, I will add a link somewhere in the video. You can watch it, right? And after that only you you solve this question. Okay, great. So what we will do, that's what we will do. So in recursive city, we have an anchor element, right? So this will be the anchor element, the first salary, right? The first salary, whatever we have for each employee, will be the anchor element. Then we will loop over this table using recursive city, and first we will apply 10%, and then in the second iteration 20%, and so on and so forth for each employee, right? And whatever is the latest salary for each employee will be the final current salary. Okay, so let me show you how you will do this. Now, before I apply recursive CT, what I will also do, I will do a row number here. So I will know, okay, this is the first promotion, this is the second promotion, right? So I will have 1, 2, and again for here 1, 2, then again here I will have 1, 2, 3, 4, something like that. So I'll say, let me just take a promotion table for now, and I'll say, give me row underscore ID, sorry, row underscore number over partition by partition by employee ID, right? Order by promotion date. Okay, and this will be my maybe promo ID, I can say. Just some name I'm giving. Okay, so if you see, by the way, I'm solving in MS SQL. In MySQL, you might have different syntax for recursive CT, little bit, right? Not much. Okay, so percentage increase is there, and this is the promo ID. This is first promotion, second promotion, first promotion, second promotion, right? Based on promotion date in ascending order. So this guy has four promotion, 1, 2, 3, 4. So we have got the row number here. Great. What we will do, we will say with the uh, promos as this. We'll create a CT and the name is promos. Perfect. Now we will start our recursive CT. We will say RCT as, you can give any name. I'm just saying RCT means recursive CT, and the anchor element will be employees table. Right. So I'll say select from employees. Right. Now here what all columns I need? So I need ID. Perfect. I need ID. In output, I have the name as well. So I'll keep the name as well. Perfect. I need initial salary as well in the output. So initial salary we know. Joining salary is nothing but the initial salary from employees table. So I will say joining salary as initial salary. This is also fine. Now at this point, when I'm joining, my current salary is also initial salary itself. So I will say joining salary as, sorry, as current salary, right? At this point, right, I will do a loop on promotion table, but at this point my joining salary is my current salary as well, right? And then I have this promo ID that I will use. So initially when there was no promo, I will start it as 0 as promo ID, right? So I have not done anything. I have just taken, or let me show you quickly. Select star from RCT, and if you see, we have ID name, initial salary, current salary, which is same, and promo ID is 0 because this is just the initial salary. There was no promotion. I starting as 0, And whenever promotions are there, we'll start from one here, from the promos table. Okay, so this is my anchor element. Now I will say union all. Right? Now I will say select, right, ID, comma name, comma initial salary. Right, initial salary will not change. It will always be same. From, sorry, from which table? From recursive CT itself. Right, just look at it. So these three things are not going to change. With every promotion, ID will remain same, name will remain same, initial salary will remain same. So I will say RCT dot ID, RCT dot name, and RCT dot RCT dot initial salary. Right. Now next is current salary. Okay. So for that I will need to join it with inner join promos table. Right. On basis on what? On, let's call it P and let's call it R. If I am calling it R, I will have to change it to R. That's fine. I will make that change quickly. Okay. So I'll say R dot ID equal to P dot EMP ID, right? In promos, I have the employee ID if you see. In promos employee ID. Now in the first iteration, I want to join with the first promo ID of each employee, right? So employee ID equal to employee ID and bring the record with promo ID 1. Initially the promo ID was 0. So I will say r dot promo ID, right, plus 1. So 0 plus 1 will become 1 equal to promos dot promo ID, right? What will happen in the first iteration? Whatever is this data will join with the first row of each employee, right? Because employee ID equal to employee ID and promo ID plus 1. The recursive CT promo ID is 0 for the anchor element, right? Again, you have to understand recursive CT to understand how this works, right? And now what I will do, I will say that my new salary will be whatever is the initial salary, right, or whatever is my current salary, right, because I will have to loop over it. So this is my current salary plus, right, now I will get percentage increase from promos. So P dot percent increase, right? Now percent increase is, let's say, 20%, right? So what I will do, I will add 100 plus 20 will be 120 and divided by 100, so it will become 1.2. So let's say current salary is 100. If I do 20% promotion, it will become 120, right? So 100 into 1.2 will be 120. As this will be my now current salary, right? So whatever is my current salary, in that you add this percentage, right? And then my new promo ID will be this. Whatever is the recursive city promo ID plus 1. Right? Perfect. Let's see if this works fine or not. We might have some errors, so we will see. Let's run this. It has run. It has run. So I'll take you how it is working. Let me do order by quickly. Order by ID and maybe initial salary. Okay. Okay. So if you see, not initial salary, maybe current salary, right? Initial salary is same. So we might get wrong output. I mean, when we see. Okay. So now if you see, Alice has initial salary of 50,000. So this is the joining salary of Alice, right? 50,000. Now, after first promotion, right? He had two promotion, right? The current salary is 5,001, 50,001. Okay, we have done some mistake. 100 plus percentage increase. Okay, we have to do into, my bad. So current salary into 1.2, right? If it is 20%. So I have to do into, my bad. Okay, now it is fine. So Alice has 50,000. Then after 10% salary, his salary become 55,000. If you remember the first example. Then on 55,000, 20% increase 66,000. Right. So his current salary will be 66,000, and so on and so forth. Now the only thing I can see is we have the output in decimal and we have to do at one decimal places output, right? So what we will do some changes, and here I want to make sure it is in decimal. So I will say, so the data type of these two should be same. So it is union all, right? So maybe what I can say, this is my current salary. I will say cast this as decimal 6 comma 1, right? Yeah, 6 comma 1, because one decimal place and 6 is fine, right? Similarly, I will say cast this as decimal 6 comma 1. Okay, and that's it, right? Let's run this. Okay, so we are getting fine, right? It looks fine. Let's see, everything is fine or not. So for Alice, the latest cell is 66,000, right? 66,000. Let's look at these decimal values. Charlie is zero point 0.5. So Charlie is zero point 0.5 here, perfect. And David is zero point 0.3. David is zero point 0.3 latest salary. So we have the latest salaries now. So from this table, we just need to get latest salary. So maybe you can write a row number again, or you can just take maximum salary, because maximum salary will be the latest salary, right? Because it is always increasing. If in your question it is possible that salary is decreasing, then you cannot do max. In that case, you will have to create a row number based on promotion date and take the latest salary. But for now, it is fine. We don't have a negative increment, right? So I can say select. I need ID, comma name, comma initial salary, comma max of current salary, right? As current salary, right? From r dot ct, sorry, from r dot ct, group by id name initial salary, id name initial salary, right? I hope this should work. Let's see. Okay, so we have 1, 2, 3, 4, 5, 6, 7, 8. Looks fine. Looks absolutely fine. Let's try to evaluate it. Perfect. So this is working fine. Now, if you look at the solution, right? In solution, I have used exponential and logarithm, right? So you can just explore this, how this works. Otherwise, let me know in the comment section if you want me to cover this part, how these things works in SQL, right? Exponential and log functions. I can cover in separate video, but for now, we solved it using recursive CT. Great, thank you. Have a good day. So today I'm creating this video for last minute preparation for your data warehousing related interviews, data modeling, data warehousing, right? So if you are giving data analyst or data engineering interviews, these are the very common interview questions. Like for example, what is surrogate key, what is data warehouse, what is dimension table, what is data modeling, right? So different kinds of questions can be asked around fact, dimension, STD type. So I have compiled all kinds of questions that can be asked in your interview, and you will be feeling very confident after watching this video, right? There is no hands on that you have to do along the video or any practical. You can just watch this video maybe at 1.5x or 2x, whatever you are comfortable. At the end of the video, you will feel very confident before going into the interview. Okay, so what we will do first, I will give you an end-to-end idea, right? What is OLTP, what is OLAP, and what is the relationship between them, how we maintain them, and using that terminology, using that end-to-end flow, we will cover all the interview questions. Okay, so let's get started. But before you start, I want to make sure that you like this video, share with your friends, and let me know your comments also, how you feel about the video. Okay, so let's start. Let's get started. So what I have done is I have created some notes on Notion, right? You can see all the notes. And what I'll do, I'll use combination of these notes, as well as I have created some visuals on Excel Draw. So I will use combination of these two to explain you all the concepts. Sometimes I may use Excel as well to show you how data modeling works and few more concepts, right? So we will use these three tools basically, Notion and this Excel editor and Excel to explain the concepts, right? So how it will go? Sometimes I will read notes, sometimes I will show you the diagram, and the combination of two will go well, I think, right? And we'll use Excel as well to explain. Great. So just to make sure we have the base, we have a good base to discuss the interview questions. I'll give you overall walkthrough of end-to-end project lifecycle in data analytics, right? How it all starts and where it ends, right? And once you have that base, then we can move on to the questions, right? I have a list of questions. Okay, so let me give you a overall walkthrough first, right? So this is my end-to-end flow, right? There are other things as well. We'll introduce them whenever required, but for now, this should give you a good idea, right? So this is all starts with users, right? Me and you are end users, right? And we are generating data every day. So for example, if you buy something from Amazon or Flipkart or namastesql.com, you are creating a transaction, right? You're doing some kind of transactions online, right? Or you transfer money to your friend through your bank app, right? That is also transaction, and all of these transaction is nothing but data, right? So end users are using web applications, mobile app, and generating data every day, right? On YouTube, LinkedIn, Twitter also you are generating data, right? You post something on LinkedIn is a data, right? It should be stored somewhere. All of the data that we are generating every day, every minute, every second has to be stored somewhere. And those systems where this data is stored is known as OLTP systems, right? Online transaction processing systems, right? These systems are used to run the operation, right? Your day-to-day Amazon work, right? So that customer can come buy something, right? And see their orders, history orders, right? For all of that, right? For all of the operation, we store the data in the OLTP systems, right? There are different systems, for example, MySQL, Postgres, Oracle, SQL Server, or we have, for example, NoSQL databases like DynamoDB, MongoDB, all comes into OLTP systems, right? So just to summarize, whatever day to day you are doing transactions, right, on your app or your websites anywhere is stored in OLTP systems, right? So this is one thing. Now comes the second kind of system, OLAP systems, online analytical processing, right? So these systems are meant for the day to day operational work. But these systems, OLAP systems, are meant for your analytics, business reporting and analysis, right? These are meant for that. Now, how they are different from these systems, right? So, why can't I do all my analytics on OLTP systems, right? Why I need overlap system? So, all of that we will understand. But let me explain you two things, how they are different, right? So, one thing is, right? First thing is, there are different technology used, right, in OLTP and OLAP. OLAP. That is the first big difference, right? The technology which is used is different, right? So here, as I said, we use MySQL and all OLTP systems, and here we use, for example, in OLAP we have BigQuery, Redshift, Snowflake, and there are other systems as well. We have Databricks, Delta Lakehouse, and other things as well, right? That is the first difference. Second main difference is, right, that the data is stored in a way is a different, right? Data is stored right. So the way data is, let me take it to the next line. Yeah, the way data is stored is different, right? So the way we store data in OLTP systems is different from the way we store in OLAP systems, right? Because the data is stored in a way so that OLTP operational transactions are fast, right? Whatever operational transactions we have to do to run my app or my website, those should be fast. Here the data is stored in a way so that data analytics is fast, right? So ultimately the aim is to make things faster. That's why these systems are different. The or technology also is designed in a way that operational transactions should be fast. And these technologies are designed in a way so that analytical queries or data analysis is fast, right? So the technology is also designed in a way so that it supports OLTP and OLAP, and also the data we store is also designed in a way that operational transactions are fast here and here reporting is fast, right? So these two things are very important to understand at this point. Now the process of moving data from OLTP to OLAP, right? As I said, the way data is stored here and the data is stored here is completely different, right? So we have to transform that data in this model, right? That process is known as ETL process, right? The process of moving and transforming data, two things. One is we have to move data from these systems to these systems, as well as we have to transform data in a way that supports faster analytics, right? That is known as ETL process, extract, transform, load. So we extract data, then transform in a way that supports analytics, and then we load it into the system, right? This is not the only way, there are other ways also, so we will discuss, right? But ETL is one of the popular way, right? So once data is there in these systems, then you can generate reports, you can using Power BI or whatever tool you can connect to these systems, and then end users will use it, right? These are the business users which will see reports or whatever, and they will take business decisions that, for example, how much inventory should be there, or what kind of customer we should target for some promotion. All these decisions these guys will take, right? And these business users are also end users in some way, right? These users will also using these app, so they are also generating their data, right? So these users are subset of these users basically, right? So this is a full cycle, right? Okay, great. I hope you understand this end-to-end flow, right? How these systems are different and why we need two different systems, right? There's one more reason, by the way, why we need two different systems. One is this technology is different. Second, the way we store data is different. Third is we should not do analytics directly on these systems, right? Because these are operational systems, right? End users are using it. If you run heavy analytics query, then these systems bandwidth will go there, and these transactions, these operations will become slow, and you don't want to give that bad experience to your end user, so they have a bad experience that website is slow or transactions are slow, right? That you should not do, right? And these systems can go down as well if you run very heavy analytics query. So you don't want to disturb this system, right? This is where you are making money, right? This is where users are paying money and doing all of this stuff. So you don't want to touch this system for any other purpose. So obviously you should have a different system, right? So we have a different system, that is one thing, but that system is also designed for better analytics, faster analytical queries. Okay, I hope you get end-to-end flow, why we need two different kind of system, OLTP and OLAP. And then now in the next section we will discuss that how they are different. Move forward in this video, I just would like to mention about one of my very successful course, Analytics Engineering Bootcamp. So if you want to end all of these things end to end, right? OLTP, SQL, and what is ETL, how you do ELT, and you want to learn in-depth data warehousing, data modeling, as well as Snowflake, how to do data warehousing in Snowflake and Power BI. I have an end-to-end course which is Analytics Engineering Bootcamp. We have covered everything end-to-end in depth: SQL for analytics, data modeling and data warehousing, Snowflake. Then we have DBT, how to transform data, and then we have Power BI. So basically end-to-end full data analytics flow we have covered in that, right? So if you want to become data analyst or analytics engineer, or you want to move into data engineering using Snowflake, you can do this course. Any promo code which is currently running you will get at the checkout page, so you can check it out. But this course will give you end-to-end idea, hands-on experience, projects, everything, right? You can see the reviews as well, people have just loved it. There's no fake review, actually people are completing the course and putting the review. I don't fake anything, if you know me, so you can check it out. If you want into more big data engineering kind of thing, after this course you can also learn Spark, right? So once you learn Spark, you will have a good idea how to handle data in a distributed computing. And this is also an end-to-end program of Spark. You will learn everything, right? So everything is Spark internals, UI, we have in depth covered every topic. And again, you can check out the reviews. This is a very latest course, and you will see everything. All the reviews are very positive and people are just loving it. It is very hands-on approach, and we have also done projects, right? So check this out. You have to go to namastesql.com. So you just go to namastesql.com, and once you are at namastesql.com, you can just click on, close that. You can click on courses, right? Once you are on courses, you will see this Namaste Spark bootcamp as well as the Analytics Engineering bootcamp. We have other bootcamps as well, individual course if you want, Python or Snowflake, individual, you can check it out. But these two, if you finish, you will complete most of the things. Okay, so let's move on to the today's topic. So let's assume that you are the user and you are placing some orders on a website, maybe Amazon or Flipkart.com, right? So once the order is placed, how it will be stored, right? Once the order is placed, how it will be stored in a database, right? So let's assume for now that data is stored in this way, right? You can see we have order ID, order date, customer ID, customer name, and all of that stuff, right? So this is order related details. This is customer related details, customer ID, name, gender, age. Then we have product related details. What is the product ID, product name? What is the cost price at the price company bought the product, right? What is the category? And then we have the sales. So for example, this was cost price was 100 and this is sales. We are just assuming that this is how I'm storing data in my backend, right? In my OLTP system, I'm storing data in that way, right? Okay. So this is a very flat table, right? We are storing everything in one table. Now let's see if there is any problem with this kind of approach, right? We'll see, right? So now there is one problem in this, right? For example, let's say customer ID, let me put filter, right? So let's talk about customer ID 001, right? So I'll just filter on 001, and you see this person has placed two orders, right? Which is fine, right? Placed two orders on a different date, and I'm storing all of the data. But the problem here is, if you see this customer information, I'm storing multiple times, right? Isn't it? I'm storing here customer ID 001, name Ankit Bansal, gender male, age 18, and same information I'm storing here again, right? So this is a kind of redundancy, right? This is a data redundancy. Let me write data redundancy, right? Data redundancy means unnecessarily same data I am storing again and again and again, right? So this is a one problem, that we cannot store all the data just like that, right? Let's take example of another product. For example, or instead of 001, let's say 002, right? So Ada Sharma. So she has placed three orders, and three times you have to store same information, right? There should be a way that, okay, I should store this only once, and that should be it, right? But that's fine, we will see, right? So that is a one problem, data redundancy, right? And this data redundancy problem will be there for the product as well. So for example, let me take product ID 001, right? So multiple people have bought this product, Ankit, Rahul Singh, Mudit, but every time I have to store this information, that this is a product name, cost price, stationery, notepad, same thing again. I am storing three times, and we can have millions of orders for this product, right? So millions of times I am storing this again and again. Similarly, one customer can have hundreds and thousands of orders. So thousands of times I am storing same information, right? This is all known as data redundancy. Okay. So we should not have data redundancy, first thing. Second thing is consistency. There can be a problem of consistency. How? So for example, let's say this product cost price is changing, right? So for example, when this price was 100 initially, later it may become 110, right? So you will see 110 here, right? So again you will see that there is no consistency. Some places the price is 100, some places price is 110, right? This is not a good thing, right? There should be a mechanism to track that when was the price 100, when was 110. It is not that I mean randomly some places it is 100, 110, right? So this is inconsistency. Okay. So how we solve this? How to solve this problem? Right? There is one more problem, which is data integrity. We'll talk about it in a while, right? But how to solve these problems, right? So that's where data modeling come into picture, right? This is when data modeling come into picture, right? Through data modeling, we design systems in a way that we don't have these issues and we have a good performance, right? That is important. See, performance is important. Without performance, how things will happen, right? If systems are slow. So we avoid these things and we have a good performance also, right? And how to solve this problem using data model, right? So let's read it quickly. What is data modeling? Data modeling is the process of designing how data is structured and related before storing it in data warehouse or database, right? So we just not flat randomly we will all the columns we will store in one table. No, we will design it in a way that through data modeling we design how data is structured and related before it is in a data warehouse or database, right? It answers what tables do we need, what columns should each table have, how are tables connected, and what is fact and what is dimension. This is more into when we move into data warehousing, but basically every kind of decision that we are taking, be it fact or be it in a normalized form, whatever, it is all part of data modeling, that how data will be stored in table and how that will be connected. Okay, great. So let's see how we can better store this data so that we don't have all of these issues, right? Now another issue will be, right? That is one thing that we have data redundancy, inconsistency, integrity. From performance point of view, if you just imagine that for product ID P001, right? Let's say one more order is coming, then I have to insert this full data, right? I mean, insertion also will take more time, right? Because thousands and millions of transactions are happening at once, right? So if you are inserting this full data, which means in the insert you will have all the customer information, all the product information, which you don't need to insert, right? Because this is already there. We should have a better way. So that also is a problem. Okay, so we will see how to solve this problem in next section. Okay, great. So I have moved this data to Excel, right? And then we will see how we can model it better, right? So if you see here, we have all those columns, right? Where we have redundancy, right? Customer ID, customer name. This is customer related columns. Sorry, right? So we have this, and then we have product related columns, right? And this is sales. Okay. Now how we can better design it so that we don't have a data redundancy, right? So if you see this customer, right? This customer has 4 attributes here. There can be more, like customer address, city, state. For simplicity, I have taken 4. So what we can do, instead of storing here, right? This is my orders table where I'm storing all the orders data, right? So this is my orders table. Now in orders table, I don't have to store this customer information again and again for each customer. What I can do, I can take this customer information, right? And put it in a different table here, right? So I will create a customer table, right? So this will be my customer table. Now what I will do in this customer table, I will store all of this information and I will create a primary key as well, right? So maybe I will say customer key, right? And I will give a running number. I'll tell you why. 3, 4, 5, 6, 7, right? This you can imagine it as maybe username. You create a username on a website. So this can be a username unique, right? Instead of ID, you can say username. It will make more sense. But what I will do, all this customer information, I will put here in a separate table, right? And I will create a key which will be a running number, unique, right? And it will represent each customer uniquely. That customer key 1 is this customer, right? And this key is known as primary key, right? Primary key is unique. It cannot repeat. So for each customer, it will be unique, right? So this is known as primary key, or it cannot have null as well, right? Now here, instead of storing this customer ID, customer name, age, gender, what I will do, I will say just store customer key, right? And I will say Okay, for customer 001 it is 1, for 001 it is 1, right? For 2 it is 2, it can be anything. I'm just putting it, and this is 3 and this is 4. Right? This is a random number. It can be 999 also, not necessarily, but it will be unique. It will not repeat, right? So I'll just put it so that you understand that it can be anything, but it will be a running number basically, right? So this is how it will be. Now some of the customers maybe so we will have 999 1 2 3, so this is not required, right? So repeat information is not required. How many distinct customers I have? 999 2 3 4, right? Let me put it one all only for now, it will be easy to explain. But basically I have 4 customers, right? Initially for now I understand. So 1 2 3 4 we have, so this information is not required at all. Great. So now instead of have these columns, I'll just remove this column from this table. Right? These columns are not required. If I want to know order ID 1, which customer has placed, I will join with this table and get the information of this. Right? Next time when he plays order, again I will take 1. I will just insert 1 in my orders table instead of inserting all the details, and I will put here. Right? And then I don't need all these columns, so I'll just put it here. Right? Now similar thing we can do for product as well, isn't it? For product also we can do this thing. So product has these 4 columns, right? So let me take. So I'll just copy and put here. Right? And this will be my product table. And this will be, product table, product, right? Or let me say product, right? And customer key is primary key, not the table. So let me put it here. So customer key is my primary key here. Okay, great. So similarly, what I will do, I will create a key column here. So let's call it product underscore key, right? So let me take it little bit right. We'll see. Yeah, now it is fine, right? So let's delete it. So I will generate a product key. Let's say 1 2 3 4. I have 4 distinct products, right? So product, this will be 1, this will be 2, this is 1, this is 3, this is 1, this is 4, this is 3, right? And again, instead of all of this information, I will just keep product key here, right? And only the unique products will go here. So we have 1 2 3, right? I'll just take 3, and then we will have 4, right? That's it. And this all is not required. Great. So this is done. Now I have a product table and I have a customer table, and this is my primary key. Let's call it PK. Okay, great. This is not the name. Name is just product underscore key. I'm just putting in bracket that this is a primary key, so you understand what is primary key and surrogate key. Okay, great. Now here we can remove all of these columns, right? So let me remove this. All of this is not required. Delete, and we'll have sales. Awesome. So now if you see, my orders table becomes so small, right? So cute, right? Earlier so much was there, now it has become so cute, right? Now tomorrow, let's say customer 1, right, is placing an order for product, it is 1 2 1 3 1 4 3, right? So it has become so cute table now. Now tomorrow when customer ID places one order, so I have to just insert these 4 5 columns, isn't it? I have to insert only these 4 5 columns, right? Let's say product 3, right? And sales, let's say whatever, right? So now if you see, inserts will be faster, right? Instead of inserting so many columns, I am just inserting 5 records, and that is what is needed. In OLTP systems, there are a lot of inserts are happening at a time, right? Thousands of users are placing orders. So inserts should be fast. And this is why tables are designed in a way so that inserts are fast. Not just inserts, deletes and updates. I'll talk about it. Right? So whenever a new customer is signing up on your website, right? Let's say you come to namastesql.com, you have to just sign up first, or you go to amazon.com. So as soon as you sign up, we will create a record here. So 5, let's say a new customer is coming. This is, I think, okay, I made the mistake. This is not 01, so this is 04, right? And whatever, I think, let me check quickly what was the data. Okay, so we had Mudit Bansal 04, right? So let me change it to Mudit Bansal. 04 was Mudit Bansal, right? Male, age, it is fine. So this is how it was, right? And now when new customer is signing up, so I can just say cust 001 005, right? And let's say this is Shikhar, male, age, let's say 21, right? Now as soon as you sign up, a record will go here, right? And when you make a purchase, that record will be here, right? It will place 5, right? As soon as you place an order, we will see, okay, this is the customer, so we will just insert 5. So my inserts will be much faster, right? So this is why we have data in a normalized form, right? Normalization means that you break data into small tables, that so that you don't have data redundancy, and you will have inserts, updates and deletes will be faster, right? So this is the first thing. Great. Now let's talk about these tables, right? So this is your, so when we are designing for OLTP systems, we called it as entity. So this table is the orders entity. We don't use fact dimensions here, right? It is entity. So this is my orders entity, right? Similarly, I have customer entity, product entity. We call it like that. Now, if you see, this customer key is referring to the primary key of this customer entity, or this product key is referring to the product key of product table, right? So these keys are known as foreign keys, right? Foreign key means the values in this column will come from this table only, right? It will come from primary key of customer table. So this is your primary key and this is foreign key. It is referencing to the primary key of customer table. Similarly, product key is a foreign key, right? It is referencing to the primary key of product table, right? So this is your primary key and this is your foreign key, right? Now with this we can maintain the data integrity as well. I was talking about that there is a data integrity issues as well, which means in this table, in this column, the values should be from this table only. You cannot insert 6 randomly here because 6 is not there, right? If a customer 6 is not there, you cannot insert, so it will give you error. We can put constraints actually in tables that, okay, in this table all the values should come from here, not outside this, right? So we can maintain the data integrity as well. Okay, so we have 3 entities now: orders entity, customer entity and product entity. But if you look at further, there is still some redundancy, right? Let me delete it. So this table is fine, there is no redundancy as such, right? Everything is unique and we are not maintaining any duplicates and all, right? This order date is fine. Order date we have to store, right? That on which date order was placed. If you want, you can create a calendar table as well, right? This is also sometimes will be there, right? But it is most in data warehousing, right? We'll talk about it later. But in OLTP systems, data will be something like this. Okay, great. Now again, if you see here, there is data redundancy, right? If you see this gender column, right? Gender, male and female can only come. But still, if I have 1 million customers, I have to store male, female, male, female, male, female multiple times, right? So still data redundancy is there in the customer entity. So what I can do, I will say, okay, I will create a separate table gender, right? And I will put a primary key here, gender key, let's say, right, and value, right, and it will have 1, 2, and it will have value like male, female. I can do that, right? And here instead of male, female, I will store 1, 2, 1, 1, 1, right? Now you will say here also there is no extra column here, which is fine. But if you see male, female will take more space, right? Every time you store male, female, that will take more space. Here you store only once, and this integers take less value. I mean less space, right? So we will say 1, 2, 1, 1, 1, right? So it will take much lesser space. Okay, great. Now let's look at the product table again. So don't you see this category will be storing multiple times? Let's say if you have 10 categories, so you can have a separate table. So you will say category table, and you will have, let's say, category key, right? And let's say category, right? Or let's say here I will say gender, column name. Similarly, here you will say, okay, I have a category 1, 2, right? And then 3, then 4, whatever categories are there, you will store here, right? So for example, we have stationery, right? Electronics, and we can have more categories basically, right? We can have subcategories as well, right? So I can store here, and instead of storing this full value stationery thousands and millions of time, I will just store 1, 1, 1. Instead of storing electronics many times, I will say 2, 2, 1, right? So this is how I will store data, so that when a new product is coming tomorrow, right, I can insert here, and inserts will be faster, right? Because I don't have to store all of the information again and again, right? If a new category I'm introducing tomorrow, I will just have to store one value here, right? When I'm introducing new category, let's say mobiles, right? So I'll just make an insert here, and whenever the new product I'm launching on my website for mobiles, I'll just insert 3 for that product, right? So that way I don't have any data redundancy, and I can maintain the data integrity as well, right? So this process of designing table, how these tables will be connected using foreign key, primary key, is known as data modeling, right? So we will have 5 tables here, right? One is orders, customers, gender, right? We can have more tables actually. We are just assuming few columns, but we can have address column, city column, lot of other columns. But you understand, right, why we are breaking data, right? So that our inserts, deletes, and updates are fast, right? Now when I say delete, so for example, if you want to delete a product, right, you can just come here and delete that, right? Otherwise, in the plain structure, you cannot delete that data, right? Because that is related to orders data. So you can never say this product is deleted. But from here, you can delete it. Or you want to update the cost price, right? You can just update here 40. That's it. Right? You don't have to update it hundreds of the place, right? And these OLTP system maintain only the latest data. They don't maintain the history, right? They maintain latest data, right? They don't maintain the history. Okay, and this form where you don't have any data redundancy is also known as third normal form, right? This is known as third normal form. There is first normal form, second normal form, but there we have some kind of data redundancy. In third normal form, which is used in OLTP systems, there is no redundancy. Now, as a data engineer, data analyst, we don't work on these systems, right? We work on OLAP systems. But as a data engineer, you just have to move data. So you should know these concepts, that how data will be there in the system, so that when you extract data, you understand already that how data will be connected. You should have some idea, right? So when you so let me go here, right? When you move data from here to here as a data engineer, you should know how data will be stored. So you should have some understanding. But mostly we should have more focus on data warehousing concepts, because we will be building data warehousing, or as a data analyst, you will be using that data warehouse, right? So more focus we will do on OLAP systems and data warehousing in the next section, right? But I hope you understand that what is data modeling. Data modeling is a way to design tables and columns and relationship between them, so that our data has no redundancy, data integrity, or inconsistency, right? And my operation should be fast. We know that insert will be very fast now, right? So I hope you understand. Okay, great. Let's move on to the next section. In OLTP systems, right, data will be in a third normal form, and this is how entity relationship diagram will look like with both fields. Like you have orders data, you have order items data, because in one order you can have multiple products, right? You have orders table, order items table, then you have customers table, order status table like cancelled, delivered, or whatever, right? Then you have customer table, you have cities, so you have city ID, you have a separate table for city, right? And then you have a separate table for state and a separate table for country, right? So nothing is basically redundant, right? We are storing data in a way that there is no redundancy, and the deletes, inserts, and updates will be faster, right? Similarly, you have order items, you have products, and then it is category, right? You can have subcategories, so there will be one more table, right? So this is how you store data in a OLTP system, right? But now let me ask you this question, right? Why you think this model is not good for analytics, right? Obviously we can move it to different systems, but why can't we keep the same data model, right? So let me ask you one question, right? Let's say I want country wise total sales, right? My requirement is give me total sales country wise, right? Now, if I have to get country-wise sales, just imagine how many tables I will have to join. So I will have to join countries with states, because country name is coming from here, India, USA. Then states has to join with cities, cities has to join with customer, customer has to join with orders, because sales will come from here, right? So I have to join 1, 2, 3, 4, 5 table, right? And this becomes very, very noisy and complex, and also it will not give you good performance, right? Because we run big analytical query. It is not that I'm inserting one record or extracting data only for one customer from orders, right? This is not like that. I will read whole data of orders, customers, cities, state, country, because I need total sales country wise. So India has this much sales, USA has this much sales. I need to get this. So I need to read full tables, and I have to join all of these tables together. So this will be very, very slow, right? Performance will be slow, right? So this design is good for OLTP systems, right, where I need to do operational transactions, right? Insert, delete, and updates are fast. But for running analytics, these structure is not good, right? So that's where come into dimensional modeling. So in overlap system, online analytical processing system, we do dimensional modeling, and the terms that we use there are completely different, right? So this is your OLTP system. Now if I have to design a overlap system, I will not store data like this. I will do a dimensional modeling, right? Sorry, modeling, right? And in that I have a concept of fact and dimensions, fact and dimensions, right? So if I have to store this data, what I will do, for each attribute I will create one dimension. So customer is an attribute because customer has some information about customer, right? So what I will do, I will not break it into multiple tables. So I will create one customer dimension table. So I will say customer dim table. Similarly, I will have a product dim table, and it will have all the product attributes, so that I don't have to join multiple tables, right? Now you will say, let's keep the flat structure. That flat structure has a lot of problem, because these dimension table will have lot of attributes. Let's say 15 attributes about customer. So you will have to store multiple times in orders table all those attributes. So that will not be good, right? We are normalizing it, but not in third normal form. We are doing a dimension table for each attribute. For customer there is one table and all the attributes here. For product dim, all the product attributes, and again in fact table we will keep the attributes of foreign keys of customer dim and product dim table, right? So let's create it quickly. So let's say I'm saying customer dim, I have key here, right? Let's say 1, 2, 3, 4, right? And I have all of these customers. So let me just put it. Okay, so I have, let me expand it. And then instead of that, I will have mail. So I'm okay if little bit redundancy is there, but it supports my analytical use case. I'm not inserting data every day in these tables, right? Generally, we have batch processing, and at once I will insert data in a day. It is not that every second, every minute I have to insert data in these tables. No, right? So I will have a key. Sorry, let me put it here. 1, 2, 3, 4, right? And I will have, let's say, customer SK here, right? It is surrogate key. In the word of dimensional modeling, we call it a surrogate key, and there are more things about it we'll discuss later, but this is known as surrogate key. It is not the same column what you see here, right? Here we generate a different column altogether here, right? We'll talk about it more, but for now you understand this. Similarly, I will have a product dim table, and it will have product SK surrogate key. I'll talk more about surrogate key, what is surrogate key, right? And then all other attributes of product. So let me just take, right? And then we will have, let's say, 1, 2, 3, 4, and we won't have this stationary. We will just keep it here as it is, right? Okay, so this is what my dimension table will look like. This is customer dimension and this is product dimension, and all the transactions that are happening I will keep in a fact table, and I will call it fact orders, right? And it will have all the data. Let me take few rows, right? And I'll just put it here. Maybe here I will put, yeah. So this is my fact orders, right? And it will have order ID, order date, and this will be my customer surrogate key here, right? Whatever I create, let's say customer SK, and this will be product SK. Okay, so this is known as dimensional modeling, and this is also known as a star schema, because we will have a fact table in middle, and this will be connected to different dimension tables. We can have store dimension table, customer dimension table, product dimension table, date dimension table, different kind of dimension tables. So in center there will be fact, and then there will be multiple dimension tables connected. So this is known as a star schema. We'll talk about it more. Right? So this is how I store data in a different way, right? So here it is in a normalized form in OLTP system, in OLAP system, because I want to do analytics. Right now, if I have to get, let's say country wise total sales, so the customer country will be there in this table, right? So I can just join it and get that. So I will have to do only one join, and I can do aggregation and all, right? Similarly, if I want category wise sales, so I will join these two tables and get you the category wise sales. So it will be faster, right? I will have to make only one join instead of 5 joins in the old TP system tables. Here I can do in a faster way. Okay, great. So this is how you store data in a OLTP system and OLAP system, and I hope it makes sense. Okay, let's go back to the notes now. So OLAP system, we do dimensional modeling. We have order table in the middle, and then we have product, customer, date table. So this is also known as star schema, right? So we have a fact table. Fact sales contains metrics, amount, quantity. Dimension table provide context, that who bought the product. I mean, which product was bought, who bought which customer bought the product, right? Or placed the order, or from which store it was bought, on which date it was bought, right? So all the context is provided by dimension table, and it has the metrics, right? Amount, quantity, and all. And foreign key is connected to the dimension table. So here also we call it as a foreign key only. There is no different term for it. In the OLTP system also we call this foreign key, and here also. So customer ID is a foreign key to customer ID in customer table, right? Okay, then we have denormalized table. Dimensions are not further normalized, right? So dimension table are little denormalized, right? Because we have repeating information. If you see, right? For example, customer ID, then location will be repeating. So these are denormalized kind of, right? This is not normalized. Normalized means we will break in a way that there is no redundancy. But here it is little bit denormalized, right? Query performance, simple joins, fast aggregations. So joins and aggregations will be fast, which is also required in my data analytics OL systems. Great. Now, as we discussed, why do we need a separate data warehouse? Operational data warehouse are built for fast inserts, updates, deletes, handling day-to-day transaction. But business team needs revenue trend over last 3 years, top 10 products by region, customer churn analysis, inventory forecasting, right? So business needs are different for analytics, and for operations, business needs are different, right? Running such queries on transaction systems slows down them, causing locking issues, impact business operations. So we have separate OLTP, operational workload, MySQL, SQL Server, Postgres or NoSQL databases. OLAP, analytical workload, Snowflake, BigQuery, Databricks, Lakehouse, Redshift, whatever. Right. So this is the quick difference. Purpose, data. You can just read it. You will understand it now, right? So you can say placing an order on Swiggy is OLTP. Analyzing monthly revenue by city for last 5 years is OLAP, right? So if you are working on a Swiggy company, so you can imagine this as example to differentiate between OLTP and OLAP. These two examples. Okay, great. I hope you have now end-to-end understanding of this flow, right? How things works. Once I have data in this format, if you see in Power BI and all, if you are creating a data model, it will be in this form. So you will have a fact table and you will have multiple dimension table, because data engineer would have done the work to move data from OLTP to OLAP system, and now you need to just build the reports, right? So I hope you understand end to end how these things works. And now let's start with the interview questions, and during that process I will tell you few more things in this diagram. Okay, great. So let's start. First is, what is data warehouse, right? Our data warehouse is a centralized system that stores integrated historical data from multiple sources, designed specifically for analytical reporting and business intelligence. Now this is important here, right? From multiple sources, right? So your data can come from multiple sources. So for example, if I go back here, right, you can have data. Let's say you have orders data, right? You have orders data, right? It is stored in some database. Let's say it is stored in MySQL. Right? Now it might be possible you have other than orders, right? So you have inventory in different warehouses. So you have inventory data. Right? It can be maybe in SAP system you are maintaining it. It might be possible, right? Or some other ERP system, right? Or you have, let's say, purchase order data. You purchase different, and that can be in a different system, right? Let's say it is in Oracle, right? You never know, right? And you might have some data in flat files. So your operational data can be in a different kind of source systems, different kind of database files, or maybe in files, right? So all of this you have to get from different systems and create one data warehouse, right? So you have to connect to different sources, right? MySQL, SAP, Oracle, flat files, Drive, Excel, or cloud storage, whatever. You can have data in a different places, your OLTP data. So you have to gather all that data and combine all the data as part of ETL process and put it in a data warehouse, right? So let's read it again. Our data warehouse is a centralized system that stores integrated historical data from multiple sources, designed specifically for analytical reporting and business intelligence, right? So we have historical data as well. In OLTP system, we have only the latest data. Okay, it is optimized for OLAP workloads, not transactional processing. Key characteristics: subject oriented, integrated, time variant, and non-volatile, right? These are the 4 characteristics of a data warehouse. Let's understand quickly, right? So subject oriented means organized around major business subject, right? So you can say I have a warehouse for sales in which I want to do analysis related to sales, or I have a database warehouse for customer. In that I have customer related all the tables and transactions so that I can do that, or product related data warehouse. So it is subject oriented, not around applications. It is subject oriented, right? It is integrated. Integrated means second one is integrated, which means data comes from different systems, CRM, ERP, APIs, flat files. Before loading into warehouse, standardize the data, clean, transform. Example, one system says M, another says mail. So warehouse standardize. Standardization means, let's say in some from one system gender is coming as M, from another system it is coming as male. So when you are moving into data warehouse, so you make it consistent. Either it is M's all the places, or it is male. So basically it will all go in a customer table, right? In customer table, either you will put M or male. It is not that for some customer it is M and for some it is male, no, right? So you have to standardize the data. Time variant means warehouse stores historical data, right? In operational database, customer address get updated, old value gone, right? So if a customer is updated the address, let's say from Bangalore to Mysore, so we will just update it. We will not keep the history, but in warehouse, right, we keep the history, right? We have a SCD type 2 concept that we can show, okay, from this date to this date, customer was in Bangalore, then he moved to Mumbai, right? So warehouse can show where customer lived in 2022. Right? So it is time variant. And then non-volatile means data is inserted and read, not frequently updated or deleted. So in warehouse, generally data is not updated or deleted. So whatever data is coming from OLTP will be inserted, right? Or whatever change we have to track, like it has moved from here to here. So in that case also there is no update here. We just say from this date to this date, customer lived here, from this date to this date here. So generally delete and updates are not there. Mostly we have insert and then we read data for analysis, right? So if interview asks what is data warehousing? Data warehousing is the process of collecting, transforming and storing integrated historical data from multiple sources into a centralized system designed for analytical reporting and business intelligence. Right? So this is how you can answer it. Great. Now this data warehousing, how we do, the process has also evolved over time with the technology is changing, right? So in traditional warehouses, we had ETL process, right? On premises expensive, right? So we used to buy servers and all, physical hardware servers, and we used to use those servers to do all the processing, store our data, right? Now in modern technology, we have cloud data warehouse. We don't have our servers around. We buy everything, we rent everything on the cloud, and there we do, right? We pay per usage, and here we use ELT approach, right? Example is Snowflake, Redshift, BigQuery, Databricks, right? Now what is ELT and what is ETL? So ETL you understand, right? So I extract data, transform it and load it. Now to do this, I had to have some third party tools. So for example, we can have Informatica or data stage, or we can do in Python, or we have, let's say, ADF, right? There are a lot of tools to do this which connect to data sources and do the transformation and put it here, right? Now in modern system, this is not how it is done. We do ELT. ELT means we will directly load data, right? So we will directly load data from here. So let me take this to here, right? And we do the transformations here itself, right? So we will have staging layer and final layer. So what we will do, as it is, whatever data is here, we will not do any transformation. We will just dump into my OLAP system, maybe BigQuery or something, and there I will do the transformation and create a new table. So we will have two layers inside it. One will be staging layer and one will be final DW layer, right? In ETL we had only DW layer here, but here I need staging to do all the transformations. So whatever I was doing here as part of other tools, I will do within this data warehouse, right? So in staging, I will have tables as it is, which are coming from OLTP. Then I will do some transformations, right? And move into here. Right? Maybe I can put it here as well. Right? So let me take some space. And the transformations will happening between staging and data warehouse within my OLAP system, right? Now there is one more advancement, that we don't directly dump data from here to here. We will have a data lake in between, right? So let me make some space, right? And I will not do this. Let me delete this. 1 second, it is all gone. So let me again select everything. Yeah, should be fine now. And now I will move. Yeah. Okay. So what I will do, I will have a data lake, right? Let me remove everything for now. So maybe I will just copy this, and I have this data lake, right? Let me remove this as well. Let me bring this. Okay, I'll tell you what is the purpose of this. So I have a data lake, right? And now what I will do, I will dump data from OLTP systems to this data lake. Right? I will not directly connect it to my data warehouse systems. I'll just dump it to data lake first. Right? And from data lake, I will move into my OLAP system and do the ELT. Right? So I will not directly dump from here to here. I'll dump here, and from here I will dump here. I'll tell you the reason for that. Okay, so this is my data lake. An example of data lake are like S3, Google Cloud. So this is just object storage, right? So we just store data as it is in the form of files, right? So we dump data from here to here, maybe Parquet file or CSV file, or we have ADLS, right? Azure storage, right? So we store data here, right? So it is nothing but you are dumping data in a rented hardware, right? So this S3 Google Cloud just store data as it is, right? So you take this data and store this in form of files. For example, orders.parquet file or CSV file or whatever form you are doing. Generally, Parquet file is used, right? So you have orders.parquet file, customers.parquet file, right? So all of that you will store in this and then you will put here. Now, advantage of this is you might have multiple ELT or ETL processes, right? Let's say ETL, right? So you might have multiple ETL processes. So if you are connecting directly from database to here, many times you will have to connect to it, right? Same orders table, we will have to multiple times. There can be multiple, let's say 10 ETL process. So 10 times you will connect it to your OLTP system and extract data, which is not good. Because again, these are operational systems. You don't want to connect with them for the same data multiple times. So what you will do, you will dump it once at the end of the day. So end of the day, you will dump everything here and all your systems will connect to this. Right? All your system will connect to this. Right? So at the end of the day, everything will be dumped from here to here only once. Right? All the data which is processed on 1st January, end of the day it will go here. Again on 2nd January, end of the day it will go here. So you will touch only once, dump all the data in a data lake, and all the systems, maybe whatever you are doing, maybe some data scientists are working on it, they are doing machine learning, neural network, whatever they are doing, they will get data from S3 instead of connecting here again and again and again. This is good for security purpose also, because you don't have to give this access to everyone, right? Once the data is dumped here, you just give access to this. And for performance wise also, you are not touching these databases multiple times, OLTP, because these are critical, right? You are getting money from here, you don't want to touch them for other things. So you will dump only once at the end of the day, and all other systems, whatever ETL, ELT, machine learning, whatever data science, whatever you want to do, you get data from here, right? And it is a kind of backup also for you, right? So there are multiple purposes we solved using data lake. Okay, so this is where your data lake comes into picture. Okay, I hope this makes sense. Great. So in modern cloud data warehouse, we have ELT approach, right? And we use cloud systems, right? And scalable storage and compute, right? Scalable means there's no problem. If you have more data, you can just keep dumping it in S3 or Google Cloud anywhere, and you just have to pay for whatever you are dumping, right? There's no restriction how much you can put, right? So let's understand one more time what is the difference between OLTP and OLAP, because this is a very common interview question, right? So OLTP, operational system, these are analytical systems. This keeps current data, they keeps historical data. Highly normalized. Highly normalized means tables are we break tables into small tables so that there is no redundancy, and these are denormalized, right? We have fact and dimension. In dimension we don't break it further, right? So that is denormalized. So example, placing an order is OLTP, revenue analysis over 5 years is OLAP. Great. Now what is star schema? Right? Star schema consists of one central fact table and multiple dimension table. Dimension are denormalized and directly connected to the fact table. Advantage, simple design, fewer joins, better query performance, best suited for reporting and BI tools. Right? So we saw here, this is my star schema. I have a fact table, right? And it is directly connected to all the dimension table. This is a very important term, right? Directly. right? So this orders is directly connected to products, orders is directly connected to customers, and this simplified my data model, right? Anyone can come and understand this data model and start doing analysis, right? So this is my star schema. There is another known as Snowflake schema, right? Snowflaking is again breaking this table into multiple tables, right? So you have customer table, and then further you, let's say you have a location table, so you create a location table again, right? So let's say in location table you have city, right? Now if you want city wise sales, so you will have to connect here to here and then here to here, right? So this is known as snowflaking. You are further dividing your dimension table into multiple tables, kind of we are going back into third normal form, right? So that is your snowflake table, where one dimension table can have further multiple dimension table, right? So you might have a table which do not have a direct relationship with fact table, because if you want city wise sales, you cannot get from customer, so you have to go through customer and then location and then you will get it. So that is your snowflake schema, and that is not very popular in analytics, so you should not use it until unless you have a specific reason, right? So next is that is your snowflake schema. A snowflake schema is a normalized version of star schema, where dimension tables are further broken into subdimensions, right? Advantage is reduced redundancy, we understand, right? Saves storage, but we have to do more joins and complex queries, right? So in analytics you will mostly see star schema. I hope you got difference between star schema and snowflake schema now, right? So star schema denormalized dimensions, simpler, faster queries. Normalized dimension, more joins, more complex. Most modern warehouse prefer star schema for analytics performance. Great. Now next question is, what is fact table, right? So fact table stores measurable business events. It contains foreign key to dimension tables and numerical metrics, right? So we saw here in our example, right? So this is my fact table, right? It has all the numeric things. So for example, sales, or let's say we have profit or whatever, right? And we have foreign keys to dimension table, right? So this is what it is, right? So for example, sales fact table has order ID, customer ID, product ID, sales amount and quantity, right? Now we have three kinds of fact table: transaction fact table, snapshot fact table, and accumulating snapshot table. And there is one more, factless fact table, right? We will talk about it later, right? We'll talk about each one of type. We have an interview question further. But since we are discussing fact table, let's discuss what is dimension table, right? So dimension tables are dimension table store descriptive attributes related to business entities, right? For example, customer dimension. So we have customer dimension, customer ID, name, city, gender. They provide context to fact table, right? So fact table without dimension table has nothing, right? So for example, if I just have fact table, so I don't know which customer bought it, right? Which product customer bought it. I cannot do any kind of analysis. So this dimension table provide context to fact table, that okay, which customer bought it. So that is the context I'm getting, right? Which product was bought, right? So these are dimension table, and which have descriptive attribute, right? So for example, customer related information, customer name, gender, age. Similarly, product related information, product ID, name, cost, price, category, right? So we will have descriptive attributes in the dimension tables. Okay, great. Now we will discuss next in what are the different types of fact table. There are typically four kinds of, or maybe three kinds of fact table, and there is one more which is not that important, but yeah, it exists. So one is transaction fact table, right? Transaction fact table is nothing but we store one row per transaction, right? So for example, we have let's say someone placed an order, right? So for that order, I will store that value in a fact table, right? So it will have sales ID, order ID, product ID. I mean, in one order we can have two products, so we will have two entries in this table, right? But basically we are storing a transaction, a order is placed, or a course was bought, or whatever, any kind of transaction you do will be stored in a transaction fact table, right? So it stores data at a transaction level. Then you have a snapshot fact table, right? So periodically snapshot like daily inventory. So for example, let's say you have a different warehouse where you are storing. So Amazon have different warehouse where they have multiple products they store. So every day they take a snapshot. Okay, for this product ID, for this stock, I have, for this product ID, I have 100 stocks, right, in inventory. And this is the inventory value, basically stock quantity into cost price. Right? Similarly, for product ID 102, I have this much stock quantity and this is the inventory value. Maybe I can keep it at the store level also. That in data warehouse, let's say we have a data warehouse in Mumbai, in Bangalore, so I can store in Mumbai this much is there, in Bangalore this much is there, right? So the granularity will increase, that for this snapshot on this day for this product on this data warehouse, this is the stock quantity and inventory value. But basically we take periodic snapshots, that on first this is my inventory for different products, on second this is my inventory for different products. So this is a snapshot we take, so this is known as a snapshot fact table. Then we have accumulating snapshot fact table, right? Right. In this, we track life cycle stages like order processing. So, for example, I can have a fact table where I can store all the tracking of an order. That this order was placed on this date. On this date it was shipped. Then on this date it was delivered. And what is the current status? It is delivered or shipped or placed. Right. So these fact tables will be used for analysis. Right. Ultimately, for data analysis, these facts are used. So this transaction fact can be used to get all the statics of, for example, month wise, what is the total sales we did, which product wise how much is the total sales, or customer wise total sales, or we see trend over time. So all kind of that kind of analysis can be done, right? This snapshot fact table. So for example, this inventory, we can check which product has more inventory, right, which is there for longer period of time, right? So all that kind of analysis we can do, right? Here we can see that, okay, which is taking more time for maybe particular kind of product, that time difference between order date and ship date is more, because it is taking more time to procure it or maybe pack it or whatever, right? Once it is shipped, why it is taking so much time, right? So we can identify product, okay, it is reaching in 10 days or 5 days, maybe some courier services are doing good, some are doing bad, so we can do all that kind of analysis, right? Then we have a factless fact table. Right? A factless fact table contains no measurable numeric facts. It captures events or relationship, right? But we can do analysis. We can derive some fact from this table. This table doesn't have any fact, but we can derive fact from here. For example, if we have this date, student ID and class ID, right? That on this date, in this class ID, who all students were there, attendance, right? So on first, in class ID, let's say 101, there was two students, 1 and 2. Right? On second, there is one student. On second, there is one more student, 3. Right? This is class ID 102, 101. So using this table, I can generate some facts, right? That daily how many students are attending the class. It doesn't have a fact. It doesn't have a numeric field like sales, quantity, or something like that, right? But we can derive. So we can say daily how many students attending each class, right? So we can derive that using group by and count star, right? But it is a fact table because we can derive some fact attributes from here, but it doesn't contain any fact as such. That's why they are factless fact tables, right? Great. So example, student attendance, promotion eligibility, or website page widgets, right? So we can have, let's say you have a website and the customer ID. So you are storing something like this, right? Let's say visit date and customer ID. Now as such, we are not storing any quantitative columns like sales, quantity, but visit date, let's say I have 1 January, and customer ID is, let's say, cust 001, right? So this is a factless fact table, right? Cust, it doesn't have any fact, but we can derive some fact from this. Okay, great. So this is type of fact table. Now you have a dimension tables, and one of the important concept is what is slowly changing dimension, right? So slowly changing dimension, SCD, it is in short called as SCD, changes in dimensions data over time, right? So SCD handles changes in dimension data over time. So whatever changes are happening in a dimension table, that we will handle using SCD. So there are mainly three types of SCT. There are more, but these are more popular, right? SCT type 1, overwrite existing value. 2, add new row with the new surrogate key and effective dates. Type 3, add new column to track previous value. Type 2 is most commonly used in real systems. So let me quickly show you with our example, right? So for example, let's take this example, right? Let's say, sorry. So let me maybe take it in a new sheet and then I will explain all three kinds of SCD. Okay. So let's say I have one more column, let's say city, customer city, right? And let's say city, I don't want in caps, let me, yeah. So let's say it is Mysore, right? Bangalore, and let's say this is Delhi, and this is Mumbai. So all good, right? Now, if it was a OLTP system, right, it was more normalized and all, and but I'm just telling, right? So instead of, let's say Ankit Bansal is moving from Mysore to Bangalore, right? So I will just update Bangalore here in OLTP system, right? In OLTP systems also, in the system you will see, okay, Ankit is in Bangalore, and they will not know where Ankit was previously, right? So now if we want to handle all those kind of scenario, we have slowly changing dimension, basically SCD, and we have type 1 first of all. So type 1 is very similar to how OLTP handles it, right? It doesn't maintain the history, right? So let's say this was the data initially we had, right? I'm talking about SCD type 1, and we have, let's say, one more column, last update date, last update date, right? So initially, let's say on 1st Jan, this was the data. Okay. Now what happened on maybe 10th Jan, right? Ankit moved to, let's say, Bangalore, and he updated this. Now in SCD type 1, what we will do, we will just update it to Bangalore as it is, and we will say last update date 10th Jan. That's it. We are not maintaining any history, right? We don't need any customer history, right? If that is my requirement, I will go with the SCD type 1, right? Okay. Now what if I want to maintain history? I want to see where he was over the period of time, right? So then we will have type 2. In type 2, we maintain the history. So let me go here and let's call it type 2, right? And let me copy this again. And okay. Now initially, so let's say, so in this I have to maintain two more columns. So I'll just tell you how and why. Effective date, and I will have one more column that will be end date or expire date, you can call it anything. So initially this was the condition, right? 1st January everything was like this, right? And end date I will keep some high date, 9999 12 31, right? 31 31 31. This is how it will be initially when the data was loaded. Now again on 10 January, Ankit is moving to Bangalore, right? So I want to keep that information. I don't want to lose that information. So what I will do, I will insert one more record. This is my surrogate key, by the way, right? And it will have cust 001, right? This is, let's say, primary key coming from my OLTP system. This is what I'm assuming for now, right? This is my primary key coming from the OLTP system. And I'm creating a surrogate key here. Great. So again, customer 001, Ankit Bansal, right? Mail, everything will be same, right? And then age 18. Now it will be Bangalore, right? And I will say from 10 January, this is the situation. And I will insert again 9999 12. Okay. This is fine, but there is a problem, right? So if I want to see on 11 January where Ankit was, so this So basically, I will say on 11 January which records are active for Ankit Bansal. So this is active because it starts from 10 Jan, goes till high date. And this will also be active. So how I will know where he is? So what I will do, I will also have to expire the previous record. Right? So when I'm finding, okay, Ankit Bansal city has changed. So whatever was active record earlier, I will update it with 9 Jan. Which means till 9 Jan, this was correct for Ankit. But from 10 Jan onward, this is the latest status of Ankit. Right? So at any point of time, I can see. So from till 9 Jan, Ankit was in Mysore, and from 10 Jan onwards, this. Now let's say again he is changing. Right? Let's say, so this surrogate key will be unique. It will keep on changing. Right? This is a unique key. Right? But this customer ID can repeat in SED type 2 table. Right? So let me take again. Right? So this will be 6. Right? Customer ID will be same because this is a primary key. And now again I will say, okay, on 20th January, let's say, he moved to Mumbai. Right? So this will be my Mumbai. And from 20th January, this is the record, and this I have to expire. So this is how I will maintain the STD type 2. Right? So in that way, the primary key, whatever was there initially from your OLTP system, can duplicate. But then you will create a surrogate key which will be running. And this surrogate key will go in the fact table. In your fact table, this surrogate key will go. So any orders which came before 9 January, in that, so let's say you have an order table here. Right? So you will have order ID and let's say customer ID. Right? So whatever, let me take order date as well. And customer ID. Right? So let's say there was order which came on 5th Jan. Right? So in that, customer SK, sorry, we keep the customer surrogate, the dimension surrogate keys. Right? So any order which came on 5th Jan. So for 5th Jan, I will say, okay, this record was active. So I will have 1 here. Right? Let's say same customer again place same order. I mean order on let's say 12th Jan. Ankit. So I will say, okay, customer ID is 001, right? Because it is coming from source system. But on 12th Jan, which record was active? This record. So I will have surrogate key 5 here. So when I join back, I get exactly when this order was placed, he was in Mumbai or whatever. And when this order was placed, he was there. So I have all the history. Again on 3rd, let's say he has one more order, right? So let's say now he placed order on 1st Feb. Right? Now on 1st Feb, which record is active? This record, right? After 20th January till eternity until he changed again, right? This is the active record. So I will say 6, right? So this is how this will help me. So this is how I will keep the surrogate key here, right? Great. So I hope you understand what is SED type 1 and type 2. Let's talk about SED type 3. Right? This is a simple one, right? Let me take again this one. Okay, so initially this was the state, right? Now here what will happen? We will have last city as well. Previous city maybe. One more column. Previous city. Right? So initially it will be null, null, null. So this is the first order. There is no previous city as such. Now on 10 January, right? Again, Ankit is moving from Mysore to Bangalore. Right? So what we will do, we will say, okay, the new city is Bangalore, but previous city is Mysore. Right? So on 10 January, I can have last update date as well, maybe. Here, last update, if I want to keep it, right? That will be 10 Jan. So I'll say the latest city is Bangalore, but whatever is the current city, I will move it to previous city. And here I will have Bangalore. So I'm just keeping information of current and previous value, not all the history. Now again, when Ankit is moving to Mumbai, so again, let's say it is on 20th January, right? So I will update it to 20th Jan, last update, right? Current city will go to previous city, and this will become Mumbai. Right? So only the previous city information I have and the current city, not all the history. Right? And that's why STD type 2 are popular, because we have all the history. I hope this makes sense. Okay, I hope this is clear. Let's move on to the next question. Right? Why do we use surrogate keys? Right? This is a very common question. So surrogate keys are system generated unique identifiers. There are multiple reasons, right? One is required for STD type 2 table. So we just saw, right? We just saw in STD type 2 table, the primary key which is coming can be duplicated. So if I want to keep the reference in my fact table, what I will keep, right? If I keep customer 001 here instead of surrogate key, then this customer 001 has multiple records, right? Then how I will know which record I should join with? I will have to make a filter that okay, order date should be between this and this. So instead of that, I created a unique key and I'm keeping it here. So I just join it and I will get it, the information, right? So in STD type 2, it becomes mandatory to have a surrogate key. So that is one reason. Second reason is, let's say even if it is STD type 1, let's say, and this is your primary key coming from source system. Now you don't want to keep a string as a primary as a surrogate key in your fact table, right? Because joins will be slow. So even if from source system something is coming as a string, you want to create a integer key so that you can do joins faster, right? So that is the second reason. So if you see, improves join performance, because we are creating an integer column as surrogate key and keep this surrogate key in the fact table, right? So that joins will be faster. Third is business keys can change and avoid dependencies on source system. Now I was telling you that the data can come from multiple systems, isn't it, in your data warehouse, right? So for example, you have, let's say, online system, you have offline system, you have orders, Oracle system, right? Or you have maybe a SAP system, right? So it might be possible that they are maintaining customer information separately and everyone has the same naming convention. So everyone is storing something like cus001 from SAP. Let's say this is coming from SAP, right? And this is a different customer. It might be possible, right? And then from Oracle, right? One customer is coming. They are also following the same naming convention, and but this is a different system, right? Now you can't keep this cus001 as it is in your data warehouse, right? Because you will never know that okay, this and this are different. If you keep just cus001, then there will be a problem, isn't it? So what you will do, you will identify, okay, this is a different customer. From source system, primary keys are same, but when I'm loading into customer table, I will have a two separate record, 1 and 2, right? So any customer coming from SAP system, if cus001 is coming, then I will use 1 in my fact table, right? Similarly, if cus00 coming from Oracle system, then I will use 2. So I identify these are two different systems, right? So source system dependency we can remove using surrogate key, right? And tomorrow maybe some other attributes are changing from source system. They are changing how it is maintained. So we don't want to depend on source systems naming convention and all. We want to create our own surrogate key so that we can keep it in dimension and fact tables. Okay, so that it is. Right? ETL, ELT we understand, right? Extract, transform, load. Transformation happens before loading into warehouse, right? I explained it. In ETL, right? Transformation, so we don't have, so transformation will happen here, maybe from data lake, and then we will load directly, right? But in ELT, we load the data as it is, do the transformation here it is, as it is, right? And we will have a staging layer and DW layer within my data warehouse, and this is extract, load, and then do the transformation. So this is your ELT, right? ELT is extract, load, transform. Raw data is loaded first, transformations happen inside warehouse. Modern cloud systems prefer ELT because they have powerful compute engines, right? So earlier the databases and all we used to use for data warehousing were not very powerful in terms of compute. So we had to use the ETL tools, but they are very powerful now, so we can use directly those systems. Okay, now what is data mart? So you know data warehouse. So what is data mart? Data mart is a subset of a data warehouse focused on a specific department. Example, finance data mart, marketing data mart. It improves performance and access control, right? So I created a data warehouse, big data warehouse, taking data from all the systems. But I can have a different teams focusing on different data, right? So we can have a finance team, we can have a marketing team, right? So what we will do, we will create a subset of data warehouse, a small data warehouse, right, specific to the data related to finance, right? There are a lot of data in data warehouse, but I'm saying, okay, whatever finance related data, I will get it, all the related columns for finance and related rows as well, right? So I will filter out rows which are not related to finance, and I will get only the columns which are related to finance for my analytics. So I will create a small data mart, right? It will look similar to data warehouse, but it will have specific data in terms of column and rows, and we may do some transformations also as per our requirement for finance. Similarly, marketing team can create their own data mart, right? So it is domain specific basically, right? This is your data mart. Okay, now we have different kind of dimensions, right? We have confirmed dimension. A confirmed dimension is shared across multiple fact table. Example, date dimension can be used in sales fact, inventory fact, shipment fact table, right? So what does that mean? So for example, let me go back here, right? Now, or let me go to the fact tables, right? Then it will be more clear, right? So generally we store order date, right? But we can create a order fact table. I mean, it is not a type of fact table. I'm just telling, sorry, calendar table. We can create a calendar table, right? So calendar table have what? So let me copy this. Sorry. Okay. So I will have calendar table and I will say ID, right? And here we will have date. Then we will have day, weekday, let's say, right? And they will have month number, right? Then we can have, let's say month for now, right? Then we can have quarter, right? And then we can have only day, right? So let's say, so this is my ID, calendar table, right? And I will have date. So let me copy it from here. Okay, so this is 1st March, let's say 2nd March, this is 3rd March. So this is a very common in data warehouse, right? You have 4th March, right? So for each date you will have one row, right? So yeah, let's say you have 100 years of data you will store in this, let's say from 1900 to 2099, maybe 200 years of data, right? You will keep it, and for each day you will have one record, right? So this is your 1st March, 2nd March, 3rd March, 4th March, and so on and so forth, and you will have all this value. So maybe this is Sunday, this is Monday, I don't know what was exact date, I'm just telling you this is Tuesday, right? And then you will have Wednesday, right? And then you will have month, so this is 3, or maybe I can say March, sorry, right? And similarly, you understand, we will have quarter value and day value, like it is 1 first date, 2, and we can have other attributes of date. So I will maintain a calendar table, right? Now instead of storing order date in my fact table, I can store this ID, right? So I will store 1, 2, 3, 4, or 1, 1 here and 2, 2. This is 2nd March, so 2, 2 and 1, 1. And then I can join with this and get all the attributes of date. Because if let's say you want month wise sales, so what you have to use? You have to use month function. Tomorrow you want quarter wise sales and you will use quarter function. So instead of that, you can just join it and get all the attributes of that date, right? So this date table can be used with multiple tables, right? It can be used with the transaction fact table. It can be used in your data warehouse with another snapshot fact table. There also we have a snapshot date, or we have the accumulating fact table, accumulating fact table, right? So there also we can store, see this ship date or deliver date, order date, everywhere we can place 1 to whatever the calendar ID is, right? So table, a dimension table which can be used at multiple places is a confirmed dimension, right? Let me read it again. A confirmed dimension is shared across multiple fact tables, right? Example, date dimension, sales fact, inventory fact, shipment fact. This ensures consistent reporting, right? Then we have a what is degenerate dimension. A degenerate dimension is a dimension attribute stored in a fact table without a separate dimension table, right? Example, order number, right? Now order number is not a numeric field, right? But again, I cannot have a separate dimension table because with order number there is no other attribute, right? And similarly invoice number. So for example, you will see if you go to your Amazon, right? Order number will not be something like 12345. It will be something like this. So let's say maybe ORD 001 2000, some naming convention they will have, right? Some big number, right? So this is a degenerated dimension, right? It is not a sales attribute or quantitative field. It is a dimension stored in a fact table itself. It is a dimension stored in a fact table itself. Similarly, invoice number you can have, right? And this is known as degenerate dimension. Okay. Now next question is very important question. How do you handle late arriving dimension, right? Now what is late arriving dimension, right? So late arriving dimension means, again let me go back here, right? Yeah. So this is your where is my fact table? So this is my fact table, right? Let me make it bold, and this is my fact table. Okay. Now what happens typically? There is a question also, I think next question, that what is loaded first? Do you load the dimension table first or the fact table first in your data warehouse, right? Now you will know, you should know by now that we have to load the dimension table first, because in dimension table we have to look up on the dimension table and get the surrogate key, right? So if a customer, it is not, so if a customer, let's say if I load the fact table first, then what will happen? Let's say some new customer is coming, customer 005, right? Now if this customer is not there, sorry, customer 005 is coming. If this customer is not there in my dimension table, how I will keep the surrogate key, right? So I will make sure first I load the dimension table so that cust 005 will come here, right? And I will have a corresponding surrogate key, and then I will load it here, right? In the my next order, right? So always dimensions will be loaded first, right? And then the fact table. This should be clear, very clear to you. Otherwise, how we will store the surrogate key, right? First, it should go in dimension table. Now, late arriving dimension means, let's say for whatever reason, right? In your dimension data, this dimension is not coming, right? Let's say an order came where you have cust 005. Let's say, let me delete it. Let's say from your source system in orders table, one record is coming where customer is cust 005. This is your primary key, right? Now let's say for whatever reason in dimension table that data couldn't come from source because of whatever system glitch. So what you will do? So what you can do, you will store that transaction here for, let's say, 2nd Feb, right? And then you will store it as -1. You will store it as a some dummy value, maybe 99999, right? Or some negative value. So you know that these are late arriving dimension, right? So you will store it as a -99999, right? Later, maybe tomorrow, this customer will come, right? That time you can do a lookup and update this value, right? So this is how you can handle the late arriving dimension. This is one of the method. There are multiple methods like delay fact load. We don't load it into the fact table. We move it into a reject table, right? So there are multiple ways of handling it, right? Most common approach is create placeholder record and update when dimension arrives, right? So we create a placeholder records and update it later, as I showed you, right? Which should be loaded first? Dimension table should be loaded first before fact tables, because fact table contains foreign keys that reference to dimension table. I hope you understand. Okay, what is junk dimension? A junk dimension is a dimension table that combines multiple rows, multiple low cardinality unrelated flags or indicator fields in a single dimension table, right? It helps avoid creating many small dimension tables, right? So sometimes we have some flags in a tables, right? So instead of storing multiple times in the fact tables, we can create a separate table. So for example, let's say our sales table has these many attributes: is gift, is discount applied, payment type, order source, right? So junk dimension, what we will do, instead of storing this information, these flags in a fact table, right, we will create a separate table, right? So we will have a junk key, and it is kind of a separate dimension table, but these attributes are not related, right? Generally, if I have a customer table, so it will have customer related information. In junk dimension, we will have all the dimension which don't have any other attributes and they are not related. So for example, is gift, it will be y or n. Now I don't want to clutter my fact table with so many flags. What I will do, I will combine them. So for each order, I will have a one row: is gift, is discount applied, payment type, and I will create a junk key, and I will put a junk key in my fact table, right? And then I can join and get all the attributes. There's no data redundancy as such, we are not doing that, but the only thing is my fact table is clean, right? So characteristics contains low cardinality attributes which have generally these values. Like low cardinality means low distinct values, n, y, or source will be 2 3, or payment type will be credit card, UPI, debit card, 2 3 kinds of payment type, right? Attributes are not directly related to each other, right? These are not related to each other as such, right? Reduce clutter in fact table. So in fact table, my fact table will look more clean, right? Improve performance by reducing repeated columns. Okay, great. Next is what is role playing dimension, right? Same dimension used multiple times in a fact table for different roles, right? So we have this example of this accumulating fact table, right? So if you remember this accumulating fact table, right? So if you see, we have order date, ship date, deliver date. These are different dates, right? But the same calendar table can be used here, right? So that calendar dimension is a role playing dimension in this case, right? Because for this column, it is acting as a orders date. For this column, it will be acting as a ship date, right? We will have a calendar ID here, order date ID we can put. Here it is behaving as a delivered date. So same table, but behaving as have a different role in the same fact table, right? So let's read it. Same dimension used multiple times in a fact table for different roles. Example, date dimension can be used as order date, shipment date, deliver date in the same table but different aliases, right? So this is your role playing dimension. Okay, now this is important. What is the difference between row store and column store, right? So the databases, OLTP databases are row store, right? So let me write it. OLTP databases are row store. Data is stored in form of rows, and OLAP, data warehouse, we call them data warehouse, have column store. Okay, now we will see how they are different, right? So row store databases store data row by row. Column store databases or data warehouse store data column by column. Row stores are optimized for transactional workloads, as I said, OLTP. Column stores are optimized for analytical workload, right? So this is how it is. So when you store data in a database or data warehouse, ultimately that is getting stored in a file somewhere, right? Everything is inside file but in a different form. So your data will be stored something like this. So let's say you have order ID, name, city, amount. In your row store, in your OLTP system, it will be something like this. Right? Full row is stored together in your file as well. Wherever underneath it is stored in this format only. Right? But in column store, data is not stored like that. What it will do, it will store all the order IDs together. Then it will store all the name together. Then it will store all the city together. Then it will store all the amount together. Right? And it will bind by, there are many ways, but maybe you can say by the position. So first position, so it has to know for order ID 101, who was the, let's say, name, city, amount. So it will check first value. You can imagine it as list, right? First value of the list. So you can pull first value of the list from each column and it will give you one row. This is how it will work. Right? There can be different ways, but this is the simplest way I am telling you. Let's say this is how it is stored, right? So each column is stored separately, but by the position. Okay, at the first position, what all values are there, that makes one row. On second position, whatever values are there, that makes second row, right? Now, why it is like this? Why in a database or in column on OLTP system, why we store like this, and why in data warehouse we store like this, right? So for row store, what we need best for inserts, updates, deletes, single record lookup, right? So for example, we need for order ID 101, get me entire row, right? This is what is needed. So you go to Amazon and you see, okay, give me entire order detail, right? So you will go, and for 101 you need entire order detail, so you will get only one row. So in OLTP, you need less number of rows always. You always have a where clause. Okay, only for this customer give me information. Only for this product give me information. You never have to read, or you never have to get data of multiple customers or multiple orders together. Most of the times, it is out of millions of rows. You need only few rows, right? So these rows are together. So if you need data for two rows, all the data is together, and you can get it easily, right? So this works for OLTP system. In column store, we need for aggregation, filtering on few columns, large scan, reporting queries. So we have reporting queries something like this. So let's say we have sum of amount from sales. So what I have to do, I don't have to read anything. If I have to get sum of amounts, I can just give from here, isn't it? If my query is give me sum of amounts, I don't have to read all the data. I can just get data from here, right? I will say 1500, right? Let's say someone is saying get me city-wise sales. Again, you don't have to read all the data. You just have to read data from these two columns. So in analytics, we always have to read data from few columns. We never read all the columns. So what is the point of storing them together? Why to scan them? We will just store column wise, and whatever column data is needed, I will read it. So city wise sale, I will just read these two columns and get the data. It will be faster, right? So this is the internals, right? I was telling two things. One is how data we store in form of normalized and denormalized thing, right? Like entities, and we have the dimensional modeling. And systems is also designed in a different way. Here data is stored in a internally row store, and here it is in a column store, right? So I hope this makes sense, right? Column store reads only amount column, row store reads entire row. Huge difference in IO. Great. So this is quick comparison. You can read row store, column store, right? And row store, if you have to give an answer, row store is optimized for transactional system where full rows are accessed frequently, while column store is optimized for analytical systems where large aggregation on selected columns are common. Okay, great. Now we are on to the last and most important question. What is the difference between data lake, data warehouse, and data lake house? Okay, so these two things we have understood already, data warehouse and data lake. So let me go back and then I will read it. Okay, so I have this data lake where I'm just dumping the data as it is, right, in form of files, right? And then I'm doing ETL processing and all, and in a nice way that I can use for analytics, I'm dumping data in a data warehouse. So this is the difference between data lake and data warehouse, right? Now there is something which has come now, which is data lake house. So what data lake house says, you don't need a data warehouse system separately, right? On top of this system, we will add database like properties where you can insert data, delete data, and do all of this, right? So this is file system. You cannot do anything. Once the file is uploaded or dumped in your S3 or Google Cloud, you can just read it. Nothing much you can do. But what data lakehouse says, that we can build a system on top of your data lakehouse, right? Where you can do all of the database like things. You can insert data, delete data, you can have ACID properties, right? Using transaction logs, right? So data lake, let me increase the width a little bit, right? And we will have some transaction logs. How it will be, that is a different topic, right? It takes a lot of time, but you just understand. We will have just some logs, and it will behave like a database or data warehouse, right? Where you can, so in this we cannot access record by record, we cannot do insert, delete, we don't have ACID properties like atomicity, durability, but he can we can build on top of data lake plus add transaction log, and it will become a data lake house, right? Right, so you don't need a separate system. On top of data lake you can build your data lake house, right? So let's read it, then it will be clear. A data lake is a centralized storage system that stores raw data in its original format. Schema on read, right? So you just dump the data, and when you are reading it, then you create the schema, right? It stores structured, semi-structured, and unstructured data. So all kind of data you can put in your data lake. It can be image, video, or Parquet file, CSV file, doesn't matter. Cheap, very cheap, right? Minimal transaction transformation before storage. So there is no transformation. You just get data from your OLTP systems and dump it. That's it. Okay, example Amazon S3, Azure Data Lake Storage, ADLS. Right? Problem is no strong governance, data quality issues, can become data swamp, and BI performance not optimized. Right? Now, what is data warehouse? A data warehouse stores structured, cleaned, and transformed data optimized for analytics and reporting. Right? Schema on write. So when I'm writing the data, that time I define my tables and all, right? So when I'm writing data after transformation and all, I will define my schema. So it is schema on write. Here we don't define any schema, right? We just dump as it is. When we are reading, that time we see, okay, what should be the schema and all. Okay, so strong governance, we can do governance, that who will get what access, table level access, database level access, schema level access. We can do all of that. Optimize for SQL queries, high performance analytics. Example, Snowflake, Amazon Redshift, Google BigQuery. Limitation of data warehouse, mostly structured data, right? We can have only structured data, less flexible for ML and row exploration. Storage can be expensive. So when you store data in data warehouses, right, they have good amount of cost, more than this, right? But storage is still cheap here, but obviously more than this. Okay, great. Now what is data lakehouse? A data lakehouse combines benefits of both. Data lake is storage flexibility, data warehouse performance and governance, right? It provides asset transaction, schema enforcement, support for BI and ML, and unified platform, right? Example, Databricks and Snowflake also now doing similar kind of thing, right? Great. So this is a comparison, right? You can just read it. It should make all sense. And this can be your interview closing line. Data lake stores raw data. Data warehouse stores curated structured data for analytics. And data lakehouse combines both to provide warehouse level reliability on top of lake storage. Okay, great. I hope you like the session. Please do like the videos, because it took a lot of effort to create all of these notes and creating all of these questions and recording it. So share with your friends. Do let me know if you have any questions. If you want these notes, check out my pinned comment how you can get these notes. Thanks for watching till here. Have a good day. Today we are going to do for Python last minute interview prep video. Now what we will do in this, first I will explain you, I will tell you that what all topics are important, right? Kind of I will give you a roadmap that these topics are important, what all you should learn as a data analyst, what are the topics, and as a data engineers, what are the topics. And then I will start solving some questions one by one. I will start with some easy questions, then medium, then difficult. We will talk about how to optimize these questions, how to optimize these solutions, and how to check what is the time complexity, right? So when you go for interviews, you might solve a question, but you might have not got the as per expectation, because it might be taking more time than expected, right? So we will discuss how to approach those kind of questions, right? Make sure, if you are not very confident about Python, you practice along with me. I will show you some resources also along the way where you can practice Python questions for free, right? So focus on this video, watch end to end, and by the end of the video, you will feel very confident going into the interviews. Okay, so let's get started. So first, let's see what are the important topics and what are the things that you should know before you start solving the questions for interview. Okay, so I have divided Python interviews in two parts. One is coding and one is analytics. So we will see what is there inside each one of them. So if you go to coding, right, there are two things. One is what are the topics you should learn, right? And then what are the patterns, basic patterns that can be asked in your interviews. Okay, so if I go to topics, these are the bare minimum topics that you should learn. And these are the good enough topics to crack any data analyst or data engineer interview. At least 95% of the interviews revolved around these topics, right? So we have variables, if else, loops, strings, list or arrays, dictionary, hash maps, right? Sets, tuples, functions, working with file, exception handling, and big O notation, right? So these are the things. If you know, if you are very much clear about these things, then you can easily solve questions asked in data analyst and data engineer interview, right? They are advanced topics, they are advanced data structures. Like for example, you have queues, stacks, you have more advanced topics like dynamic programming, linked list. You can learn that, but I'm telling you, 90-95% interviews can be solved, can be cracked using these topics, right? Because see, most of the interviews for data engineers and data analysts are not very hard Python questions, right? They are basic questions or medium questions. They don't ask hard questions. Very specific data engineer roles, right? Maybe some platform engineers or maybe 5 to 10% maximum, right? Those requires those advanced concepts. For you as a data analyst or data engineer, 90% of the time these topics are enough, right? So focus on these topics. If you are very good on all of these and the patterns that we will discuss, then you can learn more things. But if you learn these things, then it will be more than enough, right? So you should learn this. This is Python fundamentals: how to work with list, what is dictionary, what is set, tuples, what is function, how to work with files. So all of these things you should be very comfortable. I will not teach you in this video. This is an interview prep video. So if you don't know all of these things, then you cannot do interview prep, right? So you have to understand these things first, right? If you are a complete beginner in Python, like you don't know all these topics, you are not very good with fundamentals, you don't feel very confident, then you can simply go to namastesql.com, go to courses, and then we have a Python for Data Engineering course. In this, we have covered all of the important things that you need to know as a data analyst or data engineer for Python, right? We have covered what all topics I just discussed with you. Everything is there. And apart from that, also, we have a lot of other things, right? So, for example, all the basics are there, working with NumPy, Pandas, and we have in-depth Pandas video as well. We have sessions on how to create ETL pipelines, work with databases, different kind of files, how to work with AWS. All of those things are also there. These things are mostly data engineering focused, right? They will not ask these things in interview, but in your day-to-day work, you will have to do all of these things, right? Interview will focus on from here, from second lecture till I think pandas, right? Maximum till here, right? All of these things are your day-to-day work that you have to apply, right? So it is an end-to-end project which will really help you in getting your Python hands-on and feeling confident, right? You can see the reviews as well. We have very good reviews for this course, and all are organic reviews. I don't ask anyone to give some good reviews or fake reviews, right? So you can check it out. And okay, so once you are comfortable with these things in Python, then there are different patterns on which questions can be there in your interview, right? So this is very common pattern, like you have a dictionary and you have to count something, right? We will see a lot of examples on that. Then there are problems on array plus dictionary, right? When I say array, in Python, arrays are list basically, right? So array and list is the same thing. So if I am saying array or list, they are both same thing. Similarly, dictionary and hash map, it is the same thing, right? In Python, we call it dictionaries. In some other languages like Java, they are hash map, but they are the same thing. Okay, then we have string problems, right? So there are a lot of questions asked about string, how to work with string, and there will be a good question where you have to manipulate string and do a lot of things, right? Then you should know what is binary search, right? What is two pointers? So some problems can be easily solved using two pointers. Without two pointers, the solution will not be optimized. But with two pointers approach, we can have a better efficient solution. Then we have set based problems, right? Sliding window, sorting, reversal, and then parsing logs. This is specifically for data engineers, right? How to parse logs, how to get some information from the logs. So these are the important topics, right, that we need to solve problems on, right? So I will start with the basic things and then I will move forward with more things. Now I'm not going to cover these things, right? I will talk about time complexity, right? Because when I'm solving questions, I have to tell you, okay, this is the time complexity, and if you solve this way, this is the time complexity. So when I'm solving questions, that time I will tell you what is time complexity and how to go about it, how to think about time complexity. Okay. So these are the things, these are most important and cover 90% of the interviews, right? So you should be good after finishing this video. Okay. Now second thing is analytics. Now in analytics, basically for data analysts, some questions can be asked on pandas, right? And maybe data engineer, but this portion is typically rare, right? Most of the companies, product-based companies, service-based companies will focus on these things because as a data engineer, you will not be working on pandas mostly. You will be working on maybe PySpark, right? But you should know it. I mean, working with pandas, you should know it. A lot of organization still uses it, but I don't think many of the interviews ask this. They can ask, but I'm telling you, mostly they are not asked. Mostly it is around these two topics, right? These are the topics and these are the patterns. Now in pandas, also we have few things that you should focus on if you are learning pandas, right? Group by aggregation, filtering, sorting and top end, merging or joins, how to write ETLs using pandas, window rank functions, right? In this video, I will not cover this. If you think there is a good amount of interviews which are asking these things, I can create a separate video, right? But I want to focus on the most important 90% of the things, right? So we will focus on these things today, right? And maybe in the next video, I can talk about this if there is a good amount of requirement in the comment section. Okay, I hope this is clear. Let's start with the practice sessions. Okay, so let's understand what is time complexity, right? Let's read the definition and then I will break it down step by step. So, time complexity is a way to measure how the number of operations in an algorithm or program, you can write anything, right, grows as the input size increases. It does not represent actual time taken, but how efficiently an algorithm scales. It helps compare algorithm independent of machine speed or programming language. Now, a lot of people think that time complexity means the time taken by a program, which is wrong because time taken by a program is dependent on machine, right? If you are running a Python program or any program on, let's say, 8 GB machine, it will take some amount of time. But if the same program you run on, let's say, 16 GB or 32 GB machine, then it will take less time, right? So the time taken by a program is not fixed. It is dependent on machine, but time complexity we measure independent of machine, right? It does not represent actual time taken, but how efficiently an algorithm scales, right? So this thing should be clear, right? That time complexity is independent of a machine speed or which programming language we talk about, right? We just a relative measure to check how good my program is. So we will understand with a simple example first, right? So let me move on to Visual Studio and I'll explain in a very intuitive way. Let's say you have this array, right? Array or list. In generally most of the programming languages you say array. In Python it is a list, right? List is a group of elements together, right? So we have 1, 2, 3, 4, 5, 6. Okay, so this is my input, right? This is my input. This array is my input. Let's say I want to find sum of all the elements of this array, right? So what I have to do, I have to start with this, then go to this, then add this, then add this, then add this, then add this. So if there are 6 elements, I will have to do 6 operations, right? So let's write a program. So let's say my sum is, or let's define a function, define get sum, right? And it will take one array as input, right? So what we will say, we will initialize my total sum. So I will say total sum equal to 0. right? Now I will run a loop over it, right? Because I want to go to each element. So what I want to do, I want to run a loop over this list, right? I want to go over, iterate over this loop and go to each element and sum all the numbers. So I will say for num in, right, add, and then I will say total sum, right, equal to whatever was sum was there earlier plus this num, whatever num I get, right? So I'm getting 1 2 3 4 5 6, right? And I will just run over it and then I will say return my total sum. I hope you understand this. So I want to see how many times I'm doing this operation, right? So I'll say print and I will just call this function now. So I'll say get sum and I will pass array, this array, whatever we have declared here, right? And let's see. Okay, so it is giving me 21. So if you sum all of this, it will give you 21. Now, how many times we are running the loop or how many times we are doing this operation, right? So let me print it. So I will say iteration. We will see how many iteration are there. Iteration equal to 0, right? And then in the loop, I will say iteration equal to iteration plus 1. And then I will say print iteration and then iteration, right? I'm just showing you how many times we are running this loop. So if you see iteration 1 2 3 4 5 6, right? So there are 6 elements. I'm running this loop 6 times, so I'm doing 6 operations, right? Let's say if I increase one more element here, right? So how many times this will run? 7 times, which means as the size of my input is increasing, the number of operations are increasing linearly. Linearly means if there are 8 elements, then number of operations are 8. I am doing 8 operations. If it is 9, then 9 operations. If it is 1 million, let's say in this array I have 1 million elements, then I will run this loop on 1 million elements and there will be 1 million operations, right? So this is known as a linear time complexity. We represent time complexity by big O notation O and then N. Right? So this is N means linear time complexity. As you increase the size of the input in the same proportion, your number of operations will increase. Right? Now it is irrespective of machine. Right? The way we are calculating this complexity, big O N, is irrespective of machine. Right? We are saying as the number of input size is increasing, is the number of operation increasing? Now it will be true for 8 GB system or 16 GB system or for Java or Python or any language, right? So this is why this is platform or program and speed independent, right? This is how we calculate the time complexity. Great. So if I go back here, it is saying ON is linear time, right? So our example is loop over the list. So you can draw a chart, right? So if you see this chart, so on the x-axis, I am saying input data size, right? As the size of the input data increasing, how the number of operations are increasing. So in case of linear time complexity, right, ON, this is linear. So as the input size increasing, in the same manner, my number of operations are increasing. So if you see, this is x equal to y, right? The number of input data size equal to number of operations. So this is the x equal to y line on your chart, right? So this is your ON, right? Lesser the time complexity, better your program is, right? Now let's take another example. So this we understand. Now let's say my requirement is I want to get the first element of my array. So this is my array, right? Let me just comment this. So this is my array and I want just the first element of the list. So what I will do, L, and first element will be 0, right? And I will print this. So let's print it. Okay. So if you see, I am getting 1. So this is giving me the first element. Now let's say I increase the number of elements in my array, right? Now if I again run this, I am always doing one operations. it doesn't matter how many elements are there in my list, right? The number of operations will be just one, get the first element of the list. So this is known as constant time complexity, that the time taken or the number of operations done by your program is fixed irrespective of how small or big your input is, right? So this is known as O1. It will take fixed O1 time. Right? So this is your constant time complexity, where it is constant irrespective of input size. And if you look at the chart, this is my O1, right? This is flat. Doesn't matter that how big is your input data size. If we keep increasing, the number of operations is constant, which is one. So there will be only one operation. So this is known as constant time accessing an index in the list, right? So this is your O1, On. So O1 is better than On, right? Because it will just one operation, right? So always if you go up, it is the worst time complexity, down it is the best. So O1 is best, and after that On. We will talk about other time complexities as well, right? Now let's take another example of On, right? Let's say I have this array now, right? Now, what I want to do, right? This can be a sorted or unsorted array, right? Let's not take it sorted. So let's take it 15, 11, 12, something. Okay. Now, what I want to do, I want to find index of a particular number, right? Let's say someone is tell me where is 15, right? On what index 15 is there, right? So my target is this, that I want to find index of 15 in my list. So how I will do it? Let's write a program. So I will say def find index, right? It will take two input. One is array and another is target, right? What you want to search. This is also known as linear search. So I'll just explain about it. So what I'm saying, that okay, loop over it and check wherever the target is. So I'll say for, let's take I in range, right? These things you should know already. Length of array, right? So I'm saying if li, right, is equal to target value, right? Whatever target I have, then return that index value, right? That's it. So this is my linear search. You can call it linear search. I'll tell you what is linear search. Linear search. Okay. Now we will see what is the time complexity of this. Okay. So now I will just call this, I'll say linear search, and let's call, I'm passing array, right, and my target, right? Great. Let's print it. So target is 13. The target element, let's call it target element, and I'll just pass this here. Okay, let's see what it will give me. Okay, so it is giving me 9, right? 9 means, so if you count here 0, 1, 2, 0, 1, 2, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, right? So it is at ninth index, right? So the 15 is at ninth index. Now let's say I search for 7. So so it will give me where is 7. 7 is at sixth index. Great. Now let's say how many iterations we are doing here. So again, we are comparing this. So this is one operation, right? We are running this inside for loop. So I will say iteration equal to 0, right? And then iteration equal to iteration plus 1. And I'll just print iteration. Okay, let's run this. So if you see, this is running 6 iterations, right? Uh, ta- 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 ta. Okay, it has to be outside the loop. My bad. Okay. So initialization is outside the loop, and then okay, it has to be outside actually if condition, because only it will print only when we satisfy the condition, right? So iteration equal to iteration plus one. Great. Uh, okay, print is again here. So let me just fix this. Okay, so if you see 1, 2, 3, 4, 5, 6, 7, so it is running 7 times, right? So now if you see, the number of operations is dependent on where my element is. If I just, let's say, search for 2, right? So it will run only 2 times. Iteration 1, iteration 2. So there are only 2 operations, right? Now how I will tell what is the time complexity, right? Time complexity depends on that which element you are searching. If you are searching for 2 here in this list, then it is at second element only 2 operations, right? If I search, let's say, 11, then it will run maybe 8 or 9 times, right? So when we talk about big O notation, we consider the worst time complexity. Worst means if someone is searching 12, that is the worst case, right? When someone is searching 12, that time we have to run over the full list, right? So if I run this, it is running 12 times, right? So when I talk about a big O notation, it means we are considering the worst time complexity. That at the worst, how many operations I have to do. So again, this is a ON, because if the number of elements are increasing, if it is 15, then my worst will be one more operation. Right? So it is running 10 times. If I increase one more, right, let's say 20, and again, so it is again 10 times, right? So it is running 10 times. If I make it 20, this is my worst time complexity, which will be 14, right? We have to go till here, right? So whenever you think that what is the time complexity of this program, you have to take the worst case. In best case, it will be O1, right? Because maybe every time you find the first element, right? Someone is searching one, right? You will get in the first iteration itself. But you have to consider the worst time complexity, and in this case, it will be ON, right? So this comes into the category of linear search, that we are searching a element linearly, right? Linear means first element, then we check second element, then third, then fourth, then fifth, then sixth, and so on, right? So this is your linear search. Great. Now let's move on to the next time complexity, right? Which is, let's talk about ON square, right? Then we will move on to the log n. So what is ON square? Quadratic time. Generally, when you have to run the nested loops, right? Loop over loop, that time this quadratic comes into picture, and it is very bad kind of time complexity, right? Because as the input size increases, your number of operations will increase square of times, right? So for example, if you are increasing from 10 to 11, then maybe your operations are increasing from, let's say, 10 to 100, right? I'm just giving one example, right? So let's understand that. So I have written a simple program to find a duplicate transactions, right? So let's say you have a this transactions, you have a array, right? And then what you have to do, you have to find the duplicate transactions. So what I have to do, for example, 101, 101, these are duplicates. So I have to get the index of these. So let me run this and show you. Okay, so I'm getting answer as 0 to 14. So it is telling at index 0 and index 2, they are duplicates. Similarly, at index 1 and index 4, they are duplicates, right? So this is what it is returning. List of tuples. Great. So let's think about it. How do we solve this problem? So what I have to do, I have to pick first element with a very brute force method, right? First element and compare with all the elements, right? So 101, 203, 101, 404, 203. So this element I will pick and compare with all the elements. Then in the second iteration, I will pick this element and compare with all other elements. In the third iteration, 101, and then I will compare with other elements, right? So this is what we have to do. So this is a loop under loop, right? So this is a nested loop. So I'm running a loop on this list first. So if you see on transaction, and then again I'm running on the another loop on transactions and comparing, right? I'm not going to explain this program, but basically we have to run loop two times, right? Whenever you see two times loop, mostly it is a O(n) square time complexity, right? Let's see how many iterations we have to done. So I'll say iterations equal to 0, right? And we will say iteration equal to iteration plus 1. Now I will, so all the operations we are doing inside the second nested loop, right? So I have to print here, right? So for every element in outer loop, inner loop will run, right? So all the operations are happening within the inner loop. I'll say iterations plus 1, and let's print it. Print iteration. Great. So if you see, I'm doing 10 iterations, right? I'm doing 10 iterations for this program. Now let's increase the size of my transaction. Let's say I increase one more, let's say 100. Now what will happen? In each loop, I have to iterate one more time. So when 101 was comparing, it was comparing with four elements. Now it has to compare with five elements. Again, when 203 I was comparing, earlier I was comparing with three elements. Now I have to compare with four elements, right? So as the number of input is increases, it will run loop more number of times, right? So let's see. So there are 10 iterations and I increased one more element. So if you see, now we have 15 iterations, right? It is not linear that if I increase one element, then only one operation will increase. No, let me increase one more. Right? Let's say 101. 101 is already there. That's fine. 1110. Right? Anything. So from 15, we will see it is going to 21. Right? So this kind of cases where you have loop under loop or you have a matrix, right? Let's say you have a matrix. Let's say 1, 2. So this is the first element of your matrix, second, third. Then you have, let's say, 4, 5, 6, right? And then 7, 8, 9, right? If you have a matrix n by n, right? And you have to loop over it, right? So three rows and three columns. So there will be nine elements, right? So it will be O(n) square. You will have to run your loop O(n) square. If you want to traverse over this matrix, then you have to run n into n times, right? So this is where your O(n) square comes into picture, and this is worse than your linear time complexity, right? Because in this, as the input size is increasing, this is increasing quadratic time, right? If you increase 3, then maybe it is 9. If it is 4, then it becomes 16, right? So your best is so far O1 because it is constant. Then you have On and then On square. The whole purpose of our Python programs will be that if we can solve our question with less time complexity. If we can solve this with O1, then great. If not, then On. If not, then On square. Most of the Python problems you want to solve with On or O log n. Right? So we will see what is O log n, and then we will come back to it and we'll discuss the final thing. Okay, so what is O log n, right? O log n is a time complexity where the number of input size when you increase, then the number of operations also increase, but very, very slow, right? It is not like On that if you have, let's say, 10, then operations will be 10. If you have 10 size of your input data, then 10 operations. No, maybe if you have 10, it might be, let's say, 2 operations. When it is 100, then might be 6 operations, right? So it is logarithmic, which means as the input data size is increasing, this is also increasing but very slow, right? So let's see how we can visualize this. Okay, so there's a concept of binary search, right? In SQL also, if you have learned index, you will know how binary search works. So how binary search works, let's say you have an array. I'm just explaining how this works, right? Let's say you have an array and it is sorted means we know that it will be in a ascending order or descending order. So in our case, if you see, this is in ascending order: 1, 3, 5, 7, 8, 10, 13. So this is the requirement, right? That my array is sorted. Let's say my array is sorted. However we sorted it, it doesn't matter. But we are getting an array which is sorted. Now I want to find an element in this, right? One is we do a linear search, whatever we did here. We go to the each element and search it first, second, third, and wherever we find it, we are done. But because my data is sorted, I can do a binary search. Right? Now, what is binary search? Binary search means, let's say someone is telling me, so we have seven elements in this, right? Someone is telling me that find where is, let's say 3, or let's say 10. So I want the index of 10, right? So one way is linear search, we all know. But let's see how we can do with binary search. So what I will do, I will go to the mid of this array. So mid of this array is 7, right? Mid of this array is 7, and I will compare that if this element is equal to 7 or not, right? If it is not, then I will see if it is greater or less than my mid element. Now 10 is greater than my mid element. My mid element is 7 and 10 is greater than my mid element, which means 10 will be somewhere in the right? Because this is a sorted. So I'm checking with the mid element, my target element. I want to see where this 10. So I will check with the mid element 7, right? And 10 is greater than 7, which means that 10 will be somewhere in the right. So I can skip all these left element. I don't have to search. So I will search in 8, 10, 13. Again, I will take mid of it and I will check, okay, if 10 is equal to mid, yeah, mid is 10, so I will return that value, right? Let's take another example. Let's say 1. I want to search 1. So I will check with the mid element, right? If it is equal to mid element, I will return that. If it is, no. Now, if it is less or more, if it is less, then I will ignore these things. I'll just look into this. Great. Now again, I will take mid. If it is equal, no. If it is less, then I will come here and then I will again compare. Then I will return this. Right. So basically, I'm doing a binary search, right? I'm not iterating over all the elements. I will just divide it, check with the mid element. Then every time my input size is becoming half and half and half, right? So let's take this example, right? So I've written this program for binary search. I'm not going to explain today. You can learn about it. But basically, let's see how many iterations we are doing, right? So I'm saying iteration 0 and iteration equal to iteration plus 1, same thing, right? And let's see how many iterations we will do. So I'm just running it. So if you see, it is doing the 3 iterations, right? I'm trying to find 1. My target element is 1, so it is returning 0, right? And 3 iterations it is doing. So I have 7 elements, iterations are 3. Great. Now let's add some more elements. It should be sorted. So I'll say, let's say 20, 21, 30, 33, 40, 50, 70. I just increased so many elements, right? So we had till 10, I think 7 were there. Now we have 1, 2, 3, 4, 5, 6, 7. Okay, I increased 1, 2, 3, 4, 5, 6, 7, 8. I added 8 more elements. So we have 15 elements now. And we will see how many iterations are happening to reach to see where is 1, right? I'll just run it. You see, only 4 iterations are happening. So input size increased almost double from 7 to 8, but iteration increased by only 1. Let's search for something else. Let's say I'm searching for 70, right? So if I search for 70, there are only 3 iterations, right? On the third iteration, it is able to find out, right? If I increase more, let's say 101, 102, 103, right? Again, it is just 2 iterations. It depends on where is your this element, but it will be increasing by very less number of operations are increasing because we are dividing into half, right? If there are 100 elements, we are dividing into 50 first, then 25, then 12, then 6, and then 3, and then 1, right? So we are not doing 100 operations, just we are doing a binary search, right? So you can think about something like this. This is your binary search, right? We look at the middle element. If my target element is less than middle element, I will go in the left. If my target element is greater than my middle element, I will go to the right, right? And then again, I will keep doing it until I find my final element, final target, right? So this is your log n. So capital O log n or logarithmic time complexity, right? So this is your log n. If you see, as the input data size is increasing, it is increasing but very slowly, right? As you have very big size, 1 million, it is almost getting flat. right? So this is your logarithmic time complexity. Example is binary search, right? So there are other time complexities as well, like 2n and factorial and all. But these are the main ones that we need to understand. And in fact, on square also we will be avoiding it most of the times. Right? Most of the times our solution should be in on. Right? I hope this makes sense. Now, last thing I want to tell, or two more things I want to tell is, one is when I sort something, right? So uh, let's go here, or it is fine. Let's go here. Let's say this is my array, right? Or this is my array transactions. Let me comment it. And I want to sort this array, right? So I will say transactions dot sort, right? And then I will say print transactions. Okay. And I will print again here. Okay. So let's see what will happen. So if you see, this is here. And now this is sorted. So 100, 101, 101, 1203 and all. Now this is inbuilt method of sort, right? But we need to understand that how much time it will take, right? What is the time complexity of this sorting? So when I'm doing a sorting, Python is doing some operations internally, yeah, right? There are different kind of sorting algorithm, right? But when we are doing this sort, this takes big O n log n time complexity, n log n. So this will be your n log n time complexity, which will be better than n square, right? But worse than on. So it will be somewhere here between o n log n, right? It will take more than n operations, but better than o n square. So your o n log n will be somewhere here. Right? So your this is how it is. So for example, if I want to find, let's say, largest element or smallest element in this transaction, right? So what I can do, I can sort it, and then if I want the smallest, I will take the first element, right? So I will say sort and then transaction 0. So my requirement is I want the smallest element in my array. So what I can do, I can do transaction dot sort, and then once it is sorted, then I will take the first element, and that will be my smallest element, right? So if I just run this, so this is my smallest element, right? But if you look at the time complexity, so this is O1, right? So to get the first element, it is O1, O1, right? But to sort it, it is O log n, n log n, right? So when we have two time complexities like this, that this is taking so we have two operations. One is taking O n log n and another one is taking O1. So we take the worst one, right? So the total time complexity, we will take it as O n log n for this program, right? Sorting plus getting the first element, the overall will be considered as O n log n, right? So if you have two operations, one with one time complexity, let's say it was O n, and another n log n. So overall we will say n log n, right? So whatever is the worst, that one will be considered, right? So this problem we solve with O n log n. But can we make it better? Can we make this program so that it takes only one iteration and only can we solve it on, right? So we will solve this question next time in the next video. But basically, the idea is you should know that sorting is costlier than on. You should know that when you are sorting something, it is costly than on, right? So your on log n will be somewhere here. Okay, great. So hope you understand it. So generally people will just sort the data, right? And they will say, okay, I solved it. But if you can solve it without sorting with O n time complexity, that will be best. Great. Now last thing I want to discuss is dictionary, right? So when I do a lookup in a dictionary, so let's say I have my dictionary, sorry, let's say I'm saying employee ID and name, Ankit. So this is my key value pair, right? Another value pair is, let's say, 200, and value is Amit, right? Now this is my dictionary, right? Now, when I do a lookup on a dictionary, basically, let's say I want what is the name of ID 100. So I will say print my dictionary, right? And I will pass 100, right? Right. So let's run this. So if you say it is giving me Ankit, right? It is giving me Ankit. Let me comment this everything. Okay. So let's run this again. So if you see, I am getting Ankit. So what it is doing, we are doing a lookup. I am saying, give me the value of key 100. Right? This is my key value, key value. Now you must be thinking that internally this is running a loop, right? Because it will go to first element and see if it is 100 or not. Then it will go to second element, then see if it is 100 or not. Then it will go to the third element. Let's say if they are 1 million. You must be thinking it may be doing a linear search, but that's not the case, right? When you do a lookup on a dictionary, it is a O1 time complexity. O1 constant. How? So what happens when you create a dictionary? It in memory, right? It has the all the values, which means Python will know that at what address in your memory 100 is, at what address 200 is. So when you say my dictionary 100, it will directly go to that address and give you the value. When you say 200, it already know, it has hashed all the keys, so it knows that 200 is where in your memory, right? So it will just go there and give you Amit, right? So this is a constant time complexity when you do a lookup on a dictionary, right? So this thing you have to remember, right? So any lookup on a dictionary is O1 constant time complexity. Great. Now that you understand time complexity, let's solve few more questions. So let's say I have an array or list and we have some elements and that are unsorted. This is not in sorted order, right? Now my requirement is I want to find the largest element or the smallest element, anything. So we will solve for the largest element. The thing will be same for the smallest element as well. Now, how do I find the largest element? Let me make, okay, so 40 is largest in this case. Okay. So how do I find it, right? So one way is very brute force ways. I sort this array. So I'll say array dot sort, right? So once I do it, your array will be sorted. So if I say print array, right? And you see your array is sorted here, right? 1, 9, 12, so on and so forth, right? Now I can just take the last element, right? Once it is sorted, the largest element will be at the end, right? So I can just say array and give me the last element. So I can do negative indexing and that will give me 40, right? But if you see, what is the time complexity, right? So time complexity will be O n log n, right? Because sorting takes what? N log n, right? And this is not the best solution, right? N log n. Okay. Okay. So what else we can do, right? So it is O n log n to sort it, and to get this element will be O1, right? Because this is fixed. No matter what is the size of your array, if you get the last element, that will be O1. So overall time complexity will be O n log n, right? Now the whole point is, can we make it better, right? Instead of O n log n, can we make it O n, right? Can we make it O n? So let's see, can we make it or not? Okay. So what I will do, I will start iterating over this list, right? And I will keep track of the largest element. If a next element is largest, I will replace the variable with the largest one. Okay, confusing? It's okay. I'll explain you. So what I'll say, I'll write a function. So define get largest number. Right? Let's say this is the function I'm defining, and it will take a array as input, right? And I'll say, right? So I'll say largest element, or let's say max num, is the first element. I'm just assuming that first element is largest. So I will say array 0, right? Okay, so currently this is my first element, and I have stored max num as first element, which is 20. Now I will iterate over it. I will check second element. If it is greater than this, then I will assign max num to this number. then again this, then again this, and I will keep doing it. So what I'll do, I'll say for num in, right, for num in this array, right, if num is greater than max num, right, in that case I will say my max num is this num. You're getting it? Okay, so let me tell you what is happening. So first element is 20, and in max num currently 20 is there, right? I'll just write it, right? So in max num 20 is there. Now I will iterate over it. So first element is 20, right? Is 20 greater than 20? No, right? I can start with the first element also, but it is fine, right? Because first element anyway we are taking in max num. Okay, so this will not go inside it, right? So it will be as it is. So my maximum will be 20 after first iteration. Now after second iteration 12, right? Is 12 greater than 20? No. So again it will not go. So we will not do anything. Again 18. Is 18 greater than my maximum? Maximum is 20. No. Then it will keep going on like that. Let me take this as 21, right? Okay, now in the next iteration it will be 21, right? So is 21 greater than maximum? Yes, 21 is greater than maximum. At that point my maximum will become 21, right? My maximum will become 21, right? And that way in the next iteration 30, now 30 is num, right? 30 is greater than my maximum. Yes, then it will become 30, and then at 40 it will become 40, and after that it will never replace it, because 1 will be less than maximum, right? And 9 will be less than maximum, and 30 will be less than maximum. So my maximum will remain as 40 at the end, right? So I have to come out of this loop and I will say return 40, sorry, return maximum, right? So if you see the time complexity here, right, here if you see I am just running loop once, right? So if there are 1 2 3 4 5 6 7 8 9 elements, this loop will run 9 times and I am doing 9 operations. This is one operation, so again O1, and this is On, so overall will be On. So On is better than O and log n, right? So this is how you have to think about it. Let me call this function and show you. So I'll just say print, and I'm passing this array, right? So let me pass array. So if you see I'm getting 40, right? So this is how you have to think about it. Let me just remove this because it is sorted already. Yeah, now it should be fine, and we are still getting 40, right? Let me clear it, and what I want to show it, I will print here as well, so that you know after every for loop where we are, right? So I'll just say print of here, right? Print. So we are within for loop outside if condition, right? So if condition is satisfied or not, I always want to print what is my max num value, right? So let me see what it will give. Okay, so it is saying 20. So initially max num is 20. Then in second iteration also 20. Third iteration also 20, right? Now in the fourth iteration, if you see, it became 21. Now in fifth it became 30, right? Then it became 40, and after that 40 is there always maximum, because we are doing comparison. Only when the num is greater than maximum, then we are replacing it, otherwise it will remain as it is, right? So this is how you have to think about it. Okay, great. So now let's solve next question, where instead of largest element I need to find the second largest element, right? So this is my array, right? In this, if you see, the second largest is after 40 it is 30, so we should get 30. Now again think about it, right? If I need second largest element, the easiest way, again I can just sort it, right? So let me take it here, right? I will sort it and get the second last element, isn't it? I will sort it and get the second last element, and I will get second largest value, right? Let me just comment this for now, and if you see, I got 30, right? Because it will sort first. After sorting, that 30 will be here and it will give me. But again, the time complexity is n log n, sorry, n log n, yeah, right? right? So sorting takes n log n time complexity. So again, I want to solve it with log n, right? For the better efficient solution. Okay. So now think about it. Here we were maintaining a variable max number and we were checking each number. If it is greater than max number, then we were replacing the value of max number, and that we checked for all the values. Now here we have to keep track of two variables, which is largest and which is second largest, right? So let's do it. So I'll just remove it for now, right? And let me take this function. Okay, so I will call it cat second largest number. Sorry. Okay. Now what we will do, we have to declare two variables now. One is max and one is, let's say, second max num, right? So this will be my largest element and this will be my second largest element, right? For now, right? For now, I am just keeping it as 0, 1 and 0. I'll not hard code it, but just to explain what I'm trying to do, for now I'm keeping it as 1 and this is 0 and this is maybe, I don't want to keep it 1, let's say 3. Right? I'll tell you why I'm doing. So for now, consider this is my array, right? And these are two numbers. I just declared max equal to 1 and second max is 0 for now, right? We will not hard code it because in my array I can have 0, 1 or negative numbers as well. But for this example, let's say I know my smallest value is 3 here. So I'm just keeping it as 1 and 0, right? I'll change it later. Now what I will do, now I will check each number with max num, right? If number is greater than max num, right? If my number, so first number is 20. Is it greater than max num? Yes. So now my max num will become num. At the same time, my second largest number will also change, right? Initially, my largest is 1, second largest is 0. Now, my largest number will become 20, right? And what will be my second largest now? Second largest will be whatever value of the maximum, right? So my second largest will be 1 now, right? So you have to remember it. If I am getting a number which is greater than my maximum number, so my largest number will become 20 and second largest will be whatever was max earlier, which is 1, right? So before assigning this value, right? So this will become 20. So I don't have information about what was my max num, right? If I assign it, my max num will become 20, right? Now at this point, I don't know what was my earlier max num. So before assigning it, I will say my second max num equal to max num, right? My second max num equal to max num and max num is 20, right? At this point, the max num will become 20 and second max num will be 1, right? So this is how you have to keep track of it. Okay, great. So this will solve one problem. Now there is another problem. Let's see the second iteration and we will see what is the issue here. Let me remove it for now. Now in second iteration is 12. Let's see what will happen. Now 12, right? 12 is greater than max num? No. 12 is not greater than max num. My max num is what? 20, right? So is 12 greater than 20? No. So it will not go inside it. But if you see, my second max num is what? 1, right? This should be updated, isn't it? See, max num will not be updated because max num is 20 and second max num is 1 currently, right? If you see, second max num is 1. But 12 is greater than 1, right? So my max num should not be updated at this point, but second max num should be updated. That means second best max num is 12. So I have to put one more condition here. If num is greater than second max num, right? If my number is greater than second max num, then I will say my second max num is equal to num. Now what will happen, if it will not go in this if condition, it will go in elif and check if is it 12 is greater than my second maximum which was 1, yes, then update it, right? Now I have the track of maximum and second maximum properly, right? And let me return these two. So I'll return maximum as well as second maximum, right? And let me call this function now, right? Now remember, this return will be after for. So after all the iterations are over, whatever the values of maximum and second maximum at this point, I want to uh, print it, right? So I want to get I want to return it to the function, right? Let me call this. Okay, so second largest number. Instead of that, I will do this, right? And this is my array that I'm passing, and let's run this. Okay, so I'm getting 40 and 30. Let me clear it once and I will again run it. So if you see, largest is 40 and second largest is 30, right? So the function is get second largest element. I can just get this one, right? I'm just showing you, right, that this is my maximum and second maximum. In question, if you are getting, you have to just do this. Okay, I hope this makes sense. Now there is one problem in this solution still. Let's say I have another value as 40. Right? Let's say another value as 40. Right? So I have 40, 42 times and then 30. Now expectation is I should get 40 and 30 still, right? My expectation is the highest number should be 40 and next second highest should be 30, right? Let me run this and see what will happen. Okay, I'm getting 40 and 42 times, right? Why? Because if you see, it is checking if num is greater than second max num. So when it is coming here at the last iteration, right, the highest element was 40, right, and second highest was 30, right, till here. You can imagine, right, till here. Now when I reach 40, it will check, is it greater than max num? No. Is it greater than second maximum? Definitely. So it will replace the value, and that's the problem. So in elif, I want to make sure this num is not equal to the maximum. So I'll put one more condition, and num should not be equal to maximum. Then I will not have problem, right? So let me just remove this, and one more time I will run this. Now if you see, I'm getting right value 40, 30. And what is the time complexity now? This is a for loop. We are running the loop one time over the array, right? So it is on now, right? So if there are n elements, we'll be doing the n operations, right? So we again improve the solution. Instead of n log n, I'm solving it with on. Okay, great. Thing is here that we cannot hard code this 1 and 0, right? I just put it 1 and 0 so that I can explain you, but we should initialize it with a negative number, a big negative. So I will say minus infinity, right? So anything will be greater than this, right? So my initialization will be a big negative number. So everything will be greater than this, and I can easily find my first highest and second highest, right? And this all finds. Okay, great. So let's solve a next question. In this question, let me first comment this. My requirement is, let's say I have an array, right? Let's say this is my array, nums equal to 2, 3, 4, 2, 3, 5. I want to find first non-repeating element, right? First non-repeating element in my list, in array or list, right? So what does that mean? If you see, we will start from left, first not repeating. So 2 is repeating or not? Yes, 2 is repeating. 2 is here as well as here. 3 is repeating. Yes, 3 is repeating. Okay, 4 is repeating. No, 4 is not repeating. And 5 is also not repeating, right? But what I want, first non-repeating. So my answer will be 4. 4 and 5 both are non-repeating, but in array, whatever comes first out of all those non-repeating element, I have to give that. So answer will be 4, right? So let's see how we can solve this. So one brute force method is, let's say what I will do, right? I will create nums, and let's say I will create one more nums1, right? I'm just telling you how you will do it, right? I mean, I don't have to create it. I can use it again, nums 2 times in my program, but just to explain you. So I will pick first element, right? And I will check if it is there or not in this, right? If it is there, right, so I will check 2. I will not check the first element, and I will check in remaining. If it is there, then this is not a not repeating element. This is a repeating element basically. So I will discard 2. Then again I will pick 3, right? And I will check 3 if it is there or not. If it is there again, then this is not a non-repeating element. Again I will pick 4, and then again I will check in rest of the array, right? If I'm at index 3, I will check from index 4 from that array, right? Similarly, when I'm at 5, I will check going forward, right? Okay, great. So the problem here is that it will be O n square time complexity. Right? This is a brute force method. It will be O n square because you are running a loop inside a loop. So for each element of this array, you are running a loop on this array. Each element of this array, you are running a loop on this array. Right? So this will be a brute force method. You can solve it, get the right answer, but not the efficient one. So we will see how we can write a efficient code for this. So what we will do, right? Let me remove it now. I don't need two arrays, right? As such. So what I will do, I will get frequency of each element first. That how many times 2 is there, how many times 3 is there, how many times 4 is there. Once I have that frequency, then I will check from this array which is that first element whose frequency is just 1. Right? So let's go step by step. So I'll write a function, define first non-repeating, right? So most of the time you have to write a function. It is not that you have to write a code directly. You have to write a function always, right? Okay, so what it will take a array. That's it. We'll get the array and then we have to find first non-repeating element. Okay, so I will define a dictionary, right? Frequency, and it will be initially empty. Okay, great. Now, before I write the solution, I want to tell you something about dictionary, right? So let's say you have a dictionary. So you have a dictionary, let's say frequency equal to, and I will create some key value pair. Let's say Ankit, right? And it's his age, right? Or let's say employee ID 1 and its name Ankit. Let's say this is better example. Okay. So let's say this is your dictionary. Now you want to see the value of the element in this dictionary. So what you will say? You will say frequency of 1, right? And if you just print it, it will give you. Okay, so if I just run this, frequency, okay, I have to give in double quotes, or let me make it like this. Okay. Okay, so it is giving me Ankit, which is correct, right? Let me clear it once. Okay, so I'm saying what is the value of 1 frequency, and I will pass the key value, right? And it will give me the value of this. So I will pass the key in this dictionary and it will give me the value. Now if I pass some other key, let's say 2, right? Now 2 is not there. What will happen? It will give me error. So 2 is not there, right? Now there is a more sophisticated way. So instead of directly saying that give me the value of this key, you can say give me frequency dot get, and you will pass the value. So you will say give me the value of 1, right? And let's see what will happen now. So I'll say print. So get is a function I'm using, a dictionary method you can say, right? And let me run this. So I'm again passing 1 and it should give me Ankit, right? And this is perfectly fine, right? This is giving me Ankit, so there is no issue. Now advantage here is if I pass a key which is not there, it won't fail, right? So if I say, sorry, clear that. So if I say, let's say 2, right? So it will not fail, it will just return none. So my program is not failing, right? I don't want program to fail when some key is not there. I'm just saying none. You can pass an argument that if it is not there, then default it to something. So I will default it to 0, then it will give me 0. Right? So this is a more sophisticated way. If something is not there, it's fine, give me 0, right? And if it is there, give me that value, right? So this works fine. Okay. Now let me write the function. I hope you understand this, right? So let me comment it so that I can refer it back if required. And let me go back here and I'm going to write this. So initially I'm initializing my dictionary frequency equal to empty dictionary. Now I will run a loop for num in nums, right? So I'm running a loop for num in nums. Now what I will do, I will say frequency. So how to add an element in a dictionary? I can just pass a value num, right? equal to frequency of num, right? So I will get it. What is the value of, so in this what I want to keep ultimately? In this I want to keep the frequency of everything. So I will say 2 is 2 times, right? And 3 is 2 times, and 4 is 1 times, and 5 is 1 time. This is what I want to keep in this, right? So what we will do now? So I'm just checking that if it is there already, then add 1 in this, right? Right? So if, so okay, so let me do this. So what I'll say frequency dot get, right? What you get? Num. If num is there, if not, then make it 0 plus 1, right? So what I'm saying, that check if num is there or not in this dictionary, right? If num is there, so initially in the first loop what will happen, right? Num is there or not, 2 is there or not in this dictionary. Initially it is empty, right? So it is not there, so it will give me 0, and I will increase the count by 1. So at this point our entry will go and it will say 2 colon 1 in my dictionary, right? So I'll just write it in my dictionary, right? There will be a entry which will say 2 colon 1, right? This is how you have to do it. And the next station 3 will come, right? Again for 3, right? Is 3 there? No, 3 is not there. So again it will become 0 plus 1. So there will be one more entry. It will say for 3 the key value pair is this. So this is key, this is value. This is key, this is value. Now for the third iteration again 4 will come and there will be one more entry. 4 colon 1. Okay. Now in the next iteration what will happen? It will 2 will come again, right? Now it will check if 2 is there. Yeah, 2 is there. What is the value? 1. So it will get 1 and plus 1. So it will make it 2. Right? Again it will check if 3 is there or not. So 3 is there. Yes, 3 is there. So add 1. So this will become 2. Next it will check 5. 5 is there? No. So again it will default it to 0 plus 1 and there will be a one more entry 5 colon 1. Right? So let me run this and show you. So I'll just say return this dictionary. So this is my dictionary basically, right? And let me call this. So I'll just say print and first non-repeating character, and it will take just one argument, and let's see what it returns. So if you say, it is returning me the same thing, 2 2 3 2 4 1 5 1. So basically I get the frequency of each element in this list, how many times each element is. 2 is 2 times, 3 is 2 times, 4 is 1 time, 5 is 1 time, which is absolutely fine. Now what I have to do next? Now I need to run a loop again on this, right? Because I need to find the first non-repeating element. So I will check first 2. What is the frequency of 2? Okay, frequency of 2 is 2. So this cannot be the first non-repeating element. Then again I will check 3. Okay, 3 is there. Yes, and what is the frequency? 2. So this is also not non-repeating. Then okay, 4. Yeah, 4 is 1. So this becomes my first non-repeating element, right? So what I will do, I will say instead of returning this, right? So what I will do, I will say, I will come out of this, right? I got the dictionary and I will run loop one more time. I will say for num in nums again, right? I'm running the loop again. If, right? So I will get what is the count of this num, right? Count of 2. If from frequency I will get the count of, now we are sure that this number will be there, so get is not required because all the elements are going from this dictionary itself. In my dictionary all the elements are going from this list itself, right? So I'll say if frequency of num is equal to 1, right, then return it, return num. That's it, right? This is what we have to do. I have to run loop again on this and I'll check if the frequency of the number, right? So frequency, so The what is the frequency of 2? It is 2. So it will go in this? No, nothing will happen. Then second loop, what is the frequency of 3? Frequency of 3 is 2. Then again it will not go in this if condition. Then again 4, right? What is the frequency of 4? 1. Okay, now it will match and it will return me that, right? And that's it. Now let me run this again. So now it is giving me 4, right? First non-repeating element is 4, you can see, right? Let me add 4 again here. And then we will see what will happen. Now first non-repeating element, it should give me, let me add one more 6, right? So first non-repeating should be 5 now, right? So let me run this and you see it is giving me 5, right? Now what is the time complexity here, right? So if you see, we are running loop one time on this array, right? And again I'm running a loop, right? So 2 times I'm running a loop. So my time complexity will be O n, and I'm running a loop one more time. It is not loop inside loop. There are separate loop. If it is loop inside loop, then it will become O(n) square. But this is one loop. So if let's say there are 10 elements, so there will be 10 operations here plus 10 operations here in the worst case, right? So there will be 20 operations. So it will be O2n or 2On, whatever you call it, right? So On plus On, right? Which is better than n square, right? 2On is better than n square. N square will be 100, right? So it will be double of number of elements, and this is also called as linear, right? It is just doubling, but it is not that it is if there are 10 elements and it becomes 100. No, this is not happening. So this is also a linear time complexity, that number of operations will be linear. If there are 10 elements, then operations will be 20. If there are 100, then 200. It is linear, just double, right? So this is also overall considered as On only, right? Okay, great. I hope it makes sense. Next, let's solve another very famous interview question, which is based on two-sum problem. Right? Very, very common this is. Now what we have to do in this? So let's say I have an array, right? Nums 2, 7, 11, 15, and the target is 9. So what we need to find is, we need to find that the indices of those two elements in this list, right? Let me make it a little big, this list. Let me make it 1 here, and maybe I will take 2 here and 7 here, right? Okay. So in this list, right, I need to find those two indices whose value sum is 9. So for example, 1 and 2 is 3, right? Indices of those two elements whose sum is 9, right? So 1 and 2 is 3. So this is not a solution. 1 and 11 is not a solution. 1 and 15 is not a solution, right? 2 and 7 is a solution, right? So 2 plus 7 is 9. So my answer will be, right? Answer will be index of these two elements, right? So it will be, this is index 1, right? And this is index 4, 0, 1, 2, 3, 4. So answer will be 1 and 4, because the sum of values at index 1 and 4, 2 plus 7 equal to 9. And this will be given that there will be exactly one solution. There will be exactly one pair whose sum will be 9. Right? So this is the question. 1, 4 or 4, 1. Both are fine. Order doesn't matter, whatever you give. Okay. So if you have to do this with brute force again, right? You just imagine one more array is there, right? What you will do? You will pick this and then run loop over it and see 1 plus 2 is 9, no. 1 plus 11 is 9, no. 1 plus 15 is 9, no. 1 plus 7 is 9, no. Again you will check with 2. 2 plus 11 is 9, no. 2 plus 15 9, no. 2 plus 7 9, 9. Then you will return it, right? But again it will be On square, right? So again you should not do that, right? You can try solving it yourself once, but that is not an optimal solution. We want to solve it. So most of the problems, right, that you get, you can easily solve using On square, brute force, and ultimately in your interview you have to think about how I can solve it in On, right? So let's see how we can solve it. Now what I will do, let me define the function. So am I calling? Let me comment this first. Okay, so define a function and I will set get uh, to sum, right? So it will take two arguments, right? One, it will take nums, the array, and what is the target, right? Two things required in input. Okay, so this is my get to sum function signature, array and the target. Now how should I go about it, right? So what I need, basically I need to check each element with every other element, right? Now think about it, right? Once I see a element, I should be able to store it somewhere, so that when I'm coming here, so I will run a loop on this basically, right? So I will check one. So first element, it is fine. Let's move to the second element. Now when I'm coming on second element, right? I'll not do a double loop that I will pick one and check in full. No, I'm not doing it. I'm just checking the first element. So I will run loop one. Now for the first element, nothing. At least two elements should be there to check. Now when I'm at two, I will store it somewhere in the dictionary that I have seen one already, right? If it is seen, and then I will check, okay, that what is required, right? That what is required to get 9, right? So what is required to get 9? 7. So 2 is there, I need 7, and I will store 1 somewhere. So let's say I have a dictionary where I have stored that 1 is there at index 0, right? So this is my dictionary. So after first loop, I will store this. Let me do a comment that 1 is there at index 0. I will store it, right? Now in the second one, right, I need total 9, and this is 2. So 9 minus 2 is 7, right? 9 minus 2 is 7. So I need to check if 7 was there already or not in my list, right? I would have stored it in the dictionary. 7 was there? No. 7 was not there. So there is no pair till now which can give me 9. So again, I will store location of 2 is 1 in my dictionary at that point. Great. Now again, I will move forward 11, right? Now 9 minus 11 is minus 2, right? So I will check is minus 2 there in my dictionary? Minus 2 is not there, right? So I will say, okay, store 11 also, that 11 is there at index 0, 1, 2. Great. Now what I will do? I will move to 15, right? 9 minus 15, minus 6, right? 9 minus 15 is minus 6. Is it there in my dictionary? No. So I will store 15. 15 is at position 3, right? Now I will come to 7. 9 minus 7, 2. I will check is 2 is there. Yes, 2 is there at index 1. So I will say this index plus this index will be my answer, right? This index plus this index will be my answer, and that is how I will be able to solve it, right? Okay, so let's write it. It is easy, right? If you understand this logic, what we are doing, right, then it will be easy. You can watch this video again. Just go back 2 minutes back if you don't understand this logic. Once you understand the logic, writing it is very easy, right? So I will create this dictionary. Let me call it seen, anything that it is already there or not, or anything, it is fine. I am saying seen, that this number I have already seen it in my list. I'll say for, again I will run a loop num in nums. Okay, now I will get that what I need. I need that complement. What difference I need, right? Complement equal to target. So what is my target? Minus this num, right? Target minus this num. So for the first iteration, it will be 8, right? And I will see that 8 is there or not. Have I seen 8 already? Now this is the first element, so it will not be there, obviously, right? So for this iteration, it will not be there, but it is fine, right? So I am saying complement equal to target minus num. So I will get this complement. Then I will check if this complement, right, is there in my dictionary. Right? Currently for the first iteration it will not be there, but at some point I will get the complement, right, whatever complement I need, so that this number plus that complement will become 9, right? So target minus num is complement. I will check if this complement is there in my dictionary or not. If it is there, then all I need to do is return, right? Return that the index of this, right? Now here I don't have an index, right? If you see, I'm just checking num, so it will give me what it will give me 1, 2, 11. I need an index also, so I can say index, comma, and I will say enumerate. What enumerate will do, it will give me index as well as the value. Right? Maybe I can show you quickly index. Right? Let me just comment it for now. I want to show you what it gives me, right? So I will say print index num, right? And I will just call this function get to sum. Okay, so I'll say print get to sum. Okay, and let's run this. Oh, I can just call it because we are printing it inside. That's fine. Okay. So it is giving me 1 to 11, 15, 7. You see 1 to 11, 15, 7, but it is giving me the index as well 0, 1, 2, 3, 4. Okay, I hope you got it. Okay, so let me come back to the question again and let me remove it for now, right? So I'm saying if this is there, I have already seen this difference, right? I need target minus num. So if it is 1, right? If I have seen I have 8 here in this, then we are good. The sum 1 plus 8 will be 9, right? But for the first iteration it will not be there, but it was there. Then I could have said return index, right? And the index of the value which I have seen somewhere, right? And for that I have to say seen and the index of that complement, right? Where what index that complement is present, right? I'll do the iteration and show you, right? Great. Now it is fine. If I find it, it is great. I will return it and that's it. But what if it is not there? Then I have to add that into this dictionary. Then I will say seen, right? That value which is num, right? I will store this num and the value will be the index of that, right? Great. So I'll run it and take you through again. I know it is little confusing, but it will be clear. So I'll just say print get to sum, right? Print get to sum nums target. Let's run this. So see, I'm getting 4 and 1. 4 and 1 means 4 is 0, 1, 2, 3, 4, right? 7 and index 1 is 2. So 7 plus 2, 9, right? Let me add one more number in this. So if I add, let's say 10, and if I run it again, right, I'm getting 5, 1, right? I can add an element later as well. Let's say 15 or let's say 20, right? So still it is 5, 1. Okay, so this is clearly fine. Right. Now what I'll do, I'll just run over the iteration one more time so that it is absolutely clear to you, right? So what I will do here, I will just say print print seen and print num and seen. These two things I am going to print it, right? Then it will be absolutely clear how these things is working. Okay. So if you see for the first iteration, my number is what? Let me take the array. Where is my array? Okay, this is my array. Okay, fine. Okay. So for the first iteration, this num is 1, right? Num is 1. And what is there in my scene? 1 colon 0, right? Because there was no complement present in my set, right? Initially set was empty. So it didn't go in this, right? And I added this value 1 and the index of it. So the 1 and the index of 1. Now in the second iteration 2, right? Again I am checking that 9 minus 2 7, right? My target is I should find a 7. Do I have 7 in this dictionary? No, 7 is not there in this dictionary. So again it will not go inside this. Right? Again, I will just add this value and I will say there is a 2 available and the position is 1, the index position. Right? Now next 11. Right? Again 11, 9 minus 11 minus 2. Is minus 2 there in my dictionary? No, it is not there. So it will add that value again. And it will keep going on like that. Right? So till here it will not find anything. Right? So it is keep on adding, keep on adding, keep on adding. Now when it reaches 7, right? So it will check what is the complement. Target minus num. So 9 minus 7, 2. If 2 is there, yeah, 2 is there. Right? So the moment 2 is there, it will just return this value. It will just return value and function call will be over. That's it. The moment you say return, your function is done and it will return that value. Right? And that is how it is returning me 5 colon 1. Right? So I'm returning the index of this element which I'm checking currently, which is 7, and the index of the complement. Right? So 7 is there. I need the index of 2 and which I'm getting from here. The index of 2 is 1. So I'm getting 5 and 1. Okay, so these things comes with practice, right? You should solve yourself once. No matter how many videos you see, if you are not able to solve it yourself when you practice, then you will not be able to solve this in interview as well. Okay, so make sure you practice it just in your mind. First think about it. How should I solve it? What is the algorithm I should do, right? And then after that, you should start writing the code. Okay, great. Let's move to the next question. And in this question, we will introduce a new data structure, which is set. And I will talk about set. Right? So the next question is, let's say you have a list. Right? Let me comment it. So you have a list. Let's say this is your list. And you want to find all the elements which are duplicate. So what it should return? It should return all the elements. So it will return like 1. So 1 is duplicate, right? 1 is there as well. Then 2 is there, yeah, 2 is also there, right? Duplicate. 3 is duplicate, no. 4 is duplicate, no. 5 is duplicate, no. So we should get 1 or 2. Again, the brute force is you have one, you will do a loop inside loop, right? And you will just check if 1 is there again, then you will add it into this list, right? And 2 is there, then you will add it into a list. So you will create an empty list and you will keep checking. Wherever duplicate is there, you will keep adding it, but again it will be O(n) square, right? So let's see how we can solve it with a optimized O(n) method. Okay, now before I start the solution of this problem, I want to talk about set, right? Set is another data structure. So you declare it as, let's say variable name is scene and you say set, right? Now in this you can add elements. So you can say scene dot add, you will use, right? For list you have to say append, but for this you have to say scene dot add, right? This is a variable name which I declared as set, and you can add something. Let's say you can add 1, and let's say you are adding 2, and if I just say print scene, right, and if I print it, you will get a set, right? It is in curly braces similar to dictionary, but it is not a key value pair, it is just individual element. Okay, now there are two properties of it. One is it cannot have duplicate. So if I again add, let's say 2, it will not store it. So if I just do this, see again 1, right? In list, if you add, it will just add it, right? It doesn't have any duplicate issue, but in set you cannot have duplicate. Second main advantage is the lookup is just like a dictionary, right? If you are looking a value, this is used for the lookup basically, right? If you want to check if some value is present in not, it's there or not, then it takes O(n) time complexity, right? If you do that in dictionary, that will be O(n). So for example, if I just say print uh, 1 in scene. So I'm checking if 1 is there in this scene set or not, right? Let me clear it quickly. Clear. Okay. I think we went into Python environment. Okay. So we'll say, yeah, I'll just run this. Okay. So I'm getting 1, 2 from where I'm getting this 1. Okay, I'm printing this, fine. Okay, so I'm checking if 1 is there in scene or not. Yes, it is there, so it is returning me 2. 2 is there in my scene. Yeah, 2 is also there, so it will return 2. 3 is there. Yeah, it is not there, so it will return me false. And this lookup is O1 time complexity, not ON. If I'm looking this in a dictionary, so if I'm checking 3 in nums, if 3 is there in nums or not, right, this is a ON time complexity, right? Because for that I need to run a loop over it. But for set, similar to dictionary, the hash values are stored, so it will just take O1 time complexity, right? So this is how the set are beneficial. If you want to do a lookup, you want to store some values and you want to do a lookup, you can use it, right? You can use dictionary as well, but dictionaries you use when you need key value pair, both you want to store. If you just want to store one value, not key value pair, then sets are better. Okay, great. Now let's go back to the question, right? I want to find all the duplicates. So I'll say define find duplicates, right? And this will be nums, right? So this is all I need. Okay. So I will define a set scene equal to set, right? What I'll do, I'll just tell you, and I will say dupes equal to a list. So whatever duplicates I will find, I will keep in this list. I will keep appending it. Right? We'll optimize it further. But for now, I'm keeping dupes, right? And whatever elements I have seen, I will keep in set. Right? What do I mean by that? So I'll run a loop for num in nums, right? And I will check that this element is there in scene or not, right? If it is there, then it is a duplicate. If it is not there, then we are good, right? So what will say? If num in scene, right? If num, whatever element 1, if it is there in my set already, so I will append it to dupes, right? Because it is the duplicate, it means, right? Dupes dot append that element now. Okay. If it is not there, then what I will say, I will add it to my scene. So I'll say scene dot add, and I will just add that element num, right? So in the first iteration, what will happen? So 1, it will check if 1 is there, no. So what it will do, it will add that in the scene, right? Again, it will go 2, right? It will check if it is there, no, then it will go to 2 and 2, right? I'll show you. So I'll just print it here. So I will say print scene and dupes, both I will print, and then it will be absolutely clear, right? So let me just call this function. Also I need to return it, right? So I'll return it later, that's fine. So I'll say print, or I'll just call this function, that's it, right? Okay, so I'll just call this, and now if you see in the first iteration, in my set 1 is going, right? In dupes nothing is there, right? Dupes nothing is there. The second iteration, you see, again there are 2 elements in my this set that I declared, right? And nothing is there. Again 3, right? Now when it goes to fourth iteration, 2, right? Now 2 is there in my set. Yes, 2 is there in my set. It means 2 is a duplicate, so it will just add 2 here in my dupes list, right? Next, again it will say 4 is there, no, so it will add 4 to my set, right? And all this lookup is O1, right? And then it will see 1 is also there, and it will add 1 also. So this is how it is working. So all I need to do here is return I need to return all my duplicates. There is still one problem, so we'll discuss. So I'll just say return duplicates, then I need to print it, right, to see, right? So if you see, it is returning nothing, something is wrong. Okay, sorry, I need to come out of loop. Yeah, so let me run this, and now we are getting 2 and 1. So these 2 values are duplicate, right? So once this for loop is over, then only I need to return it. Now there is one problem. Let me add one more one. Now what is the expectation? I should still get 2 and 1. I should not get 2, 1, 1, right? Because 1 is a duplicate. Doesn't matter how many occurrences are there. Even if 3 occurrences are there, in my output I want to see only once. But if I run this, it is 2, 1, 1. Why? Because again it is checking here, right? If it is there, yeah, 1 is there, so it will add in this list, right? So I'm getting 2, 1, 1. How to solve this? So again, instead of, so we know in the sets we cannot have duplicates. So this dupes also we can create it as set instead of a list. If duplicate is there, it won't go inside that. I'll say dupes equal to set, and then I can just instead of append I have to say add, and that should solve the problem. Now I'm getting 1, 2, right? So this is how you have to think about it. As I said, again if you see, we are running loop only once, right? So it is again a O and time complexity. So most of the questions are around this, that it is O n square, it can be easily solved, or with sorting n log n it can easily be solved, but you have to bring it to O n, right? 95% of the questions are like this, right? From O n square O or O n log n, you have to bring it to O n, right? So if you can think like this, you can easily solve these kind of problem. Let's move on to the next question, and very interesting question this one. So here's the question, right? The question name is best time to buy and sell stocks, right? Given the prices of a stock on different days, find the maximum profit you can get. You can buy once and also sell once. Okay. So let's say you have the prices of a stock, right, in a list, right? This is day 1 price, day 2 price, day 3 price, and so on, right? You have to find that what is the maximum profit you can get. Now, two things is, one is you can only buy once at any price and sell once. Second thing is, you should buy first and then sell first, right? So for example, if you buy here, right, then you can sell any day after this, right? It is not that you will say I will buy at 1 and sell it 7. No, first it should be buy and then it should be sell, right? So let's see what will be the answer in this case, right? So if you see, if you buy at 7, 7 is highest price, so you will never get any profit, right? If you buy at 1 and sell at 5, then you will get profit 4, right? Again, if you see, maximize will be here. If I buy at 1 and sell at 6, it will be profit 5. So answer will be 5. You can try all the combination, but ultimately the profit will be 5, right? Now, if you have an array where prices are always decreasing, for example 7, 5, 4, 3, then you can never get any profit. The maximum profit you can get is 0. You can buy at 7 and sell at 7 on the same day, because it is always decreasing. You can never get any profit here, right? Okay. Now, if I have to solve with brute force, right, what I will do, I will run a loop on the array and compare with each price. So I will compare 7 with all the other price. So I will say I will buy at 7 and sell it 1. What is the profit? Minus 6, minus 5, sorry, minus 6, right? Again, buy at 7, sell at 5, buy at 7, sell at 3. So I will get all the combination and see what will be the profits possible. Again, I will buy at 1 and see with every index other than this, right, what is the profit that I can get, and I will store all the profits and keep the maximum one. Again, so I can run this on the all the elements and compare all the combination, right, how much profit I can get, but again it will be O n square, right? The time complexity will be order of O n square, right, which is not again good. So we want to bring it to O n, right? As I said, most of the time we'll be doing this. Brute force will look like O n square, easy, and then there will be some trick to get to O n. Okay, and it comes with practice. Don't think that if you are not able to solve this question at once, you will not be able to crack interview. No, it is like if you solve some 50 or 100 questions in your interview, same patterns will keep on coming, right? So practice a lot. You can practice on namastesql.com as well. I will show you later, but for now, let's solve this question. Okay, so what we will do, right, if you think about it, we need to keep track of our profit, right, and the minimum price, right. So what we will do, we will start from the first element, right. So we will start from here. Okay, let's assume I'm buying here, right. So my buy price is 7. Let me write buy price is 7 on the first day. Okay, when I go to the next day, right, I will check if the price is less or more, right. So initially the minimum price I have is 7, right. I bought at 7, so initially the minimum price is 7, right. First day doesn't matter. Okay. Now when I move to second day, right, this is the minimum price now. So what I will do, okay, so there is no point buying here. If the next price is less than this, then why not buy at this, right? When you buy at less price, you will always, there are more chances of getting a profit, right? So when I'm moving to next index value, I mean next element, I will check if the next value is less than current value, then I update my minimum price. So my minimum price will be 1. Okay, great. Now again I will move. Now this time I will see, okay, price are increasing, right? So I will check what will be my profit, right? At this point, my profit will be 5 minus 1. So maximum I can get 4 profit. Once I reach day 3, right? In day 3, maximum profit I can get is whatever minimum price I could have bought it and I can sell here. So profit I could have got 4. So I will keep this profit as 4, and in future we will see if there is a chance of getting more profit. Right? If there is a chance, then we will use that combination. Okay, so this is fine. Now again I will move to 3. Now 3 is less, right? 3 is less, which means which means if it is less, so if I do 3 minus minimum price 1, it will be 2. So we won't sell this, right? The better option was buy at once, sell at 5. And I will not update my minimum price also, right? Because minimum price was 1. If I had an opportunity to buy at 1, why I will buy at 3? So in this case, nothing will happen as such, right? Okay, great. Now let's move on to the next one. Next is 6, right? Now I will check is 6, right, is greater than my minimum price. Yes, it is greater, right? So I will check 5. The maximum profit I can get is 6 minus my minimum price 5. So now my profit will become 5, right? I will check the previous maximum profit was 4, but now I can achieve 6 minus 1 5, right. And again, now it is reducing. It is 6 and then it is 4. So again it is more than my minimum price, and if I check the profit, 4 minus 1 will be 3. So again it will be less. So my maximum profit will be 5 at any point, right. So this is how I will solve it, and let me write the code for this. Okay, so I'll keep it as it is. So I will say define get max, and it will take an array. So let me give prices itself. You can say air, anything is fine, right? So let me keep it as it is. Okay, so now I need to keep track of two things. One is what is the maximum profit I have, right? So that I can, in this variable I will always keep the maximum profit possible, right? And in this I will keep the minimum price, at the price at which I should have bought, right? Okay, so I'll define two variables, and I'll say profit equal to 0 and max profit possible, max profit possible is 0, and the minimum price or minimum buy price, whatever, right? Minimum price, let's say the first element, prices of 0, right? So we will start with 7, right? I can keep it as a infinity as well. So I can say float of infinity, some big number, right? So that when I compare, I always have a lesser, because I want to keep the minimum as a track. So I can keep a big value, and when I compare with the first value, it will be less, and I will be able to replace it. But this is also fine. We can take the first element. Okay. Now let's start the loop. So we will iterate over this, right? So for price in prices. Okay. Now what I will check? I will check if this price, right, is less than my minimum price. Right? That's what I have to keep. I need to keep the minimum price at which I can buy the stock. So I will say if minimum price is less than, or if price, whatever this current price, right, is less than minimum price, right, then I will just update my minimum price, right, because new minimum price will be this now, right. I'll go through the iteration. So I will say then minimum price will be equal to price, right. So I'm every time I'm going left to right from day 1, day 2, day 3, I'm just checking what is the minimum price I could have bought it. That is one thing. Now second thing, at every iteration I also need to check the profit, right, so that after every iteration I store the maximum profit in this variable, right, and in return I will return this max profit, right. So I will calculate my profit. My profit will be at current iteration whatever is the current price minus whatever minimum price I could have bought at, right. So that's why I'm keeping the minimum price, so that I can always compare the current price with whatever minimum price in past I could have bought the stock at, right. And then what I have to do, I need to again check that if this profit is more or the earlier profit I stored that is more, right. I will compare and keep the max profit again. So I will say that find the max of the current profit, right, as per the current price if I sell it on the current day as per the loop running, and the maximum profit I already had stored, right, that I will keep in the max profit. So I will update the max profit value to max of profit and max profit, right. I'll just print everything and then it will be clear. So I will say print. So I'll print three things. One is um, I will keep minimum price, right, and then price, right, and profit. Okay, so these three things I will print and then it will be clear. So I'll just say get max prices. I'll just call this. Okay, now it will be very clear to you. So what I am saying, initially the minimum price is this, right? Let me take this here. It will be more intuitive. Okay, so minimum price initially is 7, the first element, right? This is my first element, 7, doesn't matter. And again, and then I have the price. So in the first iteration, price is also 7, so profit will be 0, right? In first iteration, nothing much. What I can max do, I can buy at this price, sell at this price, and profit will be 0. Now let's move on to the second iteration, right? Now in second iteration, if you see, this is 1, right? Or let me put price first and then minimum price, right? Let me just say this. Just wait a second. So this is my price and this is my minimum price, right? Okay. So let me run this again. Okay. So now my price is 1, right? Now I'm getting a price of 1. Okay. Now I will check if this price is less than my minimum price, right? So my minimum price was 7 earlier, right? Second variable is a minimum price, right? Yes, it is less. So I will update my minimum price value to 1 now, right? My minimum price value will be 1 now, right? Now what will be the profit? Profit will be price minus minimum price, right? So that will be again 0, right? So I will say, okay, maximum what I can do is I can buy at this and sell at this, right? If I buy at 7 and sell at 1, it will be minus 6. So I updated my minimum price and the max we can do is 1 minus 1, 0. Okay. Now let's move on to the third iteration. 5. Is 5, so if your price is less than minimum price, no. Oh, sorry. Wait. Okay. Yeah. So if my price is less than minimum price, no. My minimum price was 1. So I will not update my minimum price now, right? My minimum price is still 1, but now I can get the maximum profit of 4. So I will update my profit to, earlier it was 0, now it become 4. So at this point I can get a maximum profit of 4, right? Then again I will move. The next element is 3, right? Now is 3 less than my minimum price? No. 3 is still greater. So I will keep my minimum price 1 only, right? Now what will be the profit with if I sell today? So 3 minus minimum price 2, right? Still I will not update my max profit because earlier I could have got 4. Why I will sell at 3, right? Okay. I hope this is making sense, right? Now next is 6. Is it greater than my is it less than my minimum price? No. So my minimum price stays. But now my profit will be 6 minus 1, 5. Right? Which means now I will update my profit to 5. Earlier it was 4, so it would have done 4 comma 5, so it will get me 5. Right? So at every step I'm keeping track of minimum, at what point I could have bought the stock, and I'm keeping track of profit as well, that if I sell today as per the minimum price, how much profit I could have got, right? And in the end I will return this. So basically you just have to say return max profit here, return max profit, right? And I'll just print this, and we are getting 0. What is wrong here? Let me clear it. Okay, it is giving me 0. Okay, so the problem here is this return has to be outside the for loop. So what is happening is after the first iteration only we are just returning, right? So when the for loop is running after in the first iteration we are just saying return, right? So it is giving me 0, right? So I have to check after all iteration what is my max profit, and then I should return it. Okay, now I'm getting 5. Okay, so these kind of mistakes will happen initially, but as you practice, you will be very comfortable with all of these things, where to keep the return and how to bring solution from O(n) square to O(n). Great. Let's move on to the next question. So next question, we will solve on parsing logs. Right? These are very common questions in data engineering specifically. Right? So let's say you have some logs of users. Right? This is how your logs are. It is a list and it has some text. Right? In some particular format, and you need to get an output on each date how many error each user has got. So for example, on first, right, this is my first data. So if you see user 1 has got error only once. So this is info. Info is fine. We don't have to count. We need to count only error. So user 1 has got error once. So if you see on 1st of um, January 2024, user 1 is 1. And user 2 has got error 2 times. You see on the first. So this is what you have to get. Again on second. If you see on second, there is only user 1 has got error 2 times. Right? And user 2 is not there because there is only one info. Right? So let's see how we can solve these kind of questions. Okay. So what we will do here is, first we need to read each of this element from the list and split it so that we can get all this in a different variable, this date, error level, username, right? So these things we need. So let me first show you how do we get it by using one element only, right? Let me just comment it out. Okay, so I will take logs 0 for now, logs 0, right? So this is my log for now. I'm just taking one just to explain how this works. Okay, so now I will say parts equal to log dot split, right? And I'll see what it will give me. Print parts. But I'll run a loop later, but for now I just want to show you how to extract all of this. So I'm splitting. When I say split, by default it will split on white space, right? If you have comma, you can give comma here. That is split based on comma. Now once I have this information, all I need to do is that okay, get me the date. So date is nothing but the first element of this list. So I will say date, or let's say log date equal to log date equal to the first element. So parts 0. Right? Now if you see, I will get this full date including timestamp. I need just the first 10 characters so that I just get the date, because I need date wise. I don't care the timestamp. Right? So further I can say give me all the elements from 0 till 9. So 10 elements it will give me. Right? Let me print it quickly. Okay, so you see I'm getting the proper date. Great. The next thing we need is what is the error label, right? So label is it error, is it info, because we are interested only in error, right? So I'll say let's say label equal to so it will be the 0 1 first part, right? So I'll say parts 1, right? And let me just print it. You see, I'm getting this info as well. The last thing I need is user. So I will say user equal to parts 2. And let me print user as well. You see, so we have got date, we have got the error label and user. These three things we need, right? And just we need to count it. Okay. So let me convert this to a for loop. So I'll say for, so instead of taking a first value, I'll say log in logs, right? And then I will just remove it and I'll just comment it out. Okay, great. I'll just give a indentation and we should be good. Let me run this so that we see for the all the logs entries. Yeah, so we are getting this, right? Now in data engineering, a lot of time you are using some API or you have some logs in JSON format in a file, and you have to work on it, right? So this is very common task in data engineering. Okay, so now what we will do, we need to now do this count, right? So for that, let me create a function first, right? We will write a function. So control X, and I'll say define logs summary, right? And input will be logs, right? And then I will start writing my code here, right? Let me put indentation. Yeah. Okay. So now what we will do, we will declare a dictionary where we will keep the result, right? Initially it is empty, right? This is my dictionary basically. So I'm initializing it with the empty dictionary. Okay. Now first thing that we need to do, right? Let me comment this, that now when we have to make an entry in this dictionary, right? Only when there is a error, not in case of info, right? So I will say if label equal to error, then I will do some task, otherwise I'm going to ignore everything, right? If it is error, then I will do something. Okay, now if it is error, now what we need to do, now in dictionary we have to have this date, right? If date is already there, I need to update just these values. But if date is not there in my dictionary, right, I need to first insert a record with that date. So I'll say if log date not in my dictionary, right, then make an entry. So I will say result log underscore date, sorry, result log date, right? So this date will go with the empty dictionary, right? So basically this will go in the first iteration and there will be an empty dictionary at that point, right? So I have only, so after first iteration I will have something like this. So like this it will be, and this will be empty, right? Right. Now when next time, now I will start adding these key value pair in my dictionary later, but basically this is what we will have after the first iteration. Okay, now this is done. Now next what I need to check, I need to check if whatever user is coming, right? If there is an entry for that already, I will do a +1, right, in that date only. Otherwise, I will make an entry that there is one error, right? So I'll say result, right? So this is a dictionary now, right? And within this, I need to update for the particular user, right? So I will use get. So I will say result log date. I have discussed this before, right? That if it is not there, it will return none and we can default it to 0. And I will get this user is there or not. If this user is not there, I will default it to 1. If it is there, then whatever value we will get, we will do +1. Right? And that will do for me. Okay. So result log date dot get user +1. And let's see what is my return result. Right? And let me just call this print log summary. Yeah, I think we have got the answer. Let me just check this. Yeah, I think it looks fine. So on first, user 2 has 2 and user 1 has 1, and on second, user 1 has 2, right? This is the, I think, expected output. Yeah. Okay. I hope this makes sense. And this is very common thing in data engineering when you are working. Apart from interview as well, this is a very common thing. You will be working with dictionary list. You will be parsing it, running a loop. So you should be very comfortable with these kind of problems. Okay, so if you want to practice more problems, right? I was telling you that you can practice more problems, right? So you can go to namastesql.com, right? You can go to coding problems. So we have a lot of different category of problems here: analytics, Python coding, ETL. So you can just click on Python coding and you can solve the questions, right? Mostly questions are on Python codings are free, right? So you don't have to buy anything. They are around 25-30 questions, so you can get a good hang of the things, how questions will be asked. And after that, maybe you can practice more on lead code, easy questions, and maximum medium questions, right? Not more than that, right? So if you practice, for example, if you practice 100 problems, right, then that will be enough. That will be enough for you to solve any kind of problem during the interviews. Okay, I hope this video helps. Please do like the video because it takes a lot of effort to create these kind of videos, right? Subscribe to the channel if you have not subscribed to the channel. And if you are looking to learn Python from start, you can just go to courses and you can buy this course, and it is very fantastic course, right? You will have end-to-end understanding of Python, how it is used as a data analyst or data engineer or even data scientist, right? And you will build a very good foundation because we have started from scratch, right? So there is no prerequisite as such, right? You can just come and start learning the Python. Okay, great. Thank you everyone. Have a good day. Make sure you like the video, and if you have not subscribed to the channel, please subscribe. So today I'm creating this video so that you can cover all your PySpark related concepts before your interview, right? Your interview may be tomorrow or in a day or maybe in a week, right? So this video will give you a good understanding of Spark, right? How distributed computing works, as well as it will revise all the important concepts like what is shuffle, what is lazy transformation, what is transformations in actions, right? It will also tell you what is narrow transformation, what is wide transformations, when the new stage will be created, how many partitions will be created, how to handle data skew, right? So all of that will be covered in that, right? All you need to do is just sit back and watch the video, because if you are revising it, then it means you already know Spark. It is just that before the interview you want to make sure that things are clear in your mind, right? So we will start with Spark architecture, why distributed computing is required, and then we will move on to see everything as visuals, as well as I will show you everything in Spark UI. Okay, so let's get started. So what we will do, we will understand first of all that why we need a Spark and what problem it is solving, right? And with that understanding, we will understand the Spark architecture. Okay. So typically as a data engineer, we do extract, transform, load, right? So we have data somewhere. Let's say we have a data in database or a cloud storage or anywhere, right? We extract this data, right? And we transform it in a machine, right? It can be any tool which requires some compute power, right? So you will transform data. Let's say you are doing some filters, some aggregation, joins, whatever you are doing, and then you will load it somewhere else. Maybe it can be a data lake again, or it can be a data warehouse or database anywhere, right? So you extract data, do some transformations, right, and load it. So to do these transformations, you need some compute, right? So this is your machine where you are doing your compute. Now there can be some capacity of this machine. So maybe it can be, uh, let's say this machine is 64 GB, or let's say 32 GB RAM, or let's say 64 GB RAM, right? And maybe it has a 4 core machine, right? So let me just take it here, right? 64 GB RAM and let's say 4 cores, right? So you are able to process your data and load it, right? Everything is working fine. Now what is happening is, as you, let's say you joined a startup and initially this setup was working fine, right? There was no issue. Now over the period of time, as your company is growing, your startup is growing, this data will also grow, right? So initially it may be, let's say, 10 GB data, then it became 20 GB, 30 GB data, and as this data is increasing, you are increasing your computing power as well, right? Because you have to now process more data every day, right? So maybe instead of 64 GB, you say, okay, I will now increase it to 128 GB, right? And maybe 8 cores or 16 cores, whatever, right? And this is fine. You increase the size of this machine, and again, everything is working fine, right? And you are loading your data and everything is fine, right? Now, again, your organization is growing more and more, right? Now, it has become almost impossible to process all your data with single machine, right? Because hardware has a limit. It is not that you can keep increasing size of this one machine to 56 GB, then terabyte. There will be some hardware limit, right? You cannot indefinitely increase size of this machine as your data is increasing, right? But you need more computing power, because with this computing power, maybe it is taking a lot of time. Maybe it is taking 10 hours, and you cannot afford to run your ETL pipeline for 10 hours, right? So what you can do, the option you have is distributed computing, right? So what you will do, instead of doing all the computing on a single machine, you will distribute into multiple machines. So for example, let me take it away for now, right? So instead of one machine, maybe you will have another machine, right? And now you will distribute the data, right? So let's say if you have uh, let's say you have 20 GB of data, right? 20 GB data, right? Earlier, this single machine was processing all this 20 GB data. Now, what you will do, you will say, okay, 10 GB data this machine will process, and 10 GB data this machine will process, right? That way, you can do work in parallel, right? Let's say for 10 GB, it is taking 10 minutes, right? For 10 GB data, let's say it was taking 10 minutes, right? So it was taking 10 minutes. Now, let's say if I'm doing 20 GB data, right? Then it will take 20 minutes. Isn't it single machine, right? If it is a single machine, it will take 20 minutes, right? Okay. But now since you have two machines, right? You will say, okay, this will take 10 minutes, this machine, right? And as well as this machine will also take 10 minutes, right? So you will distribute the data, and instead of 20 minutes, your work will be done in 10 minutes only. And this machine will also load data wherever you want to load it back, right? So this way you have parallelized your workload across two machines, right? Now tomorrow, if your data is increasing more, you can add one more machine, as simple as that, right? You will have one more machine. Now you will distribute data amongst three machines, right? So this is your distributed computing. You're distributing your work amongst multiple machines connected, right? All these machines are connected through network cables, right? Now this machines, right? This is known as the cluster, right? Cluster is a group of machines connected through network, right? So all these machines are connected, and you will distribute work amongst these machines, and then they will load the data. Okay, so this we understand, that we can distribute work amongst multiple machines. Now the problem here is, right, that when there was one machine, there was no issue, right? You take all the data, this will process the data, and this will then load it. Now, when the multiple machines are coming, you have to distribute the work, right? That this machine will do some work, this will do some work, and this will do some work, right? So, for that you need another machine, a master machine, which can manage this. So let me take this part of 1 second. Let me copy this and let me put it here. Yeah. So now let's say you have a cluster of 3 machines, right? Now how you will distribute the work, right? So there should be a person who should be able to distribute the work, because with one machine there was no issue, right? But with multiple machines, so if you have a project in that, if there is a one person, he will take all the work and do it. There is no problem. But when in your team there are multiple people, there should be someone who can distribute the work, right? So you will have one more machine, right? You will call it as a master machine. Let's say master. And this is your worker machines. So you will say worker. Worker. Right? So this is your master machine and this is your worker machine. Again, this is your worker machine. Sorry. This is your worker machine and this is your worker machine. Right? Now this master, so let's say you are the user, right? Let's say you are the user. Right? So you will not talk directly to worker machine, right? You will talk to master machine. Okay, I have some work. You do this work. So this will not do any work as such. It will just distribute the data. So it will see the code. Let's say you are running a simple query. Select star from orders where order date equal to, let's say, Jan 1st, right? So you are taking this data and you are writing it somewhere. So this filter has to be done by these machines, right? So this master will understand your code and then distribute the work amongst the 3 workers. Okay, you do this task, you do this task, you do this task, and then finally you will load it somewhere else, right? So you need a one more machine to manage all of this, right? Now in the Spark word, this machine is known as driver machine. Right? In the word of Spark, this is known as driver machine. So you will interact with the driver and then driver will interact with all the workers, right? Now, again in Spark works, these workers are further divided into executors, right? So one worker can have multiple executor, right? But we are not going into that for now. You just imagine each worker has one executor, right? So this terminology comes as executor, right? So whenever I am saying executor, it is a worker machine, executor, right? And when I'm saying driver, it is a master machine, right? So you have to understand this executor and this is executor, right? So this is your executor, let's say 1, executor 1, and this is your executor 2 and executor 3. So you can have multiple executors, but driver will be 1, right? So it is not processing any data, it will just check your code and distribute the work, right? So if you are giving 30 GB data, maybe it will distribute work accordingly. Okay, great. Now there is one more problem. When we have a cluster of machine, right? One thing was how to distribute the work. So we have the driver, it will read your code and distribute the work. Now the second problem is resource management, right? Now typically in a cluster you can have 100, 200, 300 executors. This is a simple example. We are taking 3 executors, but in reality you can have many executors. You can have, let's say, 10 executors or 20 executors or 50 executors or 50 worker machines, right? Now we have to manage the resources, right? Why we have to manage the resources? So one thing is, let's say this user is coming, right? It is saying run this query and the result of it, write it somewhere, right? So what you can do, you will utilize the full cluster. So if you have 100 machines, this driver will distribute work across all 100 machines, right? But that doesn't happen in reality, right? So this cluster might be used by many teams. Let's say there are 10 teams, right? And they are running their different jobs. You have different ETL pipelines, right? So you will not, each ETL pipeline will not use all the resources, right? Let's say there is a ETL pipeline. Let's say, let me take pipeline. I had somewhere pipeline thing. 1 second. Okay. Okay. So you have a pipeline, right? Let's say. So this is your pipeline one, right? So let me take a text here. So this is your pipeline one, right? Now in this pipeline, right? Maybe it is required less resources only, right? So this is your pipeline one, right? It requires maybe only two executors. You don't need all the executors, because if you tell all the executors, your all resources will be busy, right, running this pipeline. So as a user, you will tell driver, okay, I need only two executor for this machine, for this pipeline, right? Two executor. You need only two executor. Let's say you are telling this to driver, right? So in Spark, when you run a Spark job, you can tell how many executors you need, right? So what will happen, this driver will have to know that which machine I should contact. This driver doesn't know that which machines are available, which are busy. So that's where comes the resource manager. So we have a driver, we have a resource manager as well, right? So this is your resource manager. Let me put it somewhere here. So this is your driver, this is your user, right? And this is your resource manager. Let's call it RM, right? Now this resource manager is connected to all the machine, and this resource manager knows that which machine is busy and which machine is free, right? So when you submit a code and say I need two executor, this driver will contact the resource manager that dude, I need two machines or two executors, give me. So this resource manager will check, and maybe it will say, okay, you can use executor 1 and 2, they are free, right? So this driver will distribute the work as per whatever code you are giving, right? And it will contact executor 1 and executor 2 and distribute the work, right? So it will then contact, right? So this is how your distributing computing works in Spark, right? So there are three elements. One is executor, which are actually doing the work, right? They will execute all your data, and all your processing will do, right? You have the driver, you will interact with driver will see your code and distribute the work, right? Now it will contact resource manager because it needs to know which resources are free, right? So driver will go to resource manager will give the information back that you can use executor 1 and executor 2, and then this will distribute work amongst executor 1 and executor 2, right? So this is how your Spark architecture looks like, right? I have an image here as well. This says the same thing, right? So you have an application. Basically, a user is sending an application, and this is your driver master node, right? And these are your executors. This slot means this your worker node is of how many cores. So if you have 4 cores, 4 slot, 8 cores, 8 slot, right? This slot is of important thing we will discuss, right? So basically, this is your driver. It will contact cluster manager will check, okay, which executor are available, it will give back information, and then driver will distribute the work. Okay, I hope you understand this much, right? Let's move on to how data will be distributed, right, amongst these machines, right? So we'll move on to that. Now before we go further into learning Spark, right, I just want to mention, if you want to learn Spark from scratch and in very much depth, right? So on namastesql.com, we have a Namaste Spark course 0 to Hero, and we have covered everything in detail, right? In very much detail, I have explained a Spark UI, internals of Spark, right? Various performance techniques, writer API, catalyst optimizer, cache, join strategies, right? Spark Summit, dynamic resource allocation, Delta Lake, right? And then we have done a project on Databricks. We have talked about Ryan architecture, memory management. We have implemented a Medellin architecture also on the Databricks, right? So we have covered everything in detail. You can use code Spark, SPARK, Spark at the checkout and get the best price. You will also get notes, right? So this is my last minute prep. But if I go there, you see for Spark, I have, we have gone through the big data history, what is Hadoop, MapReduce, right? What is SDFS, cloud storage. So you will get detailed notes as well, right? And we have set up so the biggest problem learning Spark is doing a setup, right? So we have done setup on Docker, right? It will take 5-10 minutes and you will have a cluster like feeling on your system. It may be Windows or Mac, it works on both. So we have explained that also, right? And in my system also I have done same setup and I will be showing you everything on that, right? So make sure, if you are not very confident on Spark, you want to learn from scratch, you go to namasteschool.com and you can complete this course. It will take maximum 1 month if you are doing practice along with this, and you will feel very confident knowing about Spark. Okay, let's get back to the topic. Now let's understand how data will be distributed amongst multiple machines or executor and how they will be processed, right? So let's say we have 600 MB of data, right? Now one thing you have to understand that Spark is a in-memory processing engine, right? When I say in-memory processing engine, it doesn't store any data. So it is a plug and play kind of processing engine where you read data from somewhere, it will take data into memory, process it in the distributed way in a parallel way and write it back to somewhere, right? So it is in memory processing engine, right? So now when you read the data, let's say you write your code, let's say this is your orders data and you say I'm just writing some code, read.csv, and you say csv, and you say read this data, orders.csv data, right? Now this data, it will read, and it will read in form of partitions, right? So it will break this data into partitions, in memory partitions, right? So this data is somewhere, right? When you read it in Spark, it will break this data into small partitions, and those partitions will be processed in parallel, right? Now, how partitions will be created? So by default, you will create 128 MB of partitions. So each partition will be 128, 128, 128 MB, right? So in this case, there will be 4 partitions, 128, 128 MB, and there will be one more small partitions, right? So maximum partition size by default will be 128 MB, right? So it will be something like this. So you will have 5 partitions of data. Each will contain 128, 128 MB, and last partition will be small because we have total 600 MB of data, right? So it makes 512 MB, and rest of that will go into partition 5. Now what driver will do, it will check there are 5 partitions. So to process each partition, it will create 5 tasks, right? Each task will process one partition, right? Whatever transformation you are doing in your code, right? So for each partition 128 MB, there will be one task. So what Spark driver will do, so Spark driver will come into picture, right? And it will create 5 tasks, right? One for each partition, T1, T2, T3, T5, and then this driver will send these tasks to different executors, right? So driver will create 5 tasks, just focus here, right? And then it will send these tasks to executors. Now here is the very important thing, that will these all 5 tasks run in parallel? No, it depends on how many number of codes we have in our cluster. So let's say we have 2 executors in our cluster, and each executor has two codes, right? So we have total 4 codes. Now one core can process one task at a time, right? So what will happen, these 2 tasks will go to executor 1 and will be processed in parallel in executor 1, right? There are 2 codes, so this core will process task 1 and this core will process task 2, and these 2 tasks will be running in parallel. Similarly, this task T3 will go to executor 2 and T4 will go to executor T4, right? Because each of these executor can process two tasks in parallel because they have two codes, right? If they have four codes, they can process four tasks, right? So for now, they will process two tasks. Now one task will be remaining. So as soon as let's say these tasks T1 and T2 are over, then what driver will do, it will send T5 to this executor 1 or wherever. Let's say these tasks are processed first and executor 2 is free, then it will send this to executor 2. That driver will check, it will talk to the source manager, and that will happen internally. We don't have to be aware about it, right? But the important thing is that 4 tasks will run in parallel. That is the important thing, right? And then rest of the task will come after one of the task is over. So whatever task is over, let's say T1, T2, T3, T4, if T3 is over, then one core is free and immediately driver will send that task to that executor, right? So this is how this parallelism work. If you have, let's say, one more executor, right? So you will have total 6 cores, right? You will have total 6 cores, then 5 tasks can run parallelly, right? One core will be free, but all 5 tasks can run parallelly and give you the result, right? So this is how the data will be processed, and I will show you on the Spark UI as well, right? The beauty of Spark is you can see all of these things, whatever I am showing you here on the Spark UI, right? So with this understanding, let's move to Spark, right? So I have set up my Spark on Docker, right? So I have a driver installed here. Wherever you see this Jupyter, then I have resource manager where you can see there are 2 workers, right? And each worker or executor has two cores. So I can run 4 tasks in parallel in my cluster, right? So let's see, right? We will see this in action exactly. Okay, now one important thing is to enter into Spark cluster. So this is a Spark cluster. We have 2 machines, right? There is something called as Spark session, right? So we have to create a Spark session, and with that Spark session variable, we can enter into the cluster, right? For example, if I just say here 2 plus 2 and 2 plus 2, right? And if I run this, so this is not going into Spark cluster. It is just running on my Jupyter driver node, right? It is not going into Spark cluster. To go into the cluster, you have to use the Spark session, right? And with that, you can distribute your data amongst the executor or worker, whatever, right? So this is my Spark cluster. Let me remove it. So this is my Spark session. You can even see the details of your Spark session. So if I just run this, you can see my Spark version is 3.5.1 and whatever, right? Great. Now what we will do, right? We will create a CSV file. So I have a 1.1 GB CSV file, right? And we will see that how we can read it and how many tasks will be created. Okay. So I will say spark.read.csv, right? And then I will give the path. So I will say data orders underscore 1 GB.csv, right? So this is around 1.1 GB of file, right? So how many tasks or partitions will be created? We will see, right? So let me just check. So if you see, 128 into 8, right? So if I run this, this is 1024, right? And I have 1.1 GB file, which means I should have 9 partitions and 9 tasks, right? 9 partition, and for each partition 1 task. So we will have total these many tasks, right? As per our understanding, this is how it should be. Okay, great. So let's read it. So I'm reading it. Once I read it, it will create a data frame and it will be in-memory data frame, right? We all understand that Spark doesn't store data on the fly. It will create a data frame. Once the session, if I stop the session, this data frame will be gone, right? So it is only in memory, temporarily it will be created. Okay. So I'm saying df is equal to spark.read.csv. This is my CSV path. Now in my CSV, I have header. So I have to tell header equal to true, which means our first line is header, right? And if you want to see the data, you can just say df.show, right? So it will show you the first 20 rows, not full data, right? So let me run this. This is done. And then I will say df.show, and this is showing me the data, right? df.show, order ID, customer ID, these are my columns. Okay, great. Now before I show you number of partitions and all, right, let's see that how it inferred the schema, right? So inferred column name and data types also it should be able to infer. So we can see using print schema, right? So if I run this, currently if you see all the columns are string, right? Which is not a good thing, right? We don't want everything as a string. So we can tell Spark that infer schema. So infer schema is by default false. So I will say infer schema is true, which means when you are reading data, infer the schema as well, right? So I will just run this, right? It is just reading the data so that it can get what are the data types, right? So if you see here, now it is fine. See, order ID integer, 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 order date is date, price is double, state is string. So it is all fine, right? So you can tell Spark that infer schema, then it will go check the data, and as per data, whatever is there in your file, it will infer the schema, right? But this is not the best way, right? What you can do, you can enforce the schema, right? So what you can do is, you can say, so if I just say columns, I think it should give me all the columns. Yeah, so I'll just copy this, right? So you can say my schema or orders schema. You can define the schema and pass it. So instead of Spark inferring the schema, you should tell that this is the schema. You should enforce the schema, because it can sometimes read a schema in a wrong way, right? For example, if you want order date to be a string, you want to enforce it, you can do it, right? So let me do it. So I'll say orders schema equal to, and you can pass all the columns and data type in a string format, right? So let me just quickly do it. So I'll just remove this and this and this, right? So I'll quickly do it. State quantity, right? This is my schema, and I just have to pass it as string. So I'll say quantity is int, state is my string, right? And order status is also a string, order date is date, price is double, product ID is, I think, int, right? Customer ID is also int, and order ID is also int, right? So instead of Spark infer the schema, the best practice is you enforce the schema, right? And then I'll just take it here, Control X, put it here, right? And then I will say that instead of this, you take this schema equal to orders schema, right? That way, Spark doesn't have to read data. It can directly say, okay, using this schema, I will create my data frame, right? So let me run this. It is done. And then I will say df.show. It is showing me data. And if I say print schema, it will show me the correct schema. Integer, integer, integer. This is double, date, string, string, integer, right? So this is a better way to enforce the schema. Great. So we have created the data frame. Now let's see how many partitions will be created, right? We are saying that each partition will be 128 MB. So I can check it using df.rdd.get num partitions, right? So let me run this. So it is showing me 9, right? Now what I will do, I will do some filtration on this data, right? So I'll write some code here. So I'll say df.filter. This is PySpark API, right? So okay, so one more thing I want to clarify here, right? So Spark is written in Scala, right? Internally Spark is written in Scala language, right? But you can write code and send it to Spark using Python, Scala, Java, any of the languages, right? So when you use Python to interact with Spark, it is known as PySpark, right? Otherwise, engine is same. Doesn't matter if you write with Scala or Java, the Spark engine behaves the same. There is no difference. It is just that you are using Python API. So Python is a very widely used language in data science, data engineering, right? So they have a Python API of that, and that is known as PySpark. And you can write your code in Python, and you can work with the Spark, right? So let me do that. So this is the simple syntax to filter the data, right? You don't worry about syntax for now. You should understand how Spark works and then some of the interview questions around it. So I'll just write this that let me see the data quickly. So I'll just say df.show. Okay, so let me put a filter. I will say state equal to Assam, let's say, or Delhi. Assam is fine. State equal to Assam, right? So here I am putting this filter within double quotes. So inside, when you are giving a literal value, it should be single quotes, right? If you outside use single quotes, inside you can use double quotes, right? So this is what I am saying. So I am saying df dot filter. I am filtering data state equal to Assam, and then I will say df dot show. Okay, so it will show you the data. Great. Now when you do show, it just shows you the top 20 rows. So what we will do, we want that Spark should process all the data. So I will do a write, right? So I'll say Spark df.filter state equal to Assam dot write dot, don't worry about syntax for now, mode, and I will say override, right? And then I will say dot um, mode is the override, which means if file is already there, overwrite it, right? And then we have format. Let me put it as CSV for now, and then dot save, and I will just give some path. So I will say data. I'll show you that path, right? I will say dot save data, and let me call it as Assam orders underscore Assam, right? That's it. Okay. So basically I'm filtering the data and I'm writing it somewhere, right? So let me run this. Okay. So this is running. It is showing you few things, right? This is fine. Okay. Now this data will be there, right? I can show you as well. So let me go there. And so you see this data is created inside my data folder orders underscore Assam, and some files are created. We will talk about why 8 files are created and 9 files are created, right? We'll talk about it. But for now, let's come back here and you will see that I will go to the Spark UI, right? So this is my master, right, which is as localhost 8080. Now I will go to Spark jobs, right? And this Spark job is at localhost 4040, right? So I will just refresh it. Now you will see some of the jobs are created, right? Some jobs were created earlier, but just now what I ran, for that this is the job created. Okay. What I can do, I can stop it and show you again, right? Otherwise you will be confused. So what I will do, I will stop the Spark session and create a new one, right? Spark dot stop, right? Done. I will create the session again, right? And this is my orders schema, and this is I'm going to write it again. Okay, great. So this is done. So I will go back to the Spark UI, right? It would create one job. If you see, there is only one job created, right? And it is saying 9 tasks, right? I told you that if there are 9 partition, 9 tasks will be created and there will be one job created. I'll tell you why one job, right? But let's go inside this. Now, if you see, it has created one stage. What is stage? We will talk about it. But if you come back here, you will see there are total 9 tasks. You see 9, 0, 1, 2, 3, 4, 5, 8 till 8. So there are 9 partitions. So 9 tasks are created, right? And this is the input size record. So 128 MB, one was small. I told you one is small, around 153 MB, right? So this is the all the data is processed by each task, and output size is this. So after filtering the data, right, state equal to Assam, only 5.4 MB was remaining, and each task has written one file in the output. So in the output, if you see, there are 9 files, right? Why 9 files? Because each task has written one file 5.4 MB, right? You can check the size also, it will be 5.4 MB. Sorry. Okay, great. Now, if you see the timeline, right, we have two executors. I showed you some tasks are on executor 0, some are on 1, 0, 1, 0, 1, 0, 1. And you can see the timeline here. So if you see, initially 4 tasks were executed, right? So this has 2 codes. this has two codes, right? I showed you in the master. I have two codes, right? For each executor, right? So if you see four tasks, so driver gave two tasks to this executor and two tasks to this executor because they have two codes, right? Once these two tasks are over, it will then again give two more tasks. Here again, these two tasks are over, it will give two more tasks, right? Once this is done, as soon as this task is over, there is one more task left. So this will go here, right? So this is how we executed all 9 tasks. So this is how I'm able to achieve the parallelism across the machines, and I'm able to do distributed computing, right? So 9 tasks, 4 are running in parallel, then next 4, right? Then this is the last one. So as soon as this task is done, the last task was assigned, right? This is the task, this is the code where task was finished first and then it became free, so driver gave them, right? So it is driver's responsibility to manage all of this, that which code we have to give how many tasks. Okay, so I hope you understand it, right? It shows you the matrix as well, that what is the minimum duration, maximum duration, all of this, and it shows you the executor ID, that executor 0, it has total 5 tasks, is that it is executed, and this has executed total 4 tasks, right? And total size and all you can see. Okay, so I hope you understand how this works. Okay, great. So we said that by default that it will create 128 MB of partitions, and we saw that, but we can control it, right? So we have a Spark configuration, right, which is this one, right? So you can, so by default it is 128 MB. So I will just show you. So I will say uh, spark.configurations.get, and this is one of the configuration, right? So if I just run it, it says it gives you in byte, right? So let me convert it into MB. So I will say divided by 1024 multiply. So this will give me in KB, and then this will give me in MB, right? So if you see, something is wrong. I missed 8. Okay. So if you see, this is 128 MB, right? So you can set something else, right? If you want, let's say more, so you can pass it. So let's say if you want whatever size, you can give it and run it, it will change it. So your partitions will be created as per this size, right? But 120 MB is standard, right? After a lot of research and all, they have come up, Spark has come up with ideal size of 128 MB, right? So we will not change it, but we can change it. We have that um, uh, we have that property that we can set and change the max partition bytes. Great. Let me remove it for now. Now there is one very important thing here, right? So let me do this. So I'll just create another data frame. So I will say df underscore filter. So I'm not writing it, I'm just saying filter it, right? So df filter equal to, I can just comment it, or I will not run this cell, right? I am removing it for now. So I'm saying df filter, right? I'm saying create a data frame where df, it is filter. So df dot filter state equal to Assam. Okay. Now I will say df selected equal to df underscore filter dot select, and let's say I want some particular columns only. I don't want all the columns in the output. So I will say select, and let's say I want order ID and order date. Right? I want only 2 columns. So I'm selecting only 2 columns. Okay. So now if you see, what is happening is I have first of all df, right? This I have commented, right? So df is there, and then df filter, right? This is filters, and df selected. Now let me run this. Okay, it is giving me error. So let me see what is the error. Unresolved column. Okay, I have to say like this. My bad. Yeah. Okay. Now it is fine. But if you see, it ran so fast, right? So if I go to Spark jobs, right, there is only existing one job. It did not create a new job. This is the last job which we ran, right? When we write the data, filtered data. But when I'm running this, nothing is happening, right? It is not creating any job. It is not doing anything, right? So there is a concept of lazy evaluation, right? So lazy evaluation. And this is a very common question, that what is lazy evaluation, right? So maybe it is there in my interview list. Let me check. Yeah. What is lazy evaluation in Spark? Spark does not execute transformations immediately when you write them. Instead, it builds a logical plan known as DAG and executes everything only when an action is triggered, right? So now you will see that Spark will not do anything unless and until you ask for the results. So here you are just saying filter it and that's it, and assign it to df filter. Then you are saying select these two columns and assign it to df selected variable. That's it. You are not saying show me data, or you are not saying write this data, or you are not saying count this. You are not doing anything which Spark has to do some work, right? You are just saying that assign this to this and then filter and assign this to this. So Spark will not do anything, right? So this is known as lazy evaluation, and it will help in optimizing the plan, right? So now what I will say df underscore select, right? And then I will write it. Okay, so I'm saying df select dot write. So whatever this data frame is, right? Df select dot write dot mode override dot format csv, and orders Assam selected, or it's fine. I'm just putting it orders underscore Assam, right? It will overwrite. I'm saying write it in overwrite mode, right? And format will be csv. If you don't give anything, it will be PySpark format by default. Okay, so let me run this now. So I will run this cell, this I ran already, this I ran already, this cell as well. So let me run this cell now, final. Okay, so it is saying me error. So let me call it df selected. Okay. So now if you see, it is doing something and it would have created a job. Right? So if you see, there is a new job created, this one, right? It is again processing 9 task and same thing. We have the same file, right? Now, which means all the commands or all the transformations and actions, right? So all the commands are into two categories in Spark, basically transformations and actions, right? So this filter is a transformation, select is a transformations, and transformations are lazy, right? Because until and unless you trigger the action, it will not do anything. Spark will not do anything. It will just create the plan that what has to be done, and that is known as DAG, directed acyclic graph, right? You can see that in here as well. So if I go here, this is the graph it will create, that scan it, and then it will create some filter here, and then it will say write files, right? This is one stage. You see, this is what it is showing, right? So it will create a DAG. It will not execute anything, right? It will just keep creating the plan, but it will not do any work. It will not send any data to executor to processes unless and until you have done a action, right? So if you see, what is transformations and action in Spark? Transformations are lazy, right? This is a very common question. Actions trigger execution, right? Example transformation are filter, select, group by. Actions are show, right? When I say show, then it will show me the data. When you say count, so it has to count again. When you say collect, it will show you all the data on the driver. When you say write, it will write the data, right? So unless and until you trigger the action, nothing will be executed, right? So this is a lazy evaluation, and you have transformations and actions. So these are the actions mainly, right? And everything else like filter, select, or creating a new column, right? That is all a transformations. Okay, great. I hope this makes sense. Now, one very interesting thing here is that how lazy evaluation helping Spark, right? So there are a couple of reasons. So first reason is, if you see, so what I'll say df selected dot explain, right? So explain will give you the plan. What is the plan that Spark is creating, right? So I'll just run this. So for df selected, this is the plan, right? So what it is saying, you have to read bottom to top, right? So it is saying scan csv, right? So it is reading this file, and if you see, it is reading only these three columns: order id, order date, state, right? Imagine if it was not lazy evaluation, then what it will do, right? It will read this full file, all the columns, then it will filter this data, and keep all the columns in DF filter, then again it will select only these two columns from DF filter and give us, right? Instead, it is lazy evaluation, so it will check all the transformations that you are doing, and based on that, it will create a optimized plan. And this is the work of Catalyst Optimizer, right? Catalyst, you would have heard this term, right? So what it will do, it will create a optimized plan. So if you see, it is not reading all the columns. So in memory, it will get only the three columns: state, order date, and order ID. Then it is doing a filter, right? It is saying that give me all the records where state equal to filter, and then it is projecting only two columns which are required, right? Without lazy evaluation, it will not load, right? After every single line, it will just execute. After every single line, it will just execute, and it will be very, very slow, right? So this is the whole purpose of lazy evaluation, that once a action is triggered, then check the full DAG, full plan, and optimize it, and then run the final execution, right? So this is how it helps you. Okay, great. Now we have seen here that when I apply filter or select, right, I am creating 9 partitions and it is creating 9 files, right? I can show you the plan again one more time. So I will go here, and if you see, there are 9 tasks, right? It is filtering data, and there are small output records, 1.9 MB and this, because it has only the Assam data and only 2 columns we are getting in the output, and it would have created 9 files in my output as well, which is fine. Now, this thing is working fine with the filter and select transformation, right? I'll show you what will happen if I use group by or join or any other transformation, right? So let me go back here, right? Now let's imagine, right? So we have these partitions, right? So maybe let me take this here. So let's say I have this partition and I have this partition, right? And I have this partition. For simplicity, let's say 3 partitions, right? That's fine, right? And this, let's say, remove it. So this is fine. For now, I have 3 partitions. For simplicity, I am creating 3 partitions so that I can explain you the concept. Let me make it little big. Okay, I'll change the size later as per the requirement. Okay, so you have orders data, right? And it is there in the 3 partitions, right? Let me put some data. So you have order ID, and let's say category, and let's say sales. Okay, so let me reduce the size a bit, medium. Yeah, now it is fine. Okay, so order ID 1, category, let's say, or state, let's say state, right? State is UP and sales is 100. Let's say this is my data, simple, right? Another record 2, and then we have Karnataka, and let's say 200, right? And let's say one more record is there, 3, and this is, let's say, MP, right? And again 150, let's say. Okay, so this is fine, right? In my partition 1, this is the data. Similarly, I will have data in partition 2, right? Let's say it has 4, and this may be from, let's say, MP, right? This may be from UP, right? It can be any state, right? Karnataka. Let's say I have 3 states of data for now, right? Just imagine, right? So it is all random, right? In each partition, I can have all the states or only one state. So it is randomly creating partitions, right? It is not that it is dividing based on some column. So 3 partitions were created, right? They can have all kinds of states of data. And similarly, this we have one more, right? So we have 3 partitions, and this is how it is, right? Let me make it 6, and this is 7, and this is 8. Okay, great. Now, in my first query, I said, give me all the data where state equal to, let's say I'm saying UP, right? So when I say state equal to UP, right? Or maybe one more thing, let me take one more UP here, right? Just I want to explain something very interesting. Okay, so this is all fine. And let's take one more here, MP. So this will be 9, 6, 7, 8. 1, 2, 3, 4, 5, 6. Okay, this will be 7, 8, 9. 7, 8, 9. Right, and let's say one more is there. 10, and this is again MP, and this is again, let's say 500, whatever. Okay, so this is how it is. Now, when I'm saying give me all the data where state equal to MP, right? So my query is give me all the data where state equal to MP. Okay, so this partition, right? This partition will get the data for MP and write it in the output. As simple as that. Right? This is how each partition is writing its own file. Right? So it will filter data for MP and give them the output. Similarly, partition 2 will filter data for MP and give you the output. Right? So this will give you 3 MP 150. And again, this will give you 4 MP 100. Right? Each partition is getting processed individually, right? And this will give you this. Let me take this, right? So this will give you 7 MP 100 and 10 MP 500. And this is how it is working. Very simple, right? Parallelly, these tasks are getting executed. No issue. Great. Now, let's say my requirement is I want state-wise sales. So I'm saying give me group by state and give me sum of sales. Now what will happen? In earlier case, these partitions could execute independently. There was no need to talk between these partitions, right? Because this can filter individually, this can filter data individually, and this can filter. But in case of group by, there is a problem, right? When I'm saying I need group wise total sales, which means I have to bring all the UP records together, isn't it? If I don't bring it, then this individual results will come. It will say UP 100, right? And this will say Karnataka 200. And similarly, again from here UP record will come, and that will be wrong, right? In case of filter, it was fine. But in case of group by, I have to make sure all the UP records are together, all the MP records are together, all the Karnataka records are together, right? Then it will give me right result, and that is when data shuffle will happen, right? So data shuffle will happen between the executors, right? So what it will do, each executor will write result to disk, right? So it will write result to disk, right? And then this data will be distributed so that same state goes into the same partition, right? So what will happen after the shuffle, right? So each executor will write data to disk, and from that disk it will be distributed to, so let's say this is executor 1 is here, it executed some partition, and then we have one more executor, it executed some partition, right? So it will write data to disk, and this will also write data to disk, right? And again this data will be distributed to different executor and task, and it will make sure that same state is going into same partition, right? So after the shuffle, the situation will be like this. We will have all the UP records together. So UP will be here, and then this will also be there, and then we have 2 more UP records, right? So these all will be together. Let me take this, right? There is one more interesting thing, I'll just show you. Just wait. Okay. So all the UP records will come together after the shuffle, right? After that, what will happen? Similarly, all the MP records will be together. So there will be one more partition, right? All the MP records will be together. So there will be one record of MP here, and then one record of MP here, and then I have two more records of MP. So it will make sure that particular key is based on your code. So in our case, key is state. I want to group on state and all the same states are together, right? And there will be one more, which will be Karnataka. Now, one important thing here is that it is not necessary that on one partition only one state will go. But one state will always be in a single partition. Which means it might be possible that this partition has all the MP records as well as all the Karnataka records. So it depends on how many distinct values are there and how many partitions are there. We will talk about it. But one key will always be on one partition. But one partition can have multiple states. So it can have all the records of MP as well as all the records of Karnataka. That is possible. But for now, simplicity, we are taking into three different partitions. And now when aggregation will happen, it will give me right result. UP, and it can sum all together. MP, it can sum all together. Karnataka, it can sum all together. And then my output will be correct. Right? I will have three files basically in the output. Okay, great. This is fine, right? Now there is one more optimization it will do, right? Spark. What it will do, that it will check, okay, before shuffling the data, can I do the local aggregation? Which means it can first aggregate data here itself within this partition before writing it to disk, before shuffling the data amongst the executor. So what it will do, intermediately before shuffling the data, it will do a local aggregation, and it will say for MP the total sales is 600, and for UP total sales is 350, right? Similarly it will do for this. So it will say it has all distinct, right? But it can have duplicates value based on state, right? But for now it will just say MP has 100, right? UP has 200 and Karnataka has 150, right? So it will do local aggregation first. Similarly, here also this partition will also do local aggregation first, right? So it will say UP has 100, right? Karnataka has 200 and MP has 150, right? So after local aggregation, my data will reduce drastically, right? This is a small example. In big data, there will be millions of records for only Karnataka. So it will do local aggregation first, right? Once the local aggregation is done, then it will shuffle the data, right? And each shuffle will create a new stage. I will show you in the Spark UI. But this, I hope you understand, right? So it will do local aggregation first, then it will sell all the IMP records on a single partition. Similarly, all the UP records on single partition. That way the shuffle will be less, right? Because it has to write to the disk and then distribute the data, right? If lesser the data, faster shuffle will happen, right? So let's see this in action. So what I will do, okay, so now I will say, let's say I was in df. Let's make a simple one. So I'll just take df directly, right? So I will say df underscore grouped equal to df dot group by let's say I'm doing group by state, right? And then aggregate sum of which columns I have, let's say price, right? Maybe it is price into quantity, but for simplicity, or let's take quantity. I want total sum of quantity, right? Simplicity, right? And I can alias it. Don't go on the syntax, right? So I can say total QTY sold, okay? And that's it. I'll close it, right? So this is what I want. I want to group by on state, and then I want sum of quantity, and I'm aliasing this column name as total quantity sold. Now what I'll do, I will write it back, right? So I'll just take this, paste it. Okay. Now before I run this, right, what I should do, I should import this sum function. So we are using this sum function. So I will say import, from PySpark .sql .functions functions import star, right? So I'm basically importing all the functions. One of the function is sum, and let me run this now, right? So we will see what is happening. So it is running, right? So it will run, and again it has created 9 tasks because we have initial number of partitions were 9. Okay, so let's go back to the jobs. So if you see, one more job is created now, right? And you see something 209 tasks, right? Don't worry, we will explain it. Okay, so if you see, there are two stages created now, right? And that's what I was saying. Whenever there is a shuffle, there will be two stages created, right? And whenever you see this exchange, it means it is writing the data to disk and then reading it. So there is a shuffle. Wherever there is a shuffle, there is a exchange, right? So if there is one group by, right? Group by is one of the transformations. We'll talk about it where this shuffle is happening, right? So if you see, this is the first stage. In first stage, what it is doing, it is first reading data in 9 partitions, and then if you see, it is creating a shuffle write. So it is input size record and it is shuffle write size. Now if you see, there are only 22 records. You see, there are 22. Why only 22, right? There were a lot of records because it is doing a local aggregation first, and we have only distinct 22 states. The distinct states in my data are 22, right? I can show you quickly if you want. So what I'll do, I'll say df dot select state, and then I will say distinct and then show. Right? Or let me do count, right? So I'll just do count instead of show. So count is also an action. So if you see 22 states, which means it is first doing the local aggregation. So in local aggregation, it would have read 128 MB of data and would have locally get total sum for each state. Total sum for each state, and that is why you are seeing 22. After then shuffle will happen, and once shuffle happens, right? Let me go back. Once shuffle happens, then it will do group by. Now by default, after shuffle, Spark will create 200 partitions by default, right? Again, there is a property, we can change it, but by default, Spark will create 200 partitions after the data is shuffled, right? But if you see, we have only 22 states. So maximum, each state will go to one partition, right? So maximum 22 partitions can have data, right? So if I just read this, you see, there are a lot of them, but if you go here, see, till here, there is no data now, right? It all partitions are empty, right? So let me just do this maybe, yeah. So if you see, there will be only 22 partitions which have data, and everything else will be empty, right? So you see what it is doing now. It is first reading the data, doing local aggregation, right? Or if you have any filter, that also will be done, and then local aggregation, and then it will shuffle the data. And it is now in this stage, it is saying shuffle read, right? So earlier it was shuffle write, now it is shuffle read, right? So this is how it is happening, right? So it is reading 9 records, and this is how it is happening, right? Now there is a one important thing, right? So there are two kinds of transformation. One is this kind of transformation where shuffle will not happen, and there will be another kind of transformation where shuffle is required, for example group by, and this is known as narrow and wide transformation, right? Narrow transformation, let me read the definition, right? So you will see what is narrow and wide transformation is Spark. A narrow transformation is one where each output partition depends on only one input partition, right? So it doesn't have to look into another partition. This means data does not need to move across executor, so no shuffle happens, right? So if you are doing a filter or select or creating a new column or doing union, there is no need to shuffle the data, right? This is known as narrow transformation. And then comes and they are fast because no data movement across nodes, no shuffle, process locally within partitions, right? A wide transformation is one where output partition depend on multiple input partitions, so Spark must redistribute data across executor, which causes a shuffle, right? So for example, if you are doing group by, right? In case of group by, in case of join also, because same key should be in the same partition if you want to do join, right? Similarly, order by, repartition, we will see other things as well, right? Now, what is shuffle in Spark? Shuffle in Spark is the process of moving data across executor in the cluster so that records with the same key end up in the same partition, right? It usually happens during operations like joins, group by, order by, distinct, right? So I hope all of this shuffle uh, and stages and narrow and wide transformations are clear, right? And always remember that we will have one job for each action, right? And how many stages will be there? Stages will be 1 plus, right? Or if you are reading one file, if you are reading two files, there will be two stages, right? So we are reading one file, 1 plus number of wide transformations, right? So we had one wide transformation group by, right? In our case, we had only one wide transformations here. So one file we are reading plus one wide transformation, so two. If you are doing one more group by, so there will be one more stage. So whenever data shuffle is happening, you will see there will be a shuffle, right? There will be a new stage created, right? And you can even see the plan, complete plan here. And if you see, these are the tasks, right? And these some of the 200 tasks it created, but some of them are nothing. Have not processed anything. They are close to zero, right? So this is why it is important to understand when the shuffle is happening, right? Because see, you cannot stop shuffle, but you should know that now shuffle will happen. So what is your data? Accordingly, you should know it, right? Now, why 99 records are coming here? Because from each partition, right? From each partition, one record will come, right? So let's say for UP, right? So for UP, from all the partition, local aggregation would have happened, and all 9 records of UP would have come here. All 9 records of Karnataka would have come here. All 9 records of Assam would have come here, right? Because there were 9 partition, and each partition has each state of data. That's why 999999 is coming, right? And one of the partition might have more data, right? So that's fine, but you understand. Okay, great. So I hope this is clear. Now there is one more important thing now. So let me see the output first, right? So I'll go here, and if you see, uh, this is my orders Assam. This is where I'm writing, right? And this has created these many files, right? How many files are there? 21, right? Other files were empty, right? So there were 21 files, but for each um, it would have created 22 states are there, right? So for each state almost one file is created, right? Yeah, great. So after shuffle, each partition will have same state. So one will have Karnataka, one will have Assam, and all of that. But if you see, these are very small files, right? Don't you see these are small files, right? So maybe your requirement is you don't want to write so many files, right? You want to merge these files before writing it in your output, right? Because when you read it back, it will take extra effort for Spark to read so many small files, right? And you don't want too many small files to be created, right? So what you can do, and that is where repartition and coalesce come into picture. There are other use cases also, repartition and coalesce, but this is one of the use case that before writing data back to your output, you want to reduce the number of partitions, right? You don't want to create multiple file. You want to create only maybe one file or two file or whatever, right? Because you can just give the folder structure and read these files. So for example, instead of giving this, right, when I'm reading this, right, I can just say read from the Assam folder, and it will just read from the Assam folder all the files, right? But if there are 20 files, then it will take some extra effort for Spark to read the files. So I don't want to do that, and don't want to create too many small files. So what I can do repartition, or I can do a coalesce. So we will see what is the difference between those two. So for now, what I will do, I will say df grouped, df repartitioned equal to df grouped dot repartition, and I'm saying repartition into 2. Right? So I'm saying repartition this into 2, right? And then write this. So what it will do, it has, after grouping, it has 22 partitions, right? Each partition contain one state, right? So what it will do, it will group data and repartition data into 2, so there will be only 2 files in the end. Okay, so let me run this. Okay, so if you see, there are only 2 files, right? The file size is more, but we have only 2 files. Right? So what repartition is doing, it is taking all the data, right? All the data from 9 partition and distribute into 2 partitions, right? So let me show you. So it will also try to distribute it equally, that both the partitions have almost equal data. I'll go to jobs, right? And this is the job, right? Now it is saying 3 stages. So I'll show you what it is doing. So repartition again creates a shuffle, right? Because there were how many? 22 files, right? 22 partition. They will again write the data and redistribute into 2 partitions, right? So if you see here, first 9 partition it created initially, then after shuffle 200. Now again shuffle is happening. So repartition is a wide transformation, right? So 200, then again it will do repartition and it will do into 2, right? So again this repartition causes a shuffle. See, 200s are there, right? And when I go back to this, the last stage, right? One more stage is created, right? It is a wide transformation. So it is creating 2 partition in the end, right? 2 tasks. Okay, so this is fine. Now there is one more thing. So what it is doing basically, right? Let me explain you more clearly, right? We have data in 9 partitions, right? Let's say each has 1 MB data, right? So it will be written to disk, and then it will create 2 partition, and each partition will have almost equal data, 4.5 MB and 4.5 MB, right? So this is how it is happening. Now there is a better way of doing it using coalesce. So let me show you coalesce. Okay, so I'll run this again. Okay, and if I just go back to Spark UI again, it has created one job. Now if you see, there are only 2 stage and one coalesce is happening. But coalesce is not creating a new stage because coalesce is not a wide transformation. What coalesce will do, it will just combine the existing partitions. It will not redistribute and create new partitions. What it will do, so for example, you had 9 partitions, right? So maybe it will take 1, 2, 3, 4 partitions and merge into one, right? It is not doing shuffle. It will just take as it is and merge these partitions. Similarly, 4, 5, 6, 7, 8, 9, right? This will merge and it will create one partition. So you will have total 2 partitions. In this case, there is no need to shuffle the data, right? In this case, shuffle is required because we are taking all the data and redistributing, right? So shuffle is required. But in this case, the existing partition, whatever it was, we are just merging it, right? So if I go back here and if I show you here, it is showing only 2 partitions, right? So it would have, so initially there were 200 partitions, out of that only 22 had data, and then it would have coalesced it and converted into 2, right? And it will be much faster, right? There are only 2, right? So this is the difference between coalesce and repartition. Let me read it for you. Where is that? Yeah. So repartition can increase or decrease the number of partitions and always performs a data shuffle, right? So when you are doing repartition, because you are redistributing data again, you can say, okay, I need 100 partitions. So it will distribute among 100 partition, or you want to reduce it, you can reduce it. But with coalesce, you can always only reduce it, right? Because it is merging the existing partition. So if you say coalesce 100, it cannot do. You already have only 20 partition. If you do 100, it will just keep it as 20 only. It will not give you error. So you can only decrease number of partition efficiently by avoiding a full shuffle if possible. And is generally faster for reducing partitions, right? So this is the difference between repartition and coalesce, right? Other use cases can be, there can be many use cases for coalesce and repartition, right? For example, let's say you are filtering data, right? You are doing a filter. And now after filter in partition 1, let's say you have 1 MB data. In partition 2, let's say you have 100 MB data, right? You don't know after filter in each partition how much data will be there, right? In P3, let's say you have 1 GB data, right? Now if you do a further processing, then you see this will be a small partition, this is a okay, and this is a big partition, so this will take a lot of time. So instead of that, you want to redistribute it equally, right? If you do coalesce, let's say you do coalesce 2, right? So what it will do, it will maybe merge these two and this will be 1, right? But if you say repartition 2, what it will do, it will take all the data. So you have around 1100 MB of data, and one partition will have 550 MB data, another will have 550 MB data, right? Or if you say repartition into 5, right? So you will have around 220 MB of data to each partition, and you can do work more efficiently, right? So they have their own use cases, right? But if you want to just reduce the number of files or number of partitions, then I think coalesces mostly works well. Okay, so this is the difference between coalesce and repartition. So these are all very important questions, right? What is shuffle? What is repartition and coalesce, right? And what is narrow transformation? What is DAG, right? What is wide transformation? What is lazy evaluation? How it helps, right? What is transformations? What is actions? How many stages will be created, right? How many initial number of partitions you can just control from here, right? So these things are very important. Also, you can, if you go to the Spark UI, right, you have this SQL DataFrame tab. If you go there, you can see all the jobs here and you can see the exact plans, right? So it is saying scan CSV, then it is doing a aggregate, so it is doing a local aggregation, then there is a shuffle, right? Then again it is doing a, after the shuffle it is doing the aggregation, right? We discussed when I doing a group by state, it will do a local aggregation first, then shuffle, exchange means shuffle, and then again it is doing a aggregation, and then it is doing a coalesce, right? In case of repartition, it would have created one more exchange, and then it would have write the files, right? So this is how this everything is working together. Okay, now let's talk about another kind of transformation, wide transformation, join, right? So we saw how group by is working, right? Another important one is join, because join also will is a wide transformation, because when you are joining two data sets, same key should be there on same partition, right? If for both the data sets same key is not in the same partition, then there will be a problem. So let's do a join. So I will say, so I have df, right? Let me make it df underscore orders just for simplicity, right? And I'll just run this again. So I have df underscore orders now. Let me copy this and let me create one more. So df underscore products, right? So spark.read.csv. For now, let me take out this, right? I'll just use it later. Sorry. Let me comment it for now. I'll just read it and see. So I have products.csv and I want to join these two data sets. Products.csv header equal to 2, df products.show. Right? So if you see, I have product ID, product name, and cost price. At what cost I'm buying the product, right? So let's create a schema quickly. So this will be my let me put it back. This will be my products schema, right? So I'll just cut it and put it here, and let me create my products schema quickly. So I'll say products schema equal to, there are only 3 columns, so we can do it quickly. This will be int, and then I have product name, this will be string, and then I have cost underscore price, looks like it is int, right? And let me quickly run it again, and this looks fine, right? Okay, great. Now we will do a join, right? So let me join these two data sets, orders and product data set. So the syntax is df underscore orders dot join and then you have to pass with which data frame you want to join. So I'll just say this, right? Now on which column? So we have product ID in both of them. So I'll say product ID. What kind of join I want to do? Left, outer, or inner, or outer, right? I am saying inner join, right? And then I'll just do it again. df joined, right? And let me copy this write statement. I'm doing write, not show, because when I do show, it will not read all the partitions. It will say only to you need 20 records. So it will give you from one partition, and full in UI you won't be able to see the full plan. So every time I'm doing a write, right? So which is fine. Right? There is one more trick. Let's say you don't want to write the data every time. You just want to see the plan. So you can say mode equal to override, format equal to no op. This also works. So it will execute the full plan, but it will not write data anywhere. But you can see the full plan. So you will say mode override, format no op, and save. And this will also work. So let me show it. Right? This is a dry run kind of thing. Right? So this is fine, and let me run this now. It is doing some work, and let's see what will happen. Okay, so there will be a shuffle and 200 partitions will be created by default. Let me go to the UI, and this is the job we just triggered, right? So if you see, first there are two stages to read each file. So this is reading one orders file, this is reading products file. Now both of them are doing a shuffle, right? So this is doing a shuffle. Why? Because same key should go to same partition. Again, this will do a shuffle. So let's say product ID 1. So this will send product ID 1 to the same partition, and this will also send product ID 1 to same partition, so that they can join together. Otherwise, again, there will be a problem, right? So this is how it is. Okay, great. So this is 9 files. This is only one partition, because it is a very small file, only 100 records in the products file, right? So there is only one partition. Here we have 9 partition, and then after shuffle we have 200 partitions, and joins is happening, right? So join is also a Y transformation, where data has to be shuffled so that same key from both the data set will go to the same partition, right? You can see this later. It is not a big thing. Okay, so this is fine. So this is a shuffle join basically. Data is shuffling and we are doing a join, right? So basically, if I just come back here, right? Um, so basically, data shuffle is happening and same key is going to the same executor, right? So for example, this is my orders data set and this is my products data set, let's say, right? And to the same task, basically, if product ID 1 is going from orders data set, this is orders, right? And this is my products, right? So it will do a shuffle and make sure all the product ID 1 will come to the same partition together. Okay. Now there is a concept of broadcast join. What broadcast join will do, okay, that it will say that okay, your product file is very small, right? Your product file is very small. Instead of shuffle, I will send this full product file, right? So let's say I have the full product data here, product.csv, right? What it will do, it will send this full file to executor 1 as well as product file to executor 2. Now what will happen? Shuffle is not required. From orders data set, data is coming in a partition way, that is fine. But full product data is available to executor 1 as well as executor 2, which means if the product ID 1 to 100 all are available here, so whatever keys are there will get here and join. Again, whatever keys are coming from this task will go there and join, and there is no need of shuffle. Now this is only possible when your product data is very small. In our case also it is small, but we have disabled a property. I will show you, right? Once I enable this property, this will become a broadcast hash join. So we will broadcast this file to all the executors, and then there is no need of shuffle, right? So if I go back to my configurations, Spark setup, data, Spark configurations, and open with text edit. So if you see, we have this, right? This property you can see, right? Auto broadcast join threshold. So I have done -1, right? Now what I'll do, I'll just comment it, and I will say that it is 10 MB. So if you converted it to MB, it will be 10 MB, right? It means if the file is less than or equal to 10 MB, you do a broadcast hash join, right? Instead of shuffle, you do this. So I'll just save this, right? And I will go back here. Sorry, I will go back here and I will create a Spark session again so that it takes the new configuration. So I'll just stop it and then do it again. I'll just run this again and I just have to run this and run this and then run this. Okay, so this is happening now and let's see. Okay, I think it created the shuffle again. I need to restart it, I think. Let me check. So I'll just go there. Jobs. It has created the 210 partitions again, right? Okay, so what I will do, I will just stop everything down and Docker console up. Yeah, so this is fine now. So what I will do, I will go back again and run this one more time. So I will create this Spark session again. Because it was taking earlier settings, it didn't read the new configuration file, which is fine, right? This you can ignore for now, that's fine. Okay, and I will read it again and then I will go down to read products dataset. Then we will do this and then again I will do this. So now you see it didn't create the 200 partition. If I go here and this is the job and you see this is broadcast exchange. So it is sending that file to all the executors and there is no shuffle, right? You can see in the jobs as well, there is no shuffle at all, right? 9 tasks created, right? There is no shuffle at all, right? There is a broadcast hash join and we are getting the output as per the join, right? So this is the difference between the shuffle join and this is a broadcast hash join. But the important thing here, if your file is very big, in our case this is a small file, right? And we are saying until 10 MB, if the data is less than 10 MB, then you can do a broadcast hash join. But if it is more than 10, right, then you do a shuffle join. But we can force it also. Let's say yours is 12 MB file, so we can here say broadcast and it will broadcast this file, right? So it will broadcast this file, so we can force it also, right? Now it depends on how much memory of executors you have. It is not that 10 MB is standard. Generally we say 10 MB is fine, but let's say if your executor has, let's say, 10 GB of memory, right? So maybe you will say, okay, until we have 100 MB of file, I'm able to do the broadcasting, right? Because this full data is going to each executor, so you have to make sure that this data is not too big that it doesn't fit into executor memory. Okay, great. So this is a broadcast join. Let's quickly read about it, right? So what is broadcast join? A broadcast join in PySpark is a performance optimization technique where a small data frame is replicated to every worker node in the cluster, allowing joins with a larger data frame to occur locally without costly process of data shuffling across the net, right? So this is your broadcast join. Okay, now with the join, right? Because we are saying when we are doing a join, right? And in case of shuffle join, right? When broadcast is happening, there is no shuffle. We are all good, right? But let's say shuffle has to happen, right? And my one of the key has a lot of data, right? So let me create that data, then I'll explain you what I'm trying to say. So I'll just take this, Control C, and this is also a data SQL problem. So I'm creating a data set, right? Just a artificial data set where what I'm doing here, don't go on the syntax, I'm just explaining you. So I have product ID from 1 to 100, but all the product IDs less than equal to 90, I'm converting into 1. Otherwise, as it is. So most of the product IDs will become 1 and rest of them will be 91, 92, something, 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 right? So let me show you quickly. Okay, let me import it. I think restarted it. So this is a function, right? PySpark. I restarted and I didn't do it from PySpark dot SQL dot functions import star. Okay. Okay, so if you see the 18 million records are with product ID 1, right? And rest of these records are very less 200k, 200k, right? So we have these product IDs, right? Now imagine when I'm doing a shuffle, right? When I'm doing a group by or when I'm doing a join, not group by. Group by will do a local aggregation, which is fine. But when I'm doing a join, right? All these product ID 1 has to go to one partition, isn't it? When I'm doing a shuffle join, when one of my data set is big, right? Then what I have to do, this will go to 1, right? And let me show you. So maybe I will have some data. Let me check. Data and I have, I think, product file. Yeah, products underscore 12 MB. Let's use it, right? So it will not do a broadcast join by default. So let me use it. So I'll say this file. Okay. So let me show quickly. Everything is fine. Cost price is null. I think some issue with the schema. So let me remove this schema first. Okay, so it has only 2 columns, right? It doesn't have 3 columns. So let me change it. So it has only 2 columns, which is fine. Okay, and I'll just paste it back and should be fine. Wait. So this is product ID and cost price. It is double. Okay, not int. Okay, let me paste it again, and now it should be fine. Okay, now we are good. Now what I'll do a join again, and I will show you that it will do a shuffle join because my file is greater than 10 MB, right? So let me do this. And if you see, it will create again 200 shuffle partitions, right? It is creating. So basically, if I go to here, you see there is a shuffle exchanges happening. So this data set is going for shuffle, and again this data set is going for shuffle, right? And then there is a sort merge join happening, and we are giving it, right? So there is no broadcast happening because my file size is greater than 10 MB. Okay. Now what I'm doing, I'm creating a skewed data set, right? And I will join this skewed data set with DF products, right? So what I'll do, I will run this quickly, right? So DF skewed is already there. So I will use this, right? DF orders skewed basically, right? And then I will join it with DF products and we will see something very interesting. This is done and this is also, let's run it. So this is all shuffle is happening. We understand why. And we'll go to jobs, right? This is done. Let me go to, so this we understand, right? It has created 4 partition, it has created 9 partition. Now you will see why 4 partition. It is a 12 MB file. You would think there should be 1 partition, right? Because we have 4 codes. So if the size of your file is less than 128 MB, right? So what it will do, it will just distribute into 4 codes, right? But generally we don't work with so small files in Spark. So don't get confused, right? So let me go here. Okay. Now one interesting thing here is if you see, where is my this? Let me check. Okay, something is not right. This looks fine actually. Maybe I didn't run this cell. No, I ran it. So df is queued. I am joining with df products on product ID. Okay. And then I'm saying df join dot write dot mode. Okay. I am seeing the right one or not. Let's see. This is the one I think. Okay, let me check this one. Okay, I think I was checking the wrong one. Okay, so now it is fine. Okay, so if you see, one of the partition has this much data, 18 million, we saw, right? If you go here, exactly you will see 18367073. So all of this data is going to one partition, right? All of this data is going to one partition, and this partition is taking 10 seconds. Other partitions are just 64 milliseconds, 75 milliseconds. And this is not the right usage of all the resources, right? Because see, if you see, all other tasks are finished so fast but waiting for this task to complete, so this is taking forever, right? So this is not a good thing, right? The minimum is 1 millisecond and maximum is 10 second, right? So minimum time taken by one task is 1 millisecond and maximum is 10 second, and which is not right, right? So this is handling 87 tasks, 113 tasks, right? And it is also showing that these are the number of records it processed, right? So this is not a good thing, right? Just because of one task we are waiting for the job to finish, right? Ideally, if the data was distributed nicely, we would have done everything in 1 or 2 seconds, maybe 3 seconds, but now we have to wait for 10 seconds. All other executors, all other tasks are empty, are idle after finishing their work, right? This is taking 10 seconds. So there should be a way of distributing it in a better way, right? And that's where adaptive query execution come into picture, right? So there is a concept of AQE, right? So what is AQE in Spark, right? So adaptive query execution is an optimization technique in Apache Spark 3 Plus that dynamically re-optimize and tunes query plans based on runtime statics, right? It reduces manual tuning by automatically adjusting shuffle partitions, handling data skew, and switching join states, right? So there are two, three things done by AQE, but one of the most important thing is at runtime, right? At runtime, it will check, okay, there is a data skew, so it will do internally some process and distribute data across the partitions, right? Before the AQE, we used to do this using sorting, right? But now with AQE, we don't have to do it, right? Spark will internally take care of it, right? So I'll just show you quickly. So I will go to again configurations, Spark configurations. Uh, right, and if you see this property is false, I will make it true. So by default it is true only. I just made it false just to show you what it does, right? I'll save it, close it, and I will start my Spark cluster again. Okay, and let me run this quickly for you. So let's run this. This is my df orders. Okay, that is still running. 1 second. Okay, just ignore this for now, and let's run this. So this is my df orders, and I need products as well, right? And I need the skewed data as well, right? Then I will do a join, right? And then I will write it. Okay, now if you see, there will be a shuffle, right? We are not stopping shuffle. The only thing is that it will be faster. So if I go there, not here, sorry. Okay, So if I go to jobs now, and this is the job, right? So there is a AQE shuffle. So it has skipped it because what happens now, if you see, it has created three jobs. So it is a adaptive query execution, which means at the runtime it will see the statics. So it has created separate stages for reading a file, right? Separate job. So one job to read one file, orders file, one job to read product file, right? So it has created two, and then it will check the statics, and then final one it will do here, right? So you see AQE shuffled, and if you check here, right, now it is what also it is doing, it is not creating 200 partitions, right? So it will coalesce the partition. So it will check, okay, there are small partitions or empty partitions, let's coalesce it. So it is doing that work also, and it is also doing work of distributing data equally in case of skew, right? Now if you see, there is no skew as such, right? Data is distributed nicely, and there are no extra 200 partitions also, right? So both the work it will do, right? It will coalesce a small partition, or if they are empty partition, it will coalesce it, so that we don't have 200 partitions always, right? And at the same time, if there is a data skew, so in our case product ID was skewed in the orders data set, and it will distribute nicely, and our work will happen better, right? So if you see, now minimum duration is 0.2 and max is 2 seconds, right? So within 2 seconds we are within almost 2 seconds we did it, right? 7 seconds, sorry. There were multiple tasks processed by each executor, right? So task time is 7 seconds, 7 seconds, right? Earlier it was more, right? Earlier it was more. We can check it actually. Oh, I stopped it, so we cannot check it, but it was more, right? Because one partition only was taking 10 seconds, right? So this is all about how to optimize the data skew using adaptive query execution, right? In 3.5 upwards, it is by default true, I think, right? Okay, great. Now, important concept in Spark is caching, right? So now what is cache? Now you will be seeing, when you call cache, cache means something in memory you are keeping in memory, in RAM, right? But we also understand that it does by default in memory processing, right? Spark is a in memory processing engine. Then what's the point of cache, right? So let me explain you. So what we do generally, right? We read data, it is processed in memory, and then we write it somewhere, right? Now the problem here is, I mean, not the problem, but the thing is, everything that is happening, that is temporary. So you read data, you do some transformation. During transformation, some intermediate objects will be created, and as soon as your job is over, all these objects are gone, right? So nothing is stored as such, everything is temporary, right? Now let's say you have some data, df filter data of Assam, right? Now your requirement is that you want to read this data multiple times for whatever purposes in your pipeline, right? You want this data frame to be joined multiple times or used multiple times in your pipeline, right? So if you read this data again and again, right? If you're using this df filtered again and again, every time it will read data from here, right? Every time it will read data from the disk, right? From your source, right? So what we can do, we will say, okay, cache it and keep it in the memory. So data frame itself we will keep in the memory, and then we will use it multiple times in my ETL pipeline, and once my pipeline is over, I will remove it from the memory, because in memory it is taking some space, right? So let me show you quickly how this works. So what I will say df underscore filtered equal to, and I will say df dot filter. Let me copy it from here. Where is that? Yeah, let me take this. Okay, so df underscore filtered, right? And let me maybe I will stop the session and create again once, right? If anything is there, it will be clean. Okay, and I'll just read this df underscore orders, and then I will create this. Yeah, now it should be fine. df is not defined, df underscore orders it is. Yeah, now we are good. Okay, So now what I'm saying, I want to use it multiple times. Now if I use it multiple times, right? So what again, df underscore filtered, and I'm joining it, let's say dot join, right? And again I'm doing the same thing one more time. I'm just giving you example. So here also it will do whole processing. So it will go to df orders, read the file, filter it, and then use it in join. Again second time it will go to df orders, read the file, do all the work, and then again join. I don't want that. I want to store it into a cache. So what I will do, I will say df filter dot cache, right? And I run this. Now if I run this, it is running immediately, and I don't see it is getting cached, because caching should take some time, right? So now again this is also lazy, which means until and unless we do an action on this df underscore filtered, it will not cache it, right? Because if you're not using it next time in your pipeline, what's the point of caching it in memory? So Spark is smart. So what we will do, we will say count. So when I do an action, it will go into the cache memory, right? So it is running, it will give me count, right? It is giving me count number of records in df filtered data, right? But if I go back here, go to storage, right? It is showing something that it is there in the storage, right? So it is in memory. So there were cached 9 partitions, right? 100% of the partitions are stored, right? This is size in memory. So this is a compressed size. So it will compress it and then store it into memory, right? So this is how we can cache it. Now next time when I use it, it will be much faster, right? So I will again do dffilter.count. Now we know df filtered is already in cache. Earlier it took some time. If I run it again, see, it is so fast. It is so fast, isn't it? Let me put some other filter. So I will say, and you will see it is very fast. So order status equal to shipped, let's say, right? So I will say df filtered dot filter dot count, and I will put order status equal to uh, shipped, and you will see it will be very fast, right? So if I run this, you see so fast it is coming. Why? Because this data set is in cache now, right? So it doesn't have to read the data from disk, enforce schema, apply filter, nothing it has to do. It is cached, it can directly do this, and it will immediately give you the result, right? So this makes things faster, but it has a use case that when for particular data set you want to use it multiple times, and once you stop the Spark session, this caching will be go, right? Or another ways you can unpersist it. So you will say df filtered dot unpersist, right? So it will remove data from the. So this is a good practice because it is taking some memory, right? You should not keep your memory busy if it is not required. So it is gone. So in Spark, it is not just so maybe we have covered Spark now. A lot of things we have covered, right? But it is still, I would say, 15-20% things we have covered, right? But many of the interviews will be around these things, what we are doing, right? But there are a lot of other things. If you really interested in learning Spark end to end, get that confidence to work in any project or face any interview, I would suggest go to Namaste SQL and do the course, and go to courses and check out this Spark. We have covered everything in detail, right? Very much in detail, everything we have covered, right? You will also get notes there. So I have created notes if you see here. If I go to the top, why I'm not seeing. Okay, I have the notes. I don't know. I'm not able to. It came. Okay, my bad. So if you see, within Spark, right, for each chapter we have in detail notes. So you will get these notes as well, right? Everything we have covered: join strategy, sort aggregate, hash aggregate, catalyst optimizer in detail, AQE in detail, number of executors, Spark submit, Spark a file, Delta Lake, Spark architecture, memory management, cache and persist, right? So all of these things are covered in detail, right? So make sure, if you are not very confident on Spark, you can do this course, and you can use code Spark SPAR at the checkout. And yeah, thanks for watching. Please do hype and like this video, right? And let me know if any other subject you want me to cover as a last minute interview prep, I will be happy to do it. Thanks for watching. Have a good day. So let's start with the data frame API operations, right? Great. So now we will learn everything like group by, aggregation, join, window functions, those kind of thing we will understand. And now you can, okay. So before I start, I just want to mention that these things, whatever we are doing now, you can practice on the Databricks as well. Other things we were not able to do in Databricks because we don't have Spark UI access on the free version. I'm telling, right? In the free version of Databricks, you don't have access to the Spark UI because they give you serverless compute, right? They don't allow you to create compute of your configuration, and there is no dedicated compute. It is serverless compute, and there is no dedicated Spark UI and all for that. But I'll just show you how you can do it. So Databricks free edition, you can just go to the edition, right? And you can sign up. I will just log in quickly. Um, you don't have to put any credit card, nothing. It is absolutely free, right? So don't worry. This is my free edition account. Yeah. Okay. So this is my homepage, and what you have to do is, so first we want to upload the data, right? Or maybe I'll show you. So go to workspace, and you can create a new notebook. Just like notebook we are creating here, you can create a new notebook here, right? And you can give it some good name. Let me say Spark Demo, right? And then you have two options here. You can write in Python or SQL or Scala or R, right? So you can do anything, right? And also you don't have to create a Spark session. It will already be there. So whatever Spark session we create, it will be automatically available. You don't have to create it. You can just directly use it. So if I just say Spark, sorry, Spark and run it, uh, it is just running and it will give me that this is a Spark session. So it is ready made. You don't have to create it, right? And then we can do whatever we want to do, right? So now what we need to upload some data, right? Because we have been reading CSV data. Similarly, here we want to upload it and then read it and practice the transformations, right? So you go to catalog, and in catalog you have this, uh, uh, you can imagine this as a database, and within that we have multiple schemas, right? So you can create a new schema. So for example, I'll create a new schema here. Uh, um, add data is fine. Create a catalog, and catalog name is, let's say, demo. Uh, Standard. Okay, exist demo one. If you see, this demo one is created here, right? This is kind of schema you can imagine. You created a database, and within that you have schema. So I'll click here. So you created a database, and within that you can create a schema, right? And let's say I have created a schema, Namaste SQL. And this is not external location, nothing. You can just say create. Okay, so you created a database, demo one, right? And within that you have a schema, Namaste SQL, right? Now here you can create a table, right? So you can create a table, or you can create a volume. Volume means you can upload a file. So I'll say create a volume. Volume name, let's say orders, right? And this is managed volume. And I'll just say choose catalog this and this. Okay. Now in this volume, I can upload to this volume. I can upload a file. So I'll say upload and desktop, path setup, data. Let me take this small file, maybe 40 MB file. Yeah, just upload it. It will be uploaded quickly. If it is big file, it may take some time, but you can upload as such. There is no limit that you can upload 1 GB or 2 GB. You can upload whatever, right? So this is uploaded. This file is now uploaded, right? You can copy the path, right? So I copied the path and it is also showing me the data, right? So just copy the path, close it. And now I will go back to my workspace, Spark demo, right? And I will start writing things. So I'll say Spark dot read dot format CSV dot load, and I can pass that path. So this was the path, right? And let's say df dot show. I have not passed header true and all of that and schema. You can pass it. I'm just showing you how you can use it, right? And I will run it. It should not take time. Maybe for the first time it is taking. It doesn't take that much time. Yeah. So it is running now. See, it is showing me the data, right? I have not provided header true and all. That's why it is coming like that. But now you can practice here, right? You can add a uh, new this here, right? And you can start, right? Just like we are doing in Notepad. Now you have multiple cells and all, right? And it will be automatically saved. You can come here again and open it, right? So you can practice whatever we will learn now for next couple of classes. You can practice on the Databricks as well. It is up to you. The same thing, nothing different. Okay, so just wanted to share how you can use Databricks to practice. So let's start what we want to learn now. So let's do this and do this. Okay. So we will do df underscore orders. Maybe make it df. We will work with one data set for some time. Let's call it df dot show. Okay. So this is showing me data, and we understand that this customer ID and all data type I'm giving. Right. Now let's say I give a wrong data type. Right. Let's say this is state is what string. Let's say I give int. Now what will happen? There are two possibilities now. One is it will fail, right? Because it will say state is int, right? And it will just give me error. Or it might do something else. Let's see what it will do. What it is doing, it is not failing. It is just giving me null value, right? This by default is a permissive mode of reading a file. We have different modes, right? We have three modes basically, right? We have permissive mode, we have drop malformed uh, record mode, and then fail fast. So by default is permissive. Permissive means load all the records and replaces malformed fields with null values, right? If the data type is not matching or there is some issue with data, it will just replace it with null. Default mode and safest option for exploratory injection, right? So even if you don't give this option, it will read it as permissive, or you can give it also. It doesn't matter because it is a default one, right? So Spark controls how it behaves when it encounters bad or malformed records using mode, right? Default mode is permissive. Let's see if I say this one, right? So mm, maybe I'll read 40 MB file because I can make changes and show you different things, right? So let's do this. So this is null, right? So I'll change it to string, right? And I will do some changes in the file. Let's close this and close this. And this is my 30 MB file, 40 MB file, right? Open with the taxpad. Okay. So now what I will do, right? This is a date, right? This is a date and this is an integer quantity, right? Let me put some random value. Let me put Ankit here, right? Now quantity is integer and I'm giving Ankit. Let's see what will happen. So I have saved it. And if I go here and run this, it is giving me null, which is expected in the permissive mode. Now I will read it in another mode. So I'll say dot option mode, and I will give the another mode, which is drop malformed. So what it will do, it will drop those records which have some issue, right? So it will basically drop order ID 1 because there is some issue, so it will just drop full record, right? And if I do this, what happened? Okay, I need to give continuation. See, order ID 1 is gone, right? So by default, it will not drop anything. If anything is wrong, not matching the data type, it will just make it null. But if you say drop malformed, which means it will just drop those records wherever there is some issue. And last one is fail fast. It will just fail. As and when it faces that, okay, there is some issue, it will just fail. See, it is failing. And you can see the error as well somewhere. Uh, okay, let me check. It should be on the top. Malformed records are detected in record passing this, right? Fail fast mode mein this has failed, right? So you have three modes basically, right? Permissive, which is by default, then malformed, which means sorry, drop malformed, it will drop the record, and then fail fast. Okay, great. Now, what we want that my requirement is this is fine, right? This is fine. But what I want to do, I want to see that which records are wrong, right? And I want to store somewhere else, right? This is a basic requirement, right? I don't want null. I don't want to drop them. I don't want to fail. What I want, whenever there is some record which has some issue, right? I should be able to identify it, right? Bad records, I should be able to identify. And if I want, I can write it somewhere else, right? So for that, what we can do, we have we have to introduce one more column in our schema, right? And there it will store it, right? So there is this property, right? It will give me the column name of corrupt record, and this column name I should use it in my schema, right? And I'll just show quickly. Let me comment it. So this column name is underscore corrupt underscore record, right? So what I have to do, I will introduce this column in my schema, right? Let me copy this. It will be string type because it will have full record, which has got corrupted, right? And then I will use a default permissive mode, right? And let me do df.show now. Syntax error. What is the syntax error now? Let me remove it. Dot load. Okay. Okay. So if you see now what is happening, there is this corrupt record. Now it is not dropping because it is a permissive mode, right? But what it is doing, wherever there is a issue, it is writing that full record to your this column, right? Now if you see, we are not able to see full record, right? Many times this will happen. So in show, you can say truncate equal to false, which means show me the full data. It is showing you the full data now, right? So this is the data which had the issue, and what we can do now, we can filter these records, right? We can filter, we can say, give me all the data where corrupt record is not null. And we will learn that later, and then we can write it somewhere else, right? And if I want to remove them, I can also remove from this data. I can say, get me all the records where this corrupt record is null. So which means those will be the valid records, right? Basically, I have a way to identify which are corrupt, which are not, right? Because I don't know which column will have issue, it will have null, where it will go null, right? I don't know. So this will be populated with the full record. So wherever it is not null, it means that record is corrupted and you can keep it somewhere else, right? And wherever it is fine, it will be null, right? So you can change the name of this column again. By default, this is the name, right? Underscore corrupt underscore record. So you should have column name with the same name. If you want to change it here first. So how you can change? You can say con.set and then you can pass the column name here, right? So it will be only for this session. If you want to do at cluster level, you can just put it in the conf file, right? But you understand how this is working. Okay, great. So this is how you will identify the bad records and store them. Great. Now, this is all fine, right? Let me go back. Let me do truncate normal, right? So we were talking about this schema, right? If you remember, I told you there is one more way to give this schema, and that is more recommended way, right? So one is this, that you just say column name, data type, column name, data type, column name, data type. Apart from that, Spark has some native data types, right? So I think I have the link. I will quickly show you. Spark data type somewhere. Let me open it. Spark data types. Yeah. So if you see, there are a lot of data types here: byte type, short type, long type, float type, double type, decimal type. So it supports a lot more data types, right? Varchar type, Boolean type, date type, time type, right? Other also struct field, struct, uh, right? There are other struct type, right? We will learn that what is struct type, right? So there are a lot of other data types as well which Spark supports, and we can use those data types to define our DDL instead of that simple statement, right? So I will have to import all the data types first. So I will say PySpark.sql.types import star, right? So it will import all kind of data types. These are the ones, right? So let me go there. So maybe I'll create a new cell, right? I'm importing all the types. If you want particular types, you can import it. Let's say in integer, you want only integer type, you can import integer type, right? But I'm importing all. Generally, you will see people will import everything so that they can use anything, right? Now, instead of this way, right, I will define in a different way. So I'll say orders underscore schema using struct, right? I'm just giving this name. Now, one of the data type is struct type, right? Struct type. So what is struct type data type, right? So let me control F struct type, right? So struct type represents values with the structure described by a sequence of struct fields, right? So basically, struct type is a data type which can define the structure of your table, right? It is a full structure of your table. This is not a just a data type like int or double or string. It is a full structure you can define in this, and within this you can pass multiple struct fields, right? So I'll show you how you can do it. You will say struct type, and within this you will pass list of multiple fields, right? So your list is starting here, let's say, and ending here, and you will say struct field, right? And then you will tell the field name. So what is my field name? Sorry, struct field. So field name is struct. Yeah, I think this is fine. Yeah, struct field, and you will say my first field is order ID, right? Second is what is the data type, right? So I will say integer type, right? And third is optional. In this, you can say true or false. True means it will be nullable. False means it will not be nullable, right? So by default, it is all nullable. You can put null values, right? So, but if you want to change, you can change it, but Spark doesn't enforce it. Even if you say true or false, you can always put null values. Okay, so this is my first struct field. Similarly, I can create multiple, right? So let me copy this, right? Let me copy it multiple times. It's order ID. Then next is customer ID. I think integer type is wrong. Integer. Okay. This is also integer type, customer ID. Then next we have product ID, which is also integer type, right? Then we have price, which is float type, right? Then we have order date, which is date type, right? And we have few more. Let me add quickly. I'm writing in front of you so that you can absorb it, right? If I just copy paste, you will not be able to absorb it quickly. You will get confused. So I'm writing so that you absorb it during the session itself. Order status, string type, and then we have state also string type, and we have one more integer type, right? Last one, and this is quantity, right? So let's verify it. 1, 2, 3, 4, 5, 6, 7, 8. Right? 1, 2, 3, 4, 5, 6, 7, 8. Right? This is fine. We are not adding this for now. Right? Now, let's take this again. And I will say my schema is this one, right? Orders schema struct, right? And I'll just show this. Let's remove all of that. Not required. And maybe I will just fix that as well quickly. I will make it one. Okay, right? So we are able to read it, and let's see print schema, right? So it is integer, float, date, string, right? So this is generally you will see how people define the table structure, not like this, right? Because it has more complex data types it supports, we will see later, but this is a standard way, right? But there is no issue as such, big issue. Even if you use this way, it is fine actually, but this gives you more option. There's no performance thing here, nothing like that. Okay, but this looks like more table DDL where we define column name, then data type, and then we say nullable true or false, kind of, right? So if I say, let's say false, right? So here you are seeing true. So if I say false, it means it will be, it should be false, right? Why it is giving me true? Nullable true. Okay, if I give false, no, I have to give in capital false. It is not taking. Let me give it to all this. Let's see. Maybe I have to pass it to all of them. I'm not sure. Okay. This is fine. Order schema struct. It is giving me true only. It doesn't matter what I give, right? So anyway, it doesn't force it, right? Even if it is you give false, it will allow you to put true value, right? So it's okay. You can leave it. Okay, so what we understand is there are two ways of giving the schema. One is simple way, we give a string, and another way is using the data types. Struct type will be the full structure of your table, and within each struct type, you can define the different fields using struct fields. These are also data type. Struct field is a field data type. This is a structure type of data type, and these are individual integer type and float type. This is how you have to think about it. Okay, great. So this also we covered, right? And we understand that. Okay, one more thing is, right? This is all fine. I mean, not related to this. Now there are some shortcut methods as well, right? So let's say I want to read this file, right? Let me take it again. So one way is this spark.read.format. You pass CSV, then you pass everything like that. Another way is you can directly say spark.read.csv, right? And you pass the CSV path directly here. This is a shortcut way of reading the particular type of file. So let me remove all of this. Right. Similarly, if you want to read a JSON file, you can here pass JSON. We will learn later, right? Or you can say spark.read.json. Or if you want to read a Parquet file, right? Again, you can pass here as format Parquet. Or this is a shortcut method, is spark.read.parquet, right? So any method you can use. And then you can pass other things. So for example, you are saying header is true, right? And then you are saying that my schema is this schema, order schema. No, this is schema, sorry. Struct type. Let me remove this, right? So a schema is struct type, right? And I think this is the only thing we had to pass, right? We have the header, we have the schema, right? And this will also work. Let me first see this. Integer float, all fine, and do show, right? So some places you will see people have used this, some places people have used that. So just telling you in case you see any one of them, don't get confused. They are same thing. Just this is a shortcut method for CSV, and similarly we have for other kinds of file, JSON and all of that, right? So anything is fine. Again, there is no performance thing. Anything is there, right? It depends on individual developer or a project what they are following. Both are fine. Okay, great. So this we covered actually, schema thing, everything, right? Read modes also we covered, right? We have three read modes basically. Great. Now we will learn how to create a different way of creating a data frame, right? So one is we learned that we said spark.read and it will just do it, right? So that's what we are doing so far, right? Spark.read, right? This is method which will create the data frame, right? So this is one of the way of creating data frame, right? Another way can be that you can create a temporary table. So let me create a temporary table. So I'll say df dot create. So there are multiple options. If you see create or replace temp view, create or replace global temp view, create global temp view, create temp view, right? Now create or replace means if a temp view is already there, right, it will replace it, right? If you just say create temp view and it is already there, then it will give you error that it is already there, we cannot create it, right? So that is the difference between create or replace and create. Now there is a global thing as well, right? Create global temp view, create or replace global. Global means, let's say you have this session and you have created one more session in another tab. So if it is global, then that will be available in both the sessions, right? So if we create normal one, this will be specific to this session. In another Spark session, it will not be available, right? And its life is during the session only. Once the session is closed, its life is also gone, right? So I'll mostly you will use this create or replace temp view, right? So I'll create, let's say, orders, right? And I told you in the previous class or first class, I think, that you can write queries. So you will say spark.sql and you will say select star from orders, right? And then you can say show. What is the error? I did not run this, I think. Yeah. Yeah. Okay. Yeah. So I didn't run this. That's why it was saying me error that orders table is not there, right? So it has created, right? And this also creates a data frame basically, right? So you can say where state equal to Gujarat. Okay, if you are wrapping it up in double quotes outside, inside you should wrap it up in single quotes, right? If you give double, then it will think that this double quote is ending here, right? So if you are outside giving double, inside you should give single quotes and you will say, let's say Punjab, right? And this is a data frame basically. It is returning a data frame. So I said df underscore Punjab, right? So this will give you a data frame basically, nothing else, right? And then you can then anything like this is a data frame, typical data frame, df Punjab dot show, or no, I need to remove this, right? I'm doing show, right? So this is creating a data frame, and if you do show, it will show you. So basically, it has created a data frame, right? So this is two ways we have learned so far. One is read method. Another is spark.sql method, right? Where I can pass the SQL and it will return a data frame, right? So these are two methods so far. Let's see what are the other method. Another method is simply you want to generate a some data like a single column 1 2 3 kind of that. So you can say spark dot range, let's say 10 dot show. Right? So this will also create a data frame with starting from 0 till 9, right? And I think you can pass range like I need from 2 to 10, right? So it will give you 2 to, it will not give you 10, the last one it will not give. So from 2, it will give you till 9. If you don't pass anything, then from 0, it will give you till 9, right? You can give the step size as well. Let me try. Yeah, so it is a step size like 2, then 4, then 6, then 8, and 10. Last one it doesn't give. If you have learned Python, it is very similar to that. In Python, last it will not give, right? If you are working with list or anything or range function. Right? So this is just to create some dummy data quickly if you want to create, and the column name will be ID, and you can just create it. Right? There is no much use case as such, but if you want to generate, sometimes you want to generate a, let's say, running number 1 to 10, and then we want to join with something else, right? You can have some use case. So you can quickly create, and this will create a data frame basically, right? Again, you can say df underscore range equal to this, and I'll say df underscore range dot show, right? So this is again a data frame, right? So this is a third way of creating a data frame, and here also we did it, right? Range 09 this. Another this is spark dot table, right? So you can directly say df table equal to spark dot table, right? And you don't have to pass any query here. You just directly pass the table name. So I have a orders table, and I'm saying from this orders table, create the data frame, right? Directly, right? So this will also do. So df underscore table dot show, right? So when you are giving table, you just pass the table name, right? And when you are saying dot SQL, then you can just say select star from orders. That will also work as spark dot table and table name, right? And if you want to pass some filter or some aggregation, then you will use spark dot SQL. If you want to read table as it is, you can just say spark dot table and then table name, and it will create a data frame, right? So these are different ways of creating data frame, right? Now there is one more way which we want to discuss now, right? So if you remember, we had the parallelize, right? In RDD, right? In RDD, if you remember, we discussed that we can use parallelize. So if I have some list, right, I can create a RDD out of it, right? Similarly, using data frame also, we can do it. we need to create the data. Let's say this is my data in this format. So you will have a list, and in this, each row will be a tuple. So this will be tuple 1, row 2, right? Row 3, right? And let's say here I have employee ID and name is, let's say, Ankit, and salary is, let's say, 5,000, right? Then I have, let's say, two Sumit, let's say 8,000. And we have to put a comma as well here, right? Again, comma here. So this is how you have to first create, right? And let's say 3 and say Nachiket, and let's say Nachiket has lot of salary. And yeah, so now you will say Spark dot create data frame, right? So D capital, F capital, C small, right? And then you pass this data set. Again, for practice, generally people do that, right? You want to practice some transformations and something, so you can quickly create data instead of reading file and all, right? You can modify data immediately if you want to try different corner cases, right? So it becomes easy. So you will say spark dot create data frame, right? And let me do show. Let's see what it will give me, right? So it is giving me, it has created data frame. I have not passed the columns, right? So it is just giving _1, _2, _3. Now here again, you can pass the schema, right? Or you can just pass the column names in a list. It will automatically identify the data type automatically. You don't have to say infer schema and all, right? So what I will say my columns are this. So let's say my columns is, first one is uh, ID. Second one is name. Third one is salary, right? And I will pass these columns here. Or you can pass this directly. Anything is fine here, right? And if I just do show now, it will give me this, right? And maybe I will create a data frame here and I will show you df.show. Not show, I want to do print schema. Uh, df dot print schema, what is on? Oh, show. I don't have to do show, right? Show will show me the results, right? So that's the problem, right? So it is considering it as long string. Long basically big int, right? So this is okay. I have given this in the single quotes. That's why it is taking it as a string. So let me remove it. Now it is fine. Long string, right? Or if you want to pass the data types as well, you can just pass the how we are passing the schema. So instead of this, you can say ID is int, name is string, and salary is int. I don't know it will fit in int or not. Let's see, right? And this is not a list. This is just the schema columns, and you can pass here. And this is also working integer string, right? So whatever works for you, you have to just create a tuple of each row will be a tuple, right? And within the list, you can give multiple tuples, right? So this is another way of creating data set. It is very popular during the practice, right? So you can just quickly create data and practice all kind of transformations, right? So I think we covered this as well. Great. Okay, so we have 5 minutes. Um, we have 5 minutes. I'm just thinking, should we cover a couple of more topics or not? Okay, let's cover select, right? Won't take much time. Okay, great. Now data frame is created, right? We know data frame is created. Let me maybe create this one, original one. Yeah. Okay, so we have the df now. Now, whenever we do df dot show, we see all the columns, right? Let's say I want to see only few columns, right? So in SQL, how do we do it? If I do select star from table, it shows me all the columns, right? If I want particular columns, let's say I'm interested only in order ID, order date. So I will pass those column names, right? Similarly, in this, you can say df dot select and you can pass the columns which you want to see. So I'm interested in, let's say, order ID, order name, and then I will say show, right? So order ID, order date, sorry, not order name, and I have to pass in double quotes, right? So I'm seeing only two columns, right? So you can select particular columns, and then if you want a new data frame to be created, you can say df1 equal to this, right? So whatever transformations we do, right, it does not impact anything on the data frame itself. It just creates a new data frame. It returns a new data frame, right? Because data frames are immutable, right? So whatever in future I will apply the transformations, right? All returns a new data frame. So this returns a new data frame which has two columns. Now you can assign it to another data frame. Then your df1 will have two columns only. Dot show, right? See, but if I do df dot show, it is the full data, right? Because I did not make any change in the df, right? So this thing will be common across all the transformations, whatever we do, right? So df dot select, it will return a new data frame and you can assign it to the new variable and then this will be your data frame which will have only two columns. Okay, great. So this is one way of selecting the column. You can also do this. You can do select star as well here as well if you want. So you can just say select star, right? So this also takes this. Okay, so we'll say df1 dot show. See, all the columns are coming, right? Because I'm saying select star, but you have to give in double quotes always. Okay, great. Now, in select, I want to do few more things. So for example, let me go back, right? Now let's say I'm saying I want, so in select, I can select columns, right? So for example, I want to create a new column in SQL. How it will be created? So you will say, let's say I want price into quantity, right? So in SQL, it is simple. You will say price into quantity as sales, right? And it will just work, right? Let's see it works here or not, right? So I will say price into quantity, right? As sales, let's say, right? We'll see if it is working or it will give me some error. It is giving me error. And what is the error? The error says a column of function parameter with name price into quantity as sales cannot be resolved. It is saying there is no column. There is no. So what it is seeing, it is checking, okay, there is a column with this name and it does not find it. Right? It does not find any column with this name. So it is not able to understand that this is an expression, right? It is thinking it is just a string which represents a column, right? So we have to do something, right? What we can do, we can pass expr, right? So expr is a function which will tell that this is an expression and it is not a column name. It is an expression. So we are saying price into quantity as sales. So this becomes a expression and now it will work. It is saying exp are not defined. So we have to import the function. So there are two things which you have to generally import all the time, right? When you are writing Spark code. One is this from PySpark.sql.types import star. And similarly for all the functions, right? You will say from PySpark dot SQL dot functions import star. So it will import all the functions for you, and then you can use it. Or you can just say expr. Sometimes you will see, because you are using only expr, you can just say expr. And let's say you want another function, let's say sum. So you can import only those which are required. Generally, you will see people say star, right? And now it is working. You see, let me take other columns as well so that we can verify. Price, quantity, right? And yeah, you see 137 into 1, 137, 134 into 3, 403, right? So you can pass expr. Okay, great. Now, there might be another column you are creating, right? Let's say you are creating one more column where it is like price divided by quantity. Just random I'm taking, right? Price divided by quantity as sales one, let's say, right? And let's see if it is working. It is working, no issue, right? Now, every time you are writing an expression, you have to give multiple times expression, 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 right? Instead of that, you can use select expr, right? Now you don't have to pass this expression. Maybe I will take in a new line. Let me comment this. And you will directly use expr, select expr, and you can just remove it then, right? So it will treat it as a expression always, right? So it is working perfectly fine, right? So you can directly use select expr, and it will just check if it is an expression, then it will convert it into expression and calculate it basically. Okay, great. So this is how you can write expressions within the select statement, right? Now, there are two ways you can select the columns. One is this. This is known as string method, right? I'm passing just a string, right? I'm passing this as a string, order ID, order date. At the runtime, what Spark will do, it will check, okay, if order ID is an expression or it is a column, it will consider it as column. It will consider it as column, 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 right? When you see XPR, for everything, it is checking if it is an expression or column, right? So that is one way. This is known as string method. You are passing it as string. Another way is you explicitly tell that this is a column, right? You can tell that this is a column, and that is known as column method, right? So if you see, we can pass it as columns as well, right? So I'll show you quickly, and you will say select, right? Let me remove this, and you will say column, right? And you are passing it as a column. So this is a column, right? And here again, you will say that this is a column, price is a column, right? Into again column, and this is a column. So you are explicitly telling that this is a column, boss, right? This is not a string, right? And you are telling that this is a column, treat it as a column, right? Let me remove all of that. So select column order ID. So you can mix and match as well. So this is you are giving as column. This is as a string, string, string. This you are giving as a column. This you are giving as a column. And if I just run this, it will give you the price into quantity, right? We'll see how we can alias this, but basically we are able to directly without expr, we are able to do it, right? Because here it was going it as a string. So we have to explicitly tell that this is a expression, not a string. Here we are telling this is a column itself. So this column multiply by this column, right? So this becomes, so we don't have to pass expr basically. Right? So there are different ways. It is not that this is better or that is better, right? This is basically very SQL type of syntax, right? In SQL, you do like this only, price into quantity as sales, right? Here it is little different. You are saying this is a column, multiply, this is a column, right? So anything you can use, whatever you are comfortable with, but you should know both because maybe you are working in a project which has a code base already. So they might be using this terminology. So you don't want to mix and match, right? You want to continue with this, or they are using this, then you want to continue with this, right? So you don't want to make the code different, right? For every line. Okay. There are other ways also. So you can also say there are two more ways to selecting column, right? And you can mix and match. You can also say df. So this is my data frame name. So you can say df dot order date, or another method is you can say df, and within square brackets you can pass the column name, right? And you can always mix and match. So there is some error. Df order date. Okay. Okay, so this is also working. So there are four ways. One is normal, you pass it as a string. Second is you say data frame name dot column name, right? This will be useful when we are joining the data sets, right? Because while joining, we want to tell that which column is coming from which data frame. So we will have to use this method there that time. Otherwise, if it is a single data frame, then you can generally people will use this call method or string method, whatever. Right? But there are four ways basically. Call method, df dot data frame dot column name. Then you have this is similar to pandas. These two works in pandas as well if you have learned pandas, right? And then this is a call method. Okay, so let's move forward and we will see distinct behavior, right? How to get the distinct value. Basically in SQL, we do select distinct to get the distinct values, right? So let's see how we can do it. So what I'll do, I'll just create a small data set to show that. Let me take this. Okay, so we have this df.show. Okay, so we have this. Now if you see here, do we have any duplicates? So if you see one delivered 150, it's a different record. One placed 150, it's a different record. One, two, three, one placed 100. So, so if you see, there is no pure distinct here. If you consider all three columns, right, there is no pure duplicate. So let me introduce one pure duplicate here. So maybe I will just put this, right? And let's create. Now I have one pure duplicate, right? One placed 100. When I say pure duplicate, all the column values, two rows with the exact same values, right? So if you want to see the distinct value, right? So df dot distinct you will do, right? Now distinct is a transformation, so you will say show to see the result. Right? So if you see, it is removing the duplicate. So we have 1, 1, 2, 3, and last one is not coming. Right? Because it removed the distinct based on all the columns. We have not specified any particular column. Based on all the columns, it is doing it. Okay. Now, let's say you want to remove duplicate based on one column, or you want to see distinct values of status, right? You want to see what are distinct status is there in my system, in my table, right? So in SQL, you will do select distinct status from orders. This is how you will do if you want to see distinct status. Right here also what we can do, we will say, okay, you select one column. So we will select one column and then we'll say distinct. So I'll say select status and then do distinct. Right? So it is showing delivered, placed, shipped. Right? So this is how you can see distinct values of a particular column. Right? Now distinct, you think about it, is it a wide transformation or it is a narrow transformation, right? Because we have to remove duplicates. So to remove duplicates, same key should be in the same partition, right? So distinct is a wide transformation. You can run it on full data and you will know that it will create a new stage, right? So this is a wide transformation because wherever same key has to be on same partition. So for distinct, right? If all the keys are not there on same partition, you will not get distinct values, right? So distinct is a wide transformation. Okay, so this is fine that we are able to see distinct. Now let's say my requirement is I want to drop duplicates based on only ID. So if ID is duplicating, I just want to keep one record, right? I don't want to remove on the pure duplicate, right? So what I want these three records in the output basically. I don't want other ones, right? See, if I want to distinct on order ID, I can just select order ID, right? And do distinct dot show. It is giving me 1, 2, 3, but this is not what I want. I want full data, but on the basis of order ID, I want to remove duplicates, right? So for that, we have drop duplicates basically, right? So we'll say df dot drop duplicates, right? And you pass here that based on what you want to remove duplicates. So I'm saying based on order ID, I want to remove duplicates, right? And then I'll say show. Drop duplicates, what happened? Okay, it should be a list. So we have to pass in a list. So you see, we are getting 1, 2, 3, and we are removing duplicates, right? Now, if you see 1, it will give me randomly any one, right? So there are 4 records of 1. This one, this one, this one, right? Here I don't have a control that which one will come, right? Because in Spark, PySpark API, you don't have any option that I want first record or second record, right? If you have a particular requirement that I want first record or last record or maximum amount, we can do a different way using window function. But when you use drop duplicates, you don't have that option. Okay. You can do two columns as well. So you will say drop duplicates based on, let's say, order ID as well as status. Status, right? So now we have 4 records because this one placed is a different record and one delivered is a different record. So now we are seeing duplicate based on combination of 2 columns, right? So this is a different record now and this is a different. These are not duplicates based on our criteria, right? And all of this, what we are doing, remove, it is creating a new data frame, right? If you look at df is not changing, right? Df is as it is, right? Df is as it is. So you have to assign it to a new data frame, let's say df1, if you want to do that, right? If you want to, after dropping duplicate, you want to store in different data frame, you have to do like this, right? So I'm just showing show every time, but remember, data frames are immutable, right? RDDs are immutable. You cannot make change in the existing data frame. You always get to create a new data frame. Okay, great. So this is how you can drop duplicates. Great. So this is my drop duplicates. You can pass multiple columns here. Great. Now you want to do sorting, right? You want to sort data and based on that, you want to see the results. So for that, we have df dot sort, right? And in sort, again, you can pass column based on which column you want to do sort, right? So for example, I want to sort based on amount, right? So I can say amount dot show, right? So it is by default in ascending order, right? So there are two ways. One is sort and we have order by as well. Both are same. There is no difference. You can use any one. So for example, I can say df dot order by, right? Similar to SQL order by. So sort also works, order by also works. And you want to do an amount, so you can just say amount. So it is by default in increasing order, right? If you want in decreasing order, you will say amount as DSC. Uh, okay, you have to, I think, put EXPR. Let me check the
Dot DSC.
no, in the sort, that is column one. Without column one, I think this is working, right? df dot order by amount as DSC. Oh no, not as. I don't have to use as, right? This is not alias, my bad. So you can just say amount DSC. I think this should work. This is also not working. Okay, let me try with sort. Mm, okay, is resolved. Let me put in expr. Let's see. Yeah, now it is working. Yeah. So anytime you give any expression, it has to be, uh, no, it is not working, I think, right? I'm seeing amount descending, but it is still in increasing order, right? Uh, okay, let me check syntax. How to sort in descending order without call in PySpark. Oh, got it. You have to give like this DESC and then column name. Okay, my bad. So, okay. So instead of this, you have to say DESC. Yeah. Okay. Yeah, now it is working. See, right? So you have to pass DSC here and then the column name. So it will do in descending order. By default, it is ascending. So even if you give ascending, it doesn't matter, right? You give or not. But if you want in descending order, you will put like this, right? Let me copy it and put it here. This is wrong. Okay. So that is one way. Another way is using column method, right? So you can use a column method. So you will say df dot sort or order by anything, doesn't matter, right? And then you will say column. Now you are telling it is a column by amount, right? And then to show, right? So this is in increasing order. And now there is a method of column and you can directly say dot DESC, right? And it will just work. Let's see in descending order, right? So if you're using this method, string method, you can just say descending and the column name. But if you are using column method, you have to say dot DESC, right? So this is how you can sort base data ascending or descending, right? You can pass multiple columns as well. So for example, you want to first sort on amount, right? And if there is a tie, so for example, on amount, if you see there's a tie, right? 150, 150. Let's say you want to break the tie based on status. So you will say comma, column, and column name is status, right? And again, I want it to be descending. Okay, great. So if you see now what is happening, it is first sorting based on amount. Okay. So these two amount are same. So what it will do, it will sort based on descending order. So alphabetically P comes later. So placed is coming first and then delivered, right? So if I just say ascending or if I don't give anything, what should happen? Delivered should come first, right? D comes before P. If I done, you see, when there is a tie, D is coming before P. Right? So this is how you can sort it ascending descending, pass multiple columns. Here also you can pass one more column if you want amount comma and one more column, like that you can do it. Okay, so this is how you will do order by. There is no limit how many ever column you can give, right? So for it is always like this, it will first sort on first column. If there is a tie, to break the tie it will check the second column. Let's say that you have a third column, right? For example, here if you see both are same. So first it will check, okay, they are same. They are also same. And if you give third column here, so it will break the tie based on third column, right? So this is how it will be. Great. Now I think we will move on to the filters. Yeah, let's move on to the filters. So filters are very common, right? We all know that day in, day out in data engineering, we use filters, right? So let me take this bigger data set to show some filters. Maybe I will make it as DF order. So both are there. We can use anyone, right? Yeah. So we'll use DF orders. Okay. So let's move on to the filters. How I filter data, basically where clause in. SQL, right? So where clause runs row by row. Basically, it will check first row, second row, third row, right? This is a narrow transformation, right? Because when I'm checking some value for this row, I don't care about any other row, right? So I'm within a same partition, I can just check if that row qualifies or not qualifies. As simple as that. Okay. So how do we do filtering? So I will say df underscore orders dot. Now either you can use filter or you can use where. Both works. Right? There is no difference. In syntax, they have given both the options. You can use where or filter. Anything is fine, and after that the syntax is same. Okay. Now if you are using a string method, you will simply say, let's say state equal to uh, let's say Goa. Goa. And we will say dot show. Right? So it will show me. Let me remove this. So it will show me on Goa, 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 right? So it is basically going row by row. Let me show you. So it is checking first row, right? It is checking if state is Goa. If it returns false, then this row is not coming. Again, second row, third row, and it is all happening in distributed system, right? And whenever it encounters Goa, okay, then it will give me this record. So first record you see is order ID 8. Right? So this is how it will go row by row by row and give you the result. Great. And now you can use column method as well. So we will say df underscore orders dot filter or where anything doesn't matter. And you will say column and your column is state, right? No, wait, I don't have to give this. Okay, and then double equal to you will say, and you will say Goa, right? So what it will do, it will check same thing. It is a different syntax, right? Some people prefer this. This is more kind of SQL style. This is more kind of data frame API. I mean, both are data frame API, but this is more kind of declarative type of thing, right? Not SQL type, basically, I will say. So let me run this, and you see it is working fine, right? So, okay, I have to say dot show, and let me comment this both. Okay, so this is also working. So when you are using this method, you have to give double equal to. I think single equal to won't work. Yeah, single equal to won't work. So you have to give double equal to, right? This is a SQL style. So in SQL, we give single equal to only, right? So it works. But here, if you are using column method, you have to give double equal to. Okay, so this is simple. Let's say I want to check quantity greater than something. So I can say quantity greater than 2. So it will give me result wherever it is greater than 2 quantity. Quantity greater than 2. Okay, quantity is not there, then what is quantity? Okay, spelling mistake. Okay, so greater than 2, it is giving, you can say greater than equal to 2. So it will give you greater than equal to 2 and greater than equal to 2, or you can say equal to 1, so only 1 it will give, right? As simple as that. Equal to equal to. Okay. Now, many times you have to give multiple conditions. So, for example, I want all the records from Gujarat which are delivered, right? So, it should be Gujarat as well as delivered, right? So, what we will say? We will say state equal to Gujarat. And by the way, it is case sensitive, right? So, if I just say Gujarat, it will not work, right? So, if I say Gujarat, it will not work. Okay. So, nothing is coming, right? So, it is case sensitive. Say Gujarat. Okay. Now, second condition I want to give is I want to give that order status should be delivered. Right. So I'll say ampersand. This is how you give and condition here. Right. And you will say column order status equal to delivered. Again, it is everything is in capital, right? Okay. Now let's see it will work or we have some issue. So what we are saying that State should be Gujarat, and order status should be delivered, right? And this is an and condition, not all, and condition, right? If you are giving an SQL, you simply say and here, and it will work. You give another condition, right? But here you have to use this ampersand sign to give the end condition, and let's see if this works or not. Okay, so it is giving me some error which was expected. Now what happens is when you give multiple conditions, you have to put every condition in the brackets. So this is my first condition. I should put in brackets. This is my second condition and I should put in brackets, right? Otherwise it will give you syntax error, right? Now if you see, it is working. Order status delivered and state is in Gujarat. Only those records it is giving me. Okay, great. Now, if you want to give one more condition, then obviously you have to use ampersand and then within bracket, you can give the another condition and as many condition as you want, right? We can give or using pipe. So I can say pipe, right? So what it is saying, it is saying either state should be Gujarat or order status should be delivered, right? So one of these condition will be true, right? So if you see here, order status is delivered, 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 but here you see order status is placed, but still it is giving why? Because state is Gujarat. So if either one of the condition is true, then it will give you the result, right? It is just like and or in SQL. Okay, so this is how you pass filters. Otherwise, for date filter, you can just give date, nothing much. So for example, let me add one more filter here quickly. Let me put ampersand and ampersand, and I will say column order underscore date. Let me put this in brackets equal to, and then you can pass. You can give in single quotes or double quotes. In Python, both works, right? So order date equal to, let's say this one. Okay. And it is just one record, which is satisfying all three conditions. There is only one record, right? Delivered Gujarat and this order date, right? So this is how you can put multiple conditions in filter, right? I'll show you where also, right? That where also works. See, where also works. So you can use anything, doesn't matter. Okay, so this is your filter, right? And then you can check null and is not null as well. So let me put null here somewhere, or maybe here I will create a null. Let me create none. None. So when you want to pass null, you have to pass it as none here. In when you are creating data like this, right? If you see this is coming as null, right? So it is df. So in df, I want to see which are null and which are not null, right? Null is not null in SQL, right? I'll say df dot show, right? And I will say df. And then what I have to do, I have to tell the column that which column, right? So I have to filter on this column and this is my condition, right? So instead of saying equal to or something, you have to say df dot filter, right? And you will say column is amount, right? Now typically what we do, we put a condition that amount should be greater than 100. This is how we will do, right? Dot show, right? And it will give me greater than 100. Now what I want is null. So I will say dot is null, and that's it. Is null. I think n is capital. Yeah, n is capital. Yeah. So it is giving me all the records where the column amount is null. Similarly, you have is not null, right? So you will just say, give me all the records where amount is not null. Right? So it is not giving you the null one, others it is giving. Right? And along with that, you can add one more condition, right? It is up to you now. Like the way we have put, so this becomes one condition, right? Then you have to put it in brackets and then next condition you can get. Okay, so this is your is null and is not null, right? Just to check. Great. Okay, let's move forward. We have another function literal, right? So sometimes in SQL, let's say I want to create a dummy column, or let's say I want to give a default value. So what I'll do, let's say select star from orders, right? And you create sometimes for whatever reason one as dummy. So it will come as 1 1 1 1 1 for each row, right? Or let's say you want to give some default value, order status is placed for everything, right? So it will come as placed, right? Some kind of literal value you want to give, right? So for that we have lit function, lit. With lit you can pass a literal value, any value basically, right? So you can say something like this. Right? Or maybe I can show this one. Right? So you have to pass lit, right? And literal mein you can give anything. Lit one and then you give alias, right? So placed is like literal and status is your alias column name, right? So if you see, we are getting dummy 1 1 1 1, right? So this is how you can give a literal value. You can pass something like string as well. So for example, you can say placed, right? And this is again your literal value, right? Some constant value you want to give in a column, you can just do it using lit function, right? Directly you give, it will give you error. It will think that this is a column, right? If you don't give this, it will think this is a column, but placed is not a column, it is a literal value. So that's why you have to tell, okay, this is a literal value and use it, and this will be my column alias. Okay, I hope this makes sense. Okay, let's move forward. Okay, now we will learn how to create a new column, right? So many times we create new columns. So for example, select star from orders, right? So when we once we saw that expr method, right, a string method where we can write the expression, right? Like for example, quantity into price, right? We were doing it. There's another way of doing it using with column, right? With column will create a new column. So let's see how this works. So I'll say df underscore orders dot show. Right. Now let's say I want to create a new column, multiply unit price and quantity and create a new column. So I will say df orders dot with column, right? C will be capital. And then it will take two arguments. First is what should be the column name, right? So whatever existing columns are there, that will be there and it will create one more column, right? So I'm saying my new column name is, let's say, sales. Okay, so that is your first argument is your new column name. That's it. In second, you will give the expression that what expression you want to give. So I am saying column unit price multiply by column quantity. Right? This is what I want. So I don't have to do alias here, right? Because I'm already giving my column name is sales and this is my expression. So you don't have to say dot alias, not required, right? What is the point? Because column name will be this, right? And then I will say dot show. So it is giving you unit price multiply by quantity, right? So this is how it is working, right? So again, I will tell the syntax. And if you see, it is adding, it is basically created a new data frame which has existing column plus this new column what we have created, right? So with column sales, this is your column name, header name, just like you give select star quantity into price as sales you give in SQL, right? So this sales I am giving here. This is my column header, nothing much. And then the actual expression you give in the second argument. So the two arguments you have to give in the with column, right? And then again, it is creating a new data frame. It is not making any change in the DF orders, right? So this is applicable for everything. Right? And this is again a narrow transformation. Right? Why narrow? Because when I'm creating a new column for this row, I don't care about other rows, other partitions, right? I can just calculate this into this. So this is a narrow transformations. Right? All the filters are narrow transformations, obviously we know. And this is also creating a new column is also a narrow transformation. So filters narrow transformation, with column also narrow transformation. Okay, great. Okay, one more interesting thing about with column is that when you give this column name sales, now what happens is if you give a existing column name, then it will update that column. I mean, it will create a new data frame and it will put values in the existing column, right? So for example, let's say you have unit price here, right? So what I'm saying, this. So I'm saying with column unit price and unit price into quantity. So it will create this expression, it will multiply it and update in the unit price column itself. It is not updating, it is immutable, but basically it is creating a new data frame and in unit price only it will keep these value multiplication, right? So if I run this, you see there is no new column, right? No new column because we are saying in the unit price itself you do that. So it has done that. So you can update the existing column or create a new column using with column, right? Both the things with the same function you can do, right? You can update the existing column or you can create a new column. If this name is already there, it will update it. If this name is not there, then it will create it. As simple as that, right? I hope this makes sense. So this is how this works. Let me revert it back and this is all fine. Now it has created a new column, right? Great. Let's move forward. So this will add a new column or modify an existing column, right? This is an arrow transformation and it is not an action, right? It is a transformation. Okay. Now you have a with column renamed, right? If you want to rename a column name, right? So for example, you created this sales. Now you want to rename it, right? So you can chain multiple transformations, right? So either you can, if you want to, let's say, rename order status to status. Let me do that first. So let me copy this. Okay. With column renamed, right? And let's say I want to rename order underscore status to status. It will give you new data frame where order status header name will change to status. You see, order status to status, right? And obviously you can always chain them, all the transformations. So you can say here itself. So you will say, let me take this, right? And then dot show. So what it will do, first it will calculate sales, new column. And let's say I want to also rename order status to status, right? And if I just do, see, so order status is renamed to status and we have a new column as well, right? So you can always chain it together and you can, or any transformations that we are doing, right? All of them you can chain it. So for example, you can put filter first here, then you create a new column, then you say wheel column rename, and then dot you can say group by, and then again you can say filter. So there is no limit. In one only you can put everything, right? And there is no performance impact. This and that anyway worked in the same way because internally Spark will create a new plan, it will chain everything together and then whenever there is a shuffle then it will shuffle, right? So it doesn't matter how you write, plan will be created as per the combined thing. So when you say action then it will see what all things are there and it will optimize it and run it. So how you write doesn't matter, but for clarity generally you can write step by step, right? So you assign it to one data frame df1, or for example in this, let's say I want to do it in two steps, right? So I will say df, let's say 1 equal to this, and then let me wait, and then I will say df2 equal to df1 dot, right? This is how you will do, and then you will say df2 dot show, right? So now I'm doing in three steps, right? First, creating a new column and assigning it to a new data frame, then again renamed, then new data frame, then df2 dot show. There is a syntax error. Okay. Right? So this is how you do it. So if you see, we have a new column sales as well as the order status has been renamed to status, right? Great. So this is your with column renamed. Okay. Now we will see how we can cast I mean, for example, I want to change the data type, right? For example, from integer to float or float to integer or whatever, right? So we can just simply do using with column, right? Because with column will update the existing column, right? So for example, we have this unit price. Let's say I want to change it to int, right? So what I'll do, I'll say df orders dot with column, right? And you will give this column itself because this column itself you want to change it to int, right? So we know that when we give existing column in with column, it will just update it. And then I will say column unit price dot cast to int. Right? I think this is the syntax. Let me just cross verify. Yeah, cast to int, right? And then you will say dot show. You see, this is now int, right? Earlier it was a float, right? And we changed it to int. You can change the data type from date to string or string to date. We will see. We'll see how to work with dates more later. But basically, any kind of data type change you can do like this with column, same column name, and then you cast dot cast. If you want to change it to a string, you pass a string. If something is can be done as date, you can change it to date or whatever you want. Okay, so this is your cast, how you do cast. Again, I have it in the string method as well, so you can check it, right? I don't want to show you every time both the things. I think I also feel comfortable with this, but it is up to you, right? But in industry, I have seen mostly people use column method when they are using data frame API. And when they are using Spark SQL, then anyway, it is a SQL expression kind of thing, right? So if you use this method, this is a mix of SQL and data frame API, but this is purely data frame API, right? But you will always have two ways in data frame API. One is using string method and one is using call method, right? It's up to you, whatever you comfortable with dates. Sorry, comfortable with. Okay, great. Now let's see how we work with date. Now, if you see here, let me go on top. So if you see, I gave here this date type, order date, and it came as date type, right? I can print a schema. Print schema. You will see it is a date, right? Okay, great. So it is easy, right? We give date, it will come as date, but it is not that easy. Now, this is a default format, right? In most of the systems, this is the default format. YYY hyphen MM hyphen DD. YYYY hyphen MM hyphen DD, right? So this is the default format. If your data, so in my file, my data is in this format. And if you tell Spark that this is my date data type, it will create it as a date data type and there will not be any issue. Now it might be possible in your file, right? This is in some other format. It can be like, for example, it can be something like this, YYYY slash mm slash dd, right? Or it can be maybe mm hyphen dd hyphen yyyy, right? Or your month can be like Jan, something like this mmm, right? It can be in any format. And if I say date, it will just fail. So let me show you. So let me go here. Data. I think this is the one. Let me check. Okay. So I have created some small data where date is in a different format. You see, it is forward slash we have 2010, then slash 01, then this. And we will try to read this file and see what will happen, right? So it is order underscore date underscore 40 MB dot CSV. So let's go back here. Let me take this and okay. and I'll say orders underscore date underscore 40 MB, right? You can also, this is not 40 MB, the file name is that. Okay, so this is all fine. And I'm giving the same structure, right? And let's see what will happen. And maybe I will rename it to orders, df orders date. Okay. So now if you see, date is coming null. Why? If you remember, by default, it is a permissive mode, which means if something is wrong, it will just take it as a null, right? In the last class. If it was drop malformed, the all records would have been dropped, or if it had been fast fail, it would have failed, right? But in permissive, whatever does not fit in the data type, it will just give me as null. And this, it is not able to make it as a date, right? Because it is expecting YYMMDD by default, right? By default, it is expecting that date should be in YYYY hyphen MM hyphen DD, and that is not there, right? So I have to tell them, right? So for that, what we can do, we can give a date format, right? So I can pass date format, something like this, right? Date format I can pass. Let me copy this, and I think I can pass here. Let me check. So I'm saying date format equal to this, right? Y MMDD, right? This is how we have the data. Let me quickly check one more time. I did with text editor. Yeah. So if you see here, YYY slash MM slash DD, right? And here I'm telling it that my data is in this format. My date is in this format. This is what I'm telling, right? So let's see what will happen. Uh, Schema. Okay, I think I don't have to pass this. Okay, let's see. Yeah. So now if you see, my date is coming properly, right? Ultimately, it converted into a date format and it shows always date in this format, YYMMDD, right? But while reading, we told that Spark, my date, whatever dates are there in my system, right? These are in this format, YYMMDD. This is one method. But the problem with this method, I mean, there's no problem, but sometimes it might be possible your one-off date is in some other format. Let's say your order date is in this format, and maybe your ship date is in maybe, let's say, let's say DD MM Y, right? That might be possible, right? You never know, right? Then how you will give? Because you can pass only one date format, right? So it will fail or it will give you null in one of the columns, right? So one way is this, then while you are reading file, you pass the date format that this is my date format. Another way is you read it as a string, right? So let me remove it, or maybe I'll take it to a new tab, right? So I'm saying, okay, read it as a string. I will handle later, right? I will say string type, right? And let me remove this. Okay. And for now, if I see this is coming fine, right? But it is not a date. I want it as a date because I cannot use date functions and filters will be slow, right? So if I do print schema, right? This is a string, not a date. Now what I can do, once I read the data, so I know that in string anything can fit, right? And now I will cast it. So I will say with column, I will change it to basically date using toDate function. So I'll say my order date is to underscore date. So I want to convert my order date to date. Right? ToDate is a function, and then here I pass the format, right? That my date is in this format, which is YYMMDD, right? Yeah. Right. So I'm saying that you read it as a string first, right? Now let's say order date is in some other format, ship date is in some other format. So individually I can change. For ship date, I will give the different format, whatever format my date is. And then for order date, I give different format and it works for me. Here I am giving just one when I was passing it. So if you have the dates in the same format, you can use this, or otherwise you can use this. Right? Dot show. Right? So this is coming as date. If you are seeing that date is coming y hyphen hyphen dd, it means it has read it as a date. Again, this is a new data frame. In existing data frame, nothing has been done. That is immutable. Okay, so we learned two ways. One is this, where we pass the date format while we are reading the file. Right? This is a shortcut method, read.csv. Right? If you are using the other method, then you can just pass like this dot option date format. Right? All the options you can give like this. Okay, great. So this is how you work with dates. Great. We'll see date functions later. Like if you want to extract year, month, all of that, we have the functions just like SQL. It will come, I think, next topic. Okay. Now we will discuss a important one, case when, right? Okay, I'll take a 5 to 10 minutes break. 8 minute break. It is 11:52 here in India. We'll start at 12 o'clock. If you have any questions, let me know.
Hey Ankit, uh, so
Yeah, Richa.
so in order date only, if two type of formats are passed, so it would be fine, right? That the format which we have passed would be applicable and the rest will be null, like the format which doesn't.
Yes.
Yes,
Yes. In permissive mode.
yes, in permissive mode.
Yes. Yes.
Okay, and in that SQL expression also, once you
Mm.
were showing like how to pass it in SQL form, and the second one was in the column
Right.
type.
Yes.
In the
Yes.
SQL one, also the or and expressions, it would be similar to the SQL only, or
Yes. Similar to SQL, you have to give all and AND.
okay,
OR and AND, I think. So if you see here, like this.
okay, uh, got it. So
Yeah.
this would be easier, right?
This will be easier. But
Mm.
again, as I'm saying, when you are working on a existing code, it can be in any form, right?
Right, right.
Developer might have written like this or
Mm.
like this. So you should know.
Okay, thank you.
Yeah. Okay. Any other doubt?
No, good. That's
Okay. Then, okay, we can continue, I think, because today's session is little simple, I think. So let's move forward. This is done. This is also done. This is also done. Yeah. Now we will discuss case when. I mean, in SQL, we all work with case when all the time, right? So, for example, let's take us, maybe I want to create a new column, right? Where I want to say, if it is one quantity, I want to say single quantity. If it is more than one, I want to say multiple quantity. Simple logic. If it is one, then the column value will be single quantity. If it is more than one, then it will be multiple quantity. Simple case when I want to write. So if in SQL I have to write it, so I will say select star comma case when quantity quantity equal to one, then single single else multiple, and as this is then quantity group, right, from table. This is how you will write, right? So this is your expression basically. If quantity is one, then the value should be single, otherwise it should be multiple. And this will end your case expression, and then this is just a alias, right? So let's see how we can do this in PySpark API. So now I'm creating a new column. So whenever we have to create a new column with column expression, right? So I'll say df underscore orders dot, we can go back to df underscore orders, right? Let me see if everything is fine there. Yeah, so we can go back to df underscore orders and I'll say with column because I am creating a new column, right? So my quantity group, this is my column name that I want to create, right? Quantity column. Now I will give the expression here, right? So you will say when, directly you will say when, there is no case as such, right? You will say when and you write your condition. You will say column. Initially, it might look little difficult, right? But if you just solve few questions, it will be simple. It is not that different from SQL, right? Little bit syntax is here and there, but I think you should be comfortable, right? If you just practice couple of days, you will feel very comfortable, right? So I'll say column quantity. If it is equal to 1, right? Then you give some value, right? So I'm saying single, right? Okay. And let me see if I just give this, will this work or not? And then I'll say dot show. Okay, so what it is doing, wherever it is 1, it is giving me single, right? And wherever this is not qualifying the condition, it is giving me null, right? In SQL also it works like that. If a condition is not qualifying in your case when, it will just put null. So it is working like that, right? So if quantity is 1, then it is giving single. When quantity is not 1, then it doesn't know what to do. Right? We have not told anything. We have told only for quantity 1. So it is giving single. But if it is not 1, what? So for that we will say dot otherwise. Right? And in otherwise I will say multiple. Right? Now there is no confusion. Whenever it is 1, then you give single. If it is not 1, right? Otherwise means else, right? In case when we have else. If it is not qualifying in any of the case when condition, then it will go to else. Similarly, we have when otherwise, right? Now, if you want to give multiple conditions, so for example, for single product, you want to say single. When quantity is 2, you want to say double. Then you want to say more than double or multiple, right? So you can add more when condition here. So you will say when. Let me copy this. And dot otherwise. And let's say if equal to 2, then double, right? Otherwise, multiple, right? So see, single. If it is 2, then double. Right? If it is more than 2, it will be multiple. So you can write multiple when, and in the end, you can give one otherwise. Right? And again, it is going very lengthy line, right? So maybe I can put it to the next. Maybe I can put here, right? Yeah, because it is within the when, right? It is working, right? If you have one more different transformation, right? Then you have to put a pipe. But this is the continuation of existing transformation, when transformation. So it is fine. Otherwise, you have to pass this. Right? So this is fine. But you understood, right? When, how much ever when you want to give, you give, and it runs from left to right, right? So all if you are like this, you can say it is top to bottom, right? So it will check first this condition, then this condition, and then it will come here, right? So for example, let's say if I say equal to 2, right? Equal to 2, then single, right? Or let's say I want to give less than equal to 2, let's say. Right. So what it will do, it will just check here, then it will not go here. Right. So if I run this, you will say for 2 also it is giving me single. Right. Because it will first check this condition. If this condition is satisfying already, then it will not go here at all. Right? If this condition is not satisfying, then it will go to the next condition. If this is also not satisfying, then it will go this. But whenever 2 is coming, it is already passing this condition, so it will give me single, 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 right? So 2 will never come in that case. Okay, great. So this is how this works. It works left to right here or top to bottom. How much? I mean, you can write code like this, so it will be top to bottom, or you write a single line, then it will be left to right. So this is how you can give multiple case when condition, and again, you can give multiple condition like quantity equal to 1 and so same thing you have to do. You have to put this in bracket, right? And condition, and then you can put another condition. So it will check if both the conditions are satisfying, then it will be single, right? So whatever we learned in filter, it works here as well. Great. So this is your case when condition, very, very useful, right? So you can give multiple conditions, and this is a single condition, when and otherwise, and here you give multiple, when, otherwise. So all of this works. Again, there will be a string method. You can just check that, or I can add in the notes, but it works. Okay, great. So this is how you write. Yeah, it is there, right? If you want to use a string method, you can say select star, select all the columns, and then you can write a expr, and then you can write your case when statement here. Or in this, you can also give when otherwise condition, right? Select star, then when otherwise, right? With column, what it is doing, it is creating a new column using this, and here you are doing a star and then creating a new column, but you can give same when otherwise clause here as well, right? And then you can give alias, right? Because here you have to give alias. Here with column first argument is the column name, but here you have to give a alias. So you have to write this full condition, and then you can say dot alias. This is my new column name, right? So if you want to practice all of them, you can do. I'm mostly showing you with the call method, right? Great. Now we have string and date functions, very similar to SQL, nothing new. Trim upper, lower. I'll just show you quickly all the data. So let me copy this. And what is this? This is okay. First, see the string functions, then we will see the date functions. Okay. So we have this data here. If you see, I have put some extra spaces in the end. Here we have some spaces, leading spaces. This is trailing white spaces, and then this is normal. So we have ID, name, and email. And then what I'm doing, I'm saying df.select, and I'm creating multiple columns. You can create multiple columns using with column, with column, with column, with column multiple times you can do. Or like this. Here you can create all the columns together. You don't have to give with column multiple times. Right? So let me run this. It is too many things. Let me remove few things first. Okay, so this is my ID name, original name, right? Then this is trim name. So trim will remove all the leading and trailing spaces, right? And this is the upper function. So trim function, upper will change it to uppercase, right? Then lower will convert it to lowercase, and then init cap, so it will change it to first letter. I mean, in each word, first letter will be capital letters. Initial letter is capital, init cap. And then you have length, right? Nothing new as such here. And then let me remove this time. Okay. And then it is substring. So what I'm saying, give me from first letter until 5 letters from the first letter. Right? I need 5 letters from the first letter. So first letter is A. From here it will take 5 letters. 1, 2, 3, 4, 5. Right? So this is how it is. Again for Rohit Sharma, there are two white spaces if you see. Right? So two white spaces, 3, 4, 5. So all white. Here it is starting and Virat, right? So let's say if I say 2 comma 5, right? So it will give me from the second character, 5 characters. So if you see NKIT, So there is one more space which is coming, it is not visible, right? Here again it is ROHI. Right? So this is how it is working. There are two white spaces here. Okay, great. If I do 6, let's see. So you see it is coming 6. Right? So from second characters, give me 6 characters. From second characters, give me 6 characters. This is how it is. Okay, now it is concatenation. You want to concat multiple columns. So you will, what I'm doing, I'm trimming it first, right? Because there are white spaces, and then I'm adding comma and then email ID, right? So this is giving me name, comma, email ID, and in name also I have trimmed it first, right? So you can use concat, and then you can add more things, how much ever you want to concat. So I have given 3 values if you see, but if you want to give more, you can give more, one more value, comma, 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 and you can give multiple. Either you give literal or you give a column name. Okay, great. Last one is split. Basically, you want to split a column, right? So for example, here I have email ID, right? Let me take email as well. Email. Right. Now from this email, right, I'm splitting it based on at the rate. So when I do split, this will become first part and this will become second part. Or this will become first item and second item. Let's say you have one more at the rate, then it will be third item. Right. Now what you want? You want to uh, you want to get the first item or second item, right? So if you say get item 1, so it is giving you the first item, right? It starts from 0, I think. If you give 0, it is giving you the first item after the split. Right? So it will start from 0. So this is 0. Then this is 1. Right? So this is how this works. Okay. So this is your split and get item. Great. Let's see some date functions. There might be more distinct functions. You can just see the PySpark functions, right? PySpark string functions. There is nothing as such that I should explain to you here. If you have worked on SQL, you already know. So you see coalesce, null if, and lot of functions are there. Is null, like, regular expression, sort functions, mathematical. Then you will have string function. String function you see char, chr, lot of them, right? So you don't have to as such by heart them. Whenever required, you can just search and get it, right? There's nothing as such you have to by heart or you should know everything. It is okay if you don't know all the functions. There are a lot of them. No one knows, right? If you see hundreds and thousands of functions are there. Okay. Let's see the date functions quickly. So let me create this data. So we have two columns, ID and order date. And what I'm doing is, why it is coming? Okay. So if you see, I'm converting it to to date, right? Because when I read it from file, when I read, I give that read.csv and this is my format and it reads. But here you have to convert it into date, right? It is reading it as string. Okay. So if you see, we have ID, order date, which is in date format. Now, if you want to get the current date, today's date, you will use current date function, right? And this is just the alias. You want to add something, you can say date add column name 7. So it will add 7 days. So for example, if it is 17, right, it should be something is not right. It should add 7. Okay, this is the one. Sorry. This is my order date, right? In order date, I'm adding 7. So 10 plus 7 will be 17, right? 15 plus 7 is 22. So this is how it works, right? Or maybe I can take something like 28 so that it goes to the next month, right? If you see 28, 7 if you add, it will be 4th April, right? You want to subtract days, just use date sub. So you have date add and date sub. It will subtract 7 days, right? You want to calculate difference in two dates, right? Difference between two dates in days, right? So you can give first date, it can be a column or current date, anything, and then the second column, right? So difference is, if you see 7, right? Okay, this is 2025, this is 2026, so difference is 372 basically, right? Again, this is 2005 and this is 2026, 336. So it is giving me number of days between two dates. Then if you want to extract year, you can just extract year. If you want to use month, extract month, day of month, and then you want to change it to a string, right? So this is a date. Basically, you want to, in your report, you want to show it in this particular format, right? This is no more a date now, basically. This is a formatted date, but it has become a string, but you formatted it. You are saying, I need in this format. So date format, and you give your column name. Basically, it should be a date and you convert it to this format. So it is just doing that. Okay, great. So this is how you do it. Then we have drop, where you can drop the column, right? So for example, let's say you created this df1 equal to this. Sorry, show I will remove. Yeah. Okay. And if you do df1 now, df1. Okay. Now let's say you are saying I don't need this column. Right? So you can say df1 dot drop and you can just pass the column name. Right? Again, it is not dropping from the existing data frame. It is just giving you a new data frame after dropping this column. Right? So you have to put it into a different variables if you want to store it. So if you see formatted date is gone. You can pass multiple columns. So you can say drop formatted date as well as today. Right? So it will just drop both the columns. Right? So whatever columns you want to drop, all of them you can give here. That's it. Nothing complex as such. Okay, so this is your dropping columns. Okay. Okay. Now we will discuss union all and all the set operations basically. In SQL also we have set operations. Let's discuss here. So let's go here. Now, what is union, right? Union means you have two tables. Let me take two tables first. Yeah. Okay, so you have two tables, right? df1 dot show, and you want to combine the data basically, right? So you have this orders data which has 3 rows, right? And it has 2 rows. Now maybe you are reading from two different data sources data. One is coming from file and one is coming from, let's say, S3 or some other location, and you want to combine that. Maybe you have a different source for India sales and different source for, let's say, US sales, right? And you want to combine it and do analysis final, right? You don't want to separately do analysis, right? You want to combine data and then do analysis, right? So for that you can do union, right? So what it will give you, it will give you the combined data of these two data sets together, right? So what you will do, you will say, or let me keep it as it is. I'll say df1 dot union and just the df2. That's it, right? So it will just union it. What happens? df1, sorry, right? So dot show. Again, it is creating a new data frame. Right? In this data frame, you see all of them are together. Okay. Now, let me do one thing, right? If you are coming from SQL background, you may be thinking that it should remove duplicate, and let's see, will it remove or not? So let me introduce some duplicates. Let me make this same. Okay. So one placed 100, one placed 100. These are duplicates now, if you see, and let's see what will happen. If you see, it is not removing the duplicates, right? So in PySpark DataFrame API, right, union and union all are same. It won't remove the duplicates, right? But if you're using Spark SQL, if you're writing, it will remove the duplicates. You can try it. You can create a template table and then you can write a Spark SQL on that, right? So I think earlier union all was there, then it is deprecated, and then we have union now, right? But both just, if you see, union and union all are same, right? Both keep duplicates, generate identical execution plan. Union all is still exists only for backward compatibility. Yeah, union all was there earlier. Now only union is there, but this also works basically, right? So you can use union all as well, right? So this works. Now the only thing for union is the data structure, basically number of columns and data types should be same, right? So you have order ID, order status, amount. Here also it should be same, right? Otherwise it will give you wrong result, right? So let's say if it has two columns and if it has three columns, then that will be a problem, right? We will see that, right? So what we will do, uh, let me do this, right? So, or maybe I will take another cell, right? So now what we are doing here, if you see here we have order ID, different schema, right? This is order status and then amount. But in data 2, if you see we have order ID, then we have amount, right? And then we have status, right? So what will happen? We'll see. So when I'm creating df1, I'm passing order schema 1. When I'm creating df2, I'm passing order schema 2. Right? I hope you understand what we are trying to do. So let me show the data also once. Okay. So let's see what it will do. So I'll say df1 dot union df2. Okay. So if you see, it will just merge the data, right? But it is all wrong, right? So what is happening? What it does? So one of the column is string and one is int. Here also one of the data is string and one is int. So it will say, okay, what should I do? It will make everything string because in string int can also go, right? What it will do, it will make this column as a string, but basically it will just in order status for three rows you have order status, but for two it is amount because order matters. Second column is amount here and here it is order status. So it doesn't know that third column is amount and here second column is amount. So I should keep data that way. No, it will just go by the order. So first column here and first column here, second column here, second column here, third column here, third column here. That's it. And the column name it will take always from the first data frame. So if I say df1 dot union df2, so whatever column names are there in df1, those column names it will take, right? So if I do df2 dot df1, right? So if you see column names are amount, right? Because in df2 column name is amount, first and then order status. So column names will be taken from the first data frame always. Okay. So how we will fix it? We will just reorder it. So what we can do, we will say in df2 dot df2, let's say I'm fixing it, right? I'll say df2 fixed is df2 dot select, right? And then I will select the column. So I will say order ID, it should be order ID. Then it should be, second column should be order status, not amount, right? Second column should be order status and third column should be amount. Now I can union them, right? Now I can union them and it will be fine. Right? Now it is fine. So you change the column order first using select and then you can union it. Right? Great. Okay. So now there is another thing. One more thing you understood is that one is a string and one is int. So it converted into a string when we were doing this, right? Let's say one is int, one is date. What it will do? Here it is fine. It understood, okay, fine. I will convert it to a string. But if let's say one is int, right, another is date, then you can try, it will fail. It will say that data types are not compatible, right? So the number of columns should be same and data type should be compatible. Compatible means if you are taking int and a string, then it will make everything a string. But if you make one int, one date, then it will fail, right? You can try, I think it should fail. Okay. Now we have one more, which is union by name. So what it will do, right? Let me remove this fixed one. Or let's take another cell, right? Let's remove this fixed one. And this is my df2. Okay, so currently if you see it is wrong, right? Because it is just taking by the order, first order ID, then order status and amount and order status, right? So this is how it is happening. Now there is one more which is union by name. What it will do, it will union them by the column name. Right? This we have not seen in SQL, right? Union by name is even if the order is not same, it will check that what is the column name and those columns it will bring together, right? If you see, now it is coming fine. Right? Even though the order is different, but union by name is smart. That okay, it will check what is the column name and accordingly it will union the data. So all the order status is in one place and amount is in one place. So this is fine, right? The only problem here is this looks good, right? Union by name. But the problem here is it might be possible your column names are not same in both the data frames, right? So for example, here it is order status and here let's say it is status. It might be possible, right? You never know, right? And what will happen, right? Let's see. See, it is giving me error. Cannot resolve column name order status among this. So what it is doing is it is checking that order status column, it is trying to find another data set because we are saying union by name. Now this order status it is not able to find in the other data set, right? Cannot resolve column name order status among, this is order ID, amount and status, right? So if your column names are not same, then this is not a right way of doing it, right? Only if column name are same, but their ordering is different, then you can use union by name. But again, tomorrow if column name changes something, it will be a problem. So I feel you should go a traditional way. Just align the column names and that should be fine, right? But it depends on use case, but we have this option basically that. Okay. So let me change it to order status and it is all fine now. Okay. So this is your union. Union means combining data of two tables or data frames or data set, whatever you call it, right? So it will just give you the, and union all are same, right? Let's say you want to remove duplicates. Let's say you have that requirement. So let me do this. So maybe I will go here, right? And we have the duplicates here. Let me create some duplicates. Somewhere we created duplicates, right? One place, here we created the duplicate. So let's see. Okay. So let's say my requirement is after union, I want to remove the duplicates, right? Because a union doesn't remove duplicates or nor union all remove duplicates, right? My requirement is after union, I don't want to see duplicates. If duplicates are there, remove them, then I can just do distinct here. Distinct will just do on full data set, right? Okay. So now duplicates are gone. Right. Now remember this union was a narrow transformation, right? But this distinct will again become the wide transformation. So this thing you have to remember. But basically you can just do distinct in the end and it will give you the, it will remove the duplicates basically. It works as a union, actual union in SQL, right? You union it first and then do distinct. Okay, so this is how you can do union and distinct. And we have apart from that, we have other set operations like minus, intersect. So let me quickly show that. So intersect, return common rows between two data frames, right? Intersect means whatever rows are common, right? Full rows it will check, and whatever rows are common, it will give you. So for example, this 3 delivered 300 and 3 delivered 300, right? Full row it will check. We cannot check on individual. So we have to select those column and then do intersect, right? But here I'm just saying that df1 intersect df2. So it will check which rows are common and those rows it will give you, right? So it is giving you just one row. Right. Let's see, will it remove the duplicates or not? Right. So let's say 3 is again here. Right. And if you see, it is not giving you duplicates as well automatically. Right. If you see this 300 is duplicate and it is here as well. Let me put one more. Let's see what will happen. Will it give me both or only one? Yeah, so it is always removing the duplicates, right? So it will give you the common value and it will not give you the duplicates as well, right? Let me check if we have intersect all. I'm not sure. Yeah, intersect all is also there. So in intersect all, it is, I think, not giving you duplicates. So this is common and this is something like that. It is working, but it is not giving you duplicate. Let me add one more and see what will happen. Yeah. So basically, if there are two rows common, right, then it will give you two rows. This is how it is working. Right? But by default, intersect will remove duplicates, no matter how many are there. Okay, so you have intersect and intersect all. Right? Again, same requirement that the structure should be same. Basically, number of columns should be same and their data type should be compatible. Otherwise, it will give you error. All set functions have same requirement. Right? So this is your intersect, and then we have except, similar to minus or except in some data frames. And if I go here, so what I'm doing is I have created two, right? And then I'm saying, let me show you the subtract first. Again, subtract removes duplicate and accept all keeps duplicate, right? So subtract basically, it will take all the records from first. So this is df1 is the first one minus this. So whatever is there in this, but not in this, right? So if you see one placed 100 is there, but not here. Two shipped 200 is also not there. Three delivered 300 is there, right? So the last one it will not give. It will check if it is there or not in this. No. So it will give. It is minus means remove it if it is here in data 2. This is there, 2 ship 200. 2 ship 200 is not there. Right. So it will keep that as well. 3 delivered 300. Yeah. So it will not give that. So let's see. What happened? Data frame object has no attribute subtract. Okay. Subtract is it? Yeah, it is subtract, not subtract. Okay, let me fix it here. Subtract. Okay. Okay, so if you see it is giving me 1, 2, the third one it is not giving because third one is there in this, right? Now if you do accept all, right? I think accept is also there. Let's see. So it keeps the duplicates. So let me create a duplicate here, right? And it is keeping the duplicate. And if I try this, it is removing the duplicate, right? So this is how it is. Let's see if accept is also there. Not sure. Accept is not there. You have accept all only. Okay. So this is your minus, basically present in this, but not in this, right? So these are the basically three set functions we have everywhere. Union, all generally we have two in SQL. Then we have intersect to get the common records and A minus B. This minus whatever is in this, right? So if I do reverse, it will be different result. So if I do df1, df2 minus df1, right? So it will check, get you everything from here, but then if it is present here, it will not give. So 3 delivered is here, right? So this it will not give, it will just give 4. Only 4, right? So the order matters here. In everything else, like intersect or union, this order doesn't matter. If you see df2 intersect df1 or df2 union df1, the result will be same, order might be different. But in subtract, it matters because this is a minus b, b minus a. So that will be a different result. Okay, so this thing you have to remember in case of accept or subtract. Okay, great. Now let's move on to the aggregation, right? We will learn how to do different kind of aggregation, and we will see that count is a action and transformation both, right? We discussed, I think, in last class that count sometimes behaves as action, sometimes it behaves as transformation. So we will see what is the funda behind that. Okay, so let me do using uh, hmm, we have df underscore orders dot show, right? Perfect. Now let's say I want to do some kind of aggregation, right? So one is simple aggregation. You want to do some count or something like that, right? Without group by, right? You want to do simple aggregations, right? So you can just say df.agg, right? And then you can pass the all your transformations or aggregation. Let's say count star dot alias, let's say total records, right? And let me take one more. So let's say sum of quantity dot alias as total quantity, right? And let's say dot show. Sum of, okay, I have to give in double quotes. Okay. Okay, so this is on full data set. It is telling me that you have 1 million records, right? And this is the total quantity sold basically, right? So it is on the full data set we are doing, right? There is no, let me show this. There is no filter, nothing, right? On full data set, I'm doing this aggregation, right? So on full data set, whatever those are there, total is this, and this is my total quantity. Similarly, I can find sum of unit price or whatever, right? Okay, great. Now, the only thing which we need to learn here is the count function, right? Count function behave little different, right? So maybe I can take a sample data to show that. Um, let's take this. And okay, so okay, so let me show you data first. So if you see in category column, I have a null, right? If you see null. Now what count does, when you do a count star, right? It will give you the total records. So 5 records are there, it will give you 5, right? But when you do count of category, right? It will count the number of not null value, right? So if I just run this, you see this is giving me 4, right? And this is giving me 5. This is also count of literal one, so it is giving 5. Again, this is sum of sales. Even if I do count of sales, right? It is giving me 5 because there is no null value in 5 in sales column, right? But in category column, 1 is null, so it will not count, right? I think we should have count distinct as well. Let me check. Yeah, so count distinct will give you count of distinct category, right? So again, it will ignore the null, right? So it will give you fashion and electronics. Two distinct values are there, so it will give you 2. Right? So if you want to count distinct values of a column, you use count distinct. Otherwise, you just say count. Okay. This is like count one, right? We write count one many times in SQL, right? It is same as count star. So if you want to just say count one, you can say count and literal of one. This is how you have to give. Okay. You can also do df dot select here because here we are not doing any group by or anything, right? So you can do select, that also should work. Yeah, this is also working. Right? So either use AGG or select, doesn't matter because this is on full table. When we do group by, then we will have to use AGG, right? But here it is just a select. So you can just say select or AGG. It works. Both the things works. Okay, great. So when I don't give the alias, so if you see there is no alias here, right? So it has created column names similar to the expression itself. See, count of sales, count of one, right? So you can just alias it, dot alias, or you can say with column renamed and then rename whatever you want to rename. Anything is fine. Okay, now let's understand that here. Okay, so if I just, let's say I do this, right? I'll show you two different behavior. Okay, so let me take this much, that's it. No, this much. Okay, count star. Right now, if I just done this much, right? Let me comment this as well. If you see, it is not giving me anything, right? Because this is a not a action, right? It is a transformation. It is lazy, right? Until unless I say show or something, it will not show. Okay. But now what I will do, I will say df dot count. Right. Now it is giving me count, right? So the count function which you use on data frame, this count function is for the data frame object, right? This count function is a function of this data frame object. This is an action. Again, I will say this count function is a function of a data frame object and this is a action. But this count is coming from, when I say from PySpark dot SQL dot functions, right? Import star. So that count function is coming from here. So when I'm using in select, when I'm not using directly on data frame object, right? Then it is a transformation and this count is coming from this here. Right? But this count is a function of data frame object, right? So if you see, df.count belongs to PySpark.SQL.data frame, right? It is a function of data frame, right? It is a method of data frame, right? Returns a Python integer, triggers execution immediately. This is an action, right? Now you might be thinking why they made it an action, right? They could have made this also as transformation like this. But my understanding is, I don't know if it is written, but if you see this df.count will return you one integer, right? You can't do further transformation on top of it, right? This will always return an integer value, just single value. So you can't do further transformation. What transformation you will give on a integer count, right? So they said make it an action because anyway user will not be able to do anything. So the only intention is to get the number of records from this data frame. So they made it at action, right? This is my philosophy. But here you can do a lot of things, right? You can select, you can do group by, you can have multiple things. So this is a transformation and you will have to trigger using an action, right? So count is the data frame method count is an action, but the function from PySpark.SQL function, the count is a transformation, right? So this is how you have to remember it. Okay, this is also can be interviewer can confuse you sometimes, so you should be clear, right? The data frame method count is an action, but this aggregate function is a transformation. Returns a column expression used inside this and needs a uh, action to execute. And this is a transformation. Okay. Great. So these are the simple aggregation on full table if you want to do. You can do average, max, min, anything you can do, right? So for example, you can do, let's say you want to get max of sales, right? You can just use max from PySpark dot SQL dot functions. Okay, so it is giving you max of sales, which is 400. Right? Similarly, you can give min, and you can obviously alias it. So min is this, or you can do average. Then it will give you average sales is 280. Right? So average means sum of all this divide by 5. Okay, and again, if you want to write some expressions here, let's say if you want to calculate sales using sum of sales divided by count, you can write here using column method directly either, or you can write in an expression, right? So whatever you write, but you know how to do it. Great. So this is all fine. Now, whenever we are doing analysis, right, most of the times our requirement is like, I want category wise sales, right? In each category, how much sales I have done, right? So if I say df underscore orders dot show, right? So here, let's say I want state wise total sales. Then in each state, how much sales I have done, right? So if I do total sum, normal sum like this, it will give me overall sum. But when I do group by for each individual value, so for example, Gujarat will fall into one category and it will sum it up sales for Gujarat and give me. Similarly, all the Punjab, whatever are there, will fall in one group and it will give me sales for Punjab. Similarly for Bihar. So for each state, I will get one sales, I mean one row, and it will have sales for that state, right? Or quantity, whatever, right? So for that, we will have to use group by. So I will say df underscore orders dot group by, again b is capital, and I give the column that on which column I want to do group by. So for example, I want to do on state, right? Then again agg, right? And now you can give what values you want. So for example, I want, let's say I want count star first one, dot alias total orders. So it will give me total orders state wise. And then in each state, how many orders are there? Again, this is a transformation, not action, right? If you see, it is just giving me this data frame that what will be the structure, right? It is not giving me anything. This is coming from df orders dot show, right? So I will have to do dot show. And if you see, it is giving me state-wise total orders, right? It is showing 20, but I think we have 22 states. Let me make it 30. Right? So yeah, right. Now let's say your requirement is now I want top two or top three states by sales, right? So you know what to do, right? So you will just say dot sort by what? Let's say I'm saying column sort by total orders, right? And I want in descending order, right? Let's run this dot show. Right, so this is in descending order. See, this has the maximum order 864, 775, 783. So Delhi has the highest orders and Karnataka has the lowest. If I want top three, I can just say show three. Right, so it will show me Delhi, Goa, and Telangana. See, Delhi, Goa, and Telangana. I think take three will also work. Take three will give me a object kind of thing. It is just not the print, right? When I do this, it is a formatted print. When I do show, right, it is just the in a print format. You cannot do anything right on top of this. But when I do take or collect, it will give me a list object, right? You can store it in another variable, and maybe you want to run a loop or whatever you want to do, you can do it, right? But when I do show, this is just a printable format. Nothing you can done on top. You cannot store it somewhere and do anything, right? It will be a string. That's it. but this is giving you an object of type list, right? And you can, on top of it, you can work. This is one row, second row, third row. Okay, so it is fine. So we got how to got the top three states by number of orders. Okay, so let me remove this for now, and then let me remove this as well, or it is fine. Now I want more. I want total quantity sold as well. So I'll say sum of quantity, right? Again, I want to alias it. Alias quantity sold, right? And that's it. So I'm getting two columns, total orders and quantity sold. And I have sorted based on total orders in descending order. So I can sort on whatever I want. Okay, simple, very much like SQL, nothing new, right? Just little bit syntax different is there. See, in SQL also we say group by, and then with along with select we put it all the aggregation. Here we have to just put AGG and then the all the aggregation and their alias, aggregation their alias, aggregation their alias. Okay, great. Uh, okay, this is fine. Let's see if we have anything else. This is a, yeah, this all we understood. This is fine. Yeah. Now, one more thing is in SQL, we have a having clause, right? Here it is little different, right? So we have the having clause. Having clause means, so let's say you want all the state where quantity sold is, let's say, more than 91,000, right? So which all will come? These will come. Or let's say total orders is more than 40 or okay, let me do quantity sold sort, right? Then it will be clear. Okay. And okay. So you have these many orders. Your requirement is you want only those state where the quantity sold is more than 91,000, right? So these records should come basically, right? Your requirement is you want all the states where total quantity sold is greater than 91,000. So these will not come. This is less than 91,000. So how you will write SQL? So you will say select uh, state, comma, sum of quantity sold as total quantity from orders table group by state having sum of quantity sold greater than 90,000. This is how you will write, right? Once you write this, then you will get this result, right? You can write a Spark SQL if you want, or let me write one, right? So that you guys are also comfortable. So let me say, um, let me comment this first. And I will say df underscore orders dot create or replace temp view, and I'll say orders, right? And now once this is there, let me create that, and then I will say spark.sql, right? And then I will just put this, right? Okay. Now it may go to multiple lines, so I think I have to give in three single quotes, right, Nchiket? I don't remember.
Correct.
Let-
Thank you. Yeah. Double quotes, three double quotes.
Three double quotes, okay. Because it will go in multiple lines, right? So you have to give like that. So select state, sum of quantity sold, column names I'm just tracking from orders. This is my orders table I created here, right? This we can comment. Okay. and group by state having sum of quantity sold. No, quantity sold, yeah, correct. Is greater than this. Okay, quantity sold is not there, right? Quantity is there. Quantity sold we have created here. So column name is quantity. My bad. It has to be quantity. Total quantity, total quantity, total. Yeah. Okay, and let's do dot show. Okay, so if you see, we have coming from Bihar, right? Bihar, Odisha, okay, greater than 90,000. So it should come from Haryana to Delhi, right? And it is coming, uh, okay, my question was 91,000, not 90,000. Okay. It should be greater than 91,000. My requirement is, right? So these will not come, right? If I say greater than 91,000, these will not come. From here, it will start coming. Okay. So let's change it to 91,000, right? So these states are coming now, right? So below 90,000 are not coming. So this is how I will do it, right? And I can store it in another data frame, and then further I can apply other transformations using data frame, or again create a new table, whatever I want to do, right? Now, same thing if I want to do in data frame API, right? So in data frame API, you don't have as such this having clause, right? So you can chain transformations here, right? So you already are saying, so let me take it here, right? So you already got this, right? Quantity sold, right? Now you can put a filter after that. So you will say dot filter, let me put here, dot filter, right? And here you can put the filter condition. So you will say column name is quantity sold, right? And greater than 91,000. Right? So this is a little different in that way, right? Because we are creating a new column, and in the next chain, we can say simply filter. There is no having clause required, right? And I can just run this. You see only those states are coming greater than 91,000, right? So if you want to apply a having clause, you can do it. It is very similar to, for example, if you are writing a subquery, right? So you can, instead of saying this, you can say select star from here, right? And you say where total quantity is greater than 90, right? This kind of thing we have written using data frame API. Aggregated first, got new column, and then we are putting a filter. There is no having clause, no requirement also. The way it is designed, we can directly use filter on top of it. Okay, I don't know if this will run or not. Yeah, this is running. Perfect. Okay, great. We will start with joins, right? So most of the times we work with multiple tables for transformations and everything. So we will see how to go with the joins, right? So we have two tables, right? One is we have this orders table, right? And we will have one product table as well. So let me read that. So let me show you first what is there in the product table data, and this is my products.csv. Okay, so I have just three columns: product ID, product name, and the cost price, right? Cost price means what is the at what cost I am buying the product, right? And in the orders table, I have the unit price at which I am selling, right? So for example, 137.51, I sold one quantity. Here 134.45, I sold three quantities, right? So total sales is 134 into 3, and the cost will be 3 into whatever is the cost price of that product, right? So like that it is. So let's read this table. So we will say products.csv, right? Header is true. Schema, let's create product schema. Product schema, I'll create the simple one. So we'll say product ID. It is a int. Then we have a product name. it is string, and then we have cost price, which is integer, I think. Yeah, in this it is integer, so let's keep it integer. Generally it will be float. Okay, and then we will pass this product schema here, right? And let's see the data. So this is my DF orders and this will be DF products. Okay, all looks good, I think. Quickly we will check. Dot show. Yeah, looks good, right? Product ID, product name, cost price. Okay, great. So we have these two tables and we want to join them now based on product ID, right? Product ID is the common column between these two tables. And let's say we want to see how much is the profit. So it will be unit price minus cost price multiplied by quantity. I mean, whatever we want to do. We want to get product wise sales where we want to see product name. Then again, we can join and get, right? So basically we can join these two tables and do the analysis, product analysis, sales analysis, whatever you want. So let's start, right? So syntax is very simple. What all you need to say. So they are left table and right table always, right? So for example, when you write in SQL, you write something like that. Select, let's say from orders, and then let's say you are saying inner join products, right? So the table next to from is the left table and this is your right table always, right? This is how it is in SQL. Here also, when you say df underscore products, sorry, orders dot join, and here you pass the another data frame, right? So this becomes your left table and whatever you give here is right table. So this is how you have to understand left and right table, right? So df orders and df products. Okay. Next, you have to tell on which column you want to join. Now, if the column name is same, so in our case, column name is same. If you see product ID, so I can directly pass product ID here. So I'll say join on product ID, right? And last one, you have to tell what kind of join, inner join, left join, right join, right? So let's go with inner join first, right? And this will give you a new data frame, right? Let me put it into DF, final data frame. So we have DF orders, DF products, and this is my DF final. And I will say DF dot show. Okay. So now if you see, we have all the columns from the orders table, right? All the columns from product table and product ID column is there at front only once, right? Because it understands that product ID column you are doing an inner join, right? So this is a common column. So it is not giving you two times as such. It is only once, right? So if you see the print schema, so we have product ID and all other columns are there, right? Okay. Now what we will do, that is one way. Now it might be possible that in this table, your column name is, let's say, product ID, and in this column it is ID. It might be possible, right? So then you have to give something like this. So you will say from df underscore orders, take product ID or whatever is the column name equal to df underscore orders, sorry, df underscore products dot product ID, right? So this type of uh, like selecting the column will help you when you are joining, right? Data frame name dot column name, data frame name dot column name, right? Let's see. I think we have to give double equal to, yeah. So we have to give double equal to, and now it seems to be fine. Now, if you see all the columns from left table is coming first, right? And then product ID is coming again, right? Because we are specifically telling, right? If we give only one product ID column, it understands that it is a common column. But when you give like that, it gives you separately, right? So product ID column is there two times, right? From both the data sets, it is coming, right? And then you have other columns. Okay. Now let's see, we will do the print schema. Maybe on the next line we will do. So we have df dot print schema. Okay. So if you see order ID, and product ID is there again, right? Now what will happen? Let's say in the next transformation, right after this, I want to select one column, product ID, right? There are two columns. right? Then what it will do? It will give me error, or what it will do? Let's see. So I'll say df.select, right? And let's say I want two columns. So I will say order ID, comma, product ID, right? I need these two columns. That's it. Okay, and then I will say dot show. Now it is giving me error. It is saying ambiguous difference, product ID is ambiguous. Why? Because product ID is there two times, right? In this data set, the one we have combined, right? Product ID is two times and it doesn't know that from which you want. You want this product ID or you want this product ID, right? This becomes ambiguous now, right? So Spark is confused. In that case, you can give the alias that give me product ID from whatever data frame. So let's say I want this one, the one coming from df underscore orders. So I will say df underscore orders dot product ID, right? Okay. When I'm giving data frame name dot column name, I don't have to give double quotes, right? So now it is working, right? So when you are giving data frame name dot column name, you don't have to give the double quotes, right? It understands. But when you give this, right, it will give you error. So it will think that order ID is a variable or something like that, right? But there is no variable. So you have to tell this is a column. And when you give data frame name dot column name, then it understands that this is coming from a data frame, right? Because this is a variable kind of, right? This is a data frame. So we don't have to give double quotes. Now it is working, right? So whenever this kind of situation, when you have common column names, right? In both the tables, same column names are there. Other column names can also be different, right? So at the time of join, it doesn't give you error, right? In SQL, generally we get error at the time of join itself. We have to give alias, right? But here join is done. It will create two columns with the same name, right? It doesn't have any issue. But when you are selecting next, right, you have to specify, right? And I can select the other column as well. So I can say df underscore products dot product ID, right? So this will give me both the products ID, right? So this is aliasing, right? Great. Now, once it is joined, right, we can do all the calculations. So for example, I can say, give me order ID, product ID. Let me remove this. And then I will say call, right? And let's say I'm saying take unit price, right? Minus call cost price. Cost price is the price at which I'm buying the product. And this is the column on which I'm um, selling the product, right? So this will give me what? This will give me difference, right? So if I just run this, so this is giving me difference, right? I think they are not linked, so it is coming minus minus. Some places it is plus, but that's fine, right? And then we have to multiply it with quantity, right? Then I will get the exact profit. So I will say into column quantity, right? So this will be my final the profit or loss, whatever is happening at each order level. Right? So once it is joined, you can do any kind of calculation. You can alias it. So you can say, so let's say this is starting here. Let me put one more. Or you could have done with column as well, right? Dot alias profit. Right? So this is my profit. And then further I can aggregate in the next step whatever I want to do, right? So this is how join works. You join two tables and then get it, right? If you want another table you want to join, right? So this is your data frame, right? After join, you can have another join, right? In that you will say df dot join. Let's say you have customer, right? Df underscore customer, right? So you can join one more time, or you can chain also, whatever you want, whatever you are comfortable with, right? So it is like this. At one point, you can join only two tables. Then you have to chain it to join with the third table, fourth table, fifth table, and or you can create data frame at every step. Right? Internally, it will create the similar plan. Once Spark will try to optimize it and do it, right? But you can write in any way, right? Okay. So this is your join. Now in join, we know there are different kinds of join, right? We have inner join, left join, right join. So let's understand all of them. So let me do one thing. Uh, let me take a small data set, right? It will be easy to explain all kind of joins because in big data set we'll have to do more work to understand, right? So let me do this. Yeah. Okay, let me copy this full code and then I will show you all kinds of join. Okay, it is not copied. Okay, so let me remove this. Okay, should be fine. Okay, so let's understand all kind of joins, right, with this data set. So you have employee DF, right, which has 10 employees, right? 1, 2, 3, 4, 5, 10. And if you see department, we have 100, 200, 300, 500. 400 is not there. None of the employee belongs to 400 department. This is salary. This is the manager ID, right? So for example, for Ankit, the manager is with ID 4. This is again employee ID. So you will go here and Rohit. So for Ankit, the manager is Rohit, right? This is how you have to understand this. And then this is employee age, right? So everything is employee data. This column is only the manager ID of this employee. And this is referring to this ID itself, right? So for example, for Mohit, the manager is 5, which is Mudit. Okay, then we have department ID. So in this department ID, we have 400, 200, 300, 400. 500 is not there, right? Just to showcase all kind of joins, I have created this data, right? And then department name. Okay, so let's start with the inner join, right? So for inner join, in inner join, you get the common records only, which are common in both the tables, right? So we will join on department ID to get the department name. So if you see 100, 200, 300, so 100 is common, 200 is common, 300 is common in both the tables, right? 400 is not there in this table and 500 is not there in this table. So 400 will not join with any department ID. Again, 500 will not join with any department ID on department table, right? So if I do inner join, we will get only department 100, 200, 300 employees, right? So I'll say, and in inner join, it doesn't matter at left table, right table. But when you are doing a broadcast join, your small table will be right table, always remember, right? So you will say join and then you give here the small table in case of inner join as well, right? So this table will be broadcasted. Okay, so you will say employee df dot join deptdf and we want to join on department ID, right? So I can say department ID directly. It is a column name is common, right? So that's fine, right? And then I will say I want a inner join, right? And we'll say show. Okay, so you see, we have department ID 300, 100, 200. Right? So 400 and 500 are not coming. Only the common records between these two tables will be there in the output. Right? So this is inner join. Now when I do left join, and left being the employee table, right? I told you that this will be your left table and this will be your right table, right? Inside join, whatever table you give, this is right table and this is left table. So all the records from left table will come irrespective of there is a matching key in the right table or not. So we will get all of this, whatever we got in the inner join, as well as this record, right? 500 also we will get because this is the left table and all the data from left table will come. The only thing is, see, for 500 we don't have data in department table. So what will happen? Department name we will not get because we don't know for 500 what is the department. But since I am doing left join, all the data from left table will come. So department name will come as null, right? Or department ID also will come as null. Let me do one thing. Let me make a normal join so that I can show you both the columns. Equal to department df dot dept underscore id. Okay, this is inner join, so this is fine, right? Department ID 100, 200, 300 and 100, 200, 300. So this is matching or whatever is matching, right? Okay. Now I will do a left join. So I will say left. Now you see this is coming as null, right? You see department ID 500, right? And here department ID is coming as null and department name coming as null, right? Because there is no matching record in this table for department ID 500. So both the columns from this table will come as null, right? So both the columns will come as null. Now let's say someone is asking you that give me all the departments which are present in this table but not in this. All the employees for which department ID is not present in department table. So how you will solve? So you will do this left join and then you know that department ID will be null, right? Whatever employee doesn't have any department ID in department table, for that person department ID will be null, right? From the department table. So you will say dot filter and you will say column. My column is this one DPT df dot department ID, right? And dot is null, right? I hope the syntax is fine. No, it is not fine. Okay, I think the spelling mistake. DEPT dot, where is the spelling mistake? It says DEPT ID cannot be resolved. Okay. Uh, dot filter column. Oh, sorry. Again, I don't have to give double quotes. I always get confused. So whenever you are giving data frame name dot column name, you don't have to give double quotes, right? It will be wrong. Okay. And I think, okay, let's see what is the issue now. Column is not iterable. Okay. I think I don't have to give this as well because this is a column now. And dot is null. Let's see. Yeah, so now it is coming. Okay, I don't have to give column also because it understand it is a column, right? When we are giving in a string form, then I was telling that this is a column. But since it is already understanding that this is a data frame name dot column name, so you can just say is null. So now you are getting that employee for which the department is not there in the department table, right? So dptdf dot department ID is null, right? So this is how you can solve that. Okay, great. So I'll just comment this part. Okay, so this is my left join. We understand that all the data from left table, all the 10 records are coming, and then whatever is not matching, it will be null. Simple. Great. Next is right join. Right. Right is very similar, right? So all the data from right table will come, right? And for non-matching records, it will be null from the employee table, right? So now all the data from department DF will come, right? And matching data from employee DF, right? So now we will have 100, 200, 300, 400, right? For 400, there is no matching data. So it will be all null from employee table, right? And 500 will not come because this is my right table and I am doing a right join. Let's see. So if you see this 400, this one you see, everything is null from the employee table, right? So this is your right join, right? And to be honest, you never need right join. You can always achieve this with left join. So you what you can do, you can put this table as left table and employee table as right table, and you can do left join. Now all the data from department table will come. So it is the same thing, right? So again, same thing. For 400, if you see, it is null, 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 null. So it's the same thing basically. Right, so I'll just revert for now. Okay, so this is your inner join, left join, right join. Now we have the full outer join. Right? In full outer join, you get all the data. So all the matching records you will get. So 100, 200 and 300 are matching. So these two will get. Then you will get 400 as well. Right? So for 400, if you see this, all the data from employee table is null. Right? As well as you will get the 500 as well, this 500, right? And the data from right table will be null. So this is a full outer join. So all the matching data and non-matching data from both the tables. Whatever non-matching data from the other table, data will be null, right? So this is coming from employee table, which is not in department table, so department data is null. This is coming from department table, not in employee table, so employee data is null. Right? So this is your full outer join. Okay, great. So these are typical joins, four joins we all know, right? Inner, left, right, full outer join. Now they have given some more joins which are not something new. You can always drive those things using joins and filters, but there are some direct join types, right? So let's understand them. So so we have left semi join, right? Returns only columns from left used for existent check, right? So let me show you left semi. So I will say left semi. Now what this join will do, right? Let me run this. So if you see what it is telling me that it will give me all the records, right? It is working like a inner join. If you see we have 1 to 9. This is just a fake kind of join. It is like an inner join only, but it is giving me data only from left table. It is not giving data from the department table. Right? So we have all the data from 1, 2, 3 till 9. 10 is not there. So it will just check existence that this department ID is present or not in this table. It is something like this. Select staff from employee where DEPT underscore ID in select DEPT ID from department table, right? So this query will give you only data from employee table, but only for those departments which are available in department table. Something like that it is happening, right? But with normal inner join also you can achieve it. You can just select whatever columns you want, but it is there. So I'm just telling, but nothing new in this left semi join. Great. Okay. Next is left anti-join. Now this can be of use, right? So if I do left anti-join, let me show you quickly. Let me remove this. And so this is my left anti-join. Now it is giving me only that record which is there in this table, not in this. Now earlier we achieved it by using left join plus this, right? So basically it is giving me all the data from this table for which there is no matching record in this. So only 500 is there. And earlier we did it using left join plus this filter, right? This can be directly achieved using left anti-join. So left anti-join means all the records from left which are not there in right. So only 10 is there as per the department ID because my join condition is department ID. So this is your left anti-join. So that's why I showed you. If you wanted to do it using left join and filter, you can achieve it. But we have direct left anti-join to achieve that, right? So again, nothing new. We can achieve it using left join and filter as well. But since we have it and if we have a requirement, we can directly use it, right? Nothing special here again. Okay, then we have I mean, these are the two different kind of joins that you see in Spark, which are generally not available in normal databases that we work, right? All other works, cross join also we have. So cross join syntax is different, right? So generally, ideally, you would think that it will be something like this cross join, right? But it is not like that. Cross join means there is no in cross join. Each row will join with every other row. So we will have 40 records basically 10 into 4, right? And the syntax is like this. So I think they have made different syntax so that you don't make a mistake because cross join you should not do, right? Because it will create a lot of data and unless and until you have a particular requirement and your data sets are small, you should not use it. So I'll say employee df. Again, in this order doesn't matter because every row is getting joined with every other row. So left, right doesn't matter here. You will say cross join and then you will say um, department DF. Right? That's it. There is no join condition here, right? So we give three things. One is data frame name, right? Second is join condition. So there is no join condition. And third is join type. Join type is coming here only. We are saying cross join, right? If I run this dot show, right? So you see, we will get 40 records. So let me just show. So we have 40 records. Maybe I can do count and show. Count, right? 40 records are there. Okay. So I'll just show that as well. So if you see for employee ID 1, let me do a sort on what EMP ID. Okay, so if you see EMP ID 1, right? There are 4 records for each department, right? Again for EMP ID 2, you have 4 records. Right? There is no join condition, so every record will join with every other record of the table. So likewise, you have for all employees 4 records, so 40 records, right? So this doesn't matter. You give DEPT DF here or employee DF here, cross join, there is no condition, so it doesn't matter, right? In case of, see, in case of left and right join, this order matters, right? Similarly for left anti join and left semi join, this matters. But for inner join, outer join, and cross join, the order doesn't matter, right? Because you will have same result. Doesn't matter if you are doing a inner join. So order of table doesn't matter, whatever you give here. Inner join, cross join, and full outer join. Great. So these are different kinds of joins. I mean, different kinds of join type in Spark, right? These are physical join types, and then we have a logical join, right? There is no different keyword for self join. It is a kind of logical join we are doing. So we call it a self join. In that, what we do, so for example, so this is my data. Let me show this one. Dot show, right? Now, let's say I want manager name here. That for each employee, what is the manager's name or manager salary, whatever, right? So what I have to do, right? You think about like this. I will create two instances of this table, right? Right. Now what I'll do, I will join this table manager ID with the employee ID of the second table. So let's say this is df1, this is df2, just imagine. So I will say df1 dot manager ID equal to df2 dot employee ID. So what will happen? This 4 will join with this 4 and I will get all the details of Rohit next to here, right? So will have Rohit 100, 500, 216 here, right? Similarly, this manager ID 5 will join with this row, right? Mudit, and I will get all the data. So basically, in each row, I want manager's data as well here, right? And this is how I will achieve it by joining manager ID of this table with employee ID of second table. Basically, they are same table, but this is how we achieve it, and this is known as self join because we are joining a column with a column in the same table, right? So this is a self join. Right, in SQL also we create alias. So something like this we do select star from EMP and we call it E1, right? Then inner join. Again, any join you can use here, left join, right join, right? E2, and then we'll say E1 dot manager underscore ID equal to E2 dot employee ID. Something like this we do in SQL, right? So E1 dot manager ID equal to E2 dot employee ID. And then once we join, all this data will come next to each row as per the join condition. So we want to achieve that using now PySpark API, right? So for that, we will have to use alias, right? Here also we used alias employee E1 because it is same table basically, right? It is a same table. So I have to alias, otherwise how it will know, right? So we will have to do something like this for Spark API as well. So let's see how we can do it. So let me take this and take this. Okay. So what I'm saying, I'm using a alias keyword here. So I'm saying employee df dot alias e. right? Alias E means this first table. First table I'm aliasing as E, right? Dot join employee df dot alias M, right? This table I'm aliasing as M. So you can imagine something like this: E M E dot manager ID equal to M dot employee ID. Okay. Then I'm giving the join condition. That column E dot manager ID. Now with alias, you will have to use this syntax, right? You will have to put it in double quotes and use column, right? And this is my second condition, column E dot manager ID, right? Equal to M dot employee ID. And then I am saying do a inner join, right? And then we will see what we are getting. See, I am getting for each employee, I'm getting its manager details, right? So for employee Ankit, right, manager was manager ID 4, and for manager ID 4, this is the guy, right? I can show you maybe separately. Let me do here itself. Okay, so if you look at employee ID 9, right, let's look at 9. So 9, if you see Mukesh 6,651, till here it is coming from the employee table first. Now we are joining and saying join with the manager ID 6. Who is 6? Agam 212,000. So you see Agam 212,000. 214, right? So I got each manager's detail next to employee detail, right? Now if anyone is asking any question, so let's say give me all the employees whose salary is greater than manager salary. So this is basically manager salary, this is employee salary. So we'll have to just put a condition that E1 dot salary is greater than E dot salary is greater than M dot salary, and then I will get the result, right? Many kind of question can come here. Another question can be, give me all the employees who are younger than their manager or who are older than their manager, right? All the employees who are older than their manager. So I will just say employee dot age is greater than manager dot employee. So this is your manager's data for each employee, right? And this is your employee's data. And this manager ID is manager's manager ID, right? So for employee ID 9, manager is 6. And for this 6, manager is 2. Right? So this is how it is. Okay, so this is your cell join. So always remember anywhere, not in just Spark, SQL, Snowflake, anywhere, cell join is not a keyword, right? It is not any new kind of join. It is just a logical join that we are joining a table with itself, right? Employee DF, we are joining with employee DF on a different column. So you will never have a separate keyword cell join. Like we have inner, there is nothing like self. Right? It is a logical thing. Right? So this you have to understand. Many people I have seen, they get confused. They said that cell join is not used here. Nothing like that. You can use left join also here. Right? Anything you can use. Right? So it is just a logical thing. Okay, great. So these are your different join types, right? I think this is all join types. Yeah. This we all know, null never equals to null. Those with null join key do not match, right? If we have null, let me show you also quickly. So let me introduce null. Let me say this is null, right? And yeah. So if you see, this is null department ID, right? So this null will never join with any value, right? Even if department ID has null, let me introduce in department ID also one null. Again, this is not specific to Spark. This is a general thing. Okay. So we have null here, right? And we have a null here, right? So these nulls will never join. Null is not equal to null. Null means unknown, right? So if I do this, let me do inner join, right? And let's see what we will get. So if you see this guy is not coming, one is not coming because null is not equal to null. So these nulls are not joining. You see, we are getting from 2 till 9, right? 500 is not there anyway here. When I do left join, right? In left join, irrespective of there is a matching record or not, all the records will come. So now all the 10 records will come, right? But this will be a record which will not have any data from department table, right? So if I run this, you see we have this null, right? But there is no matching data in department table, so this is coming as null, right? So null behaves like this, right? Null is not equal to null. Okay, great. Uh, this is fine. Okay, so this is all about joins, right? It is now more about practicing it. But if you have worked on SQL also, same thing it is. Just the syntax is different. There's no difference in the logic that you apply, right? That is exactly same. So if you have built your logic building in SQL, here also they are transferable, right? You don't have to learn anything new, but that syntax is little different. Otherwise, everything is same. Okay, great. Let's move on to the window functions. Okay, so uh, let me check if I have created some new data. Okay, this is fine. Yeah, okay. So we will use the df orders data, right? That will be better. Df underscore orders dot show. Okay. Now, what are window functions, right? So we have learned group by. Like for example, I want order status wise total sales, right? Or state wise total sales. So I will say group by state and give me sum of sales, right? So just after when I do group by, right? After group by, what will I have? I will have only the columns which you have grouped on, right? Columns on which you grouped, right? So if I have grouped on order status, I will have only order status column plus whatever aggregation you have. For example, sum of sales, this you will have, or max of sales, right? So we will have only two kinds of column after the group by. Columns on which you want to group data. So you can do group on multiple columns as well. So you can pass two columns, right? You can say order status, comma, state, and on this combination, you give me total sales. So you will have both the group by columns plus aggregate columns, right? You cannot have unit price, right? It will give you error because you are grouping data. You are saying grouping. So you are saying group all the delivered order together, right? And then you are saying give me unit price as well. So it will be confused, right? Because for each order, unit price is different. So it cannot give you unit price. Either you use aggregation, give me sum of unit price. So it will group all the delivered order together and give you sum of unit price. But you cannot say group on delivered and give me only unit price in the output. So that it will be confused because for each delivered order status, there are multiple unit price. It can give you aggregated value, but just unit price it cannot give, right? Because for this delivered, unit price is 137. For this delivered, it is 185. So what it will give? It will be wrong, right? So this is how group by works. You get only the columns on which you are doing group by or whatever aggregation you are doing, right? So I hope you understand this. Okay. Now let's move forward and see that what we can do with um, window functions, right? Now, just to recap, right, how you write window function in uh, SQL, right? So select stuff from, let's say, orders. Now, there are different window functions. So, for example, you drive rank, right? A rank of, let's say, or let me take employee DF. It will be easy to explain again, right? So let me take this employee DF dot show and let me remove this. Okay. Okay. So let me fix this. Department ID 1 and let's remove this. And yeah. Okay. Oh, sorry, it is not 1, it is 100. Yeah, now it is all fine. Okay. So in SQL, how you write? Let's say you want to rank these employees, right? So the one with highest salary should be 1, then 2, then 3, then 4, right? So we'll say rank, right? Over, and you will say order by, sorry, order by, and you will say salary descending, right? So what it will give you? It will give you rank, right? So the one with highest rank, or let me show you quickly. I will say dot create or replace temp view. Let's call it EMP. Let me take it out for now. And then I will say spark dot SQL, and I will put my query here. And this will be EMP. Right? So I'm saying select star, comma rank over order by salary descending as added from employee dot show. So what it is giving is, it is saying that the highest salary is rank 1. You can ignore this now. We will discuss later. Right? Highest salary is rank 1. Then this is 2, 2. Right? Because they have same salary. Then we have 4. This is how rank works. Right? 4, 4, 6, 7, 8. And again this is 9, 9. So what you are saying is give me rank. So there are two things. One is you give me rank. Second is order by salary descending. So you are saying over this, as per this condition you do order by salary descending. Right? So now what we will do the same thing using uh, DataFrame API, right? So you will have to import from PySpark .sql dot window import window, right? This window W is capital, so you will have to import the window functions first, right? So PySpark dot SQL dot window import window, right? So this W is capital, just remember this is all case sensitive. Okay, now I will say so I will have to create a new column, right? This is a new column, right? So how we create a new column? We say with column. So I'll say this dot with column, right? And column name, let's say RN, right? And now I will have to give this condition, right? That what I want to do, right? So I have to tell that over this, give me whatever, right? So I want rank for now. So I'll say rank, right? And then I think I have to use bracket. Let me check quickly. Uh, yeah, correct. So where is my rank? Mm, yeah. So yes. So you will have to give your rank function, whatever function, dot over. And here you can say that you can give your window, right? Now, general practice is in DataFrame API, you define your window separately and pass it here. You can directly also pass here, whatever your window is, right? So whatever you are giving in dot over, right? You can directly pass here, or general practice is you define your window separately here. So you will say window underscore spec, whatever, any name. So this is window specification, right? So you can give your window specification here and then pass here this variable, right? Or you can give directly also here, right? But general practice, you will see that people define window specification separately and then pass it here. So it looks more clean You define here and simply pass here, right? Directly also you can do. Okay. So we will say window dot order by, and you pass your column. My column is mm, my column is this salary, right? So you are saying my this is my window specification. This is my window function I have to use. Window dot order by salary, right? You can pass directly here as well. I will show you, right? And then you do it and dot show, right? So you are getting the same result. So by default it is in ascending order. You see, right? So you can change it to descending, and you can say maybe column dot desc. I think this is how you can give. Yeah. So if you see, this is the highest sales one. Sorry, not sales, salary. Then 2 2, then 4 6 7 8 9 9. Right. So I can show you. You can pass this same thing directly as well. Right. Let me comment this. See, this is also working, right? But in general, you will see most of the time, this is how it is, right? People define their window here in a separate variable and then pass it in the over. So you say your function, what function you want, dot over, and you pass your window specification here. You can give it any name, window specification. Some people give just W, right? Whatever you feel is right. I feel this is right. This is my window specification basically. Right, so this is the syntax, right? Let's say you want more columns. So you can say, let's say one more column. Let me show you. Right? And let's say one more column. So what I will do, I will just take it to the new line. And this is rank. And here I will say dance underscore rank. And then here I will say row underscore number. Right? And let's run it. Okay, all our column names same. So let's call it uh, rank column. Let's say this is my tens rank column, and this is my row number column. Okay, so if you see, all three columns are coming, right? What will be the difference? So in rank, it will skip the rank. So basically, if you see one, then this is two, this is two. Right, the next person will get 4 because this is fourth person, 1 2 3. So if there is a tie, they will get the same rank, but next person will skip the rank and next rank will come. So 1 2 2 4, then again it is 4 and 4, same rank, right? Then next person will get 6. If you count 1 2 3 4 5 6, so this is sixth person, right? Then 7 8 and 9 9. So this is your rank. In dense rank, it will not skip rank. So if you see 1 2 2, the same person with same salary will get the same rank, but next will get 3. Right? It is a dense rank. There is no gap. Right? So 1 2 2 3 3, then again 4 5 6 7 7. In no number, nothing like that. In no number, it will just give you the 1 2 3 4 5 6 7 8 9 10. Okay. So this is how these three functions differ, and this is how you give. Okay. Now another thing is, right? I want within the department, I want rank, right? So in SQL, you do something like this: partition by DEPT ID, and then this. So within each partition, it will give you the rank. So for that, you can give partition by here. So you will say partition by, and you pass the column. So in our case, we want to do partition by on department ID. Okay, so I'm saying partition data on department ID, then based on salary descending, you give me rank. So within each partition, it will give me rank. So 100 department ID will have some rank, 200 will have separate rank, and so on and so forth. Right? So if you see this 100, right? We have 1, 2, 3, 4, right? So within 100, this is the highest salaried employed, then next, then next. This is rank, so 1, 2 to 4. Right? Now 200 is a separate department, so it will again give me separate rank because I'm saying within partition drive the rank. So each department becomes one partition. So 200 is one partition, and again we have 1, 1, 3, 4. Right? Same concept that if it is a tie, they will get the same rank. And if it is a rank, then it will skip the rank, then will not skip it, and this will just give you running number. Right? So this is your partition by. So we have partition by and order by. Simple, very similar to the SQL, right? Just you have to, I mean, same thing. If you see, we are just saying rank dot here, right? Instead of rank space over, we are saying rank dot over, and then here, whatever we are writing, it is in a different syntax. So we are saying window dot partition by dot order by, right? So that is the only difference. Otherwise, if you see, very similar syntax to SQL. Okay, so we learned how to do order by and how to do partition by, right? Great. So these kind of things will help you in getting those questions, like for example, within each department, who are the top two employees, right? Within each department, which is the highest salaried employed, or within each category, which is the highest selling product. Those kind of thing will help you in this. Okay, great. So let me see if we have covered this. Yes, order by, partition by, this is all fine. Okay. Now let's understand two more functions, right? One is this is rank. Then we have lead lag. The lead lag is to get the, so for example, let's say you want to compare this salary with the next salary, right? So let me write it first. So this window spec is fine, right? And let me take only this much. Okay, so employee df dot with column, and let's call it next salary, right? For now, let's remove it. I'm just doing order by. Okay, and this is my this one show, and now instead of rank, I'm saying lead, right? And in lead, I have to give a column. I will tell you why, right? And comma one. Okay, so let me run this, and then maybe I can explain. So what it is doing, lead salary one, right? So I'm saying order the data based on salary in the descending order. So if you see, it is ordered, right? In the descending order of salary, if you see 15,000, 12,000, so on and so forth. That is first thing, that order the data in this, and then within this, give me next salary, give me lead salary. This is my column name, next salary. Then I'm saying lead salary one, which means give me salary of the next row. So when I'm on the this row, right, what is the next row? 12,000. So I'm saying of the next row, give me the salary. When I'm here, I'm saying next row, go to next row and give me the salary. When I'm here, I'm saying go to the next row and give me salary. So this is how it is coming, next salary, right? This is generally month on month comparison kind of thing you do. In that it will be helpful, right? You get data at monthly level and then use lead to get the next month sale or next year sale, and then get the percentage increase or whatever, right? Now here you can change it, right? So by default it is 1. Even if you don't give, I think it works. Yeah, by default it is 1. Even if you don't give, it will give you the next row, right? From next rows, it will pick salary and give. You can give 2 also. So it will go to next row, right? So if you see here 12,000, Next to next is, sorry, it is 15,000. Next to next is 12,000. So you are getting 12,000. Now you have 12,000. Next to next is 10,000. So 10,000. Right? But it all depends on what is there in order by. Right? If I do order by on employee ID, then it will sort the data on employee ID. Then it will give salary from the next row. So let me show you. I'll say employee ID and let me do one for now. Right? Simple. Now if you see, employee ID descending order I have done. Let me do ascending. Right? So employee ID in ascending order. Right? And when it is in ascending order, this is 10,000, next salary is 15,000, right? So it is 15,000. So always this lead, lag, rank works along with order by, right? All these five function, rank, row number, dense rank, lead, lag, works along with order by, right? Again, you can give partition by here. So you will say partition by department ID. So within department ID, it will give you the next. And last one, if you see, is null because there is no next row, right? There is no next row, so it is giving you null, right? So let me put partition by here, right? Partition by department ID. So within department ID, it will do lead lag based on the employee ID in ascending order, right? So if you see, so employee department ID 100, right? This is my 100, right? So 10,000 next is 15,000. So it is sorted on employee ID. Then 15,000 I am getting. 15,000 next, 10,000, 10,000. 10,000 next, 5,000, 5,000. And now there is no next salary because we are saying within each department I need this next salary. Right? So within each department, this is your next salary. And for 5,000, there is no next because this partition is ending. This is the last row in this partition. So it is null. Within each partition, the last value will be null. Right? And in these two departments, there is only one employee. So next value is null. Right? Let me see if we can give default argument here. So let's say I'm saying a literal 10. I'm just trying if it works or not. It doesn't work here. Let me give salary. Sorry. Salary. No, it is not working. Okay, it doesn't work here. So in SQL Server, in some databases, you can give a third argument, right? That if next row is not there, you give some default value. So you can do this using coalesce or NVL function, right? But I don't think it is working here. Okay, fine. So this is how you can use lead. And similarly, we have lag. Lag will give you the previous value. Same concept. Instead of next, it will give you the previous one, right? So if I run this, you see this one, right? So the first row will be null, right? Because there is no previous row. It is going lag previous, right? So it is sorting by employee ID in ascending order within this department 100, and then previous is not there, so null. 15,000 previous is 10,000, so 10,000, right? 10,000 previous is 15,000, 15,000, right? So whatever you do order by, based on that, it will jump to the next row or previous row based on lead or lag, right? So this is your different kind of window analytical functions to get rank or lead, lag, all of those things. Okay, great. Um, let's move forward. Okay. Now we can do aggregation also with this window functions. So let's say my requirement is that uh, I want to get, let's say, percentage of salary. That out of whole salary that I'm giving, right, to my employees, how much percent this guy is getting, right? Let's say total is 1 lakh. So 10,000 of 1 lakh is 10%, right? Now, how can we solve it? There is one way is I get the total salary in a separate column, right? In a separate variable and then do divide. So for example, let me do it quickly. So I'll say employee df dot egg and then I will say sum of, sorry, sum of salary dot alias total salary, and this will end, and then do show. So it is 91,000. Okay. So this is my total salary, and I need to get 6,000 divided by 91,000, 7,000 divided by 91,000, right? So how we can do? There are different ways of doing it. One is, instead of show, you do collect, right? If you do collect, you get a list, right? And from list, let me say df total, or let me say total salary, right? And if I say total 0, right, this is a list, right? It is giving me this, and from this again, there are different columns. In each row, you can have different columns. So we have only one column. So again, I will say 0, right? So this is a Python variable, basically integer type. So if I just say type, right, it is an int. So basically, I can store this in a variable, right? This is why collect is different from show, right? It gives you a object, list object. So you will say total salary, and you got this in a variable, right? And then you can just divide with this variable. So you will say, for example, employee df dot with column C capital, right? And then you can say percent salary, and then derivation here, which will be salary. This is my column salary, right? Maybe I'll say column salary divided by this total salary. This is a variable, I can pass it here, right? And dot show, right? So it is telling me 0.1. Let me multiply by 100, right? So this is 10% of 91,000, right? Whatever it was, 10.98, almost 11%, right? 16%, 10%. So this is one way, right? But this here it is fine, right? But what can I not do, right? I cannot say that within each department give me percentage salary, right? Now with that approach, this will not work. So for example, in department ID 100, right? Total salary is 10 plus 15, 25, and 15, 40, right? So I want 25% because 10,000 or 40,000 is 25%, right? Now here we are getting just one data point, right? I need four different. That for this department ID, this is the total salary, and then I can get it, right? But I just wanted to tell you that sometimes this collect and all are useful because they return a object. But show will just a print string, right? You cannot do much with that. You can just see data. But with take and collect, they return a this list object, right? So that list object you can further use, right? But show is just a print format, a string, and you cannot do much with that. Okay, so this you understood, right? Let's do this with another way. Now, another way can be I can get the total salary, right? So let me just do this and do this, right? And let's call it total underscore df equal to this. And if I run this total df dot show, okay, so this is a data frame which has one column and one row. Now, there is only one row, right? And basically, I want this row next to all of these row of employee table, right? So I have 91,000. If I get 91,000, 91,000, 91,000 against each row, I can do division and get the percentage, right? That is another way of doing this, right? One way was I got in a variable using collect and just dividing. Another way is I can join this employee data frame with this total data frame and do a cross join. In this cross join is fine because I know there is only one row, right? So each row will join with this row. Each row will join with this row. So I can do a cross join. Might not be a best solution, right? But I'm just saying this is one way, right? So let me do it quickly. So I'll say employee df dot cross join, right? And cross join with total df dot show, right? So I got it. Now you can say dot with column, and then you can say salary divided by total salary, right? And this will work. Same. Here you will say salary divided by total salary, and after join, we have done cross join. This is another way of doing it, right? So this is all fine. Okay. Now my next is that I want within department percentage of salary, right? Within department percent of salary, right? So now what I have to do? It means I need to first get, right, this something like this. So I need to get department ID and salary. So for department ID 100, total salary or department total salary, let's say. So department total salary is 40,000. And for 200, department total salary is 12 plus 12, 24 plus 14, right? 38,000. And for 300, we have only one, I think, 6,000. And for 500, we have one, 7,000, right? So first I need to get this. Once I have this kind of data, I can join it back on department ID, isn't it? When I join it back on department ID, I will get 40,000, 40,000, 40,000 for these four rows. Right? This 200 will join with this, and I will get 200 here. Instead of 91,000, I will get 38,000, 38, 38, 38, right? And then I can divide. So at department level, I can get the percentage of salary, right? So let's do it, right? So for that, we will have to do a kind of join, right? So with this approach, we cannot do this using collect, because once I do collect, I'm getting one variable, one value. Now here we don't have a one value, right? We have four different values. One for department ID 100, one for 200, one for 300, one for 500, right? So what we will do, we will just say here group by dot, and I want at department ID level, right? A department ID, give me this. And for now, let's do this total df dot show, right? So I got for 100, 40,000, right? For 200, 38,000, right? For 300, 6,000, and for 500, 7,000, right? So this we got. Now we will join it back with the employee df, and next to all rows, we will get that department salary, right? So let's do it. So we'll say employee df dot join with total underscore df, right? Now based on what I want to join, based on department ID, right? Column name is same, and I want to do inner join, right? Inner join is fine because anyway these departments are coming from this table itself, right? So all the departments will be common, we know, right? These all departments are coming from employee table itself, right? So we know that it will be same department, so inner join should be fine. All the records will be common, right? If I run this, there is a error. Okay, I need to give in the double quotes. Yeah. Uh, what happened? Okay, I have not done dot show. Okay, so let me. Okay, this is fine. Okay, so if you see for all the 100, 100, 100, right, I'm getting 40,000, right? And for all the 200, I'm getting 38,000. Now again, you can do with column and you can say salary divided by total salary. Total department salary actually it is, right? So you can achieve it this way as well, right? Now with the window function also, we will try to solve it, right? With window functions, it becomes more easy, right? So let's do it. So I'll remove it for now. and I will say my window spec equal to window uh, um okay, let me write that first. So I'll say df underscore employee underscore df dot um with column, right? Let's do on the full table first, 91,000 thing. So total salary, right? And I'll say sum, right? I want sum dot over, and I will not pass anything in over, right? Because I want cell sum over full table. So I'm not passing any window. When you don't pass anything, which means on the full table I want, right? And I will say dot show. It requires one positional argument. Okay. Okay. I think in partition by, let me try window underscore spec. Okay. In sum, I need to pass. Sorry. In sum, I have to give, right? On what I want sum. I want salary, sum of salary. Okay. Over also requires one. Perfect. So I'll say window underscore spec equal to window. Let me pass it here. Window dot, and then we will say partition by, sorry, partition by, right? I don't have to do any partition by, so let me keep it empty and let's say, yeah, perfect. So you are saying partition by nothing, right? This is how you have to give. You have to pass window spec, it is mandatory, but basically you are saying in partition by nothing. You don't want to partition by anything here, right? So you are getting the total salary, right? So now you can do salary divided by total salary, right? And it will give you percentage of salary compared to the full salary, right? So this is simple. You don't have to do cross join or anything. Simply you can say window function, right? Sum of salary over full table, right? Now let's say you want department ID wise. You will say department ID, right? Now within department ID, it will give you sum of salary, right? So your window specification is partition the data based on department ID and give me sum of salary, right? If you see within each partition, it will give you total salary. So if you see this is 40,000, right? We achieved the same thing using joins here, right? And this the same thing we can do here as well, right? So here also we are doing kind of aggregation, right? But when we were doing aggregation using group by, we would have got only the department ID and the total salary in output. We cannot get all other columns, right? But when we are using window function for aggregation, we can get all the columns and the aggregated column as well, right? So aggregation is based on department ID. So for a particular department ID, this aggregation value will be same, right? Because we are saying the partition by department ID. So for 100, if we sum everything, it is 40,000 and it is just repeating 40, 40, 40, 40. Similarly, for 200, it is 38, 38, 38, 38. And this is only one record. So this is how it is, right? So this is your partition by and aggregation. Okay. Now in this, we can also do order by, and let's see what will be the impact of that. So I will say dot order by, let's say order by employee ID, right? I'm saying order the result by employee ID in the ascending order, right? So what it will do a running some kind of thing within each department, right? Let me run this. So what it is doing, if you pick this one, right? I have done partition by department ID. So this has become one partition. Order by employee ID. Order by employee ID 1, 2, 3, 4, and then do sum of salary. So what it means is, so first one is 10,000. Second is running sum, because order by employee ID I am doing. So it will do a running sum. 10 plus 15, 25. 10 plus 15 plus 10, 35. plus 5,000, 40,000. If I don't give order by, right, so it will give you same value, 40, 40, 40, 40 for all four records of 100, right? But now I'm saying order by employee ID, so it will do a running sum based on this column. So it will order the rows in employee ID and then do a running sum, right? If I, let's say I do order by age, so order by age and then running sum it will do. So if I say emp age, right? And if you look at this 100, right? Now they are in random order if you see as per employee ID, but it is in order by age. So 16, 37, 39, 48. And now it is doing running sum 5,000, 5 plus 10, 15, 5 plus 10 plus 10, 25, and plus 5, 40. Last one will be always same. It is ultimately the sum of all the rows in the department ID 100. Now here if I don't give partition by, then on full table it will do the running sum by ordering the age. Right? So 5 plus 9, 14, 9 plus 12, 26, and it is in the employee age, sorted by employee age. Okay. So this is your running sum. You can attain running sum using this. Right? And within department or without department, whatever you want, you can do. Again, you can do sum, min, max, average, right? So it will do running min, max. For example, between these two, right? So for the first row, when we are at the first row, the minimum is 5,000. So it will give you 5,000. Now, let's say I'm doing minimum instead of sum. So between these and this, minimum is 5,000. So it will give you 5,000 again. For this row also, it will give you 5,000 again. Again 5,000. So it will give you 5,000 because minimum is 5,000 only. Right? After doing sorting on employee age. Okay, so this is your running sum. Now next category is you want a window sum. Right? Running sum means from starting till the current row. Right? So when you are here, from starting till current row, you are getting the running sum. Right? If it is within department, then within department. But basically this is running sum, right? So you are getting all the salary. So when you are on this row, you are getting running sum of all the salary till here. If I'm doing sum, right? Now, next is window sum, which means let's say I want only sum of previous two rows and current row, right? So when I'm here, I don't want full running sum. I want this plus this. I mean this plus previous two rows. So three rows sum I want, something like this. So 10,000, 5,000 plus 12,000, that is what I want here. So for that, we have rows between, right? So I will say dot rows between, right? And then I will pass two arguments here. So I will say minus 2 comma current row, right? And current row I think should be like this. No, this is current. I don't remember. Let me check the syntax. Uh, Order by is fine. Where is rows between? Okay, here. Okay, window dot current row I have to give. My bad. Okay. Rows between window dot current row. Okay. Rows between window dot current row. Okay. So, okay, I'll just explain you what is happening here, right? So let me run this. Okay. So I'm saying, so minus 2 window dot current row. So when I'm at this row, right? When I'm looking at first row, this is my 0th row, right? You can say index 0. Then this is 1, this is 2, this is 3. And if I go up, then it will be minus 1, minus 2. For this, we don't have anything, right? Let's assume I'm calculating this, right? For this row, right? So this will be index 0, and which is current row basically, right? This is minus 1, this is minus 2. So when I'm saying, oh, sorry, here, right? This is my current row, minus 1, minus 2, right? So I'm saying for the minus 2 till current row. give me the sum. This is how it is. Rows between -2 and current row. So when I'm here at 10,000, -2 will be, this is 0, this is -1, this is -2. So -2 to current row, right? Give me the sum. So 5,000 plus 10,000 plus 10,000. So it is 25,000. Let's look at the last row. So this is 0, current row. Current row and 0 means same thing, right? This is 0 and this is -1, -2. So I'm saying from -2 till current row, give me all the sum. So 7 plus 6, 13 plus 12, 25. Right? Let's say I do -1. Right? So -1 means previous row and current row, right? Only that. So 6 plus 12, 18. Right? If I'm here, then 15 plus 7, 22,000. Right? So this is how you can pass it. Right? You can also say that between current row and next two rows. Right? So for example, current row is 0. So this will be 0, 1, 2. So it will give you some of these three here. Right? So let's run this. So if you say 15,000, so this is your current row and then 2. So 0, 1, 2. So 15 plus 7, 22 plus 6, 28. So you have 28 here. Right? So you will have, it is with respect to row, in which row you are. And for that row, as per this range. So this is a range from this to this. You do this. Okay. Now in this, we have more variations. So you can say unbounded preceding. Unbounded preceding means all previous row, right? So you will say window dot unbounded preceding, right? So all the previous rows till current row, something like this, what we achieved with order by, normal order by, right? So So if you see 5,000, then 5 plus 9, 14, 5, 9, 12, 26, and so on and so forth. When we come to 12,000, it is all previous rows and the current row as well, 91,000. Right? Let's say you don't want current row. You want all the previous rows, ignoring the current row. So you will say all the previous rows till, I mean all the old rows, previous rows till the previous row only. So if you see here, it is 79,000, right? So this is not considered, right? So 91,000 minus 12 will be 79. So sum of all of this will be 79, right? So you can play with this. You can just change, right? I think 0 also works here instead of current row. If you give 0, yeah, that is also working, 91,000. Okay, similar, you have unbounded following, right? So unbounded following means window dot unbounded following. So basically it is saying all the previous rows, all the following rows, everything. So it will give me basically total sum 91,000, right? It is like not giving anything in the partition by, something like that, right? And we are doing order by, partition by not here. So if you do partition by, then within each partition these things will happen, whatever I'm showing you, right? It is the same concept. The moment I give partition by, within that partition by, everything is happening, right? So 91,000, or I can say window dot current row, right? Between current row to all the following rows, right? So 5,000 and all the following rows. So it will be 91,000. Right? So basically from here, if we are here, this row and all the following rows. And how it decide which is following row based on order by employee age. So it will sort data and employee age, then it will do this thing. So if I am 6,000, so 6,000 current row and following rows. So 6 plus 12, 18,000. Okay. So this makes life sometimes easy, right? So for example, in this case, where we wanted to calculate percentage of total salary or department salary, you don't have to do joins and all. You can directly do using window functions, right? And these are window functions are narrow or wide transformations. What do you guys think? It will be wide, right? Because if you are doing, let's say, partition by, right? So all the same department ID should go to same partition, right? Even if you are doing order by, right? So for order by also, you will have to do shuffle data and make sure all the keys are together, right? They should be sorted. So order by is also a shuffle. So basically this is white transformation. Any window function is a white transformation. Because there is always a comparison between this row and next row and kind of thing, right? So whenever it is there, it has to be a white transformation. Okay, let me check if I have missed anything. Right? So if you want to remove the duplicates, you generate the row number first, right? So for example, for each employee ID, let's say there are duplicates, right? So you generate the row number and then you get the first employee, row number equal to 1, right? So that way you can remove the duplicates using window functions. This is again top N. So you generate the row number and then say Rn is less than equal to 3, right? So let's say you want within each department top two employees. So partition by department ID, order by salary descending, and then you will get less than equal to 3. So you will get top three employees in each department. So this is the same thing, right? Window functions are white transformation, cost shuffle on partition by, required sorting on order by, memory intensive, can spill to disk. Okay, window versus group by reduces rows, preserve rows. So this reduces rows, right? If you are doing group by on department ID and you have, let's say, 4 departments, only 4 will come. But this will preserve. If you have 10 rows, it is not going to reduce or increase number of rows. Window function will give you same number of rows. If in your table you have 10 rows and if you are applying any window function, right, it will not reduce any rows. It will be 10 rows only, right? Same, cheaper. This is cheaper. This is more expensive, right? And I think you understand it. And this is how we do in SQL as well. Sum of salary over partition by, order by, and rows between. And you can give there as well, -2, and current row and unbounded preceding following. I think you all would have done using SQL. So this is how we do in SQL. Okay, so same thing, nothing different. It is just that for the syntax, you have to do a little bit of practice. But logic wise, whatever you understand from SQL point of view, same thing here. Nothing different. Okay, great. Great. Now, if you would have seen, I'm not going too much into logic and all because that is part of SQL learning, right? I don't want to spend too much time in logic building and all because this is not a SQL course, right? You should learn all of this logic building and all when you are learning SQL. Here it is like just implementing with DataFrame API, right? So if you see all of these things I teach in SQL in 4 or 5 weeks because there the focus is on logic building and SQL. Here the focus is not on logic building, right? Here just to tell you the syntax, how to work with DataFrame API and some of the concept. So we were able to do it in just 2 classes, right? Compared to same topics when we learn in SQL, it takes 4 or 5 weeks. Okay. So yeah, that's about most of the transformations. There might be some more, but I think you can learn yourself now, right? But most of the important ones we have covered. If you feel something is missed, you can now learn, you understand how it works, right? Great. So we will learn UDF now, but as I said, UDF are not good performance wise. So you should make sure that normally it is not possible. Then only you should use UDF, right? So why it is slow, we will learn in next class, but implementation of it we will learn now. So what is UDF? UDF is user defined functions, right? User defined function allows you to define your own custom function and use it in Spark just like a built-in function. What does that mean? That means that we have learned a lot of built-in functions. So for example, we learned date function, right? Date functions take two date, right? Date 1 and date 2, right? It gives you a number of days. So let's say 10, right? So basically you are passing two dates and it is returning you integer. And this is a built-in function, right? It comes with PySpark installation. You don't have to do anything. You can directly use it. Or let's say length function. Length function takes it as a string. Let's say Ankit, right? And give you length. So it is taking one parameter, Ankit, a string kind of column it wants, right? Maybe name, name column, it will return an integer value. So these are all built-in functions, right? These are already existing with the installation of PySpark. Now there might be a possibility, right? You want your whatever your requirement is not fulfilling with the built-in function. You want to write your custom function and use it. Just like you are using date, diff, or length function, in similar way, you want to create your own function with some complex or your business specific logic, right? And then use it multiple times, right? Just like date diff, you can use your in all the projects, right? Because it comes with PySpark. Anyone in any project can use. Similarly, you want to create a function and then anyone can use it. You can use it in multiple places, in multiple pipelines, something like that you want to do, right? Now that custom logic can be anything, right? I have just taken one example, right? So I've written a custom function in Python. So you can write your custom function in Python and then you can convert it to a UDF. So I'll just show you. Okay. So I have created something order priority. It takes all of this as input: order status, state, unit price, quantity, right? And based on this, it creates a order status, right? So this is a Python code simply, right? It takes four argument, this Python function. Then it is calculating unit price into quantity, right? And then we are returning a string. So this is returning an integer, right? This is also returning an integer. Substring function is there. It returns a string itself, right? It takes two arguments. One is the string itself, column, and three argument actually. We want to start with one and let's say four characters, right? So it takes three argument and it returns a string. Similarly, this function takes four arguments. This is a custom function I'm writing. So this takes two argument, this takes one argument, this takes three argument. It is returning integer, integer, and this returns string. Right? Similarly, this function takes four arguments, right? And based on whatever logic I have written, it is returning a string. Either it returns a ignore, basically order priority, or P1, P2, or P3. Now, what logic is, it doesn't matter, right? That's not the purpose of this. Whatever logic is there is there. But basically, in my orders data set, right, I want to create a new column, order priority, based on this, right? Now, maybe we can achieve with DataFrame API case when condition, but I'm just showing you if we have to use UDF for that, right? So we define the function in the Python language basically, right? So you write your function, right? Then you have to register this function, right? So you have to convert it to a Spark UDF. So you will do this. Okay. So UDF will be imported from PySpark.sql.function. So I have already done star, right? So it is not required, but I am just telling you that UDF also comes from here. Then this string type, because I have to tell that this will return what kind of data, right? So I'm saying order priority UDF. This is how I'm registering the UDF, right? Order priority UDF. You give UDF function. This is my Python function name, order priority, and I'm saying it will return a string type, right? So while defining the UDF, we have to tell that what data type it will return, right? In our case, it will return a string. In some functions, it may return date or integer, so you can just pass it, right? So this is how you will register it, right? So let me run this, and this is now registered, and we can use it, right? So uh, let me take this. Okay. Okay. So let me check what is my df underscore orders, I think, right? So yeah. So this is my data set df underscore orders. Now in this, I want a new column order priority, right? So with column order priority. And now instead of using date, diff or substr or whatever, I'm using this UDF, which I just registered. And it expects four arguments, right? For example, this was expecting two arguments. So we have to pass two date, let's say order date and ship date, right? Or I will pass the employee name, or I will pass the employee name and all of this. So similarly, I'm passing four columns here, right? It is expecting four columns. If you see in same order, I have to give order status, state, unit price, quantity. In same order I will pass. And then it will run this logic for each row and give me the priority. What is the order priority? And this will be my new column, right? So if I show this, sorry, run this, you see I'm going to order priority, right? P2, P3, ignore, whatever, based on the logic, right? You can check that it will be according to this logic. So basically you can create the custom function, right? So this is your user defined function. Simple, right? You create the function, then you register it. How? You will say UDF, function name, and what data type it will return. Once that is done, then you can just use it. Order priority UDF and pass the column names. Okay, but we should ideally avoid using it. That we will understand later why. Okay, now this UDF you are using in DataFrame API, but if you want to use in Spark SQL, the process is little different, right? So you have to register like this. So let me copy this. Right? If you use this directly in Spark SQL, it will not work. So you have to say that spark.udf.register your UDF name, what name you want to give. So for example, here we give order priority UDF. So this here I am giving order priority SQL UDF, and then your actual function name, order priority, and what it will return, string type. Right? So these three things. Spark.udf.register this, and this. Right? And let me run this. Okay, so this is done. And then let me use it in Spark SQL. So I'll just copy this and let's create a, I don't know if we already have, let me create again. df order does create a replace view orders. And then I'm saying select all of this. And then I'm calling this order priority SQL UDF. And I'm passing these four columns as order priority. So I'm getting the order priority here. Same logic. P1, P2, P3, ignore whatever. Right? So this is how you can write your user-defined functions and can use in DataFrame API or Spark SQL. Okay, great. I think that is it for today. Let me see if anything else is missing. No, we are good. Great. So, yeah, this is it for today. Maybe we have 5 minutes. Maybe I can solve some questions just to show you how things works. Maybe I can solve one question, right? We have just learned transformations. Let me solve one question. Uh, so I had put three questions, but I don't think we have time. I will add it to the assignments. Okay. The question is using the orders and products data set, right? Find the top two most profitable products in each state, where profit is defined as unit price minus cost price into quantity, right? Consider only delivered orders, return state, product ID, total profit, and drag within the state. Okay, so this is my requirement. Now, whenever you see a question, right, first you should see that can you filter something, right? That should be your first step. So if you see, it is saying consider only delivered orders. Right? So I don't care about any other order, right? So I will just say first thing that filter data. So df orders dot filter, and I will say column. Column name is what is the column name? Order status. Right? Equal to delivered. Right? So step by step you should go. Dot show. Right? So consider only delivered orders. Perfect. So I have only the delivered orders. So first step is done, right? Now next is find the top two most profitable products in each state, right? Where profit is defined at unit price minus cost price. Now to get the cost price, I have to join with products df, right? Because cost price is not there. We have unit price. So I have to join with the product table. So I will do here itself just to show you that we can chain different things together. So I'll say join with, I think we have df underscore products already, right? And not this. This is our data frame name. And then I will say join on product underscore ID, right? And I want a inner join. Right? For now, I'm doing inner join, but it depends on other things. Okay. So I got the product name as well as the cost price, right? Now what I can do further, I will say dot with column, right? I want to create a new column, which will be profit, net profit or something like that. Net profit, and the calculation for this is, so we have unit price, right? Then I have we have a unit price and cost price, right? And then once it is there, I have to multiply it with quantity, right? So I'll say multiply it with column quantity. Where is quantity? Here, right? And the column name will be net profit. So let's see. Dot show is already there. Okay. Okay. So if you see net profit is coming here, we have too many columns, right? But net profit is here, right? After doing this calculation, right? Great. Now, once we have this, what we need to do is we need to get the top to most profitable products in each state, right? So in each state, I want profitable products, which means I want something data, something like this: state, products, and total profit, right? So for each state and product combination, I want the total profit and then I can rank. So first I need to do aggregation on state and product, because one state and product I can have multiple rows, right? So for I can have UP, product P1, profit 100, right? There are hundreds of orders. Again, UP, P1, right? 200, right? So first I need to bring all this together, that for UP, P1, this is the total profit. UP, P2, this is the total profit. Then in each state, I can tell which are the most profitable products, right? So first let's aggregate data, right? So I'll say dot group by, group by, and in group by, I need to pass state and I need to pass product. So I will take maybe product name, right? And then AGG, uh, sum of profit, net profit, right? Which we calculated here, right? And then we'll do dot show. Let me alias it, dot alias is profit, total profit, something like this. Okay, great. So we got state, product name, and total profit. It is all negative, which is fine. I think they are not in sync on the data, but that's fine. It doesn't matter, right? So it is showing top 20 rows, but you will see if I just do order by, let's say state, right? So within each state, I have a product and the total profit. This is how it will be, right? So far good, right? Now next what we need to do, we need to get top two products within each state, right? Which means I have to do partition by on state and get the rank based on total profit, right? So maybe it has become too long. So let me call it df1, right? Then on top of it, I will write window function. You can chain everything together. I just wanted to show you, right? Let me remove show. Okay, so now we will define our window. So I'll say window underscore spec equal to window dot partition by state. Within each state, I want rank, right? And order by net profit, this total profit. Column total profit dot descending order, right? Because we want top two. Sorry, what is this descending? DESC. Yeah. This is my Windows spec. And now I will say df1 dot with column. Sorry. With column. And then let's call it RN. And this will be rank dot over my Windows spec. Right? And dot show. So within each state, I will get rank 1, 2, 3, right? So within Karnataka, the maximum profit is in wireless earbuds 6087. Then wireless mouse 6051. So these are my top two products in Karnataka. Right? Similarly, we will have for others. So let me make it 200 maybe. Okay, so this is all Karnataka. Now Odisha, right? Odisha again is starting with one. Highest profit, second highest profit, third highest profit. So the top two products in each category, sorry, each state will have rank 1 and 2. If I want top 3, I can say 1, 2, 3. So for each state, it will be, again for Kerala, it is starting with 1, right? So we just have to put a filter here and we will say dot filter or where, whatever you call it, column Rn less than or equal to 2. Top 2 if I want top 3 less than or equal to 3 and so on and so forth. Right? So for each state, if you see, I am getting the top two products. Right? So this is how you need to do it. Right? So just wanted to solve few questions so that you get the idea how you solve with SQL. I think it is more simpler, right? Because you can do chain the things together. Sometimes it looks very simple, but if you are used to SQL syntax, it will take time to adjust. But once you are adjusted, you feel this is more simple because step by step you can chain the things. That it is more in a in a one direction, right? In SQL, it is like join, you are writing somewhere from somewhere, then select somewhere, group by somewhere. Here you are doing things one by one. You are doing a join, then the next chain you are driving a new column, then again group by next. So sometimes this also feels simpler. Okay, I hope this helps. Thank you for watching this video till here. And if you really liked the video, please make sure you hit the like button because it really motivates me to create more powerful and strong content for all of you. Also, I see a 50% of my viewers are not the subscriber of this channel. So please subscribe because as more subscribers come, I feel more motivated. I feel more energy to create more content, right? So please support me, like the video, share with your friends, subscribe to the channel and keep learning, keep going. Thank you. Have a good day.